gyroscopes, like I said at the beginning, I'll repeat myself. I don't mind being a broken record.
Okay, so you don't. So it's an assumption that you're moving.
Yes.
Affirming the consequence.
Yeah, that's a logical fallacy.
Can I just get in here as well? Just
Yeah,
quickly,
go for
do
it.
you have a demonstration of this?
Demonstration?
Yeah.
Let me get yourself off this fucking push to talk.
Okay.
Language, bro. Chill.
No need to get angry.
Relax.
There. Now I'm off push to talk and I have to keep pressing keys.
Is that better?
But how do I measure it? I just use my gyroscopes. And you can actually measure their drift. You can
Wasn't what I
measure-
asked.
I don't know how to explain it to you. I'm not a scientist.
I'm not asking for an explanation.
Whatever.
I was asking for a demonstration. You either have one or you don't.
So if we, do you guys feel like you want to take a question from chat?
I was wondering if you could actually answer my question, because I don't feel like we finished that yet.
I'd like to finish this guy.
God 420, because you've made a claim there. I was wondering if you have a demonstration for that.
Well, I can set up and do some video streaming and show some gyroscopes in operation, but you're not going to see much, except for a change in angle over the course of an hour. You'll see a drift of 15 degrees.
But that is the claim that you've made that I'm asking for a demonstration of.
I am.
You understand?
I'll do that if I have to, but we'll be here 1 hour to watch it drift.
Sounds
look,
good.
If you don't have it, I'm not going to judge you. I'm not like saying if you don't have it, then you're wrong. I'm not saying
He doesn't
that.
have it. Listen, he doesn't have it.
I know he doesn't, but
Okay, so
I'm asking
let me,
for it
really
anyway.
let me tell you why he doesn't have it, and this is easy to demonstrate. Because you would only measure a 15-degree drift at one of the poles. Are you at the North or South Pole?
Wrong. You can
You're going to measure 15 degrees.
Right.
You're going to measure Okay, listen. You want me to tell you the formula? Because you're not going to measure a 15-degree per hour drift unless you're at one of the poles. You would need a
That is
3-axis
correct.
gyro, and you would measure a cumulative. If you summed all 3 axes, then you would measure a 15-degree per hour drift. But you said you had a regular gyro, regular mechanical
I
gyro.
also have the aeronautic gyros that they use for aircraft.
Yeah, and those are single-axis gyros.
No.
Yeah.
It's for the ones on the main.
They use multiple gyros. They use multiple gyros in the aircraft.
Yes.
And in fact, they're called an attitude indicator.
No, I'm not talking about the indicator. I'm looking at the gyro.
The attitude indicator is the gyro, and the gyro isn't the purpose of it.
No.
Nuh-uh, it's not a reputation. Nuh-uh. Do you want me to just pull up a PDF that has all this, that has the schematic for the attitude indicator for an aircraft? Do I really have to do this?
I don't care about the attitude indicator.
The attitude indicator is what has the gyro, dude.
Ignore me then. Talk over me.
The attitude indicator is your reputation is nuh-uh. Okay? That is what your nuh-uh. Listen, the fact is, the attitude indicator is a device in the airplane which has the gyro, and the purpose of the gyro is to damp the sway of the device.
Wrong.
Okay?
I know
Nuh-uh.
exactly where it is. It is down in the belly of the plane.
So who cares?
In the control
So
room
may I
of
try
the
to
plane,
move this
where all
discussion
the
into more
computers are.
productive direction?
Listen, I'd like a concession. I'd like a concession that he never actually did this test, because to measure 15 degrees per hour on a single axis, you would have to be at a pole. This is not debatable. This is objectively true.
Agreed.
Objectively true. You can.
So if you're at 40, listen, if you're at 45 latitude, you're going to measure a 15 degree. Listen, so if you're at 45 latitude, you're going to measure a 15 degree per hour drift that is on a single axis.
Do you realize how equatorial telescope mounts work?
Yes.
Okay. You can measure the drift throughout the entire surface of this planet, including the equators and the poles.
Do you have to correct for latitude? Yes or no? You have to program it for latitude.
Oh my God! Talk over me. Fuck it. Talk to someone else.
Answer the question. Yes,
You're
it's a yes or
refusing to
no
answer me.
question.
Listen.
May I
John,
You guys are both trying to lie, and that's why I'm acting like this, because you're both trying to lie.
it is
Like, I've been doing this for
retarded
4
to call
years,
someone
dude.
a
I know how
liar
all
because
these
you don't
devices
like their
work.
argument. That is
No,
retarded.
because you're
Stop it.
lying.
Yeah, well, listen, I mean, God 420 can't get to the demonstration, which he would then have to beg the question of. So, yeah, I think we can probably move on.
Okay, so I'm
We will sit.
Me and you-
We'll go get. We'll get the display set up, and we're going to sit for 1 hour, and you can watch the machine physically fucking drift.
Yeah,
You won't do
and then I'll
shit.
ask you-
You won't do shit.
So listen, don't move the goalpost. You said 15 degree per hour drift is what you already measured.
Right. So we'll set for 1 hour, and you can watch it
Okay.
drift 15 degrees in
Okay, let's do this.
camera if we have to.
Yeah, okay. Okay, go
Let's
for
do
it.
this.
Set it up, God. Right, set it
Let's
up.
do this,
and then-
dude. Listen, I'm gonna
Let's
laugh,
do
dude.
this.
When you measure
do we
7.3, when you
do we
measure
need-
7.3 degree drift because you're at something like 43 latitude, I'm gonna laugh at you.
Wrong.
May
That's
I
not how it works here.
please interject
Nuh-uh,
for
some more.
in the-
Corvo,
in the-
guys, let's let Corvo get in here.
Yeah, I was going to say that.
I mean, we can at later time do a live stream with God 420 if we guys want interested.
How about I post citations? Will that suffice, and we can just end this? I'll just
So
post citations.
EA
We can
Sports.
we can
It's in the
both
game.
post it. So I think I have a question by King of Kings, who have a question for the flat earthers. If the curvature of the globe is 8 inches per mile of distance, wouldn't the difference be?
Can I stop you right there?
That
Per
parabola.
mile is a slope. No one is claiming to live on a slope, are they?
Well, hold on. Let me finish the question.
Yeah, but the question is already wrong, so it needs to be
Okay,
correct.
so let me finish it. I'm just reading it. Yeah, the guy isn't talking.
Okay,
We'll say
but the
8
question
inches
is
per
already
mile
wrong.
squared.
That's the point.
Yeah, we'll correct him and say it's 8 inches per mile squared, not 8 inches per
Okay.
mile. As in
That's a
just-
parabola.
Okay,
that'd be
eight
right.
inches per mile squared. Wouldn't the difference be difficult to detect with just your eyes? To me, it's like trying to spot a ruler a mile away and be able to see it move 8 inches to demonstrate the difference in position.
Yeah,
You
but then over 10 miles, they tell us that would add up to around 67 feet of drop, which is measurable. So someone in human history would have measured this physical drop. We're not saying that you should just eyeball it and then make your decision. This is why people are doing point-to-point tests over a distance and comparing it to the rate that the globe model does predict. God,
It's
I know
called
you're
a parent
upset.
drop,
I know
not
you're
physical
upset.
drop.
I know you're upset, but you're just going to have to chill. We gave you your chance, and you were going to go and set up your gyroscope that you were then going to say, I'm claiming that's Earth's rotation. And we were going to say, okay, how do you link that? And you'd say, well, just because we know. Right, so let's not do that, God. You can just chill.
Of course,
Let's give other people a
they won't
chance
even
first.
accept the balloon photographs from Dr. Bob. Or not
Okay,
Dr. Bob,
God.
but Bob, what's his name?
So just to the new people as well, this is the type of
Mr.
person.
Sensible.
This is the type of person that you
Mage
get
program.
who's been arguing this for years, but still hasn't found any measurements of curvature. So they just argue the same redundant points again and again. This isn't a new person to the topic, by the way. This is a diehard who's been emotionally wounded by the flat Earth. So just to point that out to the new people.
Fuck.
I would just like to. Can I just bring it back? To
Please don't laugh. It's actually serious.
Can I just bring it back to something I said about 15 minutes ago? I asked for a demonstration. A demonstration was not provided. If God 420 goes back and provides a demonstration, then we can talk. I feel like there's no point talking about it because he made a claim, he hasn't demonstrated it. I feel like it's moot. So let's just move on.
I feel like speaking to him is moot.
But that's kind of what I'm saying is like, if anyone else wants to discuss this, all good. But he's made a claim that he hasn't demonstrated, and I personally think can't demonstrate. So I think everyone listening already knows what kind of person God 420 is. Now,
10-4.
with regards to the, what was it, the question before about inches per mile, to do with eyeballing it. I mean, I know, Cyclone, you already kind of went ahead with an answer. I would say this is something, when I said squared, someone else said that's a parabola. All good, but he didn't seem to have a problem with the Earth being a slope 30 seconds before. This is the problem with a lot of these debates, is that when we try and get into the actual details, like the meat of the issue, people only oppose it when it's flat Earth. Yeah? If Earth's a slope, not a problem. If it's a parabola, then they're opposing it. So you start to realize that a lot of people are very emotional about this subject. They don't actually want to discuss it. That was all I had to say, really.
Well said.
I agree completely with what you said.
respect.
Yeah, exactly. And it's like I said at the beginning, right? Pay attention to who's speaking about empirical observations and measurements and who's just kind of getting a bit emotional. So yeah, Corv, I don't know if you want to open up to see if anyone else has questions or.
Yeah, anyone else has a question? Want to try to be the interlocutor? Could be interesting.
I have a question.
Let me just see which name.
My question is, if the Earth is flat, how come there are time zones?
Time zones, classic. Crypto, you want to answer this, or someone else on Flat Earth side?
Yeah, if someone else wants to go ahead, otherwise I'm happy to.
You're good, Crypto. You take over, man. You explain it very well.
Yeah, go for it, Crypto.
Yeah, it's really simple. So, let's say that you were, living on a table, right? You, me, and a few other people were living on a table, and there was a light going around above that table. It's really quite simple. When the light is above your head, that's midday. As the light moves away from you, that's called evening, afternoon, and then evening. And then as it becomes dark, that's nighttime. So your proximity with midday defines the time, right? So it's got nothing to do with the shape of anything. It's got to do with the cycle of day and night. And that's all it is. Because it's a repeated cycle, you call this 6 p.m. and you call that 3 p.m. and this is 10 a.m. But they're just... Think about it as like sections of a day rather than sections of a ball. And yeah, it's easy enough to understand.
Also, most people have confusion about the nature of the sun because they've bought into the heliocentric model, which is entirely theoretical, including the alleged distance of the sun as being 93 million miles away. There's no hard evidence for that, so there's no reason to think that's true. In fact, there's lots of evidence to counter that idea. So that's another reason why sometimes people get confused about the sun and the daylight.
I have a question.
Oh, I was actually hoping to ask the guy who asked the question, like a counter question.
Oh, okay, go ahead.
Yeah, but I'll be very quick. I don't know who it was that actually asked.
That was me.
Sorry, what's your name?
Shamron.
Shamron, why do you think that time zones would only be possible on a ball?
It's a fact.
Based on the way you're saying that, the way that if it's like a light shining on a flat surface, essentially. Okay, how do I put?
You think that the sun would illuminate everything, right?
Yeah, wouldn't the sun...
Like a table lamp over like a dinner plate or something, right? So everything should be lit up.
In the text.
Yeah, so that's why I wanted to ask this question, because often that's what people think. So I wanted to kind of lead into this. Think about a massive warehouse, right? So you've got a massive warehouse, and you've got one light in the middle of the warehouse. Does the light in the middle of the warehouse illuminate the entire warehouse?
Well, if it doesn't illuminate the entire warehouse, but I've worked in a warehouse myself, and if there's a single light, and it's in the middle of the warehouse, you'll see some of the light from even the farthest corner of the warehouse, as long as it's bright enough.
Absolutely.
Well, the warehouses you've worked in aren't the same as the one that I've worked in. We'll have to agree to disagree on that one. I've worked in massive warehouses where you can't see. Like, every inch of the warehouse needs to be lit, or there's no light.
Or either way, imagine that warehouse is like 20 miles long, and there's a light at the far end. Then you won't see it.
Would you then say that the size of the Earth is like larger than...
Way larger.
Yeah, the sun is more small and local than they tell us. And that movement over the face of Earth is what dictates day and night. Like a small light over a flat table.
would you have proof to provide that? I mean, proof to justify these claims?
Well, do you know how you see the sun move every day?
Yeah.
And do you know how when you see the sun move away from you, it starts to get dark?
Yeah.
Okay, so prove to me that that's not what's occurring. Because you're saying that's not what's occurring, right? You're saying you're the one spinning, and that's the reason that it's actually going dark. But in reality, you just see the sun move away from you, and when it gets a sufficient distance away from you, it gets dark and it's nighttime.
Crepuscular rays help too.
So
Another distraction.
Really, that's your logical axiom. The sun moves over your head, and eventually it gets far enough away that it becomes nighttime. The light is not reaching you. This matches what we observe of light. It doesn't go forever.
How can you see the sun rise?
Because that's when it's moving towards you. But it's not actually rising from beneath the earth, right? That's an optical effect. Okay, so with it over distance, due to the way optics work, it'll appear to compress with the horizon, but it's an optical thing, right? You can demonstrate this if you have a long table and you take an object and you draw it away from you, get a friend to pull it away from you, you'll see the bottom of it start to disappear bottom up, right, on a flat surface. So when the sun's moving towards you, it has kind of the reverse of that effect. It appears to rise from the compression point of the horizon, but it's just traveling towards you over a distance. And we can show you footage of the sun not doing that, not appearing to optically sink, but rather shrink into the distance as it travels. You can see this in areas on the equator when the atmosphere is a bit drier, generally, and Africa and places like that.
I'd like to counter that, because if you measure the disk, it doesn't change in size. So that makes no sense what you're saying.
Boris, it's good to hear you again. Been a while.
Yes.
So what was your
factually correct?
Boris is back.
Where's Natasha?
Yes. So I want to ask you, I asked this a long time ago, and no one was able to answer it, because you believe there isn't a vacuum. So why does the ISS not burn up?
What are you talking about?
What's that?
Because it's at Building 9 Space Vehicle Mock-Up Center, Houston, Texas, and it's climate control.
No. You can see it with a telescope. You can see it with a telescope. You can
That
see
was
it
a
with
good answer.
Good pair of binoculars. You can even see it with the naked eye. But
So
you
what do you
see
see?
clearly
What
what
do
it
you
is,
see?
and it doesn't burn up.
It's not clearly what
How
it
do you
is.
explain
Dude.
that?
It's not clearly what it is.
It doesn't matter. It's an object that's
It's an object that is way. Listen, now tell me, if the ISS, what you think is the ISS, was at 40,000 feet, was 7 feet across, and going 350 miles per hour, would it look any different than what you see now?
That's not my question. I'm asking why does.
Well, I'm asking you. You think that you positively ideated a space station flying at 17,000 miles per hour, 400 kilometers in the sky, and 300 feet long? That you positively ID'd it with a telescope or binoculars? And I'm asking you.
I don't care what it is. It's an object that you can see. It doesn't matter.
Yeah, and it could be at 40,000 feet.
Why does it not burn up?
Why would it burn up at 40,000 feet?
Because things screaming that fast tend to get
350 miles an hour is not fast.
What's that?
He wants it both ways.
Listen, the International Space Station would be where you think it is would be visually identical to an object that's going 350 miles per hour at 40,000 feet and 7 feet long. That's the same angular size. It's the same angle that it would travel across the sky. It's just everything is identical. Be visually identical, where you could not tell the difference. But why would it burn up?
Because it's going so fast in an atmosphere. But if there is
350 miles per hour, that's actually smaller than a commercial airplane.
I thought this is a question and discussion.
Well, if you don't look. So we start with a false premise, and then you continue.
Yeah, the ISS is going so fast that if there was no vacuum, it would burn up.
No, it's not.
Okay, so prove the speed of the International Space Station.
It's not, huh?
Prove the speed of the International Space Station from observation.
It comes back over my head every 90 minutes. That's
not what I
pretty
asked.
First of all, that's not true in the first place.
It does.
Oh
it
my
comes
God.
over.
The
Well, not
International
directly
Space Station
overhead,
does not
but
pass over the same location. If you look up, if you
No,
go
I know
on
that.
spot the station, so then why are you saying it?
Well,
It's going to go over the same spot.
Well, of course, it doesn't go over the same spot because it's around the spinning globe. But I'm not arguing that. I'm only arguing is why this thing that goes so fast, and you can actually measure its speed with
So you just keep
ham radio
saying it.
equipment.
Prove it's
You
going
can
so
measure
fast,
speed
dude. That's
with
what I'm
ham radio
asking.
equipment. What's that?
You can measure it.
Prove it's going so fast. What's the evidence it's going so fast other than a press release?
I just told you. You can measure its speed with a ham radio when it sends out its beacons. You can measure. Hang on. You can measure.
Oh my
You can
Lord.
measure the Doppler shift of the frequency.
Boris, come
I've
on.
measured it with my ham
Can
radio
you
system.
show us any data of measuring the Doppler shift of the ham radio operator? Can you show us any data supporting that?
Oh yeah, you can do it
Okay,
yourself.
so post it in flat earth text.
It isn't that I need to show the data. You need to do it yourself and see that. Oh, this.
That's called an owner's probandi fallacy, where you're trying to switch the burden of proof to me.
No.
Yes.
You're. I'm just asking you. Why does this thing that travels so fast not burn up?
You don't know that it does. It's like you say it over and over. Yeah. Can I just get in here very quickly?
For a minute. Go ahead.
You can't just keep claiming the same thing over and over. And when I didn't finish. You can't keep claiming the same thing over and over, and when asked to prove it, you just assert it again and again and again. At some point, you have to actually. I'm still talking.
You guys
didn't finish.
Sort of thing.
Moderator, can I be allowed to finish my sentence, please?
No, you are. What am I?
Boris, chill. Let Crypto finish his sentence.
Yeah, you can't just keep reasserting the same thing over and over. Obviously, anyone listening knows that that's the case. If I tell you over and over that unicorns exist, it doesn't matter that I tell you they exist.
I get what you're saying.
I didn't finish.
But you don't
didn't finish.
You don't need to repeat.
Why are you talking over me, bro?
Let him talk, dude.
Fuck me.
Chill.
Like, I'm just trying to emphasize the point that over and over again, saying unicorns exist isn't proof that they exist. India has asked for proof. You haven't provided it. It's the second time tonight the claim has been made with no proof. Just worth knowing. You know, the audience that doesn't listen to this stuff very often, you guys should be considering this. Many claims, zero evidence. And that's going to be the theme for the night.
Yeah, I feel like all Globers try to use these sneaky debate tactics.
He left. Still waiting. I would like to add that in order to have the speed of the ISS, right, you must first assume that you have a distance between the center of the Earth and the distance to the ISS. Then you're going to be figuring out, you got me, bro. Then you're going to have to be figuring out how long it takes to make a circle around the entire Earth. And from this, you can calculate how fast it's going based on the assumption that you know the radius. So at some point, we should talk about how that was proven.
I think he left. Are there any other Globers in here?
There's a question in the text there. Grumpo is asking, I would like to ask about tides. How would that work with the flat Earth?
Yeah,
I mean, it's a simple. It's very simple. Like they're gonna be. You're gonna ask a lot of questions about how things work. That in reality, since we can't scientifically provide evidence for how something is working. You have an assumption on one side, and then there's a burden for us to say, well, how does it work if it doesn't work in the heliocentric model? When the reality is, you're standing on the beach and the moon is heading over you. You don't feel the hairs on the back of your neck or the top of your head stand up. Nothing is happening. There's no change. There's no difference. It's quite obvious that that's just a story that's told.
Yeah, if I could just add on to this point. So tides it's a good question, but again, like we're saying, it's not really something that you can scientifically test all over and empirically validate any of these stories that they're giving us. But an important thing to note is that they'll give you the story that the moon's gravity is causing tides. So then wherever the moon is, those tides would have to be occurring, but they only occur in oceans, right? Salt water. They don't occur in inland seas and lakes and any other body of water, which should experience it if it's simply the moon's gravity. So observably, you can see that the heliocentric globe model story isn't correct, but
so
what it actually is a bit more complicated. Sorry, just quickly, I think Indio wanted to add something, and he's usually got some good info on this. Indio?
Oh, yeah, hold on. I was muted at my mic. Anyway, and it doesn't even tides don't even occur on over 50% of the ocean. There's something called tidal nodes in which there's absolutely no measurable tide difference at all. So there's that. It's like nearly the entire like southern ocean.
Yeah, let me just remember to add. So tidal nodes is a good one to look into, but also if you join the 24/7 Flat Earth Discord, where someone can post a link in the channel, you scroll down to the additional information section. We've got loads of channels, all alphabetized, and Currents is one of them where it speaks about tides, but it goes through, we've got channels on gravity, NASA, astronauts, sun, the moon, stars, all this stuff. And it's stuff that you won't find on YouTube or Google because they censor Flat Earth. So it's worth joining the server. So I'm getting some background noise. High viscosity liquid. Could you chill? I'm going to pop you on mute.
Sorry, I was actually...
but yeah, so check out the Discord server that someone will post a link to, and there's loads of information on this kind of stuff. But
you can join the Discord in announcement page.
Yeah.
And I wanted to give the gentleman that underwater currents probably are the best explanation for why tides happen.
Well, I would say this about tides, that there is a weak correlation with the position of the sun and the moon, but not really that strong. So if you look at actual tidal data, so the theory is that the moon is pulling the water along, and that sometimes the sun, if they're in the right position, interacts. But if you look at, say, the tidal data for the UK, right? So the pull of the tide, high tide should follow the moon when it's at its local meridian. That would be directly overhead, right? The water should be going towards the moon, like where it is. But if you look at just the island of England, you'll see that the difference in high tide can be up to 12 hours, and England's not that big of an island. So the tidal theory, the gravitational tidal theory, is demonstrably wrong just from data. This thing on?
Yep, we heard you. That was good.
Okay.
Good answer.
And if you actually want, I'll actually post it. Oops, sorry about that. I'll actually post.
There's another question in the the text channel, unless someone else has something else to say about tides. King of Kings wants to know, in the flat Earth model, the sun is smaller and closer to the surface than on the globe Earth model. Is there something preventing the light being emitted from the sides of the sun from reaching the outer edge of flat Earth? I don't really understand that question, but maybe somebody else does. Is there something preventing the light being emitted?
I answered him previously. He didn't understand what I was talking about. So there's something called Laplace's Extinction Theorem. There's this idea that air is transparent. It's actually not transparent. And it falls off as a double exponential with the distance. It's not the inverse square. Because there's something called optical extinction. In any other medium, absorbs and attenuates light. So because it has to travel through this medium, for example, if you just measure just the sun at solar noon versus when it's on the horizon, sunset, the difference in brightness is a factor of 23,000. It's 23,000 times less bright just at the horizon. And that's just from the change in angle. That has nothing to, that's not even a calculation for distance. So if you want the physics mechanism why the sun can't illuminate the entire surface of the Earth, that's what it is.
Yeah, I think Hibiscus and Liquid had a question.
Yeah, I was just about to say thank you, Aaron. I'm gonna mute Hibiscus. So just a second. Hibiscus Liquid is a glass blower, so he has some interesting devices running in the background. But Mr. Liquid, do you have a question for guest?
Not a question so much as a comment. I unmuted myself earlier because I was wanting to interject, but I was waiting for a chance to talk, and I've got too much background noise here. Sorry about that. I just wanted to say that freshwater lakes do indeed have tides.
I believe also rivers, maybe. Like I know I live in Stockholm, and sometimes the water gets like lower and higher during the day.
Absolutely. Rivers tend to experience more of what's known as a tidal bore, where you get the water flowing backwards up river, and it's held back by the river, so that you end up with an actual wall of water. When it does manage to push up river, it's pushed into a wall, and so the tides rise incredibly quickly in rivers. But that's ocean water coming up river. But lakes very much do experience tides.
Okay, can I ask you a question? What's the mean tide level change in the Great Lakes, say like Michigan?
I missed that. Say again.
What's the mean average? What is the mean change in tide on Lake Michigan? Like, what's the difference between high tide versus low tide?
Lake Michigan is the one that Google offered me an actual number for as well. So if you're if you're testing my knowledge is, according to Google, it's 1.5 inches.
Okay, so 1.5 inches, which is like what, 2 centimeters?
If that's
okay,
how
so,
you do your math, fair enough.
Okay, so my point, I'm trying to make a point here, is that this change of high tide versus low tide is not within this, it's within the uncertainty of the measuring device. Okay? That means the measuring device does not have enough precision to draw a conclusion from the measurement. Okay? Random variation of water level can account for change in height of the water.
Okay, so first of all, you want to round 1.5 inches down to 2 centimeters. And then you've already cherry-picked Lake Michigan, which isn't that big a lake.
Well, I can also do the Mediterranean Sea. I mean, pick one. I mean, seriously, it doesn't even matter because the measuring device
it's
itself.
Just funny how you come with all these.
Okay, I was told to pick one. How about Lake Malawi? It's nice and big.
Okay, what's the difference in tides?
I don't know. I would have to Google it. But the fact of the matter is, there's that information to be Googled. And you're telling me, their measuring apparatus isn't accurate enough to measure 1.5 inches. It's like bullshit.
Okay.
Okay.
What does it measure?
Find someone else to talk to. I'm not wanting to argue. I just wanted to interject that you were wrong saying that freshwater lakes don't have tides.
First of all, I didn't say that. And when we say does not have tides, which means they are not measurable to any precision where you can separate it from noise. Understand?
You did say that there were no tides in lakes and stuff.
Yeah, no, that was
but when we say no tides, it's not measurable.
Was essentially that, but my point was that they're not the same as the coastal tides. That is what people are talking about, which have variations in the feet, right? These ones that they're talking about, and only in recent years have they started really saying that places like the Great Lakes have tides. Like Indio is saying, they're a few centimeters at best, and they do not correlate to the movement of the moon, which they would have to in totality if the story about the moon's gravity causing tides was true. So even if you want to quibble a few centimeters variance in freshwater lakes and rivers, that's not the same as the coastal tides, and it doesn't correlate to the movements of the moon. So what's the point? It doesn't say anything for the globe.
All I have found is that
I'll just underline that.
The maximum 5 centimeters.
Yeah, can I just underline that just by saying that the real point here, which Cyclone, more or less touched on, is that when people say lakes have tides too, It's a massive oversimplification and it doesn't actually mean anything. And again, it's just another claim without evidence that doesn't actually support the globe, even though people think it does.
And I'd like to also add that most people don't even know what the actual theory of tides actually is. The theory of tides, the gravitational theory of tides, is not that the moon is pulling the water and making a tide. It's that the moon is pulling the water at some place, and this displacement of water is creating a hydraulic pressure that's pushing the water up and creating a tide. So it's creating the tide in another location. And I'll post a link to this. The title of the video is actually why most physicists get tides wrong. The tidal theory, the gravitational tidal theory, is just, it's utter garbage.
Can I mention something here also? So when I was talking about the hair on the back of your neck, I was being serious, right? So now, if you think about the vestibular system, it's the liquid inside of the semicircular canals in your ear that helps you stay upright, right? And so I would think that this small amount of liquid in your ear would be affected, right? If the tides are being affected, then why wouldn't some small change here affect you in the sense that you might become a little dizzy? This never happens. Is that crazy to say?
Well, if we're 70% water, surely the moon should affect.
Are you measuring your 15-degree drift with the vestibular apparatus in your ear?
Yeah, and the common theme here is that there's no proof of the cause of any of these things people have been asking about. There's another question.
I'll tie both of these together. So with the vestibular system, I would assume that this would be affected the same with the tides. Because it's like, okay, well, we're going to make a correlation somewhere and say, well, the moon causes tides. And I'm like, okay, well, if the gravity of the moon causes tides, then shouldn't it affect other things? And that's the same way for this, the gyro that's supposed to be detecting a 15-degree shift. Well, if that's the case, then shouldn't we experience the movement of the Earth? Like, say, when you send a drone up in the air. So when it's in the inertial reference frame, shouldn't the sun or these other things that are also in the inertial frame not be moving?
Well,
Yeah, and I think it's good since... Oh, sorry, go ahead.
Sorry, no, Dandy, you go first.
Well, I was just going to talk in general about the nature of science. If you got something specific about that, then go ahead.
Well, no, I just want to make the point that to any objective and independent listener, the three kind of points that have been tried to use to counter what we're saying here is nothing relating to Earth being a globe. We had a begging the question fallacy about a gyroscope, where someone's observing a gyroscope spinning and saying, well, that means Earth is spinning. No, it doesn't. Then we had Boris talking about the ISS, something he doesn't know what it is or where it is, begging the question that it's in a vacuum and that it should burn up. And then this one about quibbling whether or not the Great Lakes changes by 1 or 2 inches. Right? These are nowhere near proof that you live on a spinning ball in a vacuum. But these are the points that they have to really labor. And it gets you nowhere.
Can I address that comment you just made?
It wasn't finished, bro.
I'm asking
Boris,
you
you're
to
back.
explain it. That's all. That's all I'm asking.
No, but Boris, you're begging the question to begin with. You're saying your default is that this object is in a vacuum. You can't even prove that there's a vacuum there. So no.
No, I'm not saying there is a vacuum there. I'm saying is that you claim that there is gas. So I'm asking, why doesn't it burn up when it's flying at 27,000 kilometers an hour?
You don't know that it's flying at 27,000 kilometers. You're just saying that. That's the whole point.
No, you can measure it with the Doppler shift.
No, you can't. You can say that.
We asked for that data.
Yeah, you've not shown anything, Boris. We're not doing this again right now, Boris. We'll come back to it if there's a lull.
I wanted to ask one more question relating to that. Is if there's perspective, like when the sun goes down, is there perspective when it comes to radio signals?
Absolutely not.
Then why can't I detect ISS all the time?
So again, this is just another insane reach into nothing. We're talking about the Earth being a spinning ball here, Boris. Have you got anything for that?
No, I'm not. I'm
No,
asking
you're not arguing
you
that
to
Earth is a spinning
demonstrate
ball because
that
you
it's
know
flat.
there is no evidence for Earth being a spinning ball. So stop wasting our time.
This is a whole bunch of misdirection, to be honest.
Yeah, exactly.
No, it's not.
May I? I'm actually curious in where this leads. Can we go down this road for?
Let's do it.
Let's give it. May I just moderate quickly? Let's give it 5 minutes back and forth. One question, one answer, one question, and be fair. All right. I want to see what this leads.
Can I ask the Globers just generally a question?
I want to see where this. First, let's do the Boris thing. Let's see where it leads.
Sorry.
Let's give it 5 minutes. Does that sound fair to you, Boris?
Yeah, sure. Yeah, it probably won't take that long. I just wanted to address the claim is that the Earth is flat, and Globers claim that the Earth is a globe. I'm just basically asking the question is why can't, in the case of the ISS or that thing up there, why can't I detect it with my radio all the time? And I get told that I have to prove it, and I'm not making a claim. I'm saying, why can I not detect it? So what I'm trying to get is a model of the flat Earth that fits that issue.
Okay. So what is, can I just talk to this guy for a second? Okay. What is perspective, Boris? How does perspective work?
It doesn't matter. I asked the question.
It does matter. You said if perspective is why we can't see the sun, why can we see? But does perspective work with the ISS? And yes, perspective does work with the ISS. But I have to make sure you understand what perspective is in the first place.
No. Somebody said that there is no perspective when it comes to radio signals.
Well, because it's not. Perspective is a visual term, right? We're talking about vision.
Right.
But the same principle applies, right? So the angular size of an object changes with distance, right? It subtends visually a smaller angle, right? It does not matter what wavelength of electromagnetic radiation this is. The further away something gets, it subtends a smaller angle.
Yes. So that's when.
So when the ISS is further away, it has a smaller cross. Please let me finish. So it has a smaller cross section, right?
Sure.
Okay. So let me ask you this: can you, let's say radar? I'll just for the purpose of this conversation, I'll call radar seeing. Okay. Now, does the radar wave? What is the wavelength the radar waves?
Depends on how old the radar is. When it was invented, the wavelength was 11 meters.
Okay, 11 meters. Can you see something smaller than 11 meters with 11-meter wavelength radar?
No. That's why they made radar to be smaller and smaller. And during Second World War, I think they got it down to somewhere around
you can't see
centimeters.
Yes, you cannot detect things smaller than the wavelength that you're looking at something with.
Yeah.
Right?
Sure.
This is the red light criterion.
Yeah.
Right?
So, yeah, but that's not.
So if light is at 400, if the average wavelength of light is 550 nanometers, right, which is a lot smaller than 11-meter radar, why do you think you'd be able to detect something with 11-meter radiation that you can't detect with 450 nanometer or 550 nanometer?
Yeah, but I'm not talking about radar.
Can I comment?
Oh my God! Yes, you did. You said, "Why can't I detect it with radar?" This is the shit I can't put up with. Lying,
5
dude.
minutes.
I literally can't put up with lying.
I'd like to just wrap it up then, if it's over. I'll just simply say that's not what I said. I says, why can't I not detect it through radio reception? Why can't, like I can when it's overhead? Like, where does it go?
What frequency is radio?
Can I address this argument that's being thrown out there? Because I think it's absolutely silly to suggest that things actually shrink when they get further away. I mean, visually they appear smaller.
That is a straw man. No one.
That is a nice straw man.
No one said that.
Nice
No.
try.
No, but that's what would
Nice try. You want to pull up where somebody said that?
That would be the case in order for these radio waves to suddenly be missing the thing because it's smaller than 11 millimeters or whatever. There's 11. Yeah. Anyway.
Again, that's a straw man. You're straw manning.
It's a straw man. You don't understand the conversation. Okay. Now you said radio waves. What does radar stand for?
Hang on, I'm saying
is radar radio waves. Yes or no?
Can I explain it? Because I think you're missing something here, and you're not gonna let me deal with the part you're missing. What I meant was not sending out a signal with radar or any radio wave and getting a bounce back. I'm talking about the fact that this thing, the ISS, as it's called by a lot of people, puts out a beacon and they can talk to people. Why
in what frequency?
Why can't I detect its beacon when it goes off into the distance? Why can't I detect it if it's a flat Earth? Because theoretically, from a flat Earth, I should be able to detect it anywhere on the planet.
No, you're wrong. You don't know how any of this shit. You don't know how this shit works. Okay, you're just talking outside of your pay grade or something.
Oh yeah. Okay.
So the antenna. So the antenna has a size.
Just please, we shouldn't insult each other. Boris is an engineer.
Are you kidding me?
Let Indio finish.
Please go ahead.
Are you really kidding me? He's an engineer. And what? Sorry, I'm mind boggling. Listen, because I think he should know better, and I kind of get I don't know.
Just say it.
The antenna itself, the antenna is an emitter, right? And that emitter, that antenna that's on the International Space Station has a size, right? It has a size. So let's say the antenna is 50 feet long. Say the entire International Space Station is an antenna. It's a 300-foot antenna. That antenna can only emit, say it's full wave radio waves, right? So the wavelength is the entire size of the antenna. Or let's say there's a bunch of emitters on the antenna. The angle subtended by the entire antenna is smaller than the wavelengths. Can't see it, dude. It's sub-wavelengths. Okay? That's why you can't pick up, radio waves. You can't pick up, 95.5 FM with your cell phone antenna because the cell phone antenna is designed and engineered for 5 millimeter waves. Okay? Does not matter because the antenna has a size, man.
Well, the antenna isn't your filter.
Oh, the antenna is an emitter and it has a size. Okay? And the size
of that all
antenna,
kinds of sizes.
Okay, so let me ask you. If I have let me ask you this. Okay, so if I have a 10-foot diameter spotlight and a 1 millimeter diameter LED, do you think you can see them from the same distance?
Depends on where that LED is located in the spotlight.
Oh Jesus,
But besides that, you can have antennas of different lengths. It's an irrelevant thing. Like you can use
it's not irrelevant
ground plane or a half wave dipole, or you can use a Gaggy antenna, or you can use a dish or a corner reflector.
Why do we make antennas bigger? Why do we make antennas bigger? Why do we just use one size antenna for everything if it doesn't matter?
My 2 meter antenna is small compared to, say, a 11 meter antenna. So how do you figure it actually works better? Because you want an antenna that's resonant in a certain frequency. So you tend to make them to the size.
That's a straw man.
I have a Yagi. No, it's not a straw man. I'm talking technical issues here, and I'm trying to make
You're saying random antenna types
without too much jargon. I'm being talked over. Why? Okay, anyways, so just drop it, right? Because it just proves you're trying to talk about things you don't know anything about.
Right. No. Before we draw a line under it, just to confirm, Boris, you weren't saying any of that proved the globe, were you?
No, I wasn't. I was simply trying to understand.
Exactly. No, hang on. Right. None of that proved the globe. This is obfuscation, Boris.
I'm not talking about the globe.
Really quick, guys. Really quick.
Problem. None of you guys like to talk about.
Guys, really quick. I just want to interject in here. I know this can be a super touchy topic. All I ask is that everybody in here flat earthers, globers, whatever, let's try to show everybody the same respect that we demand of ourselves. I've seen lots of over talking and then people being like, oh, well, don't over talk if you don't want to be over talked. And let's stop insulting people and dismissing things. We're trying to have a discussion. This should be a discussion, not, okay? And it hasn't been going that way. So can we all try to reset, stop insulting each other if, this is obvious, and have an actual discussion?
Yeah, no, I agree, and that's what we're looking to do here. So this was just to highlight that.
Can I say one more time?
Here,
can I finish up like one more statement? It's going to be 2 sentences long. Then I'll shut up.
No,
I can just point out. Boris claims that the size of the antenna does not matter for detection of the signal emitted for the antenna. I just want to say that. That's what he said. That the size does not matter at all. Okay. Anyone with half a brain knows that is utter nonsense, and I don't even know why he's saying it. See, listen, and I know you said everybody should be respectful. I don't think lying is respectful. I actually think that is the ultimate disrespect. And that's why, at least me personally, I just sit here and listen to 3 different people tell things that they know are absolutely 100% false. It's not because they're incorrect, or it's not because they're misinformed. They know they're false, and they're saying it anyway. Okay, I find that disrespectful.
How many antennas have you built?
What does that matter?
Well, I'm just.
What does that matter? Does that somehow prove that antenna size doesn't matter?
No,
Obfuscation.
I'm trying to determine how much you really know about antennas, because antenna length you can tune in any
Instead
length.
of actually trying to prove your own point, right?
Indio, please don't respond. Let me respond to that. We're trying to move the conversation along. You yourself said, hey, I'm going to drop the conversation. And now 2 minutes later, we're going to get dragged back into something about I find that, hold on, I'm going to be done in a second. I agree with the guy that just came in to say, let's calm things down, because this isn't calming things down. This isn't talking about what we came here to talk about. I actually want to ask the guy that came in here to try to get some good conversation going. Would you like to ask a question, sir?
Sure, I'll go ahead and ask a question. So to me, there's an interesting experiment that was done. It's a flat earther who has a channel. His name is Jaron. I think his channel is Jaronism or something like that. He's associated with Bob Nodell. And I'm not sure if you guys have seen the experiment, but he did an experiment on a canal with some lights, with cutouts. I'm just really curious, what do you guys think about that experiment?
It could have never worked even in principle. Because of divergence of light, diffraction.
Yeah, so this is from the Behind the Curve Netflix documentary, right? So this is one that a lot of people see and they think, oh, look, a flat earther proved that the Earth is curved. But that's not what happened. I mean, this was selectively edited. The laser that they intended to use broke, so they never used it. They tried to do something with a flashlight, but it didn't work. And the results they got wouldn't correspond to the globe's claimed curvature anyway. So that was, but if you understand the principle behind the idea of that test, we can show you plenty of demonstrations where there is a successful test where we actually do manage to shoot a laser 40 kilometers and hit a target on the other side that is supposed to be beneath 90 meters of Earth curvature. If you understand the principle behind what that Netflix documentary was essentially bastardizing, we can show you plenty of examples of how even you can do this yourself using a long-distance observation. And people are doing that test, and there is no curvature being measured.
Okay, I got two things to say. One, in terms of
viscosity, could you wait right now? I think the interlocutor is Curious Panda. If you would like to go next, I'll queue you up afterwards. Is that okay?
I was going to address as to why a laser curves in the atmosphere, but I'll shut up.
Yeah,
I don't mean it like that, but okay, go ahead.
Yeah, no worries. Hi. Not that you need to shut up. I'm just trying to keep it to one point at a time and ask a quick follow-up question on that. So I'm not referencing the actual footage from the Netflix. There was a YouTube video of it as well. Now that aside, I am curious what the experiment that you referenced afterwards, where laser beams have been shot over. I can't remember the exact number right now, but where they have hit a target. Where were those experiments taking place? Was there control for it? And what terminology can I look up to actually find those studies or those experiments being done?
Yeah. Oh, go on. Go ahead.
Hey, yo, howdy.
I was just gonna.
How you doing?
Yeah. Okay. Great. I'll post a link to the PDF. So this is so it was 3 sets of tests. It was more than just one. There was one done at Lake Valentine.
Can I?
Can you interrupt me? Sure. Go ahead.
Let Indio go, please, guys.
I can interrupt him. It's fine.
Anyway, yeah. So there's 3. It's a measurement report. There was 3 sets of tests. One done at Lake Valentine. There was 2 tests done there, and then there was 2 sets done at Lake IJssel in the Netherlands, right? So this is done by laser transit. The laser is electronically aimed. They had a beam collimator with a 0.08 millirad beam divergence. And yes, there was controls. They took meteorological data at both sides of the lake, and they did the test 3 weeks apart. So they replicated the test 3 weeks apart from each other, and they got the same result. So, I mean,
would you say that it could be possible, because I think this is possible with anybody in any type of belief system, that
where does belief system come into it? I don't understand that part.
Well, just what somebody believes is true. So at a point, everybody believes something is true.
Well, there's a difference between believing and knowing. We know it's true.
Right. So I don't want to derail the topic into something different. But would you say it's possible for there to be a biased or cherry picking? Because I think that's possible with just about any type of research or data. Would you be willing to admit that there is a possibility that there is cherry picking that does happen?
Cherry pick from, well, there's no, listen, I would say yes, that's a possibility. But to date, as far as I know, or no Glober has ever presented any type of laser measurement across any distance to show that it's obstructed by Earth curve.
Yeah, I would argue that.
So there's none. There is no data to cherry pick. There's only ever been one result.
Yeah, I would argue that you can't cherry pick the truth. It's just the truth.
Okay, I just wanted to establish a baseline.
Oh yeah, it could be. Listen, of course the data could be
a possibility.
It could be, and if you had contradictory data, but we don't have the contradictory data to cherry pick from. So there's more. There's more than just like one person did a laser test. There's multiple of these. There's something like 20 I know of. So and they all get the same result, and there's none that say another result.
And none of them are funded by NASA or any government agencies. They pay for it out of their own pockets.
We try to stay focused on just like the experiment and not like weird
Yeah, so
shit.
I think Elijah's trying to jump in, is he?
Yeah, I was.
Go for it, Elijah.
So all that I wanted to say was, you asked a question, good question. Indio provided an answer. You asked where you can find this information. Indio provided an answer. So I would.
Well, I didn't post a PDF. I'll post that.
Okay.
I posted.
Yes, please do. You can DM it to me.
Right. So the next step is to actually go ahead and look through the information and to really, really make sure that everything in there is up to snuff. You might want to recreate the situation and do it yourself, given all the information provided, to see if everything checks out. So Could things be cherry picked and all this? Maybe, I guess. But based on what you asked, it was provided. And that's all we can do, right?
Yeah. So exactly. So we've posted the PDF in the chat, and I've DM'd you it as well. And like I said before, if you come onto the Flat Earth Discord server and you scroll down the additional information sections, you'll see a channel called Laser Test, and there's a load of them in there. But let's just, because we're on this topic, Curious Panda, let's just, because you haven't had the chance to review it yet, just go with us on this for now, since you understand the principle of it. So if we're saying we're shooting a laser from, say, 2 meters off the surface over a lake, say 25 miles, 40 kilometers, and there's a target on the other side at 2 meters height, that laser, according to the globe model, should not hit the target. You agree?
Can you, I'm sorry, can you repeat that again really quick? I just want to make sure I fully understood exactly what
you understand that shooting a laser between 2 points over 40 kilometers, the globe model necessitates a certain amount of curvature between these 2 points. I mean, you can double check this afterwards, but just for the sake of argument, what it says is there's about 90 meters of elevation difference between those 2 points. So the laser should be sailing way above where that target would be on the other side of that curve. So according to the globe model, that laser should never hit the target on the other side of that 40 kilometers. Do you agree?
So I would actually answer that with a question. And I would say, what is the measurement or the calculation or equation that you're utilizing to determine that how much curvature or how much land should be obscured?
So it's based on them telling us that it's a sphere with a radius of 3,959 miles, which gives you an approximate 8 inches per mile squared curvature drop rate over the surface. And that's good for about 250 miles or so, maybe even more, right? That's an approximation of the curvature that they tell us is a physical necessity. So you can go on Google and you can Google Earth Curve Calculator, and you can punch in those numbers, your observer height or your laser height, and the distance to the target, 40 kilometers, and it'll show you the numbers. So you can double check this, as I said, but just for the sake of argument, this is what it tells you, and you'll see the same when you check it. So it tells us that it shouldn't be possible for that laser to hit the target according to the size of the ball that they tell us we live on. So if we do hit that target, which we are repeatedly, in horizontal pans over various distances, using different colored lasers to check for refraction, all this kind of stuff. If we're hitting that target, do you understand why that's a problem for the globe model and what that says about the nature of the surface between those 2 points?
So, given the criteria, if all of that criteria that you just submitted is 100% accurate, I could see how you could possibly come to that conclusion. However, I would posit that there's possibly an error fundamentally in that calculation, primarily if it comes to using 8 inches per mile squared as a calculation for curve, as I believe that's an inaccurate formula, because that's actually a formula, an equation used to derive the curve of a parabola. And the globe claim is not that the Earth is a parabola, it's that it's an open spheroid.
That's why.
So I would argue that equation, right? But I think my perspective would be, I think that it's errant to even utilize that equation in the first place, because it's not an accurate. That equation isn't for measuring what it's used to measure.
Yeah, go for it, Elijah.
Okay, so then how did they? Okay, so here's the thing. This whole conversation started with Jeranism, right? So what formula were they using to determine that that was Earth curve that the light was blocked from?
Can you repeat that again, Elijah? It's a little difficult to hear you. Sorry about that.
I apologize. What formula did they use, did globe earthers use to determine that Jeranism proved that the Earth was curved?
So that's a little bit of an aside. We did kind of already move on from that. I'm actually referring to yes. So what Cyclone was talking about is something different, and we moved a little bit towards the calculation or the equation that's used to measure curvature. And so my reply was, I think it's possible that there is errors in that based on improper equation being utilized.
I'm sorry to interrupt, but if we can focus on not repeating ourselves. I heard it. Everyone heard it. No disrespect. I took the mic away from Wolfgang, so I think he was going to respond to that point.
I'd like to respond to it. I'd like to respond to the parabola thing because it is a red herring. Okay, and I'll tell you why it's a red herring. So in the chat, I just posted. So this, I just buried my posts. So I just posted. So there's the equation, right? So there's the drop using cosine and the radius and all that stuff, right? And then it compares it to 8 inches per mile squared. The distance at 41 kilometers, the difference in values of the drop is 2 inches. Between 8 inches per mile squared in using sine and cosine circular functions to calculate it. So it's 2 inches at 41 kilometers. So do you really think that that is a bigger difference? That's not even detectable. Right. So listen. So let me start kind of from the beginning, right? The globe model makes a prediction, right? They say the Earth has a radius of 3,959 miles. The globe model says that the Earth has a radius of 3,959 miles. It makes a prediction of how much something should be obscured at every distance. At this distance, the distance in question, okay, the drop from eye level of the surface at 41 kilometers away should be 127 meters or 440 feet. Okay, so that's the prediction. What was measured was the laser was seen at 1.5 meters. This is a two-order of. See, this is a typical thing that always happens, right? So, can you mute that person, please?
Yeah, I put him on mute
every time, dude.
We can unmute him after Indio's finished, but T-Pan.
So I'm sorry for that. That was just some background noise coming from the random user.
So the difference. So this is a 2 order of magnitude difference between what was observed versus what the prediction is. 2 orders of magnitude. This is not a measurement error or a calculation error or some insignificant, or like where something's in doubt, right? This is a difference between the height of a person and the length of a football field. Now that is not like, oops, I thought it was, 4 feet, but it was actually 400 feet. Nobody's going to make that kind of error with measuring with a measuring tape. Right? That's not that's a huge difference. So this is not within the measurement error or the uncertainty of the instrumentation. It's way beyond it.
So my reply to that would be that if it is a red herring,
that the difference between that we're not using the right calculation of 8 inches per mile squared. At this distance, they're so similar that it's irrelevant. It's 2 inches at 41 kilometers when the actual difference that was measured is 2 orders of magnitude.
Right. So my reply to that would be is that I wouldn't say it's insignificant because if you're dealing with the distances that we're talking about, that 2 inches or whatever exponentially creates a gap or an error in measurement. So the longer the distance you have that you are measuring with that discrepancy, the larger the discrepancy that you're going to have.
You haven't understood what he said.
Personally, I think it's something that shouldn't be discounted.
Dude, you haven't understood what he said.
You don't understand what I'm saying. If we draw a parabola, right?
I'm just disagreeing.
No, you don't understand.
You're disagreeing with mathematics? Like, I mean, okay, disagree.
Yeah. Let's give Indio or Crypto a chance just to clarify the point.
Go ahead, Crypto.
Right, but I'm not going to give him a chance to like shit on me.
No. We're
I'll be very quick.
Disrespectful.
No, it's not about you, Curious Panda.
We're not trying to do that.
It's not.
No, I'm not trying to shit on you. I'm saying objectively you haven't understood what he said. Like that, this isn't I'm not trying to make you feel bad or look bad or anything. You just haven't understood what he said. So when he said that at a certain distance there's a 2-inch gap, there's nothing exponential about that because he's given you a snapshot. He said at this distance, this is the difference. There's exponential doesn't mean anything when you're talking about a specific point. It only means something when you're talking about you're going on from that point, then it matters.
Right, and so that's why I was saying I didn't misunderstood. I was just taking it to the next step.
Yeah, but Curious Panda, what I would say
as you get larger distances of measurement.
What you said doesn't make any sense then.
Well, yes, we know that at larger distances the error becomes greater, but we're only talking about. But we understand that. But
that's all
we can't see 1,000 miles anyway, so it's it doesn't matter because first of all, we use the correct calculation, but you can use 8 inches per mile squared as a rule of thumb. If you're close to the surface, right? If you're not at 1,000 feet elevation. You can just use it as a rule of thumb, but you wouldn't use it as proof of anything. You would just say, okay, say you saw the photograph and something was 150 miles away. You're like, okay, 150 miles. You could do the quick calculation in your head and say, oh, this mountain's this height. Well, that's problematic. So let's do something more rigorous and use the actual formula and get that observer elevation and all this stuff. Then you go through all the steps. We just use 8 inches per mile squared as a rule of thumb. It isn't something that's a proof. We wouldn't use 8 inches per mile squared as a proof of something.
No, that's just an approximate for the globe model. But Curious Panda, if I could just quickly, what's being missed here is we get your point about the exponential nature of it, but we're talking about this particular distance, and the crux of it is that the laser is hitting the target. So if the laser is hitting the target, how is it possible that there's curvature between those 2 points as described by whatever formula you want to use? Use the 8 inches per mile or use your sine cos, and it's going to be 2 inches different, right? Either way, it can't hit that target if the Earth is a ball. So this is the main crux of it. So if it hits that target, how is that possible on a ball the size they say?
So I'll take a page out of your the way flat Earth kind of comes. Can you show me? And not to be any disrespect, but I've generally when a globe Earth claim is made, the standard answer, and I can show in text, it has been given many times, is that show me, prove it.
Yeah.
So shouldn't you guys be held to the same exact standard if you're going to make these claims? Should you also not be able to show me?
Yeah, but that's why we posted you the information, and I said at the start of this, I know you haven't had the chance to look at it yet, so just follow along and entertain it because you can check this for yourself. Just assume that what we're saying is true for now for the sake of the conversation, and then if you later go and check it and you disagree with what's being observed and recorded, we can discuss it then. But I'm saying for the sake of argument, that we're telling you that this test shows... Sorry, I'm getting some background noise, so I don't know who that is. But anyway, if this test, when you review it, you'll see what it says. And if what it says is the case, how is it possible on a ball? That's the question. I know you haven't read it yet, but I'm saying once you have, because this is just a case of information, very possibly that you just haven't looked at yet, right? That doesn't mean it isn't true or it hasn't happened. It just hasn't come across your desk, right?
Yeah, so you have to understand that it's a system. You have to think about it as a system.
I'm just get this answer from Curious Panda, right? For the sake of argument, the laser hits the target at 40 kilometers. How is that possible on the globe?
I'm sure there's probably some certain things that do make it possible. Now, for the sake of argument, like you said, though, if I have to grant something to you guys for the sake of argument to prove a point, would you also be willing, in the same fashion, to grant certain information from
Well, that's
a
vague,
globe
but
side argument?
we're talking about something specific here right now. I mean, if you've got something that you can present for evidence, that you've got a test, and you can say this is what this test shows, then we'll have something to discuss and we'll have to review it. But at the moment, we've presented these tests, and there's plenty on the server. And the question is, how can this be possible on a globe? The answer is it's not possible on a globe. What that shows is that there's no curvature between those 2 points. If that laser hits that target, which it does repeatedly, verifiably, then there is no curvature between those 2 points. And that's a problem for the globe, because the globe necessitates physical curvature. So you understand why people hitting targets at 40 kilometers away with a laser is on paper a problem for the globe model, right?
It would have to depend. What is the elevation of the observed?
Yeah, we've told you it's 2 meters. It's impossible on the globe. All this math's been done. It doesn't.
Is the laser verifiably being fired across a point that we know is 100%
water
flat level?
I have a question.
No, the other right.
Wired
So
across water.
we're all trying to let each other finish, right?
Yeah, so go for it.
Well,
let's all give each other the
wired
same
across
courtesy.
water.
Now, if I would grant that experience of a laser being shot over 40 meters, did you say, or kilometers? 40 kilometers. Okay. To you, if that's indicative that can't be possible on a globe Earth, would you, and that's something that you accept as an experiment being accurate and true, would you grant the experiment that Bob Nodell did using a laser gyroscope picking up a 15-degree-per-hour drift? So my question is why is that experiment easily able to be discounted? Because the results of that experiment, the conclusion would be inevitable that we do live on a globe.
Right.
So it feels like it's not being treated fairly. So
they're totally different, though. One's a line
would that not be right? But they still are going to prove either flat or globe.
Because
so if one experiment proves globe and the other experiment you believe proves flat,
okay,
why is one experiment more valid than the other? Hold on, let me finish. Let's not talk over. I'm almost done. Okay. Would that not be an exact example of cherry-picking data?
No.
Now, listen. Hold on a second, Wolfgang. Please let me answer this, please.
Yeah, and that will be my last question.
So why don't you post the report that they did? Okay, so I'm going to answer you. Your question was, why aren't we giving them the same validity? Please post the report of Bob Nodell's experiment. Post all the data in the chat.
If you give me some time, I can definitely do that.
Okay.
No, you can't.
I do have to say that when it comes to
have a long search.
When it comes to flat Earth, it's kind of like it's insane to me that do you think that the government or something or someone is lying to us about the Earth being globe? Like, what do you think?
Oh, absolutely.
Yeah. Can I
so my question is, who's doing
this?
Yeah,
we're gonna get way off topic, dude. We're gonna let this get buried into bullshit, dude. Like, seriously.
It will get buried into bullshit. Yes, it will.
Okay. So before we move on quickly, then let's just say for Panda's claim that he tried to make about Bob Nodell's rotation, you're not going to find any information about that because there wasn't an experiment or a paper written up about it, as far as I know. But feel free to try.
Actually, I've seen the
data. Of information. I'm getting ready to post it right now. So.
Okay. But then you would also have
keep your shirts on.
You'd also have to consider, right, the difference is...
in before the meme.
Yeah, the difference is a laser can hit a target. That's an observed fact within that, and we can attribute that to testing a line of sight over a surface curvature or lack thereof. With the gyro, you're just observing a gyro rotate, and then you're begging the question, saying that the cause of it is Earth's rotation, because you're assuming it's a ball that spins, but you haven't got the curvature bit to even be able to assume it's a ball, let alone a ball that spins. So no, they're completely different, those two examples, but feel free. And then Crypto, I think you were wanting to answer the question from the other guy.
Well, I just want to point out that his question was, why aren't we giving them the same credence? Okay. And the reason I asked for the data, there's a specific reason. Because there is no data. It's something Bob Nodell said on Netflix that's just like an off-the-cuff comment. And I'll give you some information. Bob Nodell never had the gyro. It wasn't his gyro. Okay. Netflix has a bunch of factual errors in what they did. It wasn't a $21,000 ring laser gyro. It was a $7,000 fiber optic gyro. Bob Nodell never had possession of it. And 15 degree hour per hour drift was never measured because he would have had to have been at one of the poles. And we all know that he wasn't at the North or South Pole. And guess what? What data was generated? I've actually seen. And want to know what was actually measured? Earth rate drift of 2.24 degrees per 24 hours. Yeah, that's right. 2.24 degrees for 24 hours. Because, listen, I have a personal knowledge of all this. When it was done, there was a Skype chat that everybody involved was in it. I don't know what Bob did, whether he didn't read it correctly or whether he skimmed it or something. But the data that was spat out was 2.24 degree Earth rate drift when you combine all three axes and sum them together. Okay, this is why I asked the question. This is why why don't we give credence to it? Because there's no data. There's no data that was released. You've noticed FE Core never released anything on it. Neither did Rick Zimmerman. And plus, there's other factors of why you can't draw conclusions because they also did with this same gyro. They did other tests, right? They took it to altitude and it slowed down this so-called Earth rate drift. They put it in a vacuum chamber, right? And they evacuated the air out of the chamber and it registered a slower so-called Earth rate drift. And because they got this, they actually went and looked it up. So it is recorded. There's published papers that a ring laser gyro, when placed at high altitude or in low pressure, slows down the so-called drift precession of the gyro. Okay, these are like little factoids you guys don't know, and I don't know why you get your science from Netflix. It blows my mind.
And CGI.
We go over the snow wall in Antarctica yet?
No, so the next question was from the guy who was saying, so you guys think people are lying, and then Crypto was going to answer, I think.
You got to get into sociology.
Yeah, well, that's why I wanted to cut that off at the knees. Like, we're talking about the physical reality that we live in. Everyone knows that people lie. It doesn't matter why. People lie for all sorts of reasons: money, power, greed, just to fuck with other people. Who cares? We can actually directly measure the Earth, so let's do that. That's all I wanted to say.
Well, to be honest, like people lie about things. Sure, just to fuck with other people, but I don't really understand how that's like when hey, the Earth is flat. You're lying. Like, and I guess
I'm gonna repeat my answer. I'm going to repeat my answer. Because I gave you 5 different options, and you picked the one that you thought was weak. Right? Listen to the answer again. People lie for all sorts of reasons, including money, power, control, and to fuck with people. I could go on and on and on. Now,
okay, but what he's asking is
fundamentally what matters is
how does that apply to anything?
Yeah.
How does the
flat Earth apply?
If I'm not allowed to answer the question, I think I saw some. How can I answer the question if I'm not allowed to actually finish my sentence?
I think actually that's fair enough, Cat Pants. And if I see this is some other guy who posted a meme in the Earth chat that I didn't like. So, Cat Pants, if that happens again, I'm going to have to mute you.
Okay, cool. Yeah, so people lie for all sorts of reasons, but of course people, when they ask this silly question, it is sociology, it's not science, so fundamentally we should just hand wave it. But what I would say is if you're going to ask this question, you need to ask who, right? Lots of different people are lying about this stuff, so why does NASA lie? Well, they get funding. Really simple. Loads of people do jobs. They just do their job, right? Unless I mean, I don't know if you've ever worked in a big corporation. People just kind of get on with it because there's all this office politics to worry about. People just want to earn their money and go home. No one's really concerned with the project itself. They just do their job. They get paid. They go home, right? So that's NASA's answer. Why do the people behind NASA lie? I don't know. Don't know them. Don't care. Fundamentally, though, we shouldn't even have to answer this question because it doesn't matter. What matters is that we can actually physically verify the Earth. People lying has got nothing to do with this.
Okay,
it's more. Can I speak, please? It's more of the fact.
I'm gonna have to ask you to calm down for a moment.
Why was? Oh, okay. But basically, it's more the fact of how many people you are asking to lie about this, and not one person, not a singular person is all like, "Oh yeah, they were lying. Here's the evidence."
Okay, if I can address that, there's been entire towns that were sworn to secrecy during the atomic age to build weapons. Okay, it's not hard to keep a secret.
Can I just point out to the moderator, he's just literally asked the same question again with different words.
But the thing is, what he's saying, though, is that
let's keep that. But you're expecting
talking about not just a small town. You're talking about the vast majority of scientists among the world, the vast majority of space exploration programs around the world for multiple governments around the world. You're not just talking about one city.
Governments do.
How many people have
governments
been to space?
Governments do conspire with one another to deceive the people.
Yes, but you're also talking
about. Can I just say this a third time?
Don't ally themselves with each other. Some have actual wars going on between each other. But amongst all these governments, some of which hate each other for many different reasons,
none of this matters. None of this this is bullshit. All of this is a complete deflection. Doesn't matter. No one cares why people are lying. Talking about physical reality. People lie, get over it. We're talking about physical reality.
It doesn't matter to you because it proves your argument wrong.
No, that's not the case. I care about physical reality. I don't know how many times I have to say this. It doesn't matter what other people say. What matters is physical reality. So I don't know why we're talking about this.
You obviously don't believe in physical reality.
Okay, so hold on a second. I want to address Mr. Hey, Crypto, let me just say.
Yeah, go ahead.
If that argument proved our argument wrong, right? If not knowing why they lie proved it wrong, that means if everyone signed confessions saying that the Earth was actually flat and they were lying, it would prove the shape of the Earth. Now, is that the case? Would signed confessions from everybody in the world saying they all lied and that the Earth is actually flat, would that prove the Earth is flat?
What I'm saying is, I'm not asking
yes or no, man. It's a yes or no question. You know what the answer is. No, do you know the answer is no? It's irrelevant whether they're lying or not.
But what I'm saying is
let's try to stay charitable, guys.
Every single country that says, "Hey, the Earth is round. Hey, the Earth is round." The Earth is round. Every single why? Like, you're asking why would people?
Chill,
Cat pants.
I'm sorry. I just speak loud. That's just on me.
You get emotional. That's
fine. Yes, if you don't understand that there's classified, there's classified levels of information and that governments are perfectly capable of keeping many secrets, I don't know if I can help you. For example, the entire Vietnam War was started on a lie of this entire Vietnam War was started on the lie of the Gulf of Tonkin, which has now been declassified and shown to be a false flag event. I can get you the link from the navalinstitute.org website to show you that our government has now admitted the entire Vietnam War was started on the basis of a lie at the false flag event at the Gulf of Tonkin. So I do understand for people who are new to this information, I would hope that people who are new to this information about the globe model being a mathematical and logical failure would at least recognize that in the world today, information has been extremely narrowed to your access to information, even though you think through the internet that you have access to all kinds of information. I think you're seeing information here tonight that is new to you. In the past, when people had a genuine spirit of scientific inquiry before that was squashed in people with the current pseudoscientific mainstream, more politicization of science, people understood the concept that to do science, you had to go out, make a natural observation, develop a hypothesis, test the hypothesis, and have results that are repeatable and testable by other people. Now we have an entire field in the area of astrophysics, which is almost entirely theoretical and based on presuppositions. So that's why you see these people that come in here like Boris and God 420 earlier that just say, it's a fact, it's a fact, we live on a globe, that's what we are, we're in a lab, it's on a globe, we're on a globe, we're on a globe. I mean, do you guys not see the difference here between the global arguments, and do you not stand back and say, gosh, if this is settled science, like, why is it so difficult for these people to show that we live on this spinning globe? And then you might, when you're sitting by yourself tonight, or maybe going out and sitting under a tree, think, maybe there's something to this. Maybe I should rethink the programming I've been exposed to through the mass media owned by a very small number of corporations. And then you guys are in here telling us you don't think those guys who are raking in billions can maintain a lie if it profits them? I mean, how about just try to figure it out first, like people used to do, understand their own reality, not just believe what they've been told, because there's a lot of assumptions going on here, starting with the assumptions, we definitely live on a spinning globe. There's got to be some way to prove it, got to be some way to prove it. And just say, oh, maybe I should set that to the side. If I'm a person who wants to understand how to use and exercise reason, because to be able to hold a position and to be able to effectively debate it, you should explore the other side and understand where it's coming from. And to be able to do that, you have to consider, even for an instant, give it a 1% chance, this mathematical, theoretical model of the spinning globe that you have never observed or experienced, that you are going on somebody else's report on, and even on NASA, even if you just think NASA is the greatest thing in the world, right on their own website, they say, and I'll put the image there in the Flat Earth text channel, they say, Robert Simon, visual designer for NASA, he doesn't say we went up to take a picture of the globe for you. He says, the hard part was creating a flat map of the Earth's surface with 4 months of satellite data. Then we wrapped the flat map around a ball. My part was integrating the surface, clouds, and oceans to match people's expectations of how Earth looks from space. That ball became the famous blue marble. So right there on the NASA website, you got them saying, we're not taking these pictures, guys. We're making them up with a computer. It's hidden in plain sight. So you can either choose right now to rethink what, the truth is, or you can keep listening to your television and your computer screen, and you're not going to get the information there. I can guarantee you, because Flat Earth is a highly censored and shadow banned topic, proven in congressional hearings where that YouTube admitted that they do that. So you remember 10 years ago or whatever when we said, China, oh my gosh, they don't let people see all of the internet. They control Google. We're doing that now here. Where's the outrage? Where's the upset? Where's your sense of adventure and spirit to find out, is there something to this? Like, you wonder why some people in here feel combative about this? It's because we are constantly being attacked just for saying, the math doesn't add up, guys. The math doesn't add up, guys, and we're never given a decent argument on the other side.
Can I get in here for a sec?
Hold on.
Oh, by all means.
Hold on. Before you go, Viscosity Liquid, I just want to anchor this point that Mary Mum has made, because there was a whole lot of outrage just then with the insinuation that the Earth is not a ball, which means you would have to have proof that it is a ball, which means that you would have to have a measurement of the Earth's curvature. So as an open question to all the people who currently believe they live on a ball, could you provide us with anyone in history who has physically measured, demonstrated, evidenced the Earth to be curved and to match this radius value of 3959 miles that NASA tell us? Someone from the globe side, what is the measurement? Who did it and when? Because that's the foundation for all of your claims, all of your outrage at us for saying, no, this isn't true. You're saying that exists. So could someone provide it? Thanks.
I would just like to mention, actually, Numa has just come up in the text and has mentioned Eratosthenes, which is one of my favourite subjects. So, would anyone like to discuss Eratosthenes? I don't know if you guys, both guys, know.
Yeah, that'd be a good one for you to go over, Crypto, if you're up for it.
I can do. I just want to make sure that people are actually familiar with it. Otherwise, I'll be saying stuff that doesn't make sense.
Who's that?
So Eratosthenes.
Well, before you get started, I just want to say he was a bitch. But go ahead.
And I don't.
Wasn't he smart? Do you not like smart people?
4 times already.
What a straw man.
From our side, that's not. We don't have to do that. That's like sitting in a. See, look, we don't have to do all that. Okay, let's just provide evidence as best we can, and leave the insults to the people who feel insecure about the topic. Okay.
Yeah, cool. Okay, so we're told that Eratosthenes proved the Earth's a globe, right? And the way he did this is he put 2 sticks in 2 different points on the Earth, and because we quote-unquote know how far the sun is away, we know quote-unquote that the sun's rays are parallel, and therefore the only way that you can get different shadows, when you compare the shadows, you can actually work out the circumference or the radius of the Earth. The problem is, of course, is that it's literally, well, spherical logic. No, it's literally circular logic. You've assumed that the Earth's a ball, you've assumed the parallel rays, and you've assumed that the sun is 93 millimiles away, to then find the conclusion that the Earth is a ball and that the light rays are parallel.
Wait, he didn't assume anything. Those are the conclusions that he came out with.
No, and I'll tell you why. So, if you were to assume that the Earth was flat, that the light rays weren't parallel, and the sun isn't 93 million miles away, then you can prove that the Earth's flat.
No, there was like an in-depth video of a guy explaining this, and those are the conclusions that he came out of it. He never asserted those.
Yeah, based on the assumption of parallel rays, yeah.
And a curved surface. Yeah, so Eratosthenes made 2 assumptions. The surface is curved and the light rays are parallel. Both contradict what we actually observe in reality. We observe a flat Earth. We observe divergent rays from the sun. So 2 assumptions he made, and there are academic papers.
Wouldn't there be
on
like
this.
strong gravity if you had a flat Earth?
Wait a minute. There are academic papers discussing his assumptions and confirming that it would work on a flat Earth with a sun with divergent rays. So it proves nothing.
Even
someone can post that in the flat.
Neil deGrasse Tyson himself says the same.
I'd like to go through a thought experiment with you, Victor.
I'll post it. 1 second.
Yeah, go. Victor Enjoyer. Do you have a room?
Yeah, I have a room, yeah.
Perfect. Does the room have a flat surface on it?
Yeah.
Anywhere. The floor even's fine. Do you have a light source in the room?
Yep.
Perfect, okay. So if you were to get 2 pens and put 1 pen directly under the light source and another pen off to the side, so far off to the side that the pen in the middle has no shadow and the pen off to the side has a 7.2 degree angle shadow. If you can do that, then we can actually calculate the circumference of your floor using Eratosthenes' model. So does that prove that your floor is a sphere?
No, I think he observed like how he wasn't able to see like the full the whole stick when he put it up in Egypt or whatever.
I don't really care about him now. I'm asking you to engage in a thought experiment with me. So if you have 1 pen directly underneath the light source and another pen off to the side, if it's 7.2 degrees, as in Eratosthenes' case, he says it's 7.2 degrees, I can actually calculate the circumference of your floor.
Okay. What does this
Is your floor a sphere?
No, my floor is not a sphere.
Okay. So do you understand the problem now?
I don't think that's how he did anything, dude. I'm sorry.
Exactly how he did it.
Listen, we speak about this every day, guy. This sounds like something you've kind of just read 10 minutes ago.
So if you go into, can I say something real quick? If you go into Flat Earth, I just posted a video of this actually being done. So this is actually a blind test. So he outsourced and hired some people, some engineers in Indonesia to actually just do this, do the measurements, set up the light, set up the nails. He didn't tell them what the purpose was, and they just sent them the data. And he calculated the circumference of his table.
Okay. Can I get in here with a question?
I did want to finish what I was saying.
Wait. So why is that when we observe like a solar eclipse? Like, why is like the shadow like a sphere?
Can I finish?
How about you get one question?
You're cutting into a conversation here, bud. Let the gentleman finish.
Yeah, is that possible? So we can calculate the circumference of your floor when we know it's not a sphere, right? Now, the way that he quote unquote proved the globe is that he assumed that there were parallel rays, and then he said, okay, there's a 7.2 degree angle, therefore 7.2 degrees is 1/50th of 360 degrees, therefore the distance between the 2 points is 1/50th of the Earth, therefore times the distance by 50 to get your circumference, right? That's all he did. It's just maths. There's no proof there. He's assumed the Earth is a sphere, and then he's calculated what the circumference would be if the Earth was a sphere. But he hasn't actually proved that the Earth's a sphere. He's just assumed it and then concluded it because it's in the assumption.
And
do you have any like debunkings of like modern like ways that we find like the Earth is flat? Wasn't that like thousands of years ago?
Well, hold on.
Good, but we were talking about Eratosthenes, right? So you understand that Eratosthenes concluded what he assumed, and that's why we can put this to bed.
I'll have to look into it, yeah, but at the moment, yeah, we can put it to bed. Like, yeah, I'm just asking if any debunkings.
But I want you to just tell me, do you admit that you can calculate the circumference of your floor?
I don't know.
Okay, but I just showed you how to do that.
You showed me, no, you told me.
Okay.
Well, I showed you a video of, you can watch the whole thing of them actually doing it. You can watch the whole 30 minutes and watch them do it.
Yeah, and as I said, I'll look into it later. But at the moment, can we just move on?
Yeah, sure.
So this is what I'm saying, right? So we came up with Eratosthenes because the question was put to the room, who has measured Earth to be curved? Because that's what you need for all your other assumptions based on Earth being a ball, meaning Earth is curved. So we've agreed. Eratosthenes didn't measure curvature. He looked at shadows and assumed that it was a ball already. So not Eratosthenes, so who else? Globe believers. Next person, who actually measured the curvature? Tell us.
That glass blower guy's been waiting to ask a question for quite a while. So I think he should get a shot.
Yeah, who was that? High viscosity.
Viscosity liquid?
Yeah. Here's a thing. If we were allowed to turn on our cameras, which I'm fine with, because I can talk in hypotheticals, I'm sure that some of us could go outside and turn on our cameras and show that it's daylight, and some of us could go outside and turn on our cameras and show that it's nighttime. How is this possible?
On a globe?
I actually addressed this, and you actually talked right after I addressed it.
Wait, what?
You mean how?
Called Laplace's extinction
Think about the
theorem?
table.
No, he's talking about why the sun does not illuminate the entire Earth. Right?
Yeah, and one of you said that.
Yeah, that's not a good idea.
Imagine a table, and then you said if you had a table and you shined a light on it, that it would refract.
That was not the answer. That was not even close to it.
Yeah, wait to show you're not
summing it up.
That's not what
the sun light up the bottom of the
Two
Earth.
things I wanted to. Sorry.
Go for it, Elijah.
Because the water absorbs the light. Now the air absorbs light too. And I talked about this. There's something called Laplace's extinction theorem, and there's optical extinction where light absorbs and attenuates light. So much to the point that just the comparison of solar noon to sunset is a difference of 23,000. This is only due to the angle. This is just the calculation due to the angle has not.
So yeah, light doesn't travel forever. There's an extinction point.
The sun moves. That's what we observe. If the sun moves away, the further away it gets, the more air the light has to travel through, the less bright the light source is. It moves far enough away so it's dark where you are.
Depending on the humidity, you could actually watch a sunset while you're in darkness in certain parts of the world. But also, so I posted at some point, I'll probably post it again, it was an Alaskan cruise, and the guy looks to his right, and he can see the floor illuminated. He looks to the well, he looks to his left, and the water is illuminated, and the right of him, it's not. It looks completely dark, as if looks like nighttime. So there's that. And then, like Indio said, light attenuation. Light doesn't travel forever. Like how far away do you think you could see, say, for instance, a candlelight forever? Or do you think that the air in between you and then will eventually be so opaque that it wouldn't be visible? Because from your location, it could be a sunny day. 2 towns over, it could be, cloudy. And so it really depends on the angle between you and the light.
Okay, some people. I mean, how could the sun be below the horizon for some people and just having gone below the horizon for some people and high noon for others? I mean, I realize it could be it would only be high noon for somebody.
You're begging the question.
But you're...
It's not below anything.
Yeah, you're begging the question by saying, how come it's below? So you're already making the assumption that the Earth is a sphere and that we're spinning away from...
Okay, phrase it how you want. Somebody just watched sunset, and there's somebody else for whom it is noon.
Yeah, because the sun's moving, like you observe. Right? Covered this with the other guy. You observe the sun.
I think the misconception is that... Sorry.
Row of streetlights on a flat surface.
Yeah, I think the misconception is that he thinks that the sun is 93 million miles away.
Doesn't matter how close it is. If the sun is below the horizon, like out of sight below the horizon, and you watched it disappear below the horizon, and somehow it's still overhead for someone else, I don't see how that's me being daft.
It's not going physically below
anything. It's not below the horizon.
Yeah, it's not below anything physically, right? We can demonstrate to you that an object will appear to disappear bottom up over a flat surface, then that eliminates the claim that this can only be due to going behind a physical curve. This happens on a flat surface when an object moves a sufficient distance away from you.
What, you're talking the inverse square law? It just it gets dimmer because it's further away? I mean, that's not making sense to me.
No, I'm talking about the optical effect that you see of something sinking on the horizon. You're claiming that's a physical ascent or descension below a physical curve, when we can show you this effect of an object appearing to disappear bottom up on a horizon on a flat surface.
Flat Earth.
So if it's apparent on a flat surface, it doesn't indicate a curved surface. You observe the surface to be flat. You observe the sun to move. Right, when the sun gets a sufficient distance away from you.
No, straight triangulation, okay? If I'm seeing the sun low on the horizon, then you can argue it's still above someone else. But as it lowers down, it appears to be getting lower down. Now you say it's just moving sideways further away. At what point does it it just doesn't make sense as far as...
Can someone post the shrinking sun video? Have you ever seen the sun appear to shrink off into the distance rather than setting or appearing?
I already posted it. I'll do it again.
So if you look in the text channel, if you look in the text channel, Indio is about to post a video where you'll see the sun not set below the horizon, but go off.
What the fuck?
In size.
Okay, 2 things to say about that. One is it appears to be some sort of fog to the extent that it is real, and you're going to talk. And you're going to talk about. You're going to talk about. You're going to
just go one at a time. You can't even hear this with this guy having his fucking static on.
Well, don't worry about static. And I did interrupt him, but I'm sorry that I interrupted. But that's the exact point I made, based on the angle. And the atmosphere that you're seeing through, it can block the light. And now you're telling me or telling us how, the reason it's appearing to disappear that way is because of what? The same thing I just told you. Now, if you're talking about, why it appears to get lower in your field of view, well, I mean, if you take any kind of light, a street lamp, and it's above your head, the further you walk away from it, the more it's going to get lower in your field of view, right? That doesn't mean that it's actually shrinking. It's just a part of perspective.
Yeah, okay, but the problem comes where it suddenly goes dark. It gets dark over the course of about 10 minutes as the sun drops below the horizon. In my perspective, apparently I'm making assumptions, and I shouldn't phrase it that way.
Sometimes it takes 3 hours. For instance, I live in New York City. And as a matter of fact, I'm going to do some more observations as I did some last year. And the sun would set at 7:30. Meanwhile, I still had daylight till about 10:30 at night around the summer solstice.
Wait, you had that's impossible. I've never heard that before in my entire life.
What do you mean that's impossible? I can show you pictures, videos. I did this all last year. Myself, not some other person.
Well, how would I? Okay, how would I know that it's actually 10 o'clock?
Because the videos that I've taken, they also have the information. So you know how you take a picture or you take a video and you click information. It sometimes gives you the location, but it gives you the time it was taken as well.
Yes, we're getting off into the weeds a bit. I mean, I would just like to say we can demonstrate these effects of objects appearing to crush into the horizon and go beyond your vanishing point, like when you're looking down a hotel hallway and the roof and the floor seem to converge and the walls seem to converge. This is just how our eyes work. At a certain point, you can't resolve it, and due to the atmospheric occlusion and everything else, the light doesn't travel forever, so it becomes nighttime. The sun is moving like you observe. So,
yeah, and this is Art 101.
It's an awful perspective. It's an awful quick transition, and I'm sorry, but the inverse square law says it should be dimmer. We should still be able to see it. It's awful bright.
The inverse square law applies in vacuum only.
Yes, I'm aware that you have to add the filtration of the air, but the air doesn't suddenly become...
Which is a double exponential, which is our exponential function.
No. There's not an exponential...
No, they are exponential functions. I'm literally gonna post the math. I'm really gonna post the math, and you're gonna not on again. Like seriously, you're just not on, dude. Like,
can I also point out that? Sorry for the whip. Let me stop here. But when the sun is overhead, it's a white light, so bright that a lot of people shy away from looking directly at the sun, while some are brave enough to do it. But as it gets closer to the convergence point that we call the horizon, it looks red, which happens to be the longest wavelength of light. So what do you mean when you're saying it's not dimmer? That's exactly what we're doing.
I'm not saying it's not dimmer. I'm not saying air doesn't filter out.
Brief, because
I'm not saying air doesn't filter out ultraviolet.
No, we're all together.
Guys, please let me
When we
finish.
try to talk one at a time, it becomes very difficult to follow conversation.
Okay, so...
Discuss it. Please finish your point. Go ahead.
Yeah, I was just trying to finish my point. Thanks for interrupting me to give me the floor. I mean, at this point, I don't know what to say other than if that's the best argument you've got, that it gets dark like drastically quickly, like over the course of about 10 minutes. Just because it's suddenly moving away quickly? No, because of the double inverse square. Well, no, it's not an inverse square as to the added filtration. Every foot of filtration only...
I don't know why...
Every foot of filtration only adds another foot of filtration. It doesn't increase exponentially, much as you might wish it to.
Yeah, that's a straw man.
I literally posted the graph. I literally posted the graph. And the claim that the sun, it gets dark rapidly, that's just empirically false, objectively false. There's something called civil, nautical, and astronomical twilight, right? But each of those lasts 30 to 40 minutes, depending on the time of year. Each of those. So this idea that... Yeah, go ahead.
I was going to say, it also depends where you are on the Earth. Twilight actually happens more quickly in the south than it does in the north. And all of these things are factors that globers don't even consider, they don't even think about. But I just wanted to make a more general point to the moderator, Corvo. We seem to be having a lot of... What globers do is they go, we observe an effect, therefore globe. But they never actually seem to present why it proves a globe. And when you actually go more than scratching the surface, you realize it doesn't actually prove the globe. So
why are you appealing to me as a moderator? If they feel...
What I'm asking for you to do, if you can just look out for that in future, because I feel like
I don't think that's a bad argument. So if they feel that's their strongest argument and you feel that's a very weak argument, then as in the spirit of the discussion, let them fall on their own poor arguments.
Okay, I'm going to go ahead and finish though. Yeah, I'm going to go ahead and finish. So
Can I finish? Fuck.
No, he was talking.
Okay.
Yeah, let Crypto finish.
Jesus Christ.
Okay, Crypto, then high viscosity liquid. Let's do it in that order.
Yeah, okay. So the point... Yeah, the point I'm trying to make here is that a lot of time is being wasted on this nonsense, where it's like, we see an effect, therefore globe. We've gone through about 5 or 6 different things now where we've demonstrated that it doesn't prove a globe, and yet then there's number 7, number 8, number 9. I would like at some point for you as the moderator to say, right, it's time for the globers to prove the globe instead of throwing out random obfuscations and weird stuff that doesn't prove anything.
Yeah, I agree. After these next two people talk, then I would think that somebody here who's, believes they live on a spinning globe could present their best evidence. That'd be cool. But yeah, there's 2 other people in the queue first. High viscosity, what did you want to say? And then Elijah after that.
I'm just responding to the claim that there's an exponential increase as you've got a further...
No, you're the one... Okay, I'm sorry, but you're the one who brought up a question that was already asked at the beginning and already answered multiple times. Then we answered it again, and then you're quibbling about the details. So what we're saying here is, if we live on this spinning globe, let's see some evidence for it. But what were you going to say, Elijah?
Okay, so I'll just fuck off then?
I mean, you can repeat what you already said. We all know what you said. The point is that it doesn't address the main point. But continue. We want to listen to everybody. Again, go ahead.
I don't want to have to mute everyone. If I may, I think we need to bring this back into a more civil direction. I think it's high viscosity liquid's time to make his point. Then we should try and move on from this point.
And then Elijah, and then we can move on.
Okay. I wasn't actually trying to make my own point here. I'm still trying to respond to India. He said he posted the graph. Yes, I look at this graph, and I understand what's going on because, of course, when the light is overhead, it's going through less atmosphere. It's going through vacuum until it hits atmosphere. When it's coming at you sideways, it's going through a whole bunch more air. Yes. So it stands to reason that there's an increase in the filtration. And I'm not sure where this graph comes from. Does this include the fact that, or what I'm calling fact, what I think of as fact, that it's dropping below the horizon? Or does it show this curve, this exponential curve based on it going through air? It doesn't make sense that it increases exponentially as it goes through that much more air. There's an exponential increase, yes, I would concede partially because the air is thicker lower down. And so per foot that it's going through matters more, but okay, as I said, this isn't my argument. My argument was about going outside and seeing with your own damn eyes that you can have nighttime, daytime, sunrise, and sunset all happening at the same time on camera. And this is being hand-waved away as far as I could tell. So yeah, Have at it.
Sun.
Have at it, kids.
Listen, I'm going to explain to you. The sun is local, and when it's far away, it has more air to go through, and it's not being filtered, right? This is a property of electromagnetic radiation that when it passes through a medium, it is absorbed by the medium, and it is attenuated by the medium. Both of these, if you look at Maxwell's equations, are exponential functions. So they're compounded exponential functions. You also call it an impedance, right? So there's different ways to this. I'll actually post the formula, and this comes from an astronomy site, and this is based upon the value they use is air mass, the volume of air that the light has to penetrate through before it reaches wherever you are. Break up? Somebody hear that?
Yep, I heard.
Okay. So I'm actually going to get the source and I'm going to post it. Like astrosim.org or something.
May I just make a quick announcement, please? I was informed that we should conclude the event in 15 minutes. Does that work for the...
Yes, but this is when we're getting to the meat of it now, right? So we've went the whole time without anyone presenting any evidence for the globe.
Yeah, I think we should keep going.
And sorry, guys, can you hear me?
Yep, that would be good.
Right, so we're coming back now to where we left off, which was what's the evidence for the ball? Who measured curvature? We had Eratosthenes. We agreed it didn't prove a ball. So we're still waiting for that evidence for a globe. In this whole conversation, we've had tangential non sequiturs that don't come close to evidencing we live on a spinning ball. So now's the last 15 minutes for you globe believers to show us who's measured Earth to be curved so that you can claim to live on a ball. Show us that. This is what the 15 minutes is going to be. It's either going to be you presenting evidence or it's going to be awkward silence.
They don't have any evidence.
Let's see it. Globers, step up. Who measured the curve?
Wait, I'm sorry. Are you asking why we think the Earth is a globe? Are you a flat earther?
No, I'm saying,
Yes, that's what we're asking.
We're all flat earthers.
The Earth is a ball, so that there must be curvature, because balls have curvature. Okay, so who measured the curvature for you to presume you live on a ball? Who was it? When?
I don't believe the Earth is shaped.
Cool. So no one's got anything for Earth being a ball then? Is that what we're concluding?
We're
Sorry, go
keep
ahead.
going.
No, go ahead.
I was just going to say, are we all in agreement here that the Earth is flat then?
I guess it is.
No, absolutely not.
Okay, so who measured curve?
Okay, wait. You can't
No, this guy who just said no. No, this guy who just said no.
Wait,
who measured curve
don't let him own this debate. First off, you got to prove your position.
It's not a debate. There's been no evidence presented for the Globe 2 debate.
Wait. Okay, so here's the problem. You can't keep saying, well, someone try to defend it. Are you going to defend your position as well?
We have for the last 2 hours.
What the heck?
3 hours.
I just joined.
Guys, so welcome to the server, Ryan. I'm proud to have you. Guys, I don't like to use priority speaker. So the event will be concluded soon. Everyone in staff is very fatigued. Formally, it will be concluded. Then we can continue on as you guys like.
Well, can we just keep discussing without the staff?
Moderator, didn't the Elijah had the next on?
Yeah, Elijah's got something to say, so I guess we've got 13 minutes left.
Well, it's too far removed to go back to the other guy. I mean, he kept saying...
You guys have 15 minutes.
Right.
Well, the globe has...
Yo! It's really
I just showed up to the server, but if I have to say one point here is that the flat Earth theory or hypothesis or perspective.
Holy shit! Somebody was in the middle of something.
Yeah, dude, come on.
I'm sorry. Go ahead.
So we can do two things, okay? Forget what the other guy said. We can just get down to brass tacks. We can do two things. We can either wait for you guys to tell us who measured Earth curvature to figure out that we have a radius of 3,959 miles, or we can use the only method we know of to either conclude that it is 3,959 miles or it's not. So we can go on the offensive or we can wait. We already went on the offensive with the laser, but we have other ways. So there has to be convexity somewhere. The ball is in your court. Which would you like us to do?
So I had a question earlier. I was wondering, do we have to lead with
Which would you like us to do?
the problem is for
there is only 10 minutes for the live portion. I mean, you guys are just burning up time.
Well, the thing is, I was wondering if we had no choice but to respond to that specific, because I had a completely different point.
So are we conceding that there is no one?
The young woman came in and she said, well, you guys have to prove whatever. And I said, well, we can do that two ways. And I just laid it out. And I asked, which way do you want to go? Based on what she said.
Yeah, I mean, I think we could either, we could just have no one talk except for one flat earth person who could present the black swan argument, for example, or, we could take some more questions from people who, I don't know, Shamron has some other question. I guess what we want to make sure that anyone listening to this, especially if they're new to the topic of the flat earth, to realize that when we asked for the best evidence of this thing that's supposedly settled science, nobody said anything, okay? So you guys, a lot of you, if you've grown up here on the earth, you probably thought, at least up until today, if you're new to the topic, that you lived on a spinning ball. And many of us did. When I first researched this when I was working on my master's degree in science education, I was writing a paper on how to show to students that they're wrong if they think the earth was flat. Because just like most people do, because the propaganda works, I believed that, these flat earthers, they're just stuck in the dark ages, they're just uninformed. And that's how most of us have gotten to this, because we actually looked at it and we thought somebody must have conclusive scientific evidence, right? Because it's all over the place. And we found out it wasn't there. So that's what we're trying to tell you here. And you've just had this demonstrated to you live, that people don't have measurement of curvature or rotation. They just don't have it. So yeah, I mean, are we taking a poll, Elijah, or what? I don't know.
Did we get to gas pressure without a container?
Yeah,
I don't think anybody talked about that.
Yeah, let's try and do gas pressure and the black swan in the last 5-10 minutes, if someone can bother going through it.
Again, I was saying, do we have to? Because I have a completely different point to bring up.
Well, if you can be quick, just ask your question.
Okay, so basically, the way how I have learned how a lunar eclipse works is when the Earth goes between the sun and the moon.
Yep.
That's not observably true.
Right, so that's the story they'll tell you. Sorry, Elijah, go on.
The quick answer is that's not observably true. Now, it's on you to say, how do you know that? Or, fine, I accept.
Okay, so how do you know that?
Well, there was just a lunar eclipse just the other day. It was a total lunar eclipse, and everyone who observed it observed the moon and the sun in the sky while they were standing on the thing that was supposed to be obstructing the light. So no, these three bodies, so-called, aren't in alignment.
Let me just quickly say as well, if you look up something called the Selenelian eclipse, Selenelion, this is when the sun and the moon are both observed above the horizon at the same time. So they're not in syzygy. They're not in alignment like they tell you they have to be for there to be an eclipse. Both above the horizon, and yet the moon eclipses. How is that possible based on the story that they tell us about the alignment? It's not, right? It's not possible. They need to be in syzygy, but they're not. So the moon eclipses, that debunks the syzygy theory. So what it is exactly, we can't tell you because we can't test the mechanism, but what we can tell you is that it's not based on the alignment of a ball, sun, earth, and the moon. So yeah,
the shadow.
Wait, what part of the flat Earth conspiracy do you follow? Do you believe in that Freemason shit?
So, just to summarize what Dandelion was saying, we've went the whole chat without one piece of evidence for the globe. A lot of questions, a lot of stories going around.
They provided evidence, but you just denied it. You just denied it and said it wasn't good evidence.
What was the measurement of curvature? What was it?
I'm pretty sure that one guy that had like a turbo mic offered something.
Right, what was it? What did he offer to give a measurement of curvature?
The shadows.
And don't tell him. What was it?
Yeah, like what he said.
So you don't know. So this is it. These guys are just taking the piss, right? So
I'm taking the piss. Why do I take that?
Soon, but I wanted to thank Corvo for even entertaining it. And now Corvo.
Wait, what's your IQ score? I'm wondering. I'm just genuinely curious.
Providing anything.
No, don't burn up the last 5 minutes.
Because they've got nothing. Yeah, I'm just gonna mute him.
Directly into the Black Swan.
Yeah, someone post the Black Swan in the Flat Earth text. Right. So if you're looking at the text chat, we see oil rigs. There's a predicted geometric horizon to a ball Earth. You can go onto Google and type in distance to horizon calculator, put in your observer height at 1 foot, which is where this is taken from. And you'll see that the horizon is seen beyond the second rig, which is over 10 miles away. The Globe Earth model says that the horizon can be no further than 1.2 miles for a 1 foot observer if boats are going over a curve of horizon. But obviously not, because we see that horizon beyond the second rig. This has been repeated multiple times. There's no geometric horizon.
Isn't the rig extremely tall?
It was a ball.
What? Yeah. That's a terrible argument.
Very tall.
What's the argument?
You can see the bottom.
Hold on. What's the argument?
The legs are covered in the one.
I'm asking him a question. He says a terrible argument. What's the argument?
He's saying that if you're able to see a rig, and
that is
like
not the
that's 10 miles. No, I'm speaking, right? I'm speaking. Don't interrupt me. If you're able to see a rig from 10 miles away, and like the spherical globe model says that you should only see it from like 1 mile away, and that's like the amount that you can only see it from.
Hold on,
from 10 miles.
The oil rigs are not.
Wait. I was talking to him. That's not the argument, by the way, because you didn't even listen to the argument. It wasn't about the oil rig. It wasn't about the oil rigs. It was about the horizon.
Was it about a boat?
No, it's about the horizon.
Yeah. He was talking about like seeing an oil rig.
We can see it further.
No. He's talking about the horizon. The horizon is further than what the globe Earth predicts.
Based on the site of the oil rig.
I'm talking. You said. Oh, you were talking. Now I'm talking. The oil rigs are just demarcation to where it's the distance. In other words, there's just markers of the distance, not the horizon itself.
Yeah, you're able to see the oil rig because the oil rig is like 10 times as high as it is far away.
Victory, why is the horizon seen beyond the oil rigs, Victory?
Huh?
Why is the horizon seen beyond the oil rigs?
What do you mean horizon?
What do you think the horizon is?
I actually don't know what a horizon is. Like you can be able to see that
conversation. Why are you having this conversation if you don't know what the horizon is?
To learn something.
Okay, the horizon is the apparent demarcation point between land and sea or sky, right? So where it appears to meet.
What does it look like?
He's trolling.
So he's just trolling.
Minutes.
Yeah. I'm not trolling. I'm asking you a question.
Hold on. Here's the thing. The girl asked the question because she came in late. I offered to go on the offense. This is the offense, and it's not being. We're not allowed to just run it through the end zone. Okay, this is what you people asked for. What is the problem? Seriously.
The problem is they can't tell us why the horizon is seen beyond the oil rigs when the globe model says it can only be seen at
they're getting scared.
miles.
They're scared now. They're scared now.
Okay.
We're still waiting for an answer.
Like I said, let's avoid things like that,
defenders and right there at the goal line.
Helio, let's avoid things like that, please. That's like super provocative when you make statements like that. So hold on, let me ask you guys, okay? Okay, guys, stop. I'm staff here for a second.
Can I ask you?
I hate to pull the card. Okay,
Let's stop this for a second. All right.
I believe someone doesn't know what a horizon is.
You guys got 5 minutes left. Okay, you guys got about 5 minutes left.
We have as
All
much
right.
time as we want. We do this 24.
Do you want in this server? You guys got about 5 minutes left.
All right.
Let's not derail it. Okay, with accusatory stuff. All right.
Can I politely request that all flat earthers, apart from Cyclone, shut up, and then he can just finish his presentation.
Here. Good idea.
Yeah,
Yep.
well,
Take us out, Cyclone.
If we've got,
Let's all be respectful and let's take it out on a respectful note. How about that?
that's what we're doing. That's what we're doing. Listen, all I'm doing is asking for an answer as to why we see the horizon at a distance that the globe model says is impossible, and the response we get is just trolling, right? But it's there. The horizon is visible for all to see. It's been verified. There's no answer to why you can see it on the globe model. If you want to get into refraction, that's a different story. But there is no answer to that observation that works on the globe model. It debunks it. So that's another good point highlighted. No evidence for the globe, no response to the direct observations that debunk the globe. And for the last 5 minutes, we can just go on gas pressure. Gas pressure, by necessity, by definition, requires a physical container. On the globe model, there is no physical container, but we do have gas pressure. That's what we breathe. So if you can't demonstrate gas pressure existing without a container, then there's no demonstration for the globe model. It's a violation of the law. High pressure flows to low pressure. So the high pressure of Earth, its atmosphere, would rush into the low pressure space, which is space, the vacuum that you've been told about. Gas pressure requires a container. Natural law debunks the globe model. So do we have any globers here who could show us gas pressure existing without a container for this story to be true?
Before we do that, the time is up. I'm just
we have 5 minutes.
I know. I'm just gonna do this quick speech for a second. I really appreciate the Flat Earth community coming over. So I officially just conclude the event. It will continue on, and Curious Panda is being given official authority over moderating, and he's a very fair guy with 10 years of moderating experience. So for everyone coming, thank you so much for coming. I am personally just extremely fatigued and exhausted. It's 2:30 a.m. for me. So I really appreciate everyone showing up, everyone doing their best to argue their point and belief. I really enjoyed.
Really appreciate you having us here.
Of course, man.
It's been a really fun time. To be honest, I've been listening the whole time. Been an awesome stream. So.
Yeah, I've been listening the whole time as well. It's very interesting,
I'll go
very
ahead
informative.
end the stream, from here, and then I'll move it back over to back to our live stream.
So I was thinking it can continue on the discussion, but the moderator will officially be Curious Panda, and he's a very fair guy. So thank you so much, everyone.
This was a very, very interesting
in a regular
event.
fashion now.
Sorry, could we get, anyone who's got some comments or anything, feel free to make them. It would be interesting to hear your thoughts. Thank you.
This was a very interesting event to listen to, and honestly, a lot of the things that I thought before have definitely been challenged. I do like it.
Well, we appreciate that. Thanks for coming along.
Great. That's the best news I've heard all day. Somebody who's has food for thought and continuing to think about issues. That's what we like to do, is talk and, discuss new ideas about the Earth. And I think, I really appreciate Corvo inviting us and providing this platform for us to talk to new people. It's been fun.
Yeah, and for all the new people, could we get someone to post the link to the server?
Yeah, please.
Yes, the link to the Flat Earth server is in the announcement. Please check it out.
Yeah,
thanks, guys. Heliosceptic, I'm gonna post the link to the to your stream as well in the chat, if that's okay for you.
Great. Yeah, please.
Okay.
Please go ahead and do that.
So make sure to check our announcement page.
Can I just add
also let us know that you come from the chatterbox, because there is a check-in process, and we'll definitely get you there.
Folks, can I just add, I've got a Google Drive if anybody wants to look more into the Flat Earth sort of evidence that we've got, and a lot more. I'll drop it in the Flat Earth chat just now. It's got gigs and gigs of stuff in it.
Excellent. And Eli, I think you were trying to say something as well, right? Thought I heard Elijah.
If I was, I can't remember.
I think it was me.
Can I put in my 2 cents?
Thank you for having.
Go ahead.
Okay.
I want to put in my 2 cents. None of us here are trying to convince you the Earth is a flat or a globe. We're just trying to convince you to think for yourself. So the question of what the shape of the Earth is, you know, some people don't think it's important, but we do. Because a lot of people are making, you know, life decisions and base their entire worldview that they're an insignificant speck in the middle of a vast cosmos, and that their lives don't matter and don't mean anything. So if you're going to think that, that's fine, but we think it should be based upon objective empirical evidence and be proven, and not a talking head on TV just telling you it is so. So, a lot to say.
Yeah.
Thanks for having us on, guys. See you next time. Anytime that you want to do this again, we're ready to do it. That was really fun. Thanks.
I'm out of here. And Epstein didn't kill himself.
You've been listening to 24/7 Flat Earth Discord 2.0. We hope you're having a fantastic day on this flat and stationary plane. If you too would like to join the debate, please click the link below. We'll see you there.
You have been listening to excerpts from the 24/7 Flat Earth Discord Live YouTube channel. If you would like to join the discussion, simply type in your address bar discord.gg/flatearth. Thanks so much for listening.
was brought up on one of the other things earlier. Got one. Like from Ghostbusters. We've got one. Anyway, check this out, guys. This is Bob's explanation of the gyroscope. And it's from this room where he came and explained what was happening, what was going on with him and his Netflix, whatever they did with the Netflix crew. So anyway, let's go do this.
Okay, so obviously you don't know me, right? You only know me because of what you saw in Behind the Curve, correct?
Yeah.
Okay, and from what I said in Behind the Curve, you took that and interpreted it as, what I was saying is that the Earth was spinning, right?
Yeah, you said 15 per 1 hour and 15-degree drift.
That is correct. That's exactly what I said. And you know what? I wasn't lying. That's exactly what we registered. The problem is what the producer interpreted that and actually cut the editing to make it look like. So would it surprise you if I told you that, I completely agree with everything you just said. I absolutely did say that. But unfortunately, because of the way the producer twisted that around, I was not saying 15 degrees per hour of Earth rotation. Now, do you want to know how I know that?
Because your gyroscope, your like $40,000, what was? Like, how much was it?
Well, first of all, it wasn't my gyroscope, and second of all, I didn't do the initial test, but I got credited with that, so I'm just gonna wear it, okay? But we took that gyroscope, and like I said, when we first plugged it in, we got a 15 degree per hour rotation, and actually, it wasn't specifically 15 degrees per hour. It would be an interpolated value, taking the sine of the latitude times 15 degrees per hour, which would kind of equate out to that. Okay, so let's make that perfectly clear for one thing. But secondly, when I was in the movie, at that time when I stated that, I had no idea. I was just as surprised as anybody else, and I was very reluctant to accept it because I was trying to interpret, exactly what we were seeing. And I came to find out later on, and by the way, I did tell the movie producer this, exactly what we were seeing had actually been measured and discovered over 100 years before in what was called the Michelson-Gale experiment, right? The rotation of the luminiferous ether. So at that point, then what we were faced with is we had the challenge of, well, how do we prove that it is not Earth rotation and was in fact the luminiferous ether? Now, some people, and I'll even say even in this panel, don't believe necessarily that the luminiferous ether exists, but there's also a lot of Nobel laureate, physicists that say that it does, and it's, there's a big debate on it. Let's just put it that way. But by using that very same gyroscope, whether you believe in the ether or not, we actually devised a way to tell us whether or not it was in fact Earth rotating, okay? And it was really pretty simple, right? So first of all, do you understand at all how the fiber optic gyro works, how laser interferometry works?
Well, not really, but I mean, I get the gist of it. I get how a gyroscope works and how the gravitational pull works on it. And then when there are spins, there's different. It marks one spot, and then it calculates the time interval it takes. Then it calculates the angle, how much is the angle is like changed.
Well, that would be for a gyroscope, yes, but a fiber optic gyro works a little bit differently. It works on something that's called the Sagnac effect. And the Sagnac effect is basically, it goes under the assumption that if light is traveling through a medium, right? In other words, they speak of light as a wave, right? So you have to ask yourself, well, what is a wave? What is it waving, right? What is it traveling through to cause that wave? What is the medium that light is actually waving, right? Well, scientists have been saying for centuries that it is in fact this luminiferous ether. And that is what I actually wound up claiming that it was that was actually rotating, the luminiferous ether. Now, here's how and why I came to that conclusion. So we went back and we looked at these experiments from over 100 years ago and the assertions about the Sagnac effect and laser interferometry. And it turns out that what they say about the luminiferous ether is that it rotates very much, or it behaves very much like a magnetic toroidal field. Are you familiar with a toroidal field in a magnet?
Yes.
Okay, so the ether very much behaves in the same way. It actually is moving. It's not a stationary thing. It is moving, and believe it or not, it propagates vortexually, right? And it just so happens that that vortex rate is about 15 degrees per hour. Now, again, how is it that we were able to figure that out and that it was not Earth rotation? And the answer is really quite simple. So if I'm taking, and this is, by the way, exactly what we did. So we took the fiber optic gyro and we went to a place in Colorado called Pikes Peak. And Pikes Peak is at 14,125 feet above sea level, okay? And we did our measurements there and we got essentially our equivalent to the 15 degrees per hour rotation rate from Pikes Peak. Now, again, whatever you want to call it, you can call it the ether or you can call it Earth rotation, whatever you want to call it, that's fine. But what we're trying to prove here is that it was not Earth rotation that we were picking up. So we did that measurement at Pikes Peak and we got a value for it, okay? And then we went down to eastern Colorado following the exact same line of latitude. Right? And why we followed the exact same line of latitude, I'm going to tell you here in just a second. But we went directly east in Colorado on the exact same line of latitude down to just over 4,000 feet. And then we did another measurement. Okay? So would you agree that if I am measuring something that rotates, or that measures spin, right, or a rotational rate, that it should not matter whether I take that rotation rate at the bottom of a device or at the top of a device, especially a spinning ball? It would be the same whether you took it right on the globe or an inch above the globe. Would you agree with that?
Yes.
Okay, and you would be absolutely correct. It would not vary at all because it doesn't matter where you would be, high or low, on that same latitude line. It is going to rotate at precisely the same speed. Well, here's the problem with that. What we found was that when we did the measurement with the fiber optic gyro at the 4,000 foot elevation, we had about a 1.3, 1.4 degree per hour variance from that done at the 14,125 foot elevation on Pikes Peak. Okay, so we thought, well, that's pretty interesting because that actually equates to be 26, 27 degrees per day, right? That's a huge number. So we did it again at a different place, Guanella Pass, and again, and again, and again. And we did it in several different places in Colorado. And again, each time we then went to its corresponding latitude line at a lower altitude. And every single time we got a greater than 1 degree variance on the two measurements. Well, why would that be? Well, if you think back to what I just said about how the luminiferous ether was always said to propagate, and this comes from the people that coined the term, Newton, Maxwell, Clerk Maxwell, all these people that talked about this originally, then all you have to do basically is visualize it as a vortex, i.e. like a tornado, okay? So if you are looking at a tornado and you look at it on a z-axis, right, then at the top of the tornado, right, it's rotating fairly slowly, and as you go down that z-axis down towards the ground, it rotates faster and faster and faster, right? So you have a considerably faster rotation rate at the ground that you do, from high up in the air. Would you agree with that?
Yeah.
Did I lose it? Okay,
yeah,
good.
No.
All right. So So that, again, is exactly what we are saying that the luminiferous behavior is propagating as, right? A vortex. So the problem here for the globe is that when you get a 1.3, 1.4 degree per hour, which equates to 27, 28 degrees per day, something like that, difference in rotation, then that pretty much tells you unequivocally that what we are picking up is not Earth rotation. And it is more commensurate with that vortexual behavior that science has always told us that the luminiferous ether actually behaves in this vortex, right? So we did this multiple times, and every single time, we weren't expecting such a huge variance. But, when you're talking 1.3, 1.4 degrees per hour, that's actually huge for 10,000 feet. So we can only imagine that number grows even greater if we were able to go higher and lower. But the most important thing is what it proved unequivocally is that what we were picking up was not Earth rotation. And do you see the logic behind that as to why we know that it wasn't Earth rotation?
Yeah.
Okay, so that's it. So whether or not, anybody wants to accept that it was in fact the luminiferous ether, as I claim, and as other people claim, that's up to you. But the primary goal here is to prove that what it did pick up was not Earth rotation. And in fact, when they did this over 100 years ago in the Michelson-Gale experiment, they had to do another experiment called Airy's failure to try and determine what exactly it was that was spinning. Was it the Earth or was it the sky? And so what they did was they devised a very simple optical experiment called Airy's failure, in which they measured the rotation rate optically with the telescope, and then they filled it full of water, and theoretically that would slow down the propagation of light through the telescope. And then the idea was that if they had to tilt the telescope further forward, then the light would not be coming in at the correct angle. However, if they didn't have to tilt the telescope forward, then the light was already coming in at the correct angle of 15 degrees per hour, indicating that it is in fact the stars that are rotating and not the Earth. Well, guess what? Airy's failure, same conclusion. It concluded that it was in fact the stars. So now not only do we have the FE cores version of testing whether or not it was Earth rotation, but we also have Airy's failure from back in antiquity. And to this day, you still have people saying, well, we built these gigantic laser interferometers that are stationary and sitting in one place, and of course they are going to be picking up a rotation just like we did. But the problem is there's no way to falsify that if you cannot move that detector up and down on a z-axis to see if whatever it is that you're measuring is changing velocities at different altitudes or different z-axis. Okay, so that is how we know unequivocally that what we were not measuring was Earth rotation. And of course, because the producers of Behind the Curve did not want that information to come out, they skewed it and made it look like, wow, dummy flat earthers, they proved it, with their own equipment, and then sit there and keep denying it. Well, they didn't include the rest of the story, and that's kind of the problem that we have with Behind the Curve. And that's all I have on that, unless you have any questions.
No, I'm just wondering why. I mean, it's just weird why they wouldn't include it.
I'm sorry, it's weird why they wouldn't what?
Include it, because lots of people, I don't think you've told this to many people.
I have told this countless times. It doesn't get any press. And I told it to them, and I'll tell you why. And the producer even said it himself. They were all for giving Behind the Curve a fair representation until they went to the 2017 Flat Earth International Conference in Raleigh, North Carolina. Okay. Then at some point,
So what happened?
Then at some point, a kid in the audience said something made them change their mind. That's what I remember for that. Don't know why it stopped though.
Oh, they are using light in these interferometers, right?
Say that again, Gabe. I missed what you said then.
The interferometers, they are using light.
Not sure. I have to have a look at this now.
Yeah, vast majority of them, they use lasers. Interferometers. Interferometer devices, they use lasers.
Yeah, that was the end of that video. But some dipshits in the YouTube chat saying, once all their gyroscope was, or what they claim about what Bob said about the gyro, was debunked. Now they're going to rifling, like freaking long distance shots from a sniper or some shit. They're going back to all kinds of stupid shit, which none of that's applicable either. You know, you don't use the spin of the earth as a sniper. There's no evidence for that. Not physical evidence. I mean, in a couple of manuals there are where they'll say, "Hey, you have to account for the spin of the earth." But every single, I've talked to many snipers, they never use that.
Has he ever done any rifling?
Here's what he said. Of course, there's also the proven accuracy of artillery firing solutions that calculate Earth's rotations in the formula rounds on target count. Look up the Paris gun in World War I. If Earth's rotation were not factored in the firing solutions, the rounds would have missed by 600 meters. 600 meters!
World War One. That's what he said.
Okay, he's talking. All right, so he or she. I think it's probably trillion, but I'm not talking about snipers. Talking about artillery. So he's talking about like fired rounds, maybe from ships or ground. What are you talking about, Mirakai?
Well, I did actually barrel rifling, you know. I know the mechanical work process.
So we have Jay Hutton says, can people understand that they make a big lie and then they work backwards on input info so it will make sense to people even though it's a lie? And yeah, sure. Yeah, you can convince people of the lie. I mean, that's been proven through centuries. I mean, you can think you know something, but it's a form of programming. When it's actually you have no physical evidence for it, you just believe it. So sure. All right, so the Paris gun fired from a distance of 80 miles. And since they were firing 80 miles, they had to consider
80 miles in the World War One. Is this guy hallucinating?
I know a little bit. So they had to consider the curvature of the Earth. So I'm waiting for.
No, there's no such thing. There's no 80 miles firing range in the World War One.
Well, you have to get in the YouTube chat and argue with this guy.
8 miles, maybe.
80 miles. I mean, the only thing that can go 80 miles is a railgun.
Yeah.
Unless you're using like some ICBMs or some shit. Which, I mean, it would be.
No, 80 miles on battle cruisers. Yeah, they have these big cannons. They do fire those kind of distances. But
yeah, but do they calculate the curvature of the Earth? I mean, not curvature. Well, curvature and spin of the Earth at the same time when they fire, or they just. You guys remember that game Worms, where you just like calculate the angle and you just like calculate the angle and trajectory and power.
The ballistics, yeah.
And it's that's what they're doing. They're angling the guns.
Well,
they know the weight and how much power is behind the ballistic. Boom.
Yeah, that's what I'm saying. That this ballistics is actually real military science.
All right, he says
I know it
says
looks
it's
very simple.
Krupp Paris
It
gun.
sounds and looks very simple, but it's not.
I'm gonna look it up. Krupp Paris gun. I'm gonna look it up right now. The Krupp Paris gun. Paris gun. Paris gun. The name to a.
They're calling you dumb, JB Jet. They're calling you dumb in the chat. Get in there.
Yeah. Oh yeah. Well, hey man, they call us all dumb all the time. You know, we're used to that shit. So it was a long-range siege gun, several of which were used to bombard Paris during World War One. They were in service from March to August 1918. When the guns were first employed, Parisians believed they had been bombed by a high-altitude Zeppelin, as the sound of neither an airplane or a gun could be heard. They were the largest pieces of artillery used during the war by barrel length and qualify under the quote-unquote latter formal definition of large caliber artillery. Also called the Kaiser Wilhelm Geschoss Imperial William gun, they were often confused with the Big Bertha. The German howitzer used against. I mean, this is the Wikipedia article. I mean, is this accurate? Yeah. As military weapons, the Paris guns were not a great success. The payload was small, the barrel required frequent replacement, and the gun's accuracy was good enough only for city-sized targets. The German objective was to build a psychological weapon to attack the morale of the Parisians, not to destroy the city itself. Yeah, I mean, so you have a a faulty weapon, that's your evidence for flat Earth. Okay, I mean for globe Earth. All right, thanks. Next. Paris gun. Bro, I look up the Paris gun and they're just like, yeah, it's not really effective, and that proves the globe. Yeah, come on, man. He's reaching now.
There was this Ottoman general, Tembel, and actually not general, but something like a commander, a troop commander, and he has been sent like a messenger to the Russians by the Ottoman Empire. And when he got to the palace of the Tsar, he saw there in front of the palace, the Russians, they had like these giant decorative cannons with a barrel like 2 meters in diameter. And when this guy saw these cannons so big, he asked the Tsar, are these real weapons, the cannons which the Russians have? And
was it just for show?
Yeah, but he really thought they are real, and then the Ottoman Empire feared they never attacked the Russians, you know? they never mess with them.
Instead of actually building real like artillery that we can utilize, let's just make shit look big so we can intimidate. That's crazy.
There's so many funny moments in history.
Actually, it's not funny in the way that they intimidate and try to control everybody. It's not funny at all. We can laugh at it now, looking back, but it's really sad how they utilize, propaganda and control to manipulate the population. It's really sad.
And it wasn't even the Russian Tsar, it was the Ottoman himself who said, like, if you fire this cannon, it's going to destroy a whole city,
They still do that, don't they, with the nuclear threat?
Yeah.
Helio.
What's up, Flatter Day?
What up?
Yeah, with this nuclear threat, I mean, they're always. I mean, it's just like, who's going to fire the first nuke? It's like nobody's fired a nuke since supposedly in 1942. But it's just like, but there's always the threat there because America did it, back then. But they don't. This is, I don't know. I mean, can you talk about this 70 years later, 60, 70, 80 years later, about how they really kind of faked that shit too?
Right?
The carpet bombing of Japan and then called it a nuke? Fucking firebombing? But anyway.
What they were carpetbaggers, bro.
Yeah, they're carpetbaggers off of the fake nukes.
Right? I'm right here. I'm getting off to the exit right now to go to the Black Swan, bro.
What? What are you doing with the Black Swan?
I'm just going to take some pictures. I didn't bring my camera. I'm just going to use my phone to take pictures.
Are you in Santa Barbara?
Yeah.
Oh, you gonna go look at the oil rigs?
Yeah.
Cool.
I'm gonna see if they put up any new signs that say that pretty soon there's gonna be no action.
Oh man, yeah. Send us some pics, definitely, man. Yeah, sweet.
I'll send you some in about 10, 15 minutes.
Cool, man.
Or I'll talk to you in a minute.
Yeah, no problem. You're kind of breaking up a little bit anyway, but yeah.
Okay, all right.
Yeah, so he's going to Santa Barbara Road to take a look at those Black Swan oil rigs. It's cool. Maybe there's some people on the beach. He loves flat smacking in public, so maybe there'll be some people on the beach that'll flat smack while he's down there. Yeah, we have a new person here, Yellow Weasel. Do you want to open your microphone and talk to us? I just unmuted you.
Hello. Yeah. So no, a friend of mine said like he got into flat Earth and he said I should check it out, but I'm not really that convinced yet.
Yeah, well, to be honest, we're not here to convince you. We're just but let's before we get into all that. How did you find this, sir? You said a friend invited you. Have they been here before?
No, he said he sometimes watches your live stream on YouTube.
Okay, cool.
And he said like maybe if I have questions I could come here and see what you have to say.
Okay, cool. So do you have any questions to ask us about flat Earth?
Yeah, I'm just a bit confused in the sense of that I hear of so many different models and versions. So for example, it's like my friend, he's like he believes that the moon is a hologram, but then also I've heard of other people who believe that it's a flat surface, and then like other people say it like crumples up when it gets like half moon and stuff, and I'm just a bit confused to like what exactly I should
hold on.
look into.
We all see the moon the same way. We experience the phases. Now, what and where and how that works, we have no idea. That's a really good question because the moon is very mysterious, and it's still mysterious to us. I mean, in the astronomers' ideas, right? They are like, well, it's a rock and it's affected by Earth's gravity. We're the third rock from the sun, and it's traversing the sun or traversing Earth, held by Earth's gravity, and the reason you see the moon phases is because of the way that the sun shines and the different times of the month and all that kind of stuff. Yeah, I mean that's a standard story. We always
I don't know. It kind of makes sense to me. I don't know.
Sure, it can, but it's not the only explanation for what the moon is. You know what I mean? Because you can explain it another way. Go ahead.
Sorry, go ahead.
No, you.
Yeah, but like I guess you also don't believe that we went to the moon.
Well, I've never been to the moon, but I don't think anybody else went there either. Yeah, you're correct on that.
Yeah. Yeah, you see, because this is something that when I was younger, I investigated a lot. Because that started like with all this. It started with 9/11, and the conspiracies surrounding that. So I would say I was a 9/11 conspiracist. And then like I got like sucked in a bit into the moon landing conspiracies. But I don't know, like from what I researched, I deducted that the moon landings happened, and so then that sounds like if I'm correct with that, then
so
we would know a lot about them. I looked into the moon landing, yeah.
Well, you looked into 9/11, but you can said you were like you came to the conclusion that the way that the official story of 9/11 is true or not true, or there's some questions.
I'm not completely sure, but I would say it's more likely to be true, because the problem with the official story is that if they were looking for a reason to go into Iraq, they would have made Iraq the culprit for 9/11.
Yeah.
And that just like sounds like very weird to me, and also like the way that the buildings collapsed is sounds expected. Looks expected.
It sounds like you've done your work on that one. But you were questioning moon landing, and then you came to the conclusion, yeah, they probably did go.
I'm really
after
sure
looking
that
at
they
some
did
of the
go.
9/11. Well, cool.
Yeah. I'm just saying so that, because that is like when it comes to, for example, the different ways that people think that the moon is, then that doesn't really compute with, like, I don't know, like if I'm quite sure, I would say like 99.9% that the US landed a few astronauts on the moon multiple times.
Okay, what makes you 100% sure about that?
I said I'm not 100. I said 99.9.
That's pretty close to 100. Come on.
That's pretty close. You're completely right.
The closest you can get to 100.
Right.
Yeah,
The thing is that at the time it would have been more difficult to fake the moon landing than to actually do it.
Oh, really? What makes you say that?
So the kind of cameras you would need, the kind of, I would say, the slow motion cameras didn't exist yet. The problem is you would have with the live transmissions.
Cameras. Yeah, we didn't have slow motion cameras, but after you shot a video, you can replay it at a slower feed.
But not with you, and if you shoot. That's the thing, If you replay it with the lower feed, you can see it in the video that the feed rate has been lowered, because it's only been shot
How can you see that?
You can measure the difference between each picture, the time difference, and that means like how many pictures you have per. You can measure the amount of pictures you see per minute, per second.
Wait. To establish that, you need the original video, correct?
Yeah, I mean, I'm wondering which pictures you're talking about specifically, because
can you point me to the original film? Yeah, it was a roller yeah, with physical film rolled on it. Can you show me the original one?
I don't have it in my possession, no.
Yeah, NASA officially is saying that the original doesn't exist.
Yeah, they don't have it.
I think they said some of it was lost.
They
That's also something
destroyed.
that I heard.
No, it wasn't lost. They destroyed it.
Well, that was the technology to go but to them. But as far as the pictures and images, I mean, you can go on NASA's website right now and look up the moon landing pictures from some of. They had like chest cameras. They had a camera on the capsule, and these were certain types of cameras. But are you familiar with how they captured this footage?
It was all analog film, and this is also the interesting part, is that if you look at that's the thing, I'm going by the difference in live transmission versus captured video that was recorded, and captured pictures. And if you look at the live transmission, there's not a single speck of dust, not a single weird blip, not a crack in the film like on it. And then when you look at the captured images, the original ones, then you see that you have influence of the radiation, you have dust on there, you have like standard analog picture problems. So that means that the live transmission couldn't have been recorded. The live transmission couldn't have been recorded in beforehand. That with the technology of the time, it would have been nearly impossible. I would even argue impossible to have this.
Or are you talking for yourself?
I'm talking for myself.
Sounds like you're reading a script.
No, that's cool. I mean, check this out. Here's something to think about. Maybe something you haven't considered.
Go ahead, man. Yeah.
Check this out. I mean, we're, in the globe idea, we're in the solar system, third rock from the sun, right? The only reason that we're not burnt to a crisp on Earth is because of the atmosphere, right? In the heliocentric model.
No, it's the magnetosphere, actually.
Say that?
That does most of the work. The magnetosphere.
Okay, well,
you know that the Earth, like that, when you have a compass, it can.
Hold on.
Yeah.
Go ahead and explain that. So the magnetosphere, instead of the atmosphere, actually prevents most of the UV rays from frying.
No, most of the high energy particles, which would over time destroy the atmosphere. So, like, look at Mars, for example. Doesn't have an atmosphere. Why? Because it doesn't have.
Are we looking at Mars? I'm talking about Earth, bro.
How do you know Mars?
Okay. Yeah, because of the measurements we've done with space probes we send out. But if you don't believe that we send out anything, if that's all fake, then of course.
Are you telling me that drones can fly in vacuum?
Well, what do you mean with drone?
Yeah, can a drone fly in a vacuum?
What is a drone from your point of view? You mean like propeller powered, or what do you mean?
Those bullshit drones, yeah, with propeller powered, yeah, drone.
No,
Don't you know what
that can't fly in a vacuum.
If they have propellers or propulsion engines,
remote control.
They don't have to have atmosphere for anything to fly.
No, but a rocket motor doesn't need an atmosphere.
And you said, if you look Mars, I'm looking Mars, and I cannot realize if his atmosphere there and if he's not. How you realize that?
Oh, that's actually also something you can do with the telescope yourself.
With the telescope. With the telescope.
See the atmosphere of Mars with a telescope.
Are you saying that you can see the Mars and you can see the atmosphere, or not see the atmosphere of the Mars? Or you can see birds or whatever. You can see the rock passing or whatever.
No, but you can. Really cool. So when you
saw Venus, Saturn, and Mars in the sky tonight. They were like right next to each other, like Venus, Saturn, and Mars. I didn't pull out a telescope, but I'm pretty sure if I did, still wouldn't see the atmosphere any of them.
Yeah. And
Well, you can see the atmosphere of Saturn.
Wait.
Man,
At the
how you
beginning,
can see? No,
Sorry?
get
let
you
me
make the claim.
finish. Sasha, I didn't finish explaining.
Sorry.
I started this argument with him. I need to clarify and end it.
Yeah, go ahead.
His claim was, he said that there's no atmosphere on Mars, but NASA showing us that they are sending a drone and it's flying. Yeah, but you were saying earlier that
No, I didn't
Mars
say
has
that.
no atmosphere. You said it.
I said it slowly
Do you
rips
want
away the
to-
atmosphere, which is what's happening to
just
Mars. And I'm saying it's
rewind-
not. I never
Just
said it doesn't have
rewind
an
the
atmosphere.
live stream because you said Mars has no atmosphere. Unlike
No,
Earth.
I don't think I've said that.
But let's say that you
Anyway,
you
if
said
it came out that way,
Otherwise,
I didn't
change
mean
idea.
it.
Because he doesn't mean that now.
Yeah. Anyway, I didn't. It came out that way. I didn't. I don't mean it.
So what do you mean then?
But you mean that we can with telescope see what is going on Mars?
All right. So if you want to find out what gases are somewhere, you can see of the light.
Or if you want to find out what gas is doing, look into and find me where we can have gas pressure without container, and then we will speak about Mars and everything.
Okay, so the thing with gas pressure without container is, like, to me, like, for example, look at the ocean. You see, like, there's at the bottom of the ocean, you have a lot of pressure.
Ocean is not a gas.
Water is not a gas. Water's not a gas.
Okay, so if it if it doesn't work with gas, then
what?
Well, if you don't believe in atmosphere, if you don't believe in gravity,
I
then
don't believe in
really know
anything.
how
I
it
don't
works.
believe. Listen, this. I don't believe in anything. I don't believe in atmosphere. That's for sure. Do you believe in atmosphere?
I know it takes guts for some. Hey, listen, you probably. It sounds like you've. Hold on, everybody. Hold on. It sounds like he's familiar with our arguments. So let's, like, No,
I'm familiar with my friend's arguments, but they don't, like, to me it doesn't sound that right. And he said I should come here because you guys can explain it better than him.
We also don't need to bombard you and
Question: do you believe in atmosphere?
Like in that we have an atmosphere around me now, or like that there is no atmosphere in space?
Do you think that what we call what is around us it's atmosphere?
Yes.
Yes. Okay. How gas taking the shape of the sphere? Can you tell me? Because
it is pulled to the sphere by the force of gravity.
What can you provide the academic citation that the gas is pulled by gravity?
Hold on, guys.
Yeah.
Both of the people who are talking to you now, hold on. Everybody here used to think. Hold on. Everybody used to think gravity was the thing before, so don't just try to take the piss at him because he thinks gravity's real.
Yeah,
come on.
I'm not angry
come
at
on,
him.
man.
Actually,
Explain how we found out that this cannot possibly be true.
all the arguments. Yeah, I want to get with him through all the
I
arguments.
hate when people do that shit. When new people come in and just like, and just like, oh, you think gravity? Then just fucking jump down their throat about gravity. I mean, it's like we all used to think that shit was real too.
Yeah, first thing first, I need to explain is, I welcome to this server. I want you to know that you don't know about the stuff that we know. You think we have beliefs and things like this, but actually we are extremists. We do not accept stories for explaining reality. When we deal with reality, we stick with science and its scientific method. And if something is not, if a story is not a scientific theory, has no experiment to back it up, then we will not accept to blindly believe that story because just someone thought of himself to say this nice story.
I'm completely on board with you. Yeah, I'm also. I want to believe as much true stuff as there is.
Yeah,
and there's the least false stuff. So
yeah, the globe model has a ton of positive claims, but none of them have been demonstrated or
none of them?
empirically proven. Yeah.
But like, for example, when we want to come back to gravity, let's say, okay? Because like...
Gravity. Let's take it from the start. The first theory of gravity is Newtonian gravity, mass attracting mass. So
yeah, let's stick with Newtonian. I'm completely fine with that.
And this includes also Newton's laws of motion. So, do you think they are real?
Do I think what is real? Sorry.
Do you think that theory of gravity, the Newtonian theory of gravity, is actually functional? It is real?
It is functional, yeah. Until you get into like the high velocity stuff where you need to go with special relativity.
Well, that's the problem, actually, because Newton's theory of gravity has been debunked and superseded, meaning it has been replaced
Exactly,
by
I completely agree with you.
Yeah, by Einsteinian relativistic gravity.
And I can also show you when you look at the... Yeah?
Wait, yeah. Which, for Einstein's gravity, you cannot demonstrate to me empirically the bending of space-time. So when I'm waiting the train in the train station 5 minutes, show me how you're gonna be bending my waiting for the train. How are you gonna bend that?
No, but this is not what bending space-time would even mean. I mean, so I can... You can... So, for example, look at... Oh, you don't believe in that? Okay, wait.
The train station is
let him answer, man.
In
Let him answer.
Yeah, go ahead.
Give him his rope.
Right. So let's say you're waiting for the train on the station, and you're just standing there. You're not really moving relative to, let's say, the guy next to you.
No, I am moving. I'm smoking a cigarette while waiting.
Okay, then you're...
Yeah.
Are you like spying on me? Get? Because that's like exactly what I'm doing right now. I'm at the train station.
So let's say if Earth was 20 times as heavy, you know, like the gravity pulling you towards Earth
you have
was
to
a lot
bring
stronger.
Imaginary concepts.
Well, the problem is that in order to see,
can you show me a Earth 20 times heavier than the Earth that we live on?
No, I can't. So okay, let's stick with something else then. No problem. No problem. Let's take a clock.
Hold on. I'll ask you a question. Let me ask you a question.
Yeah.
When you say gravity, you mean the cause of the effect? You mean the cause of the effect? Is gravity the cause or gravity the effect?
Since gravity is just the effect of a formed, no, how do you say, of curved space-time, because it's not really a force in that sense, if you want to go technical with it, but it makes sense to look at it from a force when you do like small Newtonian physics, in the same way as it makes sense to think of the what is it called? when you spin something around you in a, like, I don't know, you take a hammer and you spin around, it feels like the hammer exerts a force out from you, right? But this force also doesn't really exist in that sense. It's just the hammer wanting to go on in a straight line all the time, but you're pulling it in.
Acceleration.
Well, there's the reason I asked you whether it was a cause or the effect, because just that one question alone demonstrates that it's not actually a scientific theory. Because the causal mechanism for, say, things falling can't be demonstrated by experiment.
Yeah.
You'll have to
What do
say,
you
like,
mean?
I can't. Okay, so an experiment that has cause and effect has independent variables. Manipulate the independent variable and measure an effect on the dependent variable, right?
Yeah.
The independent variable is the cause. Dependent variable is the effect.
Exactly.
Right? So what
And
causes things to fall?
You have mass deforming space-time, which then leads to other objects' paths seeming to curve, although they still go on in a straight line.
Can you repeat that?
Yeah, I was talking about that. That's what we're talking about. That's a story, right? So where's the experiment?
Okay, I can give you an experiment. You take a very, very, very heavy sphere. I don't know, let's take a 30 centimeter diameter lead sphere. And then you take a smaller sphere, or like another object, let's say a 1 centimeter diameter lead object. And if you place them in a low friction environment, you will see that they will over time move closer to each other until they touch, without other forces put on them.
Yeah,
In a
good
vacuum.
example. Indio. I want to ask him a question
You actually
about.
have that experiment that you can show us. You can have that.
I've done
You
it.
have that
I've done it.
experiment.
Yeah, at my university.
You've done it. What
Yeah.
exactly did you do?
What?
Yeah, what exactly did you? Are you talking about the Cavendish? Is that what you're talking about?
He is.
Cavendish?
It's the Cavendish. Yeah, it's the Cavendish.
So I asked you what falls. There's nothing falling in the Cavendish experiment.
Yes, there is. You have the small ball falling towards the big ball in the same way as the big ball is falling towards the small ball.
Falling sideways.
Well, it's all just a point of. I mean, it depends on the point of reference, doesn't it? If you think of yourself as the small ball, you would say I'm falling towards the big ball, wouldn't you? I don't know, like, what do you mean?
Yeah, so we get into that I think and I imagine. That's where I jump ship, because we don't want to think and we don't want to imagine.
Yeah, I'm
right?
just. The
So
problem is
idea
we're
that
using words like fall, which don't even make that much
fall
sense.
means fall towards the earth. Fall means go the acceleration 9.8 meters per second squared towards the earth.
So are you falling right now?
Not yet.
But you're accelerated against the earth at all time.
Yeah, really awesome. But I asked you for the experiment which demonstrates the cause of that. I didn't ask you for an experiment that demonstrates
I gave you the Cavendish experiment that shows you that mass attracts mass.
Hold on. Here's I want to break down what he said. So you're accelerating against the Earth. It sounds like his English is not his native language, right?
No, it's not. No.
Accelerating against the Earth. Accelerating
towards, like you're at all times. The Earth is pulling.
Yeah, sure.
Like you're being pulled.
Earth is not pulling anyone.
And I don't even think you did the Cavendish experiment because you didn't actually describe. Well,
you take two balls and you have one. You take two big balls, two small balls. You have the small balls in a low friction
everybody
environment.
let Indio do this, please.
Okay, you have a laser, and you point it over a long distance, and you can see the movement until even both of the two balls touch each other.
And that's actually not what happens. So you're actually describing it wrong. So what happens is the big ball and small balls go towards each other, and then they oscillate. And then you measure the speed of the oscillation, and then you infer big G from that. So you're not even describing the experiment right.
They oscillate? What do you mean by
They
oscillate?
oscillate because they're on a torsion. They're on a torsion wire, so they bounce
Oh,
back and forth.
there's. I'm getting weird noises.
Torsion wire has a
India's got some background noise, but yeah, I mean, he's talking about a horizontal. Well, actually, what you're talking about is you're both talking about a horizontal attraction, not a vertical attraction.
Well, the problem is that we can't turn off gravity for these two.
What the hell is gravity, bro?
No, I mean you cannot turn off. Like as long as we're in Earth's gravitational field.
Yeah, Weasel, you claim that you've been to a university and that's where you came across this Cavendish so-called experiment. Do you know this experiment in depth? Have you studied it?
Well, no, but we've at the end, not anymore. At the time, we've done the calculations on it.
You mentioned
we measured the gravitational constant.
Listen, you mentioned that you are using lead balls. Lead is a metal, correct?
Yeah, but that's not even what they do.
That doesn't work because.
No, I need to know what do you know about lead metal?
What do you mean? What I know about lead metal at the beginning of the experiment? You let both of them touch each other in order to equalize the electric
I'm talking
forces.
about your knowledge about the lead metal.
Well, I studied two semesters of metallurgy, and I can tell you.
Okay.
Like, what do you mean? Like, it's what do you mean the properties?
Well,
in that sense?
the lead. Yeah,
is not
it has
ferromagnetic.
properties, electroconductivity, magnetic properties.
It doesn't have.
Properties.
It has. Lead doesn't have magnetic properties.
Let's get
what
to the
do you mean it doesn't have magnetic properties?
Listen, base of
lead itself. Lead is not ferromagnetic. You cannot magnetically polarize lead.
So lead, the metal, is paramagnetic, correct?
Yes.
Yeah. Yeah.
It's not
good.
ferromagnetic,
Now,
but it's paramagnetic if you have movement.
No, I didn't say it's ferromagnetic. Stop.
Okay. Yeah.
Don't do that. Don't gallop. This is the claim. The lead metal is paramagnetic. I know very well what paramagnetism is. So you don't need to explain it to me like a kindergarten. But I'm assuming that you also know. Now,
yes.
What about the lead atom? What are the magnetic properties of the lead atom?
What are the properties of the lead atom?
Yeah, the magnetic properties of lead atom.
None.
Not true. The lead atom is diamagnetic. And when it forms a crystal, a metal, when you have more lead atoms, they crystallize into a metal, and that's when they are paramagnetic. This element, now
wait, lead
has
lead
opposite magnetic properties in the same time, and because of these opposite magnetic properties, the lead is always attracted to itself, to lead metal. So when you have tiny pieces of lead metal, they are attracted together. They conglomerate always.
No, they will get attracted to to a other magnetic field, but not to itself, because that's why they're paramagnetic.
No. Have you ever seen these gold diggers? They use this ladder, where you pour water, and sand, and the gold deposits on the bottom, and the water washes all the dirt and sand away, but the gold remains because it's heavier. When you do this with lead metals, when you do this with lead, you will find that lead not only deposits itself into those crevices, but it also conglomerates itself into one place, one blob, one pile together. Because the lead metal is attracted to itself slightly. Magnetically is slightly attracted to itself. So these are very well known magnetic properties of lead metal.
If you say so, I'm certainly searching for information on that because I'm not as well versed in that as you think.
These are the most expert physicians.
Look in the live stream voice text channel.
The biggest physicians.
Excuse me?
Dude, we post everything in the live stream voice text channel. It's the text channel right above the voice channel.
Oh, I've never seen that one before. I think because before I wasn't allowed to talk, I couldn't see the text channel.
Yeah, are you VC verified now? You got
I
the
have
role?
no fucking idea. Wait, let me check.
I'll
VC
give it to
verified.
you.
I'm verified. I can see.
Yeah, you can't see that channel unless you're VC verified because people will come in and try to spam and porn and.
I see. Because is that the channel you can see in the live stream?
Yes.
Okay. Yeah. Okay, I'll look into it.
Anyway, let's not beat gravity to death because the whole point is that, I mean, even mainstream science admits that there's problems with the theory of gravity. It's not one of the fundamental forces, right? In the standard model of particle physics, it's admitted that there's a bunch of problems with it. People come in here like, hey,
of course, yeah. I mean, there are like problems with everything, like more or less, like there is nothing concrete.
No, not
per
with
se
everything.
in science.
There's no problem with boiling water.
Well, there actually is. There's a lot of stuff that goes into how, when, and where water will boil differently.
Listen, when you put water in a container and you add heat to it, it will boil. You will reach the boiling point by adding heat. So you have the cause and effect. 100 Celsius. The boiling point of water
I lived at a place where water boiled before that.
In vacuum, the boiling point drops. Yes, we know.
Exactly. So it's not always.
I just told you. I told you from the beginning there is no problems in boiling water, like there are problems about gravity. And you said
there's a bunch of variables. Yeah, boiling water is a bunch of variables, but we know all the variables, right?
Yeah.
So we know the cause.
We know. I don't like. I don't know. I haven't researched into boiling water.
Pressure, temperature, salinity.
Yeah.
Number of air bubbles are in it. There's a whole bunch of variables to determine its boiling point. Typically, we only deal with pressure and temperature.
Yeah.
But I don't know. Like I wouldn't be able to tell you that there isn't another thing that I don't know about that also influences it in a little way. Like that's I don't know. I wouldn't know about that.
Well,
I can tell you.
So let me tell you. Like, let me just go. Like, I want to go back to the beginning, kind of. So our point is, we base our view on experimentation, not things scientists say, not stories, not anything like that. What
I don't
is
give a
the
shit what someone else does.
experiment?
Yeah, exactly.
Yeah, so like I don't like, you know, if you read a scientific paper, it'll have an abstract, it'll have the experiment, and it'll have their conclusion. I don't even care about their like the abstract and the conclusion. I only care about what the experimental results. So we know that we cannot we don't have a viable independent variable for determining the causal mechanism for things falling. Because if I take, in the example you used, if I take a 100,000 kilogram lead ball and a 1 kilogram lead ball, and I drop them, the so-called cause, right? The mass has changed, but they're both falling at the same rate. So according to the scientific method,
If you don't have a difference, a difference in aerodynamic forces of the balls, yes.
Yeah. Also, so no error.
Right, like everything
right?
stays the
fall
same,
at the
just
rate.
the mass is different. Right.
Yeah.
I'm
but
bored. Yeah.
But that's the claim. That's the claimed causal mechanism for things falling. Mass attracting mass, right? That's the cause. But there's no experiment that demonstrates that. That's the problem. But I mean, a lot of people come in here with gravity. They think that Newtonian gravity predicts a bunch of particles will form a ball, but that's actually not even a prediction of the theory. So they've run this in simulation, and they can't get an ensemble of particles to actually form into a ball. So it's a common thing that people just say, oh, gravity, so gravity is as a consequence of gravity, things will form into a ball. That's not even true.
Yeah.
Can you link me, because that would be interesting
the,
evidence. Can you, if
well,
you
I'll
link,
post
can
in the
you link
live
it
stream
to me?
voice text. So what they did is this is an astronomical journal, tried to simulate like formation of asteroids. So they used Newtonian gravity. They couldn't get the shit to stop moving around, so then they added like what they call a stickiness factor, right? So basically, when the things would, it was like almost like a glue. When they would hit each other, when the particles would hit each other, they would partially stick and then bounce. And eventually it formed into something. It wasn't a ball, it was a freaking egg. And this is cheating. Even with cheating, they couldn't get it to happen. But I'll post that in live stream voice text.
Yeah, go ahead, man. Because I didn't know about that.
Mm-hmm.
Well, it's funny. It's just like something that they teach you in school, right? Right? Because it sounds good, right? Sounds good. Gravity will form things into balls. But no, who actually did the math to test that out? Is that a prediction of the theory? And it turns out it's not.
Well, then,
But
yeah,
give me like 5 seconds.
I think the so if you look at objects, let's say in the asteroid belt, but if you don't believe that there's an asteroid belt, then that doesn't count as evidence, so that doesn't work.
Well, I can look at the sky, at the night sky, and make a fortune telling. That will be the same with looking at your hand and predicting your future. Yeah.
Both bullshit, exactly.
Well, we'd have to look up there and speculate as to what's going on. And there's a bunch of different theories competing for speculative power. Quote unquote, gravity pulling stuff to a ball, electromagnetism, which I would go with, and other stuff like that. So it just depends on which theory you want to speculate with. But do we see this gravity thing pulling things into balls for a ball shape, say? Not really. We just look up there and infer, assume that that's what's going on.
But the problem is that I can provide you even mathematical equations, explaining logically correct and mathematically correct how I'm doing your palm reading and predicting your future. But I need you to pay me right now before that future actually takes place. So would you believe that this is something real, that I can do? Foretelling you your future?
But you wait. What did you start with? What did you say is a good way for telling the future? Or what was the question about?
Well, I can, when I'm doing your palm reading, yeah, I take your hand and I look on the lines on your hand of your palm, yeah. Now I can come up with logical and mathematically correct equations, yeah, calculations, yeah, and I'm telling you that these equations and calculations, they all say that this will happen in your future. You will win the lottery in 2 months. But I need you to give me half of those money right now before you win it. Because obviously there's no cost for you.
I don't see an argument.
You got to use bumps on the head.
But getting back to alternatives
I'm a bit
gravity,
confused.
well, I think he was talking about it being ridiculous to give the palm reader money before you see the future event or something like that. Being similar to these theories of gravity that we have to trust in a similar way before we see if they're actually valid with an experiment. I think that's basically what he's saying.
Right, but okay. Let's say the palm reader, like the palm reader has done this a million times before, and it has always been true. Would you then give him your money?
Yeah, I probably would, but I mean, with gravity, do we see stuff clumping into balls in our everyday life? Not really. I mean,
Well, yeah, but like gravity is a really weak force.
but gravity is a weak force, number one, which is a problem because it's not consistently seen. It's so weak we don't see it consistently. So it becomes a little suspicious. It could be, I don't think that it is. It may not be, though. It could be, it may not be. But it's just so inconsistent, it's kind of hard to tell.
I mean, that's why we would need to come up with good experiments.
Yeah. And some people are trying to absorb gravity under electromagnetism. It seems like gravity is invoked like a spell, like some sort of occultic spell to explain why we don't fall off of a ball. I mean, past this invocation, gravity doesn't even seem necessary.
But then if it's not gravity, what is it then?
I'd go with electromagnetism over a flat, motionless plane.
Me too, yeah.
Electromagnetism.
All these governing forces, electrostatic, electricity, and magnetism. The manifestation of these forces actually dictate how elements behave in nature and how they layer themselves according to temperature and electrostatic voltage, potential charge.
We get stuff to levitate by putting a bunch of electricity into, the quote unquote, the experiment.
Yeah, electromagnets, electromagnetic levitation of frogs. They are living organisms. Yeah.
It just seems that the thing that has more promise is electromagnetism. Gravity, for all intents and purposes, is dead weight, pun intended. It leads nowhere. It leads
so
the
what
mind nowhere, it leads the experiment nowhere.
So what experiment would we use to...
One very important thing to know is that electromagnetic levitation is not anti-gravity, but it actually shows that what's happening is actually exactly everything that anti-gravity was supposed to.
But you were asking about the experiment of what?
Yeah, like let's say so let's say we say, okay, electromagnetism is the reason for the quote unquote gravitational force we see. So like what experiment would we use to confirm that? Like,
well,
or like has it been done before?
Well, these experimenters, don't always set out to say we're going to prove electromagnetism causes gravity. There's a bunch of different experiments that kind of basically make people infer pretty comfortably and assume pretty comfortably that it's electromagnetism instead as a general framework. There was an
But
experiment, I
then
think, from the
how can you?
19 teens and the 20s that basically changed the magnetic fields, and you got a different quote unquote gravitational acceleration toward the mass just by changing the amount of electricity in the experiment. I forget what it was called, but these experiments and others, are general observations that are making people say, you know what, maybe the money's in electromagnetism.
Well,
but how can you? So because I would, if it was the case that gravity isn't the answer, but electromagnetism is, then I would need some kind of proof for that. Because now you're just giving a lot of doubt about gravity, and I can't explain everything you're saying, but also I'm not the smartest man on earth, I'm just some dude. But if I want to believe, what's true, and
you were asking for an experiment, and I can give you that. There is this guy, Boyd Bushman. He was a retired Martin Lockheed engineer. Martin Lockheed is the U.S. company that's making air fighter jets, stealth airplanes for the U.S. military. So it's a big company, corporation.
Lockheed Martin.
This guy, Martin Lockheed. Now, this engineer, he discovered that when you put two magnets that oppose each other, you glue them together, with super glue, the way they repel each other. And you take another two magnets and you put them together the way they attract each other. You make this setup, and you weigh that both of these objects now are having the same weight, and they have the same shape. You take them up on a building, and you drop them in the same time. Which magnets will fall the first on the ground? Which ones do you think?
Which one would hit the ground first?
First, yeah.
I don't know. I would personally expect that both of them would hit at the same time, but I haven't run the experiment. I don't know what the results would be.
The magnets that will always hit the ground first will be the magnets that attract each other. The magnets which repel each other but are glued together, those will always last at a slower acceleration rate. Very small difference, but it is noticeable and measurable. And when you do this experiment, you can see it for yourself.
I'm gonna try that out.
Yeah, and I recommend you also this using opposing magnets when you do, because this heliocentric religion perpetrators, they like to point this experiment with a pendulum, swinging a pendulum, and how this pendulum starts deflecting. And they claim that deflection is actually caused by the rotation of the Earth, which is ludicrous because the pendulum itself is being hanged on a support which is supported on the ground. That's the only fixed support that we have, the ground. And when you use opposing magnets as the weight for that pendulum, you will see that deflection is not taking place anymore. They just swing from left to right continuously, until it stops. It comes to a stop. But you will not see it deflecting like clockwise or counterclockwise.
Can someone, like, what do you think, like, Indio, you posted this video of one of the fun experiments in
Bremen
Finland?
drop tower. Yeah, so the Bremen drop tower is like a 4-story vacuum chamber.
Yeah, I know.
So
I've been there.
Oh, okay. So this guy did the experiment where he dropped different metals that had different properties, and as you can see from the thumbnail in the YouTube video, that they all fell at different rates.
Yeah.
Right. So
they all fell at different weights. Where do you
all those
see
pieces
that
of metal, because they're all different heights. Dude.
Yeah.
So they dropped that whole. They put it. So what you do, you
have
take
a
your
pod,
experiment,
you shoot it up, and it comes down in the end again. I know.
Yeah. Okay. So when they dropped it, all those pieces of metal should be at the same level. They should be the same height. For them to, if they all accelerate at the same rate, they're all going to be at the same level.
Yeah.
But you can see on the thumbnail that they're not.
Okay, but like but like when with this, wait, they should all be at the same height. What do you mean by that?
Go by the 5 mark. It's in the thumbnail that Indio posted at, 1920 after the hour. You can see the metals over by the 5 mark, and they're all at different heights. So they dropped them, and I guess they took a picture for that thumbnail. And you can see that they're dropping at a different rate because they end up at different heights at the bottom of the tube when you take that picture or something like that. Those are metals that are each at different heights. One's closer to 5, one's closer to 0. All of those metals are dropping at a different rate, basically. And so based off of their, electromagnetic properties, that appears to be determining how gravitative they are, quote unquote, gravity wise. If you're talking about gravity being the explanation for why things rise or fall or sink or whatever. You see it?
So, but like, okay, when we start the video, all of the pieces are in, quote unquote, are in free fall.
Yeah.
So like there's gravity is acting on the whole pod. Like they're in free fall the whole time. Like the gravity is acting on the pod and on the pieces inside them. So like from their point of reference, they feel no force in relationship to the pod that they are in.
But they appear to be dropping at different rates because of electromagnetism. I can't see how the normal.
What do you? But then when you look at the metals and how they behave, I don't see a clear correspondence to electromagnetism.
So you think that
each one of those metals has different. Each one of those metals has
magnetic
different
properties.
magnetic
Exactly.
properties. Yeah, that was why that guy he did this experiment and then they kicked him out. He isn't allowed to do experiments anymore. I don't know what his exact theory of gravity was because I don't speak German, so I don't really know like what his deal was. But this is just a test that he did, and then after he did it, they said no more.
So this Thorsten Müller guy?
It's some
or like
German
the guy that
He's
uploaded the video, or someone else?
Yeah, the guy that uploaded the video, he's a German guy. He did the test. He also has a website. It might be in the description of that video.
I can speak
Like I said,
German,
I don't
so that's
speak
no
German.
problem for me.
Yeah, you can? Beautiful.
Yeah.
I think his hypothesis was that, gravity has some electromagnetic link. I don't know the details, but, like I said, I don't care about what people say. It's just a test, you know what I mean? He did this test.
But like on this guy's channel, I don't see anything else about
Is there a link to his website in the description?
Not in the video description. There's just in the video description. There's just a link to the website of the institute where he did the experiment. I can try and find it.
Check his about page.
It's empty. About page is empty.
Lame.
Yeah.
Yeah, this information which comes against the theory of gravity, Newton and Einstein, or the heliocentric model, is often being fenced or removed.
Right, but like Einstein went against the like at the time accepted theory for gravity, and people tried to prove him wrong and they couldn't. And like I don't so like and he's one of like if you ask people now on the street like for a physicist.
Story. Listen, I tell you a nice story about unicorns. Yeah. How these unicorns live in people's garages, they are invisible, nobody can see them, and they are doing so many miracles for us in our lives, you know. How can you deny that story?
Well, the thing that made Einstein good was going against the establishment on some level, but the way that he went against the establishment was so problematic because it was just so wooey and mystical, talking about relativity basically destroying any sort of rational metric for measuring this physics and stuff. What does it mean when he's invoking this relativity?
What do you mean it was? What do you mean it was irrational and mystical? I mean, he came up with a whole bunch of equations that if you want to test them for different factors, you get the results as you get in real life.
You have a substance to test. I mean, it's not talking about anything mechanical, anything touching something else to cause this to happen. Something that can touch something else that can be experimented with in a lab or something to see if that's the case. There's no mechanical operation here for why these reference frames matter, or why the clock in the thought experiment is running slower. And so at that point, it becomes untestable. It just becomes mysticism.
Wait, but before we went into this whole thing, when we get asked how you can see the difference in time, and then I wanted to propose like having two clocks, two atomic clocks, put one on a plane and fly it around the Earth for 30 years, and one just sitting at the same place on Earth.
Mike,
see a difference. Yeah, go ahead.
Yeah, so I'm interested in the bending of space-time, but you see, when I ask, if you are 20 years old, yeah, and I ask you what's your age, then you're gonna tell me you're 20 years old, correct?
If that was my age, yes.
Yeah, good. Now, when you say that you believe what Einstein says, then you should say, my feet are 21 and my head is 20.
Well, no.
Yeah, because Einstein's theory of relativity, this is what he's saying, that your feet are older than your head.
Right, but not a year.
Not a year. I was just giving an example, but yeah. According to him, it means that your feet are older than your head. Now, that difference is a fraction of a second, a year, 1,000 years. It's irrelevant. There is a time difference.
Yeah, it would be. There is a time difference, but it's so small that it's
your age is not 20 then, neither 21.
Well, if you're looking,
but like age is just a concept we came up with in that sense. Like I'm a bit like, what are you disproving here?
How can you bend a concept? How are you going to bend a concept, something that is not physical?
Well, even with this conception of space-time, sir, there are more mechanistic explanations that at least try to say there's some sort of substance that we hope to find to manipulate to see whether this, concept is the case or not. People talk about the substance of space, the ether, running against the clock, making it run differently. Because basically, these clocks that they were testing for their relativistic guesses were cesium clocks. They thought that they worked by vibrating. Every million vibration, you click off a second on the clock mechanistically. And so, if these cesium clocks that they're using to measure relativity are coming up against a substance that is squeezing the clock mechanistically, it will run differently, vibrate a little bit slower, and register a different time. Less mystical, less wooey as an explanation, and at least tries to offer the hope of a mechanistic substance.
Wait, but you're saying
the material of the clock, making it work differently, and much
so
more
so
for a guy like me.
so you're saying it's like the ether makes it happen?
Pretty much. The substance
Okay,
of
so
the
but
ether
then
squeezes against the clock a little bit differently, and voila, there's your relativistic clock. Assuming that this thing happens, which people say is the case, supposedly.
but like then we could test for that, couldn't we?
We would have to try to infer that this is the case, guess that this is the case, or try to get some of this substance and manipulate it. But at least that
But
would
I mean,
offer
couldn't
a
we?
more
But couldn't
testability
we?
than
Couldn't we?
just saying that it just happens because of mystical relativity or whatever.
But like, couldn't we test for that in sense of having two of these clocks going in different directions in the same right? Couldn't we test for that that way?
Experiment like with the interferometers, which prove that the Earth is not moving, yeah. And the interferometers today are one of the most precise measuring instruments. We are using them in automotive and aerospace industry in precision metal parts production. I myself used interferometers to measure the parts that I was grinding, metal parts. I was measuring in nanometers, like the thousandth of a micron.
Yeah, and we also have the Yatvas effect.
And I can tell you, sorry, Lemon, I can tell you that when I was placing that part on the interferometer to measure it, if I put my hand on the table and just work at the keyboard, and stuff, that table will be moving and it will be affecting the measurement. So that interferometer had to be very still. So while it was performing the measurement, I cannot lean on the table or have my hands on the table because you make vibrations which will affect your measurements.
So people are very comfortable inferring that space is the substance of ether. That is basically in these experiments on some level. That's what.
But didn't didn't the Michelson-Morley experiment disprove the ether theory in the sense of that we didn't see a difference
on paper, but the thing is, they did get a 5 to 8 kilometer per second ether drift. Basically, they're saying in these interferometers, they had the experimental framework to try to interpret what's going on in the interferometer when you split light. You send light down two paths in the interferometer and recombine them. And for some reason, the light's out of phase. They said space has to be a thick treacle, a fudgy substance that's slowing down the light. That's the only way to explain why one or both of the light paths were slowing down and coming back out of phase, giving you a light, dark, light band pattern. And so that's the way people interpret these experiments, to say space has to be a thick substance that's slowing down the light.
Space has to be a fixed substance that's slowing down the light.
Like a fudge, thick like fudge. THICK. Thick.
So, I would like to get with you through the 3 points. This is something we do with all the people that come here are new to the server. Just this is not a contest, IQ test, nothing like that. So don't be afraid. If you don't know the answer to one of the questions, just say, honestly, I don't know, and we can move further. And at the end, I will tell you what it was all about. Are you okay with this?
Of course, yeah, no problem.
Good. So the first question is, do you know which man in history was first that he measured the Earth's curvature, and by which method?
The first man like that we know of?
Yeah, the first man in mankind history who discovered that the Earth is a globe, and he measured that curvature.
It was a Greek philosopher. I can't remember exactly which one. And as far as I know, he used sticks. Like at first, he came to it with like wells because he heard of a place, didn't he? Like
Yeah,
I think he measured the angle of sunlight of the sun in different places at the same time, and then depending on which version of the measurement of the ancient measurement he used, which is stadia, isn't it? I think.
So the guy
he
was
came quite close to.
This guy was Eratosthenes in ancient Greek, 273 BC. Yeah.
Right, he was the first to measure that one. But as far as I know, the Greeks knew that the Earth was round before he measured it. But that, I couldn't confirm that. I don't know. I can't speak ancient Greek.
You started to explain the method. Obviously, you don't know the exact method he used, but that's not a problem.
Well, I mean, he like in one town, there was the sun was directly above, so you had no shadows.
Alexandria and Syene, yeah. The city of Alexandria and Syene in Egypt.
Yeah, and didn't they in Syene have a day of the year where the sun would come to be directly above, so you wouldn't see any shadows?
And the problem is between Alexandria and Syene was 800 kilometers. They were 800 kilometers apart. And he's also the first man who ever measured the distance accurately between these two cities by walking on a camel. Yeah, so that's how he measured it.
Well, that
But can't we like looking at what he wrote down as his measurements between the cities and looking at the distance of the cities today? Can't we confirm that he was kind of correct on the distance between the cities?
Well, up to a point, but there was still the assumption that, the Earth was a ball. That's not necessary. You basically take two parallel lines, two lines that are supposedly never meet in math, and you cut them, and you get angles that are equal. The angles that are opposite each other are equal, and it makes sort of a Z. But you have to have parallel lines. He had to assume that light was coming from the sun in a parallel, way to make a Z basically with alternate angles that are equal to each other for these sticks and shadows to even mean anything. So he first had
couldn't you get around that? Couldn't you get around that problem by measuring in 3 points?
But you're still going to have the same problem because even over a flat surface, you could have different shadows of different lengths over a flat surface without it even needing to be a ball. The main problem is it has to be a ball first, and you have to.
But wouldn't you? No, but wouldn't you if it was a flat surface and you had 3 points with 3 angles, and if they meet at one point, then you could be quite sure that it's not a ball that you're sitting on.
Yeah, potentially, but you can still have
No.
a flat surface. That's the main thing. They basically said that the sticks and shadows were making a Z with the center of the Earth. The top part of the Z was the shadow that the angle to the shadow in Syene, Egypt. That Z goes up to the pole in Syene, Egypt, from the shadow up to the pole at 7 degrees. That pole goes down to the center of the Earth. The bottom part of the Z comes out in Alexandria, Egypt, straight up to the sun. And you now have two angles that are equal, 7 degrees to that top part of the Z and 7 degrees from the center of the Earth. That's the assumption. And now you can just do simple math formula to get the whole ball, assuming it's a ball and the Z is intersecting the center of the
Yeah.
ball. So 7 out of 360 would be your fraction. 7 degrees out of 360 total degrees is equal to 500 miles to Syene, Egypt, divided by the supposed circumference of the Earth. But that Z is meaningless if we're not on a ball.
I
Yeah,
completely
so
agree with you, but that's why when you take it from multiple
he
points and looking then at
from the assumption. Listen, he started from the assumption that the Earth is a ball, is curved, and the second fallacious assumption is that the sun is a collimated light source. Now, as a university student, I suppose you study physics. Am I
not
wrong?
necessarily, no, but I have small amounts of physics in there, yeah.
Okay, so you don't know about collimated light sources.
What is the word? Collimated?
Collimated
parallel rays.
light sources, yeah.
Parallel rays of light.
Yeah.
I want to make a historical correction, just real quick. There are no primary sources for Eratosthenes. There's not even secondary sources. There's tertiary sources.
Yeah.
Number two, we know the experiment, if this guy ever existed, is bullcrap because they didn't have degrees in his time. The Greeks didn't have degrees for another 300 years. They only saw the particles into 12 for the zodiac. And the other problem, I just lost my train of thought.
He didn't have degrees.
The primary, tertiary source.
At the time, Greeks thinking it's round. So Thales of Miletus, he thought the Earth was flat, and I'm sure you've heard of Thales' theorem, right? He measured the height of the pyramid using, sticks and he used sticks and shadows to measure the height of the pyramid, right? But he was a flat earther. He lived in the same city at the exact same time as Eratosthenes lived. We have his primary sources. We don't have Eratosthenes' primary sources. And there's actually doubt in historical circles that this guy ever existed at all. Because there's so many problems. The stod, right? The stod itself, the unit of measure he used, is not known within even 30%. Right? And on top of that, the person he said he hired to walk that distance, it's a Greek word in ancient Greek. It doesn't appear in any other Greek text ever. So this profession he literally invented.
But then what does that... Okay, let's say we don't have good evidence or even like any really...
Of course you do a replication, right? You do a replication. So if you go on YouTube, there's a guy, he says, I proved the Earth is a ball with my bike. Right? Have you ever seen this video? It's got something like 4.something or 1.4 million views. So he did Eratosthenes.
No, I don't think so.
Well, so he takes 2 meter sticks, 4 meter sticks, right? But two of them are in an L, right? So he measures the shadow of 1 meter stick on the other meter stick. And he measures the difference in the shadow length, does the calculation, comes up with the claimed circumference within something like 7%. But the thing is, he didn't actually do his experiment carefully because he was in the parking lot. Before he left to go on his bike ride, he measured different shadow lengths inadvertently. The camera caught it. These 2 sticks were 3 feet apart. And he measured a 1/2 inch difference in shadow length. This alone proves that rays of light from the sun are not parallel.
So you're saying he lied about traveling a certain distance?
No, he didn't pay attention. He didn't lie. He didn't pay attention.
Okay.
So him and another guy filmed, right? And before, like, so you got this video, right? So the video starts off, they're in the parking lot, you know, it's a YouTube video. So before he goes, so he sets up the stick in a parking lot. But before he leaves, right, to go on his bike ride with his other stick, he inadvertently filmed both of them next to each other.
And they weren't the same.
And they're not the same shadow length. And I'll post a picture of it in the live stream voice text.
So basically,
Okay.
that shows that parallel light, the sun's rays are not parallel enough for the main postulate of the Theratosthenes thing, that you have parallel light giving you this Z that's slashed and giving you alternate interior angles in the Z that are equal for these fractions that they're trying to generate for the Earth's supposed circumference. It's just bad assumption at that point.
Maybe if you, unfortunately, it's in German, because I know that this guy did a similar experiment, and he, like, similar in the sense of he asked a bunch of people to send him picture and video of the shadow length of a stick from all over the northern hemisphere, and he then calculated it. He then calculated he graphed out the measurements, and it correlates with a ball and not with a flat surface. So, like, if you skip close to the end in the video that I posted, there is, I think it's at 1735, around that time, you see he had marked the spots, and 10 seconds before that, he marked the results on a flat plane, and also what would be expected on a flat plane, and then, like, what would be expected on a ball and what actually happened. And he has all the measurements he used for it. He shows it in the video.
The thing is, if you have a sun that's circling over the flat motionless plane, your triangulation up to this object is only going to be good for as long as it's quote unquote in the neighborhood. It would be like trying to triangulate the distance to a light pole that you can obviously see in the neighborhood, even over a flat surface, but you're not going to be able to triangulate it in China because you can't see it. It's the same thing with the sun when it circles too far.
Well, of course, if you can't see the sun,
as long as you can see the object. Past that, your triangulation will be all over the place.
Well, of course, but like the shadow, like if the sun casts a shadow, then you obviously can see the sun. Or am I getting this wrong?
Up to a point. But after a while, it will circle too far away, and perspective, vision, the laws of perspective will kick in.
I'm
not going to be able to make out the object anymore, and your sticks and shadows will be all over the place as the sun circles all over the place over the flat motionless plane.
Wait, but like, if you can't see the sun, how can you still have, like, direct sunlight from the sun?
You would be able to see it for a couple hours while its light is in the neighborhood, while the spotlight of the sun is close to you. When it circles too far away and you can no longer make out an image on the sun, no triangulation. Somebody somewhere else will get a slightly different triangulation than you because they're able to see it and you can't.
Wait, but like, if I can see the sun in the sky, you're saying I can't use a stick and a shadow to measure the angle to the sun?
You can use it as long as you can see it in the neighborhood. When the circle's too far away, your triangulation will be all over the place because somebody else will be able to see the sun and triangulate to it in their neighborhood, but you won't be able to see it in your neighborhood. It's too far away.
But like,
you can measure the angle of elevation to the sun. Yeah.
Exactly. Yeah.
When you see the sun in the sky, you can measure the angle of elevation. But for that, you cannot do that on the surface of a ball sphere because you cannot have a angle.
Why can't I have an wait, what?
Well, show me a straight line, yeah, like a tangent to a circle, yeah. What's the angle between them, between the circle and the tangent line? What's the angle between them?
0. Otherwise, it wouldn't be a tangent.
Well, you need to have flat lines for an angle. That kind of
So,
contradicts a ball where
yeah.
there's no flat
You need
line.
straight lines. You can't have angles with curved lines.
But we aren't measuring the angle of the sun on the
When
sphere
you
of
are
the Earth,
measuring
but
the
we are
angle
measuring
of
the
the
angle of the sun onto
elevation,
a
that's what you're
tangent.
doing. Yeah.
No. But as soon as I put up this desk here, which I know is a flat surface outside, and I make it as level as possible to the gravitational pull. So like to what we think is like down, to what you would also say I think is down, to where all the forces lead you. Like and then this table is a tangent on the spherical Earth. And so then when I measure the light's angle on that, then I'm measuring the angle of the light hitting the tangent in the point where I'm standing on the ball. Like I don't see what you mean is the issue here.
That light is divergent. The light rays.
Look at
Yeah.
Well,
light rays
if
are
it depends. It depends on the size of your object you're measuring against, and the size of the size of the object emitting the light.
Well, going back to these sticks and shadows working on a flat plane, it doesn't look like Eratosthenes or whatever is really giving us anything definitive enough.
Right, but he wasn't trying to prove the Earth, wasn't he? Like, I mean, let's say, like another guy said that, like, the evidence isn't really clear on that. I'm okay with that. I haven't researched into if everything he said was true. But I'm saying, like, if his idea wasn't to prove an Earth, a round Earth, wasn't it? He wanted to see how big the Earth is, and so he went in with the assumption of trying to measure the circumference of the Earth, and so that's why with his experiment in particular, you can't directly prove. You can't prove a globe Earth or a flat Earth.
No, this measuring of
Okay, that's the point. Hold on, Geppy, because where did it start?
Go ahead.
Do you know anybody that's ever measured the curvature of the Earth? You brought up Eratosthenes, so that would be a big fat no. See, we always get down this Eratosthenes rabbit hole. There's so many fundamental assumptions in his so-called measurement. Okay, so here's a fundamental assumption: that everybody that's looking at the sun, that it has some common location to everybody, and that is actually not true. Okay, so this Eratosthenes, there's a guy who's dead now, flat earther. His name is Antonio Subarets. He did a 24-hour Eratosthenes experiment on a live stream. So what people did was, this is on the equinox. People did was they got a standard gnomon, so they used like a 10-penny nail. You could print off a PDF of a file. You direct it to due north, and what they did was at solar noon, they timed the length of solar noon and they measured the direction of the shadow, not just the length of the shadow. What they ended up finding out that the direction of the shadow isn't pointing to the same location. So what this led to was people actually YouTube deleted like 3 of his channels. So that
But do you have like, I don't know, does he maybe have a blog or something where he has a transcript or like the general data for the experiment? Okay.
Yeah,
well then, but then, like, why do you bring it up? If I can't see it
because there's more than that. It was going to more than that. There's more than that. So
okay, then go
because the results of this test, so people started checking, right? So people went on time and date or sun calc, right? They give you the azimuth and elevation angles of the sun from a bunch of locations. So what a couple people did, one person did it in Blender, one person did it in AutoCAD, right? So you model it out. You take the elevation angle and the azimuth and you model it, right? 2 locations, same time, right? Azimuth and elevation angles. You see if those lines of sight intersect. And guess what? They don't. Sometimes they actually intersect behind the observer. right? And I can post it to it being demonstrated in AutoCAD and another one in Blender, right? So this is, and if you go on Google Earth and you actually you start drawing lines east, all the lines pointing east end up going toward the equator. They don't follow the latitude lines, which is another like anomalous point. The point I'm trying to make is there's a fundamental assumption that the sun is at some common location. When we're all looking at it, we're all looking in like the same direction at some point in space. That's if you believe time and date or sun calc, which are, like I said, gives you the azimuths and elevation angles. Those lines of sight don't intersect.
Can you post it? Because like I don't know, like I can just like
I'm gonna post 2 videos that demonstrate it. Okay, like if I'm say there's a car in front of me and there's someone 100 feet to the right of me and we're both looking at the tire, we're both looking at the same point in space, right? Both looking at our lines of sight converge to a point in space, but this isn't happening with the sun. If you use the azimuth elevation angles, right, and draw a line from the surface of a ball to a point in space, they don't intersect 93 million miles away.
But like our idea is that the sun puts out parallel lines, so they shouldn't intersect.
But that
Like
doesn't
wait, what do you mean exactly in this case? They should stay parallel until they hit the surface of the sun.
They don't intersect. I said they don't intersect 93 million miles away. They intersect in all different locations. And when you start adding multiple people, right? With 2 people, they'll either intersect too close or behind you. But in Blender, when you use multiple locations, the lines are pointing in every which way direction. They don't intersect anywhere. And this is where Antonio found when he mapped out, when they did their experiment and they mapped out, another thing he observed, which was really weird, was that the length of time solar noon, right? So you measure, it's solar noon because the shadow is the shortest on the equinox now. So the shortest the shadow is of the measurement is solar noon. He found out the variation of solar noon was between 3 minutes and 7 minutes. As in, solar noon is 7 minutes long or 3 minutes long, which is a giant variation. But anyway, I post those 2 videos.
Wait, I'm confused. I can't post pictures or long links into the
you
text.
can't do that. You are new here, and yeah.
Yeah, but like even the link, maybe if I shorten the link, that one works.
No.
I mean, there's the link to the picture. Yeah, but like I'm a bit confused. I'm a bit confused by the argument before that the lines should meet at one point if we think that we're on a globe. Because I mean, isn't that the whole idea that we assume that we want to see parallel lines? Or
well, that's used as a counter argument against the flat earthers, but the globe earthers don't really have an argument. That's the problem. They're saying that on a flat earth, there should be some sort of perfect triangulation where all these points are mapping to more or less the same area, but that's false because of perspective and vision, making it so that you can't see any object, forever. You're only going to get a triangulation for as long as the sun is circling close to you before it circles too far away. And perspective makes it appear to merge with the ground or just merge with the surroundings.
but like I'm not saying we're making measurements when the sun is close to the ground. I mean, isn't that like we can just say like, okay, we discard all the angles, all the measurements in angles we get where the sun is, I don't know, let's say 20 degrees above the horizon. So we just look at all the data where the sun is above that.
Right.
Would you be okay with that? With doing that?
We could do that too. I mean, the thing is, it looks like it could work on a flat surface as far as I can tell. The Globers are making a weak argument saying that we should get this triangulation from all these places that triangulate to the same area, but you wouldn't even get that on a flat surface if the sun is circling too far away or circling overhead.
I mean, but like, couldn't we just like all in this server? Let's say if all the because I can trust all the data we get. I can trust the data from globe earthers. I can trust the data from flat earthers. Like if I say I disregard this data, then I would also need to say I disregard this data because I am not in the position to verify how it was done. I mean, couldn't we just all in this server say, well, we set a time and date, and everybody gets outside and takes a measurement, an angle measurement of the sun, and then we can combine all the data?
As long as we all see the sun, preferably within the similar time period when the sun is circling in the neighborhood. That would be the best quality triangulation. If you try to take it when it's nighttime on one side of the Earth and daytime on the other, too far outside of the time window when we're all seeing more or less the same object in the sky circling overhead, we're going to get, measurements that are potentially all over the place. Preferably, it's like within an hour or two of each other so that we get a quality triangulation, ideally.
Right, but isn't the US, doesn't the US cover like 20 degrees of latitude?
Yeah, even a city covers a huge area, but if you're trying to triangulate an object in the neighborhood, say the light pole at the end of the street, you're only going to be able to triangulate the object as long as it's close to all the observers. If it's too far from any of the observers, your triangulation will go away or just be really all over the place. You need to have people triangulating the object that are within the neighborhood of the object. And so that would be for the sun, I guess, within I don't know, an hour or two before it gets too far away or things get too crazy, if these angles in this triangulation are disappear due to perspective.
But that would
How about we just do a better test than one with like 50 assumptions?
What did you
There's
say?
a lot of assumptions. How about we just do a better test than one that uses 50 assumptions?
Yeah.
Okay, then
no matter what measure the surface of the Earth.
With which method?
Lasers.
Lasers, radar, microwave.
Some sort of straight standard to test the curvature of the Earth against. You shoot something straight over the surface of the Earth and try to hit a target that's at the same height as you. Either there's going to be a hump of Earth curve in the way or not, basically.
But haven't we done a lot of? I've seen some flat earthers trying to do the experiment and not being able to. Made it not being able to work.
You're talking about Netflix?
No, I'm not talking about the Netflix. Oh my god,
which experiment?
There's this YouTube channel. Fuck, what was its name again? And they had. Somewhere, I think it was one of the bigger lakes in the US. And they had three guys, one with a camera on one hand, one with a very strong laser on one hand, and then a guy in the middle with a cardboard and a hole at the correct height. And they was that Jeranism? I can't remember exactly. Yeah, but they didn't.
It wasn't a laser. It wasn't a laser. It wasn't a laser.
Wasn't a laser? Okay. But still, they didn't manage to.
Yeah, because it's impossible. It's impossible flat or round. Because he was trying to shoot it through 3 holes that were 8 inches in diameter, and because of diffraction,
as soon as he lifted the light further up, the camera guy was able to shoot the light.
Yeah, because he's not going through 3 holes.
He was going above the thing.
Yeah, that's right. Not through 3 holes. Yeah, exactly. Not through 3 holes.
But on the camera, you could. As far as I remember, you could see
He's trying to send something through 3 holes. Every time light passes through a narrow aperture, it spreads out.
But that's measurable, isn't it? We could just say we increase the strength we increase the amount of light rays we hit through, then more will pass. And
yeah, if he did that test, yeah, fine, but he didn't do that. He used a flashlight because he had a laser with a collimator. He left it on too long, and the collimator melted to the laser. Because the collimator, so the collimator obviously gets hot because it takes the divergent rays and it makes them parallel. So it gets super hot. You can only leave it on for like 5 seconds. And he left it on too long and it melted. But all those people there. So he's just like, fuck it, I'll try it with the flashlight. And obviously he got what he got. It probably wouldn't even have worked with the laser because you got to think, man, how hard is it to aim a laser through an 8-inch to 3-inch diameter holes that are spread out like 1.3 kilometers? Yeah, definitely not with your. I don't know if you could do it. Even mechanically, it would be crazy hard.
you would. I think it would be possible with a flight with a like a tripod, and if you like range it in properly. But I don't know.
Just getting the holes lined up. But think about how hard it is to get the holes lined up.
And have any kind of wind at all touch that tripod, and you're off by 100 feet at the other end.
So yeah, we can discuss a test on Netflix, right, with a flashlight, which we explained how that didn't work, but that wasn't due to curvature. Listen, we can show you laser tests over 24 miles. That's approximately 40 kilometers done in the Netherlands. You wanna? Oh, sure.
I wanna. Yeah, go ahead, man. I mean, you could tell me all the time. Like I could tell you all the crazy shit I supposedly do, and say, well, it proves, but I don't show you that. But doesn't do anything.
I just post you the document in the live stream voice text. This is a laser test done in the Netherlands, Lake IJssel. They set up a laser at point A, then they set up a target, the camera, point B, and they shot the laser to 3 points, right? So they panned the laser from point, let's say, target B, target A, target B, target C, and target C was the furthest one. So they panned that laser to A, B, C, and they all three hit. The first one was approximately 40 kilometers, 24 miles. So if Earth was a ball, then that laser would have overshot the target with 100 meters.
Okay, so the first one, I need to read through the whole document. The first one is 12 kilometers.
Yeah, you have to look at measurement 7.
Measurement 7.
That's at the end, yeah. Go ahead.
So there's the first 2 were done in Hungary at Lake Balaton. The next 5 were done in the Netherlands. So what happened is when they did Balaton, they've actually done like, this group has actually done like 3 laser tests. Cobra say that's not good enough. That's not good enough. They did one at Balaton. What they found out by hand. So what they ended up doing is they made an electronic aiming device where they could just punch in the coordinates, and the thing would, it would automatically aim itself. Get over 25 miles.
Yeah, and the laser test at
So
the
goal prediction. The goal prediction is that the laser should be 127 meters above the surface, but they captured it at 1.5 meters above the surface.
Wait, you're saying measurement 7? Measurement 7.
Measurement 7 and measurement 6. 7 and 6 are both the same distance.
I'll look into it.
But if you look at measurement 3, right before measurement 3, there's a map, and it shows you all 4 lines of sight, right? So what they did is they panned through each one of those, right? And each one is a different distance. So each target should be lower. Each further target should be lower than the closer one, right? Because the ball's curving, it's lower and lower and lower.
Wait, I'm scrolling to. You're saying before measurement 3.
Yeah, before measurement 3, there should be like a picture of.
Map of Lake IJssel, or however it is pronounced.
See the 4 lines of sight. 4 lines.
I see them, yes.
Yeah. So what they did is they went, horizontal pan, boop, 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 each target. So each target should be lower than the one before it. So if you horizontally pan, there's no way you're going to hit all the targets. It's a ball.
What is target 4? Where's target 4 measurements? Measurement for
9 point something.
28 kilometers. No, that's target 2. Wait, what the fuck? Nah,
It's a 120-page document. You don't have to look at it right now, man. You don't have to look at it right now. I'm just saying, this is just one test, right? So there's a bunch more. There's a bunch more laser tests other than this. The other longest one was done at Salt Lake in Utah. That was 21 miles. So this is not like an insignificant amount of curvature. This is like something like 200 feet. That means, like, if you shine the laser 20 miles, the laser should be 200 feet over your head. A 20-story building. The laser should be way over your head. It's not what was observed, though.
Yeah, we're supposed to be seeing 8 inches per mile squared of curvature, but we're basically not seeing that. In meters, I think it's like a meter per kilometer squared or something like that, but we're not even seeing that. So if an object is, like 10 miles away, you square the miles. 10 squared is 100.
That's just an approximation. That's an approximation.
It's an approximation that helps us debunk the globe, and the approximation is pretty darn accurate. It looks like that's what the geometry demands. And it only changes from 8 to 7 inches if you're 500 miles above the surface, and most of these observations are usually within a mile or two above the surface. So we're good as far as I can tell. Even with that, even with the best, math, it's just off, assuming that a line of sight runs tangent to this ball geometrically. And if that's not the nature of their claim, is if they're not making a geometric claim about straight lines basically hitting a ball, be it a line of sight or whatever, then what are they talking about? What is the nature of their claim if it's not geometric exactly? I mean, at that point, that just makes their ball untestable and unfalsifiable. They could add any amount of refraction to it to explain why we see too far over the ball with no hump of Earth curvature in the way. At that point, their claim is just effectively unfalsifiable.
But yes, I don't know. I need to look at the experiment before I can, of course, say that it proves anything to me personally.
Do you have a standard of proof? Because we have a standard of proof with this 8 inches per mile squared or whatever. Do you have a standard of proof, or are you just going to write any amount of curvature for the ball? Are you writing the ball a blank check, or do you have a way to falsify the ball?
What did you say?
Do you have?
Do I have a?
Do you have a standard that would allow you to falsify the ball and say this is what we would see on a ball? We don't see this, therefore it is or is not a ball. Do you have a method for falsification of any sort? Because we have the 8 inches per mile squared. What do you have?
Yeah, I would use the complete the not just the approximation, of course, but still speaking. I mean, if the measurements don't align with our expectations on the ball, that's a lot of evidence against the ball, isn't it?
Do you know the equation for the ball?
Not out of my head.
Just to let you know, it approximates to 8 inches once you solve it for the first.
Right. For the first few miles, but like later than that, it's the approximation doesn't work because the approximation will never look. If you look at the ball, see, let's say, and it curves off more and more and more until you more or less no longer have a ground beneath your straight line. And this is not possible in the approximation. And so also, I think as soon as you get out...
For 1,000 miles, I believe. You can correct me if I'm wrong, but it's good for up to 1,000 miles.
Yes, 1,000 miles, that's correct.
Yes. So think about what you're saying right now.
As long as you're within the range of the tolerance of the math or whatever, you still get a quality approximation. I mean, people have this idea that math gives you these perfect units that are just exact and to the T, but math and physics is full of approximations anyway. You don't get these perfect numbers. The question is, how much approximation do you think is acceptable or makes you reject the approximation? Like I said before, as long as you're within, like a mile above the surface, it's still going to be 8 inches. It only changes a digit from 8 to 7 if you're 500 miles above the surface if you work out the math. And so as far as we can see, it's a damn good approximation that really doesn't change or diverge in any significant way at all, not for practical purposes. So that's why I was asking you, do you know the equation? Do you have a standard to falsify this globe or not? Because if you don't even have a standard for falsification, I mean, all this stuff is going to be meaningless to you. We're basically saying we're seeing too far over the ball. So therefore, we probably don't have a ball at all.
Well, of course, if I need a how you
posted one. I posted a calculator. It's not made by a flat earther either. It's made by, and the formulas are in it, so you can check the formulas. You can actually change the radius and do a bunch of stuff. Anyway, so another problem with the ball is the horizon distance. It never matches the prediction. Nearly never.
Yeah.
So the horizon is supposed to be the edge of the ball, right? Be the leading edge of a sphere Earth, and it should have an exact geometric distance that should be measurable. So observations have been made which show the horizon 10 times too far, 30 times too far, and we know the distance to the horizon. Well, we know how far it isn't, right? So there's an image called the Black Swan, but there's a few images, few videos. So there's oil rigs 10 miles off the coast, and you can clearly see that the horizon is beyond these oil rigs, but the photo is taken from 1 foot, and the globe model predicts that the horizon is 1.2 miles away. So that's a huge problem, right? The horizon's 10 times too far, and that horizon only fits a globe whose radius is something like 320,000 miles in radius, 1.6 million mile circumference. And I don't think anyone believes they live on a ball that size.
Yeah, that takes the distance to the horizon equation demanded by the ball, which is 1.22 times the square root of the observer's height in feet. I think in metrics, it's 3.57 times the square root of the person's height in meters. And that one gives you the a readout of the number of kilometers to the horizon that would obstruct something your height or lower in meters. But for the foot one, it's 1.22 times the square root of feet of your height in feet above the surface. And that gives you the distance to a hump of Earth curvature that would obstruct something your height or lower. So if you're 1 foot off of the sand in that Black Swan observation, then it should be 1.22 times the square root of 1 foot or 1.22 miles away to obstruct something 1 foot or lower. But we're seeing the horizon way further out than that. Way further.
Yeah, I mean, if that's the case, then that's good evidence, isn't it? I mean, that's the thing. Like, I would need to go test this for myself, of course. I mean, you're saying I shouldn't blindly believe the people that tell me the Earth is round. So, I mean, you could as well just be wrong and it's another shape.
We 100% agree. We 100% agree. Go test it yourself.
Can I post a picture, because this is something that I personally feel like I haven't seen a good explanation for stuff like this, for like seeing when there are these, I don't know if you've seen the videos of or the pictures of how you say long straight lines over water, like power poles or long bridges.
Talking about Lake Pontchartrain?
For example.
Yeah.
The Lake Pontchartrain transmission line, because I haven't found a good explanation that works on the flat Earth model.
It's a temperature inversion. It's temperature inversion.
But then
Those are actually simulated.
why does it match the predictions for a globe Earth in more or less?
No, it doesn't.
Like quite close in a lot of different.
It doesn't. It doesn't because they make a big, huge mistake, right? So Walter Bislin modeled this out, and what he didn't notice is that the horizon that he thought was the horizon is actually not the horizon because it's actually a mirrored image. So this is kind of funny, dude. Like, you interpret the photograph wrong, you finagle a computer model to get it to match, declare victory, but you didn't actually look at the image closely enough.
But what you said, finagle the computer model. But like if you just punch in the ball and not just say, oh, this measurement, this amount of this number doesn't look right, we need to change the number. But if you just go with the numbers for the sphere Earth as they're being set, then I mean, like, I don't see the finagling in there.
What are you talking about? Which one are you talking about? Are you talking about the train line to when Jesse Kozlowski drove over the bridge, or like what?
Who drove over what bridge?
Okay, never mind. Okay, so they take a picture of the transmission lines, right? They take a picture. If you look at the image closely, right where the horizon is, you can see the last tower is actually mirrored. Where they think the horizon is not the horizon.
Can you post the picture you're referring to?
Yeah.
Because I know of millions of pictures from the place.
Oh, that's not true. Okay, that's not true.
Not millions, but like hundreds. Okay, it was an exaggeration.
Not showing curvature, no, because I actually watched the live. I watched the live stream with Soundly, right? Okay, Soundly's the person is the only person that's captured this image. Or is it Soundly? Yes, Soundly. So he did a live stream once, and he was sharing his screen. He had folders full every day, going to take 30 or 40 pictures of the power lines in the bridge. It took him 20 minutes to find one that showed curvature out of thousands of pictures. But anyway, I'll find the picture. Hold on. It shows the mirror.
The last transmission tower is flipped? What do you mean? Like, I can also post a link in here. Like, this guy goes over a lot of Soundly's pictures. Have I lost connection?
No, you're still here. I hear you. Yeah, Walter Bislin.
Look, I'm trying to find it, but my phone's like on 1%, so I might end up dropping. But I'll be back in like 20 minutes.
And if you like, I don't know, I've like these pictures to me seem like showing curvature quite well. Also going through the data. I mean the Walter Bislands, he has all the data on there as well and all his calculations. What? Bislands calculates for refraction. What do you mean with that, old dude?
Look, if you look at his simulation, it says extreme refraction. That's what it says. Look, you can look at the buoy data for like Pontchartrain. Okay, unlike normal, right? Unlike normal places, Pontchartrain's a 13-foot lake in Louisiana. The temperature of the water in the air invert 2 times a day. And you can look it up yourself. Look up the buoy data for Lake Pontchartrain. It has a graph. The temperatures taken, the air and water temperatures taken every 6 minutes. You can graph it all out and watch the graph. The temperature and water invert. Literally the worst place to make an optical observation in the world.
Well, then let's go to another. Let's go to another place then.
Hold on a second. 30,000 people a day drive over that bridge. If you can see the curvature of the Earth from there, how come nobody else ever saw it, and how come that's not a tourist attraction? Hey, like Pontchartrain, see the curvature of the Earth. Why? How come that's not a thing? Just one guy. That's it. One guy. This one guy is a proven liar. He actually said he captured Earthshine during an eclipse.
And how does that prove him a liar?
Because only 3 astronomers, professional astronomers, have even claimed to have captured Earthshine, and that was in ultraviolet. Okay, Soundly claims he captured it with a P900. It's preposterous. See, Soundly lives there, right? And because of the weather conditions, there's actually a different climate on the other side of the lake, which most people don't know. Anyway, the point is actually actual different climate, not like the temperature's different or just certain things. It's actually a different climate. Anyway, the point is that he's taken thousands of pictures. It's a place that's known to have different, unusual weather conditions. I'm sure if I went down there, I could take hundreds of thousands of pictures and capture what I want to capture.
Then why do you say it proves flat Earth?
Or what do you? Cars. So, Lake Pontchartrain, there's like a little on the causeway. There's a little hump. There's actually video of the cars appearing like they drove over this hump into the air. Like the cars look like they're driving in the air. Anyway. The point is that.
Oh, so the pictures don't prove anything. Okay.
Listen. No, not his because we have video that shows it not doing that. It's not like we don't have the opposite. We do. I think Radwin lives down there, don't he? Well, I'm gonna have to come back though because my phone's about to die. Like for real. Can't believe it ain't dead already.
It's a strawberry patch.
And I'm a bit confused. Like, you're saying the reason it looks like a globe in some of these pictures is because of refraction. But when others say that the reason it doesn't look like a globe is because of refraction, they're wrong. Like, I'd like where's the consistency there?
So the way...
Oh, did Al-Biruni measure the horizon if it's refracted?
Sorry,
Yes.
I couldn't understand a word of what you said.
How did Al-Biruni measure the horizon if it's refracted?
Al-Biruni?
Yeah, we didn't touch that, but
yeah, he's one of your.
Yeah.
Good.
So let me. The point is, when they use refraction, they use terrestrial refraction, which uses the R value, which is unproven because you cannot get the R value by measuring the horizon, right? Because the horizon is an apparent location, not an actual location. So they use this R value and then enlarge the globe, actually. So they tell you with a formula, we can prove that it is actually a globe because we use the R value to make the world bigger. You understand what I'm saying?
I don't see how that makes the whole argumentation circular. No.
You don't. So you want to prove the radius by using the radius?
No. We're not proving the radius here.
Yeah,
the
you
thing
are.
is,
yeah, you need. Yeah.
no,
So,
but like
so
you
what
can. Okay, let's go back to, like, you can get the R value by other methods, like discussed earlier, under the assumption that it is a globe.
Right.
Of course.
But you haven't proved that it is a globe, right?
Right, but it's
okay.
But using then these pictures and the measurements we use, from that, like, I don't know, like I'm not seeing the.
So you don't see how that is begging the question? Using the R value to prove the R value?
If you use the R value, then again in other measurements, and it seems to work out with that.
But it doesn't.
Then I don't see.
When we look at the black swan image.
Black swan image.
So when we look at the black swan image, the horizon is 10 times further, right? That debunks the fact that the horizon is a physical location. There's only one horizon, and it is apparent.
The horizon is a physical location.
Right.
Well,
on a globe, it has to be. It cannot be further than 1.225 times the square root of the observer height in feet.
Wait, that approximation would put it. Yeah, it would either be closer.
Hello, everyone. What are you guys talking about today? No response. Hey, we have a yellow weasel.
Yeah, that's me.
Hi, yellow weasel.
Saying about the horizon?
Yeah, they were talking about. Yeah, there you go.
You said you're talking about the horizon?
Yeah, I can't really remember how we ended up there. But...
What particular aspects? The apparent nature of it?
Yeah, I think Weasel believes the horizon is physical.
Well, if the Earth is a globe, then
That presents kind of a difficult problem, though, because if it is a geometric horizon, no one has ever seen it. Where is it?
how do you know? Do you like how do you know that no one has seen it?
Because the horizon is always apparent, and it moves from day to day, hour to hour, depending on the conditions above the water. So if they have no geometric horizon, they couldn't measure it. But it sounds like you may already be questioning, because you, in your in your own statement, you said if Earth is a globe. So that's good that you're questioning.
Well, I'm just saying, man. Like a friend of mine, he he got into all this flat Earth stuff, and I was questioning him, and then he said like he watches your live stream a lot, and I should just like if I have questions, I could come on and ask you guys.
I'm happy to.
But yeah, I mean, I'm just you're. It seems like you're just putting out more questions and don't really also like you're. To me, it still seems like yours have the same problem that you say the globe Earthers have, in the sense of that they don't have ways to prove what they're saying. Like for example, before you said, well, like gravity isn't like really.
Well,
Delivery.
down to the basics.
Huh?
Oh, I'm sorry.
I'm leaving.
Sorry, Elijah.
I'll be back.
Okay.
All right, I'm just saying, like for example, you said, well, okay, gravity isn't the force responding for the downward acceleration we feel. Okay, that's fine for me. Then and then you said like, well, it's electromagnetism, but then like don't you need also like if you say this is what makes sense, this is the way it should, shouldn't you have a experiment, or like shouldn't I be able to?
Well, that's
do an experiment
that appear to make us very comfortable inferring that electromagnetism is the cause.
Well, before wait a minute.
Right, but it's not about like
wait a minute. Wait a minute. Like before we talk about what causes a downward acceleration, can you give me give me a summary of what you mean by downward acceleration, like, and how it's related to a force, gravity specifically,
or any force. What do you mean by downward acceleration? What does that mean?
That I am accelerated towards the ground.
Okay.
At around 9.8 meters squared per second. Meters per second squared. Sorry.
Okay.
That's the apparent acceleration I feel.
Okay. What's the like? What do you think that? What do you mean? Like, what do you think is making that happen? I need more of a picture of your worldview.
Well, to be still, it's the apparent force of gravity. I mean, you made some good points earlier, and I'm certainly going to look into the experiments that I relied upon earlier to prove, or like that prove gravity as an apparent force.
I guess.
But I'm just like, but also like, for example, the reason I'm still doubting you on your explanations and your disproving of gravity is that
I'm walking back from the explanations because at there's a bunch of working ideas that basically come together and form your idea of what's going on, because you think that mass attracts mass, but to explain it to me, you've ascribed something that we actually can see. So for instance, you say you have an acceleration, but you don't know that. So that information is contrived.
I know that I'm accelerated towards the ground.
Listen. That's what I'm saying. The words that you're using, because if I'm standing still, I'm not accelerating. I'm not doing anything. So in a setup where you're falling and there's these other variables like wind and all of this other stuff that could affect it. Thinking about absolutely nothing else and thinking about, say, me or any other object at the top of the building, minus any other variables, we can say, hey, that thing falls at 9.8 meters per second squared or whatever. Great. Does that mean that it's the force of gravity holding us to the floor, or some other force holding things to the floor? No. The reason that you describe yourself as accelerating down is because you think that's something that's happening constantly, always, as a result of this inherent force between matter. That being said, is it a universal force? Does it affect everything or just some things?
Yeah,
well, because it's not.
I'm sorry.
Yeah. Yeah.
Is it a hard? Is it a hard question to answer? I'm trying to figure out if you think that there's this universal force that affects everything.
Because it's not a real force, just an apparent force.
It's not very apparent.
Well, apparent, real. Listen,
tell me. Does the century
apparent and real? Like maybe that matters, or maybe it doesn't. Whatever words you need to use to describe what you mean is fine by me. And I'm just trying to get down to because you have a worldview that mass attracts mass, but you're tying that idea, because when anyone says mass attracts mass, they typically think of two spheres. Let's face it. And then to explain that, we move from that idea, right, to actually viewing certain objects in certain situations fall to the ground and ascribing a cause to it. But the thing is, mass doesn't attract mass, not definitionally.
No, not definitionally. I agree with you. Mass doesn't attract mass.
Specifically because gas particles aren't attracted to each other. And that's about, I don't know. I don't know if it's 50% or majority. I mean, because all of the stars, Jupiter, stars, the sun included, in your worldview, not mine, But in the idea that space is real and there's the sun and there's Jupiter and there's the stars and they're all made up of gas, and because of gravity and gravitational accretion, all of these spheres happen. The bottom line is there's no proof for that, specifically because of how gas behaves here on Earth.
Yeah, those are all good.
So it can't be a universal force of down or more specifically attraction to the center of bodies.
Okay. Do you have a response, Yellow?
Did you want clarification on what I was saying?
I'm just saying. You're saying you don't see gravity in gas. I see gravity in gas. I mean, go on top of a mountain, measure air pressure. Go.
No. That's taking different readings of different temperatures. I'm talking about fundamentally.
Take the
gas
reading
particles.
At the same temperature.
Listen to what I'm saying. Because you're doing the same thing. You have a worldview and you're trying to put these things together. Definitionally, like mass attracts mass, gas isn't attracted to gas. That's not the case. We already know that's not the case because of the ideal gas laws. Not just because of the ideal gas laws. Yeah. But
gases are not attracted to Earth either. So I was going to ask you a couple questions.
How do you know?
Hold on, Sonny, because I want him and everyone listening to know that that's actually the case. Because we say that, and we get. Do you keep an eye on it? How do we know? Would you like to go to the live stream for a second? Because I mean, this is something that everyone knows. Like bubbles, for example. Right? Bubbles exist. When you put air in balloons, that's a thing. Because
what do you mean when you put air in balloons? That's a thing.
Meaning, like, it's not like the air and the bubble is attracted to each other because they're elastic collisions, right? So there's no energy loss. They just continue bouncing along, creating that pressure inside the available volume.
Right.
So anyway, go to the live stream.
You mean on YouTube?
No, sorry. Live stream voice text here in the.
I am in live stream voice text. I'm typing.
Not YouTube. Sometimes. Here in Google. I mean Google. Here in what is this?
Discord. And yeah, just go right above the live stream here.
Yeah, I'm in there, man. I'm in there for the last 2 hours. I've been writing a whole bunch of stuff.
Where are you writing? Because I don't see your writing anywhere.
Scroll up. 1745, I said something. Scroll up a bit. 1742, I said something.
I got it.
Can you read that out loud? And if for whatever bizarre reason you mind reading, I'll read it out loud. You're welcome.
Wait, I need to open it in original. It's too small.
It's just a quick question. Has anyone gone through the 3 points with you before? Yellow?
I think we got hung up on the first point. A whole fucking discussion started then, and the person asking wasn't able to go further.
That's all I want.
Am I interrupting, guys?
Yeah, no, I don't think so.
No, not at all, Elijah. I just wanted to ask that quick question. I'm gonna.
Because if he was going through the 3 points, I don't want to be the one to have interrupted that. You know what I'm saying?
No, it hasn't started yet. That I'm worried. Go on, Elijah. Yeah.
So it's very simple. Like people like to have these long-winded discussions about peripheral things that may or may not be linked to their belief. But the bottom line is mass attracts mass. That idea was replaced over 100 years ago. I'm sure you've heard that. Einstein and the warping of space-time. That's now what people are going with. The gravity is an effect of that, not the cause of things. So we're talking about two different things, just so we can get an understanding of, well, where we should go in the conversation. And so the first thing is, well, mass doesn't really attract mass. That's why they replaced it. Actually, they'll say for other reasons, but that's also self-evident. But if you read what I put there, yeah, I mean that's pretty obvious.
So you want me to read it out for you? Okay, it says in an insulated container, gases do not slow down. That's the highlighted, and eventually condense. Yes, the gas molecule do not interact with each other except for colliding with each other. Gases expand to completely fill a container. They would not if they were attracted to each other.
Right.
Yeah.
So that's what we see fundamentally involving gas behavior. So there's something that is contradictory to that, and that's the belief that you have air particles in space with infinitely less how can I put it? Well, infinitely less particles, things. Well, that's why they call it space, because there's supposedly more space between atoms and stuff, well, particles and stuff. So that being said, other than in that belief where gas did the exact opposite of how we experience it, there's no evidence of it. And it would have to be true for mass to be attracting mass. So on top of not having an actual experiment that proves that such a thing exists, gas behavior is also flying in the face of that belief. It's very simple, very easy to understand, especially when you see the context for where I'm talking. I'm talking about gas particles fundamentally.
They don't attract each other. I completely agree with you. That doesn't mean they can't be attracted to other things, does it?
All right, but when it comes to the sun, that's just gas.
No,
right?
It's
how did it become plasma? How is it gaseous plasma? Because that's the next
a really
step.
good question, because also as far as I know,
That's not a really good question. It's not really good question.
It's impossible.
Think about it. Instead of inserting your belief, what would need to happen for the gases to be plasma? Well, it has to be under extreme amount of pressure in order for there to be a phase change and for it to become plasma. Well, how would that pressure be necessitated if the particles aren't attracted to each other in the first place?
I don't know.
Right, it's impossible because we don't have any precedent.
Just because I don't know, it doesn't mean it's impossible.
No, what I'm saying is we don't have any precedent or any evidence of gas attracting to each other. As a matter of fact, you just read out that they're not. But you're saying that doesn't mean that they can't be attracted to other things. And I'm like, no, but we're just talking about gas. And I said at least half of the belief in the sky, the sun, the other stars, everything that's supposedly gas in that area is immediately not backed by evidence and is contradictory to our gas laws here on Earth.
Yeah, many different laws.
Because it's very simple. It's not hard to understand. It's nothing to argue about all day long. It just is what it is. When you say you don't know, that's a fair answer. If you believe that there is an answer out there, that's fine. I'm not taking that away from you. You can believe what you want.
Yep, but the empirical evidence stands fast.
I mean, people like to argue things just to argue, but I mean, because they're emotionally invested in ideas. But the bottom line is, like, it's the difference between you telling me that the thing in question exists because of this idea. What's the evidence? Well, things me being attracted to the ground by falling 9.8 meters per second squared. And I'm like,
the thing is, I would even argue that you aren't attracted to the ground. You just feel like you're attracted to the ground in the same way that with.
But you don't feel that you're attracted to the ground. You don't feel that.
You don't feel that?
You don't feel that. You know, like when you get pushed by the wind, that's being pushed by a force. When you feel two magnets in your hands and they're attracted to each other, you can feel the pull. Me standing here, listen to what I'm saying. No, I don't feel anything like that. No, I don't. I don't know why you're saying that. I don't feel that. If you think you feel that, that's fine. But guess what? These are all cages for your thoughts. Because my point was actually that it would have to be inherent in all things. And because it's not inherent in gas, the thing that's supposed to be adjacent to a vacuum, it's obviously a silly idea. And there's nothing you can say to refute it other than I don't know right now. Maybe someone else does.
But we with the text we went over earlier said that gas particles aren't attracted to each other. Not that a gas particle can't be attracted to another particle which isn't a gas particle or to a
but what does that have to do with the sun becoming the sun? Or stars becoming.
Well, I don't know. I could.
Well, listen. No, it's not. You don't know. You would have to know because your whole argument is it was gravity, which it can't be because that's not how. No, listen to what I'm saying. Because of gravitational accretion, that's why the Earth is here under the first law of thermodynamics violation, why the sun is there under multiple violations of natural law. This is what I'm saying. And I'm saying the answer to how that's possible is a part of the heliocentric paradigm. You don't have to say it. So when you say, I don't know, well, that has to be the answer for that religious belief. The idea that gas particles have become this plasmic state of particles that are just in a vacuum. In order for that to be true, the gas particles would have had to be attracted to each other by gravity. There is no other answer.
Why not? Why couldn't the gas particles...
Hold on, Yellow. Hold on.
Yeah, go ahead.
This never, and what Elijah just said, never occurs in nature anywhere, and man to this day can still not create it himself either, even artificially. We know artificially doesn't count, but this never occurs in nature ever, anywhere. Never been seen by anyone.
But couldn't you argue that it happens when stars are formed, and that's where you see the nature? Also, coming back to the fact, no. That's a stupid argument. I just realized. I'm just.
Just like Elijah said.
But okay.
But you don't have anything to back your statements. That is the point.
Yeah, but you're saying it cannot form. Form out of gas particles, and I would agree because the gases wouldn't be able to have enough gravitational pull on each other in order to collapse into a star. I completely agree.
You're doing a reification by saying gravity.
And then, but what about fluids? What about fluids?
You have no proof of
if the gas.
I'm sorry. What about fluids?
Okay, you have let's say you have a huge amount of gas. Just
no. Stop talking about gas because you're the one that decided to red herring away from gas to try to make some sort of analogy. Let's face it, that's what you're doing. So let's talk about fluid instead. Fluid, right?
Yeah.
Requires a volume.
What do you mean?
Matter in the liquid state must be contained. If you have no container, guess what? You have no liquid. So why are we talking about that? Where would liquid come from in the vacuum of space, in the void of nothingness? And you can't tell me they're attracted.
So
You can't tell me water
water
particles are attracted to each other because even though they have bonds, it's not like you can put water in an area that's not contained and have it not level off.
But there are
it would have to have some
required in order. You can have you don't believe in that. Have you been on a parabola flight? Have you been on a 0G plane?
Why would I? What is zero? Listen.
Have you seen?
You know that zero. You know that 0G is a misnomer. Did you know that?
Yes, I completely agree that people on the ISS that you don't believe exist experience gravity.
Listen.
They're just falling all the time.
Listen. Why are you responding to things that I'm not even talking about?
Because I want to explain to you that you can
But you're trying to give me an analogy for something that's a misnomer. That's why I'm responding to it. Because when you say 0G, for people thinking, they just think that means zero gravity. No, duh, 0G, zero gravity. That's what they think. And they say being in a parabolic flight, that's like zero gravity. But it's not zero gravity, and we don't know what zero gravity is. All we have is this effect of flying and falling out of the sky at the same velocity that the plane we're in is. So what?
What do you mean? So what? You can even take away the plane.
No, it's not. It's not zero G. Like you're trying to talk about. The bottom line is you're trying to tell me why the sun came together without gravity. And then you ask me about fluids. And I say, yeah, matter in a liquid state also requires a volume. So now you're asking me about 0G, and I'm like, yeah, it's a misnomer because we don't actually know what 0G is.
Okay, then let's leave all of this away, all this explanation away. Let's say it. If you have gas particles, you know why gas particles, you know why the gas pressure is due to the inertia of the particles themselves. If they collide with one another, one of them loses energy to another, which then collects the other, and in the end, all of them.
That's not true. That's not true. You know why? Because the definition you just read that I posted, it's exactly the opposite. And you can't give me a citation for gas particles losing energy as a result of bouncing off of each other. That's exactly what doesn't happen.
Exactly. And if you could please tell us or provide us citation when this has ever been observed, please do.
For what has been observed?
Your statement you made about gas.
Which one?
Creating pressure by bouncing off of each other.
That's the one that was that a liar posted earlier in this text. The whole thing about do gas particles slow down?
I'm talking about what you are saying.
Exactly. So if they don't slow down, and they're saying obviously if they were attracted to each other they would, but the reason they don't is because they're not attracted to each other. How could your argument be that they lose energy, thus slow down?
I'm not saying. Okay, so the thing is that one gas particle transfers energy to another one. The gas in its entirety doesn't lose the energy, and it also gets it back, usually by another gas particle colliding with it. So after some time, you have quite a.
So then there's no energy lost there.
If we of course it doesn't have energy losses because we described our system to not allow energy losses.
So there's
that's why
no
it says
energy loss,
insulated container. It's insulated.
Right, but if there was no container, then entropy would dictate that the gas would dissipate.
No, entropy would dictate that the energy dissipates.
And okay.
And that's the difference.
Okay, no, but because it's with the particle. If we're talking about gases, or at least the concept of gases. So in that sense, the gas particle is the energy, in a sense. But when it bounces off of another particle, that's it. There's no energy lost whatsoever. So the only thing that would happen is the spaces between the gases become more and more because there's more of a volume to fill, not because they're slowing down. Again, exactly what I posted already stated. If they were attracted to each other, they would be slowing down, which means fundamentally the opposite is happening. And the only reason I'm going with this convention is, well, I mean, what happens when you put air in a balloon? Which is something like a variable container, in a sense, because it can expand.
And like I don't know, like what do you mean with your balloon example?
It's a balloon. Listen to
I'm confused. Look,
the words are very. What does balloon mean? What does balloon mean?
You tell me. You brought it up.
If something is ballooning, what's happening? It's expanding, bro. If something is ballooning, it's expanding.
And why didn't you just say expanding? I'm like, because English isn't my first language, dude, man. I don't.
Okay, that's fine. Expanded, exactly. That's how it's a. That's right, why it's a balloon. Because the air inside, the air inside is expanding the variable container that is that whatever balloons are made of.
Right, until the force is equal. Until the force of the balloon wanting to be in its original shape and the force of the outside pressure of the Earth putting on it equalize.
What do you mean equalizes?
Well, okay, if you put pressure into a balloon,
when it goes down, that's because the air is escaping. Like we're sitting here talking about something that I thought shouldn't have taken more than me posting the definition, which is that gas particles do not slow down. That's the end of the discussion.
But no. The context, insulated container.
Guess what? So without the container, what happens?
Without the container, you can lose energy to your surroundings.
Without the container, you're losing the air particles. Or do they just stay there? The energy leaves, but they stay there. How does you tell me how it works? Is that what you're saying? Because if not, why are you stating things without a difference? The air particles escape the balloon, and that's why it becomes deflated. Because the air pressure is less. This is like, I'm the flat earther saying really simple lines. I'm not saying anything like, oh, something acts like a container because the things do the opposite of the definition that I just read. And we're not talking about the particles, we're talking about the energy of the particles. Maybe the particles stay in one position while the energy leaves it and goes somewhere else. No, the air expands to fill its available volume. If there was no container, there would be no pressure.
But
the reason there would be no pressure is because they're not attracted to each other. Otherwise, they would slow down, like I posted.
Have you been on a mountain before?
That's a red herring. Who cares?
A red herring.
How is that a red herring? Measure the air pressure at the same temperature.
It's a red herring because that doesn't change the definition. That doesn't change the fundamental behavior of gas particles. So it's a red herring because of that. You telling
So
me
you're
about
saying
air?
you don't care
You
about
telling me?
reality.
You telling
care
me
more
about
the
air?
definition than reality.
You telling me about air? Reality is air expands. There's
But also,
no
I'm telling you
instance.
that
There's no
if you go
instant.
higher up, you see.
Well, you're starting your statement with if.
That's the thing you're trying to prove. You can't use the thing you're trying to prove the
I'm
thing
not proving.
Yeah, but
I'm
it doesn't.
not
Listen,
saying anything to prove anything. I'm saying
listen. I'm not going to make this hard. You said English isn't your first language.
That's okay.
I'm stopping you because I'm telling you you're committing a fallacy. You're not going to give me the fallacy. You're not going to give me the fallacy as an explanation after I've pointed it out.
What fallacy am I
First,
committing?
a red herring.
Multiple.
I would disagree.
Well, you can't disagree because you're committing the fallacy, and there's nothing
so
to
I can
disagree.
just say you're committing the fallacy, and now you're wrong. This is not how it
Okay,
works,
and then
man.
okay. So what fallacy am I committing? And formulate the fallacy with my words that I used. Go.
I was asking you to do the same for me. Show me where my red herring is.
I'm gonna do the same thing right now. So I'm
Where's my
talking
red
about the fundamental nature of gas particles. That's what I'm talking about. You're saying, well, what about air pressure on a mountain versus air pressure at sea level? That is a red herring because regardless of whatever answer I give you to that question, it's not going to change the reason I brought up the topic in the first place. Mass doesn't attract mass universally because gas particles aren't attracted to each other. I even gave you a definition. You've given me nothing but lip service.
Sustained.
I'm telling you that the definition you said has insulated container in it, which is a scientific term that says there is no exchange of energy.
Listen, I'm going to interrupt you now because you do not know what science is.
Oh, I do not. Okay, then I guess.
I mean, that's also a red herring, though. I don't really care. So you move from one red herring to another red herring, and I'm not letting you off this specific topic at all. So now you want to talk about, bro? At the end of the day, you need an available volume for the gas to fill to get a pressure reading. At the end of the day. So you're saying, well, this is talking about air in containment. What about air without containment? Well, give me the definition for that. Go ahead and give me a citation for how you can have pressure without a container. Go ahead.
You want a scientific definition how you can have pressure without a container?
No, I want to look. I have a demonstration of how you can have gas pressure with a container. I want you to give me a real world demonstration of how you can have it without a container, without your religious worldview belief. Yeah, I didn't have to give you belief. I just said, here's a balloon, here's a container, here's the definition for air in containers. What do you have?
Yep, exactly.
Okay, so that's why I wanted to bring up the mountain example, the idea
Yeah, that's a red herring.
higher in elevation.
That's a red herring. That's a red herring.
Another red herring.
It's the same red herring, and I'm not going. I'm not going to address it specifically because it doesn't relate to the fact that gas particles don't slow down because they're not attracted to each other. Therefore, it is contradictory to your belief in mass attracting mass, which was superseded over 100 years ago for the curvature of space-time religion.
You also have to keep in mind, Weasel, that we're trying to prove whether or not the sky is an open system or closed. So you can't keep using the sky as your proof. That's the thing we're trying to prove.
Okay, so let's do an experiment then, because maybe I can find someone who's done it. I haven't done it before, but I'm fairly convinced that it would end up that way. Take a big vacuum chamber.
That's one container.
That's a container.
Yeah, you said chamber.
Right, or like you can take a big vacuum chamber container, or you can use a balloon. It's not like the air is gonna sit in some area within there. No, it's going to move until it reaches its volume, its limit, that container, and then it's going to bounce off that wall to either another part or a gas particle itself. Those are the only two options. But we're talking about not what you're trying to. Everything we're talking about right now about how gas behaves is the exact opposite of what you're trying to. You know what? What about this chamber container? What about it?
Now you wouldn't accept it anyway because because every way I could try and prove.
So why can't you just accept? Why can't you just accept that it's not possible? Because you're saying every way that I try listen. I just said here's a balloon, right? I said here's a balloon. Here's the definition. Now let me include here's a chamber. Something with walls. You give me an example of gas pressure without a container, and we're good to go.
Yeah, I would give you the Earth as an example, for example.
Yeah, that's begging the question.
But since you don't allow that,
yeah, but that's begging the question. So what's the difference? So listen, sir, let's be reasonable and smart and not get embarrassed on a flat Earth Discord. Why wouldn't you just say, well, that's what the sun is?
I could also say that's what Jupiter is. I could say that's what Mars is. That's what Venus is.
No, because Mars and Venus actually supposedly have solid matter. So that would
they
be
also
different.
have also have an atmosphere.
But anyway, that's not what we're talking about. See what I mean about red herrings? Things that aren't really relevant at all to bog down the conversation. At the end of the day, you don't have gas pressure without a container. You talking about the Earth is begging the question, like me saying you can't have gas pressure without a container, and you saying, well, look, there's the sun. No. That's the thing that's opposite to the definition, to the example, and to the gas laws that we know. You can't just insert your religious belief in the face of facts. Self-evident facts, demonstrable facts, and definitions that align with the demonstrations that we have available. Then you said, well, how about with a chamber, which is also a container? So why can't you just accept, you know what? Particles aren't attracted to each other, so it can't be this universal force. Therefore, there's something wrong with my paradigm.
Or just provide a physical demonstration that isn't pointing at the sky. Because that's the thing we're trying to prove. That's the thing that's in contention. So as I said earlier, you can't just keep using the sky as your proof. That's the thing you're trying to prove.
Yeah, if you're saying you can violate natural laws, then it doesn't matter what some silly flat earther says about it, because the natural laws are the standard. We don't. That's the whole point. We don't have to. So these natural laws are repeated over and over and over again through all of history. What you're trying to string together, this yarn you're trying to weave, and you are making it up. Guarantee it. You're talking about gas completely differently than I've ever heard or read anybody talk about gases, the gas laws. I don't understand where you got your information from of how things like that occur. But like I was saying about the natural laws, if you are claiming that you are going to be able to violate somehow any of these natural laws, then good luck to you, because you're not fighting flat earthers. You're fighting the natural laws themselves.
I never wanted
You're
to fight
interrupting
you
me.
guys.
You just interrupted me. Yeah, don't interrupt
Man.
me. Yeah, I was talking still. So if you intend, I'll just repeat myself. If you intend to violate, that you think you can somehow violate these natural laws, good luck to you. Because you're fighting the natural laws. What you're trying to say exists, and you kept saying if this then that, and if, or what about this? Like all these different ways to get away from your fundamental claims, which are curvature, axial rotation, and gas pressure without a container. But if you're going to try to violate the gas laws or any of the other natural laws, I'd sure love to see any citation you have where any of those laws have ever been violated under any conditions. Bring it. Bring it. Let's see it.
Also, like, just to remember, maybe because not everybody was here when I joined. Like, I don't want to fight you people. I came here because a friend of mine says I should look into this, and I mean, if I'm just
listen. No, I don't want you to get the wrong impression. I'm not fighting with you. What I'm basically saying is you're fighting against the natural laws. That's it. That's all I'm saying. You can fight against the natural laws all you want, but the natural laws will always win. The natural laws will always win out in the end because they're testable, repeatable, observable, falsifiable. That's why.
But I would argue that you're breaking, that you're arguing against the natural laws.
Okay, which one?
Okay, but
which ones?
Mm-hmm.
Which ones?
Because you're saying
which one? No, which laws? No,
gas pressure.
Let's say which laws. Don't tell me what we're saying. I want to know which laws right now. Tell me which laws. And how so? CB?
What?
Crickets?
Why are you trying to just make fun of me, man? I came here because people said you have the answers, and like,
which laws,
man,
bro?
give me
Okay,
a break,
we apologize for some of the jokes, and maybe it's tough being here. I don't really know, because the moment somebody uttered the word flat Earth to me, I said, "What does that mean specifically?" Now I know what Google will show you, but I was like, "That can't be it. That's retarded." So when we're talking about flat being a elevation profile, like Google uses, because they use a flat elevation profile, that's particularly what we mean.
Mm-hmm. And
a
that's
0
not a
point
natural
which
law
we
question.
which we can put against things that are higher than lower, like hills and valleys.
And I just wanted to say something about that, Elijah, that's not one of these natural law questions. It's a simple geometry question. What is the surface condition over water? That's very simple geometry. So I would like to know, do you still think we, by any of our statements, Yellow Weasel, that you think we are somehow in our statements or the presentation of the material we've acquired, how are we breaking natural laws? Are you going to concede to that?
I would say that you're breaking the real gas law.
How?
By saying that gases can't exist without a container.
Because that is the actual definition of it, and that is the actual working of it. It has to be a physical
that's with the ideal gas. No, that's with the ideal gas laws.
No, it has to be a physical container, bro. I'm trying to help you out here.
We haven't seen a demonstration of the contrary, so if you have one, just present it, Weasel.
Yeah,
but why would we accept that that's possible without demonstration? That's a little out there.
And is my volume better now?
Yeah.
Okay, good.
He's sort of invoking axiomatically and definitionally that the Earth is next to a vacuum without a container. He's invoking it axiomatically. He's saying it just has to be true despite the evidence to the contrary that we see in our everyday life. So at this point, it's just something that he axiomatically accepts as true, with despite the evidence to the contrary. At that point,
Yeah, and that's a logical fallacy.
And so he has faith in the axiomatic definition of our Earth's atmosphere as existing next to a vacuum, and he's okay with that. So at that point, there's just no more discussion.
Yeah, so bring any information you have, Yellow Weasel, from any source you can find of anywhere that somehow, someone, somewhere, under some kind of situation or circumstances has been able to violate any of the natural laws. They're considered axioms. So I would suggest you look that word up, axiom, also. And also, please provide us the source of your statement that flat earthers in our statements are somehow violating some natural laws that you haven't been very specific about. So provide that information too. Yellow Weasel.
Maybe you need to give me maybe a little bit of time in order to because I just came here.
No, Sonny. Maybe the problem. Well, yeah, homework. Because maybe the problem is that's the thing. I came into the middle of the conversation. Sometimes you have to actually take control of the conversation, and sometimes that's not asking questions other than if they understand what you
that's
told them.
That's true. Do you understand about the gas laws?
So I don't even know why. I don't even know. But why are we even talking about gas laws at all then?
Yeah, because we're talking.
You know what I mean? I don't even know why we're you came here for a reason, for a purpose. You said your friend pointed you to the server, and I'm assuming you want to know why we're here.
Yeah.
Right. So I'm assuming you want to know why we're here. That would have been an easy question to answer a long time ago, because that doesn't really require a back and.
You weren't here when I joined, as far as I remember.
Right.
Yeah, I'm back, guys.
Get me back.
I want to say, Elijah.
Oh, it's your fault, isn't it, Get Baguette? That we're talking about all these things that don't matter.
No.
I mean, I would have never guessed.
Helio brought Weasel here, and he had some friend who told him about Flat Earth, and that if he wants to learn more,
I know all
he can
that.
find us here. So yeah.
I know all that, but he was talking about this false dichotomy between something that isn't real and something that is real. Because he's asking, well, if it's not gravity that holds me to the floor, you guys think it's electromagnetism? And I'm like, well, first, what do you even think that? What does it mean? What was it? Because somehow we got onto the topic of things accelerated 9.8 meters per second squared. And I'm like, what does that mean specifically? Because if it means mass attracts mass, because there's this inherent force in matter where they're attracted to each other, that's not true because of gas particles. That's a simple enough statement. It's not really anything to it. It can't be contended because of how gas behaves, just straight up and down. But fine, if you weren't prepared to argue that, maybe you shouldn't have tried. Maybe we should have just stuck with.
I just wanted to hear you, but gas particles doesn't.
Yeah, but that's not helping you. That's not helping you here. I'm trying to help you now because you don't want to get into an altercation, right? Because you feel like us giving you these points is some kind of argument or attack, and it's like, no, we're just trying to tell you what actually is versus what people believe, because the laws work the way they work, and definitions are what they are. The only thing people come here with is misnomers and misconceptions about how things work. I was trying to point that out. Maybe that's not what should be happening. Maybe the only thing that should be talked about is why we're here, because that's why you came. You want to know why we're here and why we're flat earthers, right?
Yeah. Is that right?
Yeah, I mean, there was the
okay.
Like, I don't know. I think when Helios was,
we're never opposed to rewinding, like backing down a little bit, rewind it, go back. Let's have a little pause, have a breath, and kind of like restart. You know what I mean? So that's always a good thing in a conversation, I think, to be able to do that. So
yeah, that's what I tried earlier, but like people just in chat were like, "Well, you're just weaseling your way out of this," which I think is kind of funny considering my name. But
no problem, man. Listen, it's all right. Elijah, you want to tell him why you're here?
Well, I mean, I could.
I mean, because I know
in the middle of some raid right now.
I've heard you say it myself. So, but maybe Yellow Weasel would like to start hearing from all of us why we're here. Each one of us has a different story.
Well, but before I even begin, is that what you want? Like, what do you want? And then I can tell you whether or not I can help you.
Yeah, go ahead, man.
I mean, it's supposed to be an enjoyable experience, right? When you go somewhere to acquire information, it's usually because you're interested or intrigued by something.
Yeah.
But yeah, no. So it was my friend. So because he wasn't, I think he's just not as well versed in it as you are, probably in that sense. So like when he couldn't answer my questions, or like he was like, well, like talk to these guys. They or like listen to the live stream. Since in the live stream I I watched a bit over the last 2 days, and there often was like a lot of just flat earthers talking with each other. I didn't really hear a lot of the information that I would be interested in.
Understood.
But
so, the reason we're flat earthers is because of things that we can know, right? So there are things that you can't know and things that you can know. So, let's say space was real and hypothetically, people have been there. I'm not going there tomorrow. I'm not going there anytime soon. I'm not going there ever. So there's nothing in the way of that I can, come to a definitive answer. I just have whatever it is someone else is telling me about their experience, yada, yada, right? So when it came to this topic, I only wanted to know information that I could actually verify myself. Because, I mean, that seemed like a reasonable standard. Well, if it's true, I must be able to verify it somehow, right? So I got down to the bottom of, well, it has to be this specific shape, this specific size, in order for everything else to work. Because all of the math, everything that we see that's been fit into this particular this particular outlook is all based on whether or not we live on a globe with a specific size. So I said, well, how do we know that? Who's measured it? So if you Google that, the first thing you come up with is Eratosthenes. And Eratosthenes took a couple of angle measurements, which angles require 2 lines meeting at a vertex. That's how you get the angle. So I don't know how he did that in relation to the ground, because he's measuring the angle of the shadow on the ground. But that's nor here nor there. The point is,
I think I could come up with some ways. I think one could measure if like a surface is flat, and also if a surface is like level.
Yeah, that's what I'm getting to. If you came here wanting to tell your story, then
no problem.
I could just stop right now. No, like I said, I want to do what you want to do. Either I can help you, or I can't. Either I know something, or I don't. If you want to tell your story and espouse your beliefs, then I can just be quiet right now and let this be a pleasant conversation where you just say what you feel. Or you can get what you came for.
Nah, go ahead, man. It's interesting because I don't know, a friend of mine, he got into it because of a bunch of other stuff, and also a friend of his. But yeah.
Well, okay.
So you're here to help others find the ways to help them ask the question.
I'm here to point out something that's very wrong. That's all I'm here to point out. Because the thing that I'm pointing so this is
you're roboting.
No. So this is what I'm talking about when I'm talking about what we can know. So the claim, can you hear me now?
Yeah, but the anything before, I think like this is like, can we repeat everything before the claim? Because now it's
I didn't really say anything. I didn't say anything.
Okay, perfectly. Then just go ahead.
So the claim is that the Earth is a sphere of a specific size because Eratosthenes measured some angles, and ultimately, with some calculations, he determined that the Earth is a sphere of a specific size. I can do the same thing that he did using the same method that he used, which requires me to make assumptions. So if I did the same thing with a light source in my room, but instead of knowing that the light source is, a specific distance, I just assumed like I put on my pretender hat and assume that the same thing Eratosthenes assumed, I can give you the circumference of my floor. So there's obviously something wrong with that. But the reason that I'm here is because as a consequence of that so-called measurement, the Earth is a sphere with a radius of 3,959 miles. Now, if you Google distance to the horizon, they'll give you this long formula. In short, it's 1.2 times the square root of the observer's height in feet. Any Earth curve calculator will give you that. So that's a direct consequence of the belief that the Earth is a sphere, and when we look out to the horizon, that's an actual place, and it is measured to be the distance to it we can no longer see the rest of the ground. So it's the physical limitation or the physical obstruction that stops us from seeing the rest of the land. The bottom line is that's off, is nowhere near true. As a matter of fact, it's off by orders of magnitude. It's off more than 10 times. That's bad math. So one might ask, what do you mean? Right? Well, we're talking about the consequence of living on a sphere. The horizon is supposed to be this thing that things disappear behind because it's curving away from you, and at some point, based on your elevation above the surface, that should tell you how far that drop off, where that drop off begins. So the bottom line is, okay, that's cool. If I was a teacher, I'd like to take my students out to the beach or somewhere and tell them about that. The problem with that is it's wrong, which is crazy. It can't be wrong because that would mean the radius is wrong, which would mean all of these orbits, these satellites are in the orbit around the sun that we're going. All of that is wrong. The math for the gravity, that's wrong because it's predicated on the mass of the Earth. So this is really the only thing that people need to know. The Earth doesn't measure to be a sphere. And so my belief that level means level, except in the context of if it's a sphere, then level means basically the same elevation around a curving sphere. I don't. If it's not the sphere of the size that they claim, then I could just go on believing, well, level actually is just level, and that up is the same for me as it is for basically everyone else, because there's no proof to suggest otherwise. No measurable proof, but the measurable. But this, in my mind, when I thought it was measured, this is what justifies my belief in the sphere. Because that is not there anymore, I have no justification for believing that the Earth is a sphere. So when people say, what about satellites? What about this? What about the sun? What about that? Yeah, okay, this one fact disproves, or not even, why are you asking me about those things when all of those things are predicated on this thing being a fact, which isn't a fact? What about the seasons? Also predicated on the fact that it's the size that they claim. But it's not that. So what does the question mean at that point?
Do you understand, Weasel?
Yeah, I'm just, of course. I mean, like, I get that. I get where you're coming from.
That's very good.
I'm just like, I would certainly argue that part of me still, like, I don't know, it's part of me is asking, well, if this is all true, if the Earth is flat and everything, then why doesn't everybody know? Why would everybody be lying about that? And like, I mean, I've heard, like, my friend said, like, NASA and stuff, but like that.
I tried to tell you that matter in the liquid state requires an available volume. Same thing goes for gas, and you argued me down. So the fact of the matter is, people aren't lying. People have a belief. That's the difference. Because you're not lying, right?
I don't think so. At least not. I don't wish to.
Right. So in that context, most people, 99% of the people, aren't lying. Because only supposedly less than 100 people, maybe less than 50, supposedly escaped Earth's orbit. Supposedly. So other than the fact that you can't have orbits without the measurement that I was talking about, let's forego that and say, okay, well, the only people that have had that experience is them, which means everyone else outside of that is not actually lying. They just have a strong belief system. Just like you've demonstrated. Just like I've demonstrated once upon a time.
But like, wouldn't the people, wouldn't you need someone?
Why didn't you?
Because no, I mean, like, I'm not talking like now about like the normal.
You're just as sufficient. No, you're just normal. That's the problem. Normal people are just as sufficient as superstars, are just as sufficient as politicians, are just as sufficient as the people that are in power that we know. In fact, when we watch them, it's almost like they're really stupid. That's the joke we all make as normal people. So we all have the same cognitive abilities, we just use it to different levels. That being said, why isn't everyone else talking about this? Well, people are talking about it. You want to read something from an Air Force, what was he, a captain? I don't know. But it was somebody from the Air Force. It was talking about navigation and how people can believe what they learned in school and all of that. But when it comes to survival, what you need to understand is that you need to consider that you're standing still, the earth is not moving, and the lights above us are moving about us. In order to grasp the simple concept of navigating using the celestial bodies, this is something you must understand, regardless of your beliefs. That's what he said. There are people like that all over the place. Maybe you just didn't know. Because when you Google it, it only shows what they want you to see. It's not like you Googled it and come across somebody like me or somebody like somebody else saying what I've said. Maybe you've only come across people saying things like Eli thinks that the earth is a disc that you can just fall off of. Yeah, well, except I never said that.
Yeah, I was like Googling didn't really help anything. I would argue, like when my friend told me about it, he said like Google. I didn't.
They suppress everything. They suppress everything, so you're not gonna find anything anymore.
Because okay.
I was wanting to jump in earlier before we got too far away from it, but when Elijah was talking about Eratosthenes and how he could do the same assumptions and tell you the sphericity of his floor, and when he was going through all of that, referencing the shape of the earth, right? Because that's what this discussion's all about. Could you find any flaws in his logic within the statement he made?
In which statements? Aristophanes or Elijah's?
When Elijah was speaking about Eratosthenes, right? The claims that are put forth as to how the radius and circumference of the earth were allegedly established via calculation. When he explained all of that to you, could you find any flaws in his logic and his reasoning with the statement? Because ultimately, that's what this conversation is all about, right?
Can you please also maybe it's language here not helping me because the English is my first language. Are you talking about Elijah's statement or Aristophanes' measurements?
Elijah's statements regarding Eratosthenes, everything he said. Elijah's argument, right? His logical reasoning. Could you find any flaws within what he was saying?
I don't think he even remembers the whole subject. That's a lot to add. That was a long time ago, bro.
I think I agreed with. Was that Elijah or was that someone else? I think that was before. That was with someone. I think that might have been with.
I was just referring to Elijah stepped in maybe 5 minutes ago, and just gave you a perfectly logical explanation.
Right, but I completely agree with all of you guys that it doesn't prove a globe in any way, shape, or form. It just because it starts with the assumption that the Earth is a globe. But
correct.
Go ahead, man.
Can I interrupt? So when he says, "Can you find any flaw in?"
I said, And your
well, your response to him was, I didn't disagree with you guys saying it's not approved. That's actually
with
not
with
the
that I
answer.
mean
That's
no flaws.
I,
That's what I mean with that. Sorry, go ahead.
Okay, so if they don't have if they don't have a measurement of curvature, nor can we find the consequences of being on a geometric shape that is the sphere, what else are we supposed to do? Because all of the math is derived from these so-called observations of the sphericity, namely the horizon. There's another guy, Al-Biruni, who was from the Middle East, who at the height of using the height of a mountain, calculated how far the horizon is. That's exactly what we're talking about. There not being a consequence of any geometric edge anywhere. There's a limitation for how we see. We know that perspective plays a role because you can't see things forever. You walk away from the tree, it gets smaller and smaller and smaller until you can't see it anymore. But how does that play a role with the horizon? Well, the horizon appears everywhere other than geometrically it would appear. Like if my house is 3 blocks away and I'm looking at my house at 3 blocks. There's no explanation as to why. I would never have to explain to someone why my house doesn't appear where it is. Never would I have to do that. But when we're talking about this subject, a lot of that happens. People begin dancing and bouncing around, and the bottom line is there's just no evidence, man. That's why we're here. There's no evidence of the globe, so by default, we're here because we understand what being upright and level means. Because if I was on a hill, I would know that. I know when I'm upright. I know when I'm laying down. That's all I know. Shit, I look up in the sky and that stuff moves. That's all I know. Everything that I thought I knew was based on supposed measurements, and I going out to take the same measurements and found that that's also a lie because that's something I'm able to do.
Yeah, I think I certainly need to maybe do some homework on that. I don't know, I'm a bit...
Well, we strongly encourage that.
Right. What kind of person would you be if you weren't skeptical? That's the problem for me with society is they're no longer skeptical. They're skeptical of everything authority says to be skeptical of. They're skeptical of their neighbors. They're skeptical of their own siblings. but they're not skeptical of the things that are unseen, that are unprovable, that are unfalsifiable. Did you know that Georges Lemaitre, a Catholic priest, is the one who fathered the Big Bang?
A priest fathered the Big Bang?
Yes.
Yes. He happened to be a physicist and a mathematician as well, who happened to just be a Catholic priest. Yes.
So if I may ask the question,
who he is kind of irrelevant to me. To me, it's more like why do I believe then that I'm just a bunch of chemical reactions and that really nature just came about on its own? Why do I believe that if all of these other people think that there's a creator?
intelligent design.
You believe in intelligent design?
Well, yes, because having order, yeah, and laws requires existence of intelligence. Human DNA is not something chaotic. It's a programming. It's a software. It has a language which is used to be written, all that code. There are very specific mathematical equations, calculations, laws of how things happen. Yeah. All that contained in the DNA. Do you think that the internet magically, naturally formed out of nothing, or was it the humans creating the internet? What do you think?
Well, I would say that the humans gradually
we
designed
created.
the internet.
Yeah.
Yeah,
Okay.
yeah, but like it wasn't like from one day next like to another.
Yeah,
So like
we have on internet we have a lot of web code, correct? And that web code has been written by us. It didn't wrote itself, correct?
Yes.
Yeah. Now, when you look at that web code, it is very structured and organized. You know, it's information and mathematical laws, equations, everything. You know, if you have this here, then this happens. This you can do this. It's a lot of functions. You know, it's logics and mathematics. It's not like throwing sand in the air, you know, something chaotic. Yeah. And we find big chunks of that web code which are identical with DNA code found in the human genome.
Web code. That is it. Oh, you mean like okay, I see.
Yeah, we find big chunks of web code and functions which are identical with. Yeah, I hear you, Elijah.
Okay, thank you.
So yeah, this is one of the latest discovery of geneticians in the last 2 decades. They show that human genome didn't spontaneously popped up into existence. Someone had to actually program it to write.
So humans had to program it, or what?
No, here's the bottom line is the bottom line is there's nature, and then nature has specific functions. Things grow. You know, we live and die, but ultimately, the information, like we didn't come up with the information for ourselves. We didn't create ourselves.
Yeah.
Yet the intelligence is here in us.
Mm-hmm.
Right? You and I are having a conversation. Now, we've agreed upon the medium for which we communicate. We didn't create information. Well, we didn't create intelligence. That's not like a really mind-blowing philosophical thing. Everybody knows that in order to have something be informed, you need an informer. To have intelligence, there needs to be an intelligent designer. In order for there to be a creation, there has to be a creator. In order for there to be an effect, there has to be a cause.
We know that. I don't know. I couldn't say that I know that.
Well, what do you mean by know what specifically? I guess I said a mouthful.
That everything has a cause.
What doesn't have a cause?
Maybe the universe. I don't know. That's the like. I don't know. Like as long as me saying there are no black swans because I only see white.
But I'm saying that everything that we know, like we understand what creation is, at least in the context of us, creating things. It's not like creating matter or material, but when we say creation, we know what that means, and we know we didn't create ourselves. We know that this world that we live in didn't create itself. As a matter of fact, here's another thing that most people don't know. People like Einstein, people like Newton, Copernicus, all of these people, you step away from PBS and what PBS says, these people say, you read their journals, and they're saying basically the same stuff that we say. Sometimes you catch them saying, well, the earth could be in the center of everything, but we can't hold that position for fear. On philosophical grounds alone, not by way of science. This is what they said. It's what they said.
Yeah. If they accept God's existence, then they will have to deal with him.
But who's the one that has to deal with going against the paradigm because of truth? Because there are a lot of quotes of people saying, I think Copernicus was wrong, but I'm not going to be the first to light that flame. Like, they say it all the time. Like, scientists have this problem with getting their work published all the time.
In his lifetime, Copernicus has never told his idea, his concept, heliocentric concept, to anyone. Because he would have been burnt alive on a stake in that time.
It was published after his death.
Yeah.
And even 60 years after his death and the publication, only 15 astronomers in all of Europe upheld that stuff.
Yeah. So he wasn't popular. It was occult.
Is it? Why would he need to be popular? I mean, you guys aren't popular. I mean, it's still.
Yeah, we're not.
You might be right. I don't know. That's.
Oh no,
that's a logical fallacy.
We're just talking about the misrepresentations. It gets represented to us in the public sphere, if you will, and education, as if everyone has always known it was a globe and heliocentric, and we've known this 2,000 years back, and Copernicus proved it was heliocentric and all this kind of stuff, but that just didn't happen. That's not true. They lied to us.
Yeah.
How do we know they lied? Just read their journals instead of watching PBS. So when we say they lied, it's because, well, we read what these people had to say. As a matter of fact, Neil deGrasse Tyson, even him being the actor that he is, says things like this every once in a while. Yeah. He said something to the effect of, I can't remember the words exactly, but he said, if the people knew what they were really doing up there with the Felix Baumgartner jump, that the favor in these people would greatly diminish. He was talking about them using convex lenses to make it appear as though the Earth is curved from that height. He's basically saying you wouldn't be able to see curvature. Why is he saying that? Because the math informs him that. As a matter of fact, you wouldn't even be able to see it from the elevation of the ISS either. Paul Larson, planetarium director, someone who has a ticket to go to Mars one day, knows that mathematically you shouldn't be able to see curve on the x-axis. So basically from left to right, you wouldn't see curvature, not even at the height of 250 miles. It's not me saying it. I'm just quoting you what's out there that you may have not heard. And at any point where you're like, I would like to see what you're talking about, I'll get it for you. It's not a problem. I'm not like Google or the ballers that go, well, you have this question, but actually, I'm going to redirect you and give you this answer to the question that I want you to be asking instead.
Yeah, I've been
like, no, I'm
sorry.
Yeah,
I've
go
been
ahead.
posting supporting material to go along with what you were saying, including the quotes and links to Paul Larson's or the recording of Paul Larson saying it.
Thanks, Barry. So the nature of this conversation and the things that we brought up in this context alone is why we're here. Like, because having conversation like this, it shouldn't even exist if the Earth was a sphere. Like, no, it shouldn't even be questionable. Because the Earth being a sphere is a what is question. What is it? It is a sphere. Well, how do you know? Because I know, because we've classified this shape to be a sphere, and that's what this is that we're living on. It's really that simple. They try to make it more complicated than it really is. So it's a what is question. And so
I don't know.
that being the case,
I've seen people argue about a lot of things that I would argue are how do you say, that are fact. I don't know.
Like what? Like what?
I don't know. For example, like how big your property is and the property of your neighbor and where the line is. Just look it up in the.
Of course.
In the stuff, but still people are arguing about it.
You know why
There's
people
like a lot
argue
of this.
about it?
So I don't.
You know why people argue it? People argue it. No, they argue it because they have vested interests. A measurement is a measurement. If there's a line, there's a line, bro. Like, you can't argue that. So the very fact that people are arguing it gives you a peek into the psychology of us as humans. It's because we've been inundated by entertainment. When I say entertainment, I mean literally everything that you can get from TV, maybe even paper. When you look at the TV, when you look at not just movies, but when you look at news itself, they argue in ways that are fallacious. And so when we talk to people in real life, we argue in ways that are fallacious. And what do I mean by that? Is, well, if someone's ever told you a lie or something that didn't add up and you tried to bog them down by saying, well, wait a minute, if this happened, then Well, you have evidence of this. Like you went there at this time. Wouldn't they be able to corroborate your story? Wouldn't you? And somebody's being evasive. Yeah, that's where the logical fallacy conversation comes in. People understand when people are being direct and when people are lying and when they're reaching conclusions fallaciously. And me, as the flat earther, shouldn't be the one talking about this. I should be the one off my rocker saying things that are crazy, not things that just are simple and surface level. I'm not the smartest guy out there. I'm not. That's why I like to keep it surface level, because I'm lazy.
Can I give you an example of what this flat earth, we're in a flat earth Discord. Basically, when I was 12 and in school, I learned about geometry, perspective, and how to draw spherical perspectives. That was part of my curriculum in school. So, having that part in my education, it would be a logical step to, at the same time when I get taught the globe, to learn how to measure the globe in nature. Because it is the same principle, it's perspective and geometry. But one part is being taught in art class. The other part is being taught in topography lessons or I don't know how you call it, geography lessons. And when you question the globe in geography, you get shut down. They don't go out and teach you, hey, this is how you can verify the globe. So you would have that flat earth debate in school at that point when you're 12 or 13 years old. Because it's that simple.
Think about it like this. Geography, to talk about it, you have to have an elevation profile. So here's the problem with the globe yet again. You would have to have two definitions or two contexts for the word elevation, because you would have elevation above sea level, right? So you're standing somewhere, and then your elevation is dictated by wherever the 0 point is, which is like an average sea level or whatever, right? That's the baseline. So if the Earth is curving 8 inches per mile squared, then any point that I'm standing on the sphere would have an elevation drop of 8 inches per mile squared. The problem is we can't talk about that and elevation as we actually know it at the same time. Like angle measurements taken in geography versus the belief that your elevation changes at 8 inches per mile squared. You can't talk about both things at the same time, because that's a flaw in logic. How could you talk about them both at the same time? It's impossible. Because if you say, well, for all intents and purposes, there is a 0 baseline, because technically, if you consider being at the same elevation going around a sphere, that's technically 0 change in elevation. So for all intents and purposes, you actually have a flat baseline, while semantically trying to tell me it's not. I don't know if that makes sense, because I'm at the beginning. I can feel myself beginning to ramble. So
no, dude, that was perfect.
No, it doesn't make sense.
It's like, why would you assume a flat stationary Earth if we were on a spinning ball? You wouldn't.
Yeah.
Well, I mean, I think the spinning part isn't even a problem, but I can certainly, like, I mean, I know that it's quite difficult to even for people to even decide on what even sea level means, because sea level is changing all the time.
Do you want me to? Do you want me to go over? So do you know why the movement of the Earth also doesn't work?
Yeah, now we're
Okay,
going
because
to the second question.
because I've done a lot of mechanics, so
Yeah, of course. Now watch this. Watch this. When we're talking about it, we have to talk about it in certain terms or with certain parameters, right? Because when you're doing the math for the spin and the centripetal force and the gravity and all of this, that, and the third, they basically say it results to, from our point of view, no result, right? Because everything is relative, right?
well, wait. No,
So,
but you
okay, for instance, the Earth is moving a thousand miles an hour at the equator, but in the system that we live, because the air and everything is moving at the same time, effectively there is no effect for us to observe. We don't have to argue about this, right?
No, I mean, of course it's relative.
So you agree with all of this, right? Because this isn't the problem. This is all fine in sugar and cookies.
Yeah, I mean, it's the same. Like, I don't know, like if you, I don't know, drive on the highway and the car next to you moves at the same speed, exactly the same speed, then from your point of view, it looks like you're both, like, to each other, you're not moving at all.
Right. You know where the problem comes in?
I would be interested to see where you would see the problem in there.
The movement through space itself. And the reason it's a problem is because it's not mathematically anywhere.
It's not what you elect out there.
It's not mathematically anywhere. Like you don't include these variables in the math. Yeah. Now, they would say, well, reason is because it's irrelevant, and I would say, no, that's bullshit. Because
why would you say that? Yeah, sorry.
Because the Earth is moving through space. This is just one movement. There's many, but I only require this movement. 400,000 miles an hour with the sun through space. So air is not attached to the Earth. Even if it somehow spun and the air somehow, because of just whatever reasons that they give, is spinning with the Earth, that does not speak to the Earth itself moving through space at such a speed. Accelerating also because it's moving in an orbit around the sun, which is another movement while it's moving through space with the sun.
It's a constant acceleration.
So the fact that none of this is calculated for, but we know it would have to be.
I still didn't see your argument in there why it would have to be.
Because the air is not attached. Nothing is attached to the Earth, my man. Not the satellites in orbit. None of that stuff is attached to the Earth. As a matter of fact, the 3 days it took the astronauts to go to space, well, that midpoint in which the moon and the Earth and all of that is traveling through space, because you can't maintain, never mind momentum, but angular momentum which is not something we observe, right? Like, okay, so if I have a yo-yo, right, it's attached to a string, I spin it. That's angular momentum.
I know
right?
what angular momentum is. I like classic mechanics is one of the fields I'm studying in.
Okay,
so that's why I don't see.
So all of it, right, because all of that doesn't include actually moving.
No, but the
That's
movement. But if like
rotation.
okay, so
it's not talking
let's
about
say.
movement.
So
you get what I'm saying? Like let's say I throw a water bottle up out of. Oh, I'm getting a call. Hold on.
Because this is okay. This is something that I'm like versed in to a certain degree. I would argue, and
what are you
therefore
versed
I don't see your effect.
What are you versed in?
Classic mechanics. Classical mechanics. I don't know what's the English word. Yeah.
Is that what is that? What is that? What is that? I don't even know what the hell that is.
That is the forces between objects, the movement of objects.
Okay, now
the forces
that
between moving objects, different reference frames of objects.
Right, but that's within an atmosphere, right? So that's the only thing you can.
Well, no, often you leave away the atmosphere because you just don't care about the little bit of atmospheric drag.
Well, then it becomes theoretical, right? Because you haven't been to space, right? So therefore, you can't know for sure, right?
It's ideal. It's not. I wouldn't say it's theoretical. I would say it's an ideal version.
If such a place exists, yes, it's ideal, right?
Well, even if the place doesn't exist, you could still say this is like the ideal because like you would strive to have the least atmospheric resistance often. So like this is just the ideal version,
Well,
and then
I mean,
like in the end,
that's just like a vacuum, right? Then you're just talking a vacuum like that you can create on Earth, but see that still doesn't have zero gravity. You see what I'm saying? So I mean, that's the difference. So that's
but
space.
But you don't care about like what the forces are. Like that's the thing there. So you just say these are two objects, and they are repelled or attracted to each other by these and these forces. And
how can they be attracted?
You're missing the point.
It's all.
Well, hold on, time out. You're missing the point. My only point is the movement through space is not accounted for in the math.
Exactly.
So when you're talking, if talking about things in rotation isn't addressing the movement through space. These things aren't attached to each other. So except for, and let's just say there's a force, and let's just say that force is the reason that they're able to remain in orbit. It doesn't account for the movement through space, though.
But it just doesn't make any sense because if you cannot recreate this environment to do a proper test scientific study on it, how can you then propose
that's true. That's true, but it's not even. It's not even math. But it's not even mathematically logical. But there's no math for it. It's not even. It doesn't even exist.
Right.
Like,
because
what do you mean? There's no math for it?
Because it doesn't exist. I'm explaining to you. Okay, so we have an atmosphere. We have air, right? Let's just say we have air around this ball. The ball is moving. The air is not moving with it. It's rotating with the earth. I'll grant you that it's rotating with the earth. It's not moving through space with the earth.
Why wouldn't it? If it can also rotate with the earth.
Well, there's no math. Where's the math? Listen. All I'm saying is it's not accounted for in the math. You saying, well, why wouldn't it? Well, why isn't it accounted for? Because it's not even a proposed. Listen. It's not even proposed mathematically.
I get you. I completely get you. I completely see why you think that would be an issue. But I'm saying that because there a movement without acceleration doesn't have a force.
It is acceleration. Because we're moving
around the sun.
No. The 400,000 miles per second or whatever it is that we're supposedly moving through space is actually in a circle. You know, the Earth also moves in a circle, right?
Yes.
Right. That's acceleration. That's not accounted for anywhere.
All right, here's the thing. Do you all right, since this is his field, he says. So do you know about the
I could
Do you know
punch in
about
the numbers and tell you how much you would notice it in reality. Like based on their model.
No. You're not talking. There's no math for it, bro.
All right,
like
do you know about the
I know the math for it.
But hold on, wait. For what are we doing here?
I want to ask him questions about what he knows, because like if this is his field of study,
Did you just come in the conversation?
Hell yeah, but I mean, come on, dude, you've been going all day. Come on, give me 5 seconds. Listen. All right,
well, disregard what I said. Well, not disregard, but I guess have a conversation with Fraud now.
I just want to know what he knows about this subject. All right, so do you know about the Glenn Research Facility owned by NASA? Do you know about this facility?
The Glenn Research Facility.
Right. Do you know what kind of experiments they conduct there?
Glenn Research Center. No.
Okay, so if this is your field of study, you should know about this place,
Cleveland.
right? So this is where they.
No, man, I don't live in the U.S., man. Like
you don't have to, but you should know that. You should know about this. I mean,
but I know
this is a place
GRC.
that conducts...
I've heard of GRC before.
All right, so basically, they conduct zero gravity experiments. So what they did is they built a really big hole in the ground, and they suck all the air out, right? And then they drop the experiment down the chasm, down the hole, and they conduct an experiment inside the capsule, right? So it's falling. So that's how they recreate supposed zero gravity, by dropping something in a vacuum environment. So it's contained.
Relative zero gravity.
Right, but but it's contained. You see what I'm saying? It's a contained environment. That's the only way they can conduct this experiment. So what you're talking about is why I'm saying is just purely theoretical and you have no way to prove any of what you're talking about if these guys have to do this in a contained environment. So to get a true idea of what you're talking, you'd have to be outside of the containment and then conduct your experiment, because there's no way to do that, and there's no way to do that.
But they say they also do it in space. They say they also go.
That's better. I prefer that. Yeah, you said they say that. I'm good, Elijah. I just want to get that out.
Yeah. I know that you don't believe in that, and that's completely fine. I'm just saying, like, they do not only do that by their argumentation and their knowledge, they're also doing it in space. So they would say they don't need the container.
Weasel.
What do you mean they don't need a container? They're in a container. What the hell are you talking about?
Because the human needs the container. The human needs the atmosphere, and
you cannot do an experiment without a container. It's just impossible, dude. How are you gonna do the experiment? You'd have to have like a robot and put the robot. It's just ridiculous.
No, but when they dropped the hammer and the feather on the moon, they did an experiment outside of all these containers.
If you believe they're on the moon, you know.
Well, I mean, that's what they say. So
they would argue they don't need on the ISS. Wait, they have the same experiment with the feather and the hammer on the ISS. Guess what? The hammer is floating and the feather is falling.
Yeah, they did.
The feather is.
People have also done the same experiment in their bedrooms, and both fall at the same rate.
Yeah.
Well, it depends on. I mean, that's what you would expect, isn't it? I mean, that they with the arguments they bring, that both of these objects experience the same acceleration.
Explain to me why on the ISS a hammer, the astronaut is holding in one hand a hammer and in the other hand a feather, actually a deck card. Yeah.
Okay.
And when he drops all of them in the same time. He releases them from his hand in the same time. The hammer hangs, floats in air, and the card, is falling down to the ground.
Can you post me a video of that? But I still believe
Yeah,
that
we
that
have a
would
GIF about that. Yeah,
would be
it's
expected as
actually
well.
a GIF taken from NASA's videos, live stream, so-called live.
Yeah, no problem.
It's
Yeah,
official
but I
NASA.
mean, so okay, so let's say you are in this.
What country do you live in anyway? But if you don't mind me asking.
I'm from Europe.
Like
Germany.
where though?
Oh, good guess. Yes.
That's why. That's why you're so stuck on this crap.
Yeah.
What do you mean?
The Germans love NASA.
Yeah,
I don't love anybody. I hate everybody.
They love Americans. They love Americans. They love Americans. Yeah, that's the problem. Yeah.
Yeah.
Well, we started copying this.
Weasel.
Yeah. Anyway,
Weasel, wait. In regards to classical mechanics, is rotation constant acceleration?
A rotation.
Yeah.
Constant acceleration. Yes, towards the center of rotation, the point which you rotate around.
Towards the center or tangential to the orbit?
No, you feel a force supposedly going out tangential. No, not tangential. You have your inertia wanting you to stay on a tangential path to the
when you are
circle of
on a
rotation.
merry-go-round, when you are on a merry-go-round, you feel that you have to hold yourself still so you don't fly away outside of the merry-go-round. Yeah, it will
exactly, but the force
push you outwards.
Right, but that's just the
force that your force of holding yourself to the merry-go-round, that's the centripetal force. Yeah, I know. And when the centrifugal force overcomes the centripetal force, then you have a broken system and the object will fly off.
But look, it's not a very safe merry-go-round.
Look. No, hold on. But this isn't this. Look, I understand you have math for that. Okay, or maybe I don't even know because I'm not that advanced in that kind of math. However, that doesn't talk about the other movements. So you're talking about rotation and how hypothetically things can maintain angular momentum indefinitely as the Earth spins. I'm not even arguing about that. I'm talking about Earth's movement through space while that's happening. So because the air particles and everything else that's not attached to Earth, the satellites and all of this aren't attached to Earth, how are they maintaining this angular movement? Or these angular movements?
Yeah. In perpetual motion, it's.
No, you don't need that. That's the thing, because you are technically. I mean, that's the argument that is given.
Bro. If I spray Lysol and walk out the room, I'm not gonna smell it. It's gonna be in the room, right? Like, so what I'm saying is the Earth is moving, and there's no justification for why everything not attached would move with it. That's all I'm saying.
I mean, but didn't you already say that the atmosphere you would be okay with for this argument, assuming that the atmosphere would stay attached to the rotation?
I'm not talking about the rotation about our
the rotation.
I'm not talking about.
Yes.
I'm not talking about our rotation on an axis. That's not what I'm talking.
Right.
Right. So when I said I'll give you that, I was just saying you can have the idea that the air would move around, would spin with the Earth. I gave you that. I'm not giving you moving through space with the Earth.
But this is
and you
already
agreed.
this is included.
You agreed that mathematically it's not included. It's not. Give me it. You agreed with me already, which means we're just maybe at a misunderstanding because you already agreed that there's no math for that.
What do you mean? I already agreed that there's no math
like
for that.
math, there's no math that accounts for the movement around the
sun
space,
and the
around
galaxy.
space.
Yeah.
You know, as a separate conversation, there's the calculation of how that's happening, but there's no connection between the Earth's movement and the air or the other things that are orbiting the Earth as it's moving along another curved path outside of that, because the galaxy is also moving.
And probably also the hypercluster is also moving. Yes, of course. No, the local cluster is moving inside the supercluster, and our supercluster is also moving.
Nice
in comparison to other clusters.
Right. So mathematically, there's no expression for this.
Yeah. I give you gravity. Gravity holding the atmosphere on the Earth. Yeah. So the Earth is spinning and is holding the air on the ball, on the spinning ball. Yeah.
Yes.
You have these centrifugal and centripetal forces, yeah, and it holds the atmosphere on the ball. Now, this ball is not only spinning around its own axis, it's also spinning around the sun with 66,000 miles an hour, yeah, tangential speed, angular speed. And the sun, the whole solar system,
you can't say miles
spinning around the great attractor from the middle of the galaxy with 400,000 miles an hour.
But
so when you add up all these speeds, how does gravity holds the air on the Earth while it's traveling with all these speeds?
Okay, I can tell you, like, this is you said miles, blah blah, like a bunch of miles, and then angular momentum. But angular momentum isn't measured in miles. It's measured in degrees.
Not
right, yeah, but the degrees are actually translated.
Angular momentum.
Degrees do translate into miles. But then we're just talking about. We're just talking about distance, not actual movement.
Right, and this is why I would argue that within the model given, is that, like, look at the angular velocity of, like, the Earth spinning around itself.
That's
we're not 360 degrees per day.
We're not talking about
miles an hour.
We're not talking about that. Why? Well, look. We're not talking about that.
Okay, go ahead.
I want to bring you, like, closer to why I would argue that it's okay to leave out that other acceleration. Because if you then look at how fast, what? The other accelerations. Okay, yes, no problem. Okay.
So it's not happening. It's not happening in a vacuum. No pun intended. These things have to be working in tandem together. But there's no mathematical expression for these things working in tandem together. You agreed earlier. So I don't know why this has to be yet another contentious back and forth, because I'm telling you something that's a fact, and you either agree or disagree, and upon disagreeing, I'm going to assume that you're going to provide me with something I don't have because I'm ignorant to the fact. Like all this extra conversation, all this
if
extra
you let me
conversation
finish,
is
you'll understand where I was going. Okay.
okay. Well, before you explain, is what I'm saying right or is it wrong? Because if you give me a reason as to why it doesn't have to be accounted for, we're saying the same thing. I'm saying there's no mathematical expression for this movement. You're saying it doesn't need to be accounted for. So we're basically agreeing on that front. And then we would have to go to why you feel like your belief in this movement is justified. Because I really don't care. I already know the explanations and all that. That's why I'm telling you what I'm telling you. Because either I'm wrong or I'm right.
Right. So I don't agree with you that it is impossible to explain mathematically.
Okay.
If that was the question you were asking.
Okay, where is it? Oh, where is it? Is there an equation, or how does that work? I can just pass it off to someone.
Just look into angular movement.
Yeah, I would like to ask him a couple of questions. Because
can I please finish why I thought before?
Water when it comes to this. For one, Yellow Weasel, does gas move randomly and freely in all directions?
Which scenario are we going? Like generally speaking,
yes.
Yes.
That's.
But we already were there, and it didn't go anywhere.
No, this is just the beginning. This first question.
Oh, I see. Jay, I can see you.
A little picture here. This is an object moving through a gas. When an object moves through a gas at high speeds, the gas gets compressed on one side, where the object is moving into the gas, and on the other side, there's displacement, and so there's less pressure.
Exactly, and that's why the car would feel a force pulling it backwards.
Yeah, unrelated to what I'm saying. What I'm saying is, your globe has no effect of movement through space.
What is that supposed to mean?
You claim that the globe...
I'm saying the same thing that I'm saying. So how could you be asking... Sorry. How could you be asking what he means by that when you were answering for it when I was telling you, no, you can't answer for this?
Oh, sorry, no, I just...
now you're
that might be language barrier again. Like, I just couldn't.
Well, go ahead. My bad, Grace. I'm sorry.
Like his question in that sense. Like if it was the same question as your question, I'm fully fine with trying to answer it.
That's fine. Sorry, Grace. My bad.
No problem.
Excellent.
Yellow Weasel, I'm trying to point out that you were missing the point the whole time, and there is no effect of the globe moving in its orbit or shooting after the sun at millions of miles an hour. The gas is not getting compressed in the direction of travel and then getting less pressure where the displacement of the globe is. So there is no effect of these motions.
Right, and I can give you an example even with your example. Because here you have a car moving through the gas, right?
Yeah.
At a constant speed. Because this is like what is the speed. Like you have a constant speed inside the car, you have no pressure difference if the car is moving at a constant speed.
If you open the windows, it's not.
No, not forget opening the windows. The object itself is experiencing a greater pressure in the vector in the direction that it's traveling versus the direction it's traveling away from. The backside of the vehicle, there's less pressure, right? That's what moving through the air creates. Moving through the air. That's what it creates. So now we have this Earth moving, right? Should be the same idea. This is not accounted for or expressed in math anywhere.
Because the Earth is not moving through its own atmosphere.
How there's no way to justify that. Because not even again, I asked you for the math.
I mean, it would explain our experience, and I don't know that justification.
I asked you at least for the mathematical proof, but you agreed at the beginning of this conversation that there isn't. And
no,
you're trying to explain why it isn't
didn't
necessary.
agree. I said I agreed. I disagreed with you that there is no mathematical proof.
So then you just said the same thing I just said.
Wait, no.
Didn't he just say that there's no mathematical proof?
No, I said there is a mathematical proof. I disagree with you.
Where is it? Where is it? Where is it? Is what I've asked you from the beginning.
Can you provide the mathematical proof?
The math for what now exactly? For why?
Where is it? Not disregarding it means you don't have mathematical proof. So either it exists or it doesn't. You said it does. Where is it?
It's proof which presupposed.
Hold on, guys. I'm sorry. No, I just want to know where it is. You just said it. You have it, or not? You have it, but exists. It exists. Where is it? You telling me it's inconsequential means that it doesn't exist. Either it exists or it doesn't. Which one is it?
Wait, I'm a bit sorry.
That's fine. I'm not trying to pressure you. No pun intended. Okay, which one is it? Is there math for it or not?
Oh,
you telling me you giving me the reason that there isn't?
There is math for the effect that the accelerations, that the Earth's movement around the sun and also around the galaxy has.
Okay, but how is that? How does that work? How does that work for the air? That, for all intents and purposes, well, no. How does that work in relation to the air that is angularly conserving its momentum around the Earth? Where's the math that relates the movement to that movement and the force of gravity?
The movement of the Earth around the sun.
I'm sorry, I don't want an explanation either.
Okay, you don't want.
The quickest thing to do is tell me you're incorrect. There is no such thing, or there is a such thing. Here it is. Those are the two things I'm looking for. I don't know why you'd be trying to tell me anything.
There is such a thing. I am currently probably like a Google search away. If you want me, I can do that when the conversation dies down a bit.
I'm waiting. Because this isn't something that needed to be argued. I mean, we got a math professor in here that already knows what I'm saying, regardless of what he believes. He just thinks that we don't have to account for the movement. That's absurd, because you also said at one point we don't have to account for constant speed, and I said, well, there's acceleration. You didn't really respond to that at all. You're still going off of the premise that these things could maintain a linear momentum for some reason. You just gave an example of a car moving in a linear fashion.
Right, without acceleration.
Exactly. The exact opposite of what's supposedly happening with us and our movement through space with the sun.
Right. That's why my argument before that, which I unfortunately wasn't able to finish, is that looking at the angular momentum and the angular velocity will show you that the effects of the Earth moving around the sun and the whole solar system of revolving around the center of the atmosphere is minuscule compared to the effect that the rotation of the sun of the Earth has around itself. And
that's not okay. What informs this and justifies this belief? I mean,
look at the angular velocity of the Earth around the sun. That's 360 degrees per year.
Yeah, that's a red
herring.
It
really doesn't exactly.
That's not velocity. 360 degrees is not a velocity.
It doesn't change the fact that there would have to be displacement.
Yes, it is a velocity. It's an angular velocity.
Moving into the air on one side, so there would be greater pressure on that side.
Jace, there would be no atmosphere at all.
Yeah.
Let's keep it real.
That's giving them the violation of the second law of thermodynamics, of course. It's just they have no effect of their claims. It's all just we can't measure it because we don't actually look for validating our claims. We find the confirmation bias and say that's it. There's no actual verification.
The displacement you see around that car there only happens because in front of the car you can drive for you drive infinitely long, and there will always be air in front of the car putting pressure to the front, and there will always be a displacement zone in the back. But if you have this, imagine no, that's why I said imagine you have a container.
Bro, you have no logical coherent excuse for why the gas would be pushed away from the surface in one direction to create and pulled more on the other side to create the impression that there is no pressure differential based on motion.
Okay, so look, someone posted this video here earlier. Can I still find it? Yeah, the balloon in the car by Smarter Every Day.
Yeah, that debunked the thing you were saying earlier.
It debunks the same thing you're saying.
In the car, because they later, when you actually look into that, they talk and tell you that there is pressure differential in the car when it's moving, and that's what causes...
When it's accelerating.
But it also stays when it is moving. It continues.
No, if you have a constant velocity... Yeah, well, but imagine you have no air.
Listen. The air outside of the car, right? Is the air outside of the car? The car is moving. The air is outside of the car. The air is outside of the floor. The floor is moving, right? The ground, the earth, the ball, that's moving. But the effect isn't the same. Only one of these things we can actually observe and experience. The thing about the earth, we can't if we experienced it, that would be one thing, but we're not even experiencing it. And you're telling us to look at a balloon inside the car. No, the car is moving and the air particles are moving the fuck out the way, bouncing off and going in all directions, yada yada yada, versus the earth moving in a direction but that not happening. I don't know how. I don't know what you're thinking when why do you think this balloon inside the car has anything to do with the air particles that are hitting this moving car? The exterior of the car. We live on the exterior of this ball that's moving.
No, we don't.
And we don't have the same.
We don't live on the exterior of the car. This is this.
That's why it's
no, not even.
Yes,
not even.
yes.
And I'm not claiming.
To be a concave earther who lives inside his ball. You claim to be a globe earther who lives on the outside of his car.
Yes, but the space isn't filled. Like, not all of space is filled with air that we are moving through.
Stop. I get you.
Okay.
So no need to continue. I get you.
Okay.
I'm not concerned with air anywhere else. I'm talking about the air that's next to me right now. Like the air here on the earth. Okay?
Right.
If the earth were moving, it would affect the air right here. Because the
And
air
I
isn't
would
connected to
argue,
the ground.
and
But
I
you're
would
not
argue that
arguing.
they
But
are
you're
saying
not
it
you're
doesn't,
not
and
arguing
from
it.
my understanding of classical mechanics, it makes sense.
But you're not arguing it though. You're not arguing it. You're talking about at best the axial rotation and gravity being able to
You brought
sustain
up the
all.
axial rotation. The thing with the car was brought up later on. And if you want to talk about
Okay, but
why we don't experience a pressure zone in front of the path of the Earth and a low pressure zone behind the part of the Earth, we can, if you want to, we can talk about that.
Yeah, but you're not addressing it though.
Well, I was
Because you're
addressing it, but I'm not. I can't finish my points, and unfortunately also because of, I would argue, partially the language.
Well, it's not. Get your phone is ringing or something. It's very simple. Like we're on the exterior of this ball. The air around us doesn't act as a shield. Okay? Well, because even if it did, there's nothing to shield us from in space other than the harmful rays of the sun, I guess, in that idea. But the bottom line is if the Earth were moving through space, they would collide with these air particles. You're not giving any justification as to why it wouldn't. You haven't given any mathematical expression, and I'm pretty sure it doesn't exist.
Especially for that, I don't know, but
I'm saying I don't know is exactly what I said you said from the beginning, but you just said you didn't.
No. That was a different one. You said.
No, it's not different. It's not different because when Drace brought in his example, I said, yeah, that's exactly what I've been talking about all this time. You don't have a mathematical proof or an expression for this problem. You have a belief, and I asked you, well, how is it justified if not mathematically? What is the justification?
Okay. Let me try and formulate the sentence before spitting it out.
While you're thinking about that, I think the issue here is he's stuck on. He thinks gravity can violate the second law and contain gas, holding it all in lockstep with the globe, regardless of any motions. So that way you can hide all the facts that would be required, but gravity cannot do that.
That's what you're saying, but you also can't prove it to me in the same way that I have difficulty proving it to you on Earth inside.
Listen for a minute. Okay, you say I can't prove it to you, but what does gravity do? It makes things go down, right? Go boom boom.
No, gravity changes space. Gravity deforms space-time in order to, which then paired with the straight movements, with the inertial movement of other particles, masses, anything.
I don't want to hear the pseudobabble. Just go to the point of it. Does it make things
gravity is an apparent force.
Perspective?
Gravity is an apparent force that.
Does it make things appear to go down from our perspective? That's all I'm asking.
Yes, because down is defined as where gravity is pointing.
Yeah, so it makes things go down, go boom boom, okay?
Not necessarily boom boom, but it can make things go boom boom, yes?
Yeah, okay, so you agree. In the case of buoyancy and hot air balloons and helium balloons, in the globe belief, you must believe gravity is pulling things down under things, so it also makes things go up, correct?
Right, that's the whole idea of buoyancy.
Okay, and then in order to believe that gas shows no effects of rotation, you must believe gravity is holding the gas with the rotation to hide all effects of rotation, correct?
Yes.
Okay, so we would be able to detect that because things rising would then have to travel a longer path around the globe and would be accelerated by your imaginary gravity force, which would be detectable when it's rising. And then when it's falling, it would decelerate to match the rotation because what we see is no effects of rotation, and cannonballs are shot straight up into the air and fall straight back down into the barrel.
Have you ever done the experiment of what your parents don't tell you to do, like shoot an arrow straight up? It doesn't come straight down.
Yeah, that's called wind. Have you heard of it?
Exactly.
Yeah, that's why they used cannonballs.
They are also affected by. Where
you
are we
have
going? I'm a bit confused.
You have a problem again. The same problem we had with elevation. Elevation is used in two different contexts, but can't be applied at the same time, which is a problem. Well, in this case, the same thing is happening.
Yeah, kinda, but also not, because I don't think we have that.
It's just the same flow and logic. That's the problem. Is it's the same flow and logic, same form, different argument. That's the problem.
I'm just not all the way done to my point. So, at that point, when you're saying that things are getting accelerated to the side and decelerated to match the rotation, which everything appears to not be rotating, so that's what you must believe. So, gravity is now making things go to the sides as well. So it's making things go up, down, and to the sides.
I'm saying
omnidirectional magic force that solves all of your problems, but has no evidence for it. Can you present any evidence that gravity is containing gas and can do all these magical things to gas, or is this just based in beliefs?
Can you please repeat that question? I don't want to
Do you
get
have
you
any
wrong.
evidence that gravity has all these magical effects on gas and can do all of these things?
Demonstration.
Yes, and I would argue that the fall in pressure in when you go higher in elevation proves that there's an. That's not evidence? Okay, please explain to me why it's not evidence.
That is in no way evidence of that. That is just another claim that you have no evidence for your story. Like, there's no evidence to suggest even that that is the case.
Oh, there isn't?
Yeah, there isn't. I haven't seen any. Can you please present it?
Next time I do a hike up a mountain, I can make some measurements.
Again, not evidence of it. If you
combined with temperature.
If I drop a rock, that is not evidence of the cause of the rock dropping, other than me dropping the rock. Do you get it?
Okay, but then there must be another force on the gas creating the pressure difference, wasn't there?
Yeah, I'm not saying there's a force, but have you heard of Charles's law?
Charles's law, is that one of the gas laws?
Yes. It essentially means that temperature and pressure are correlated and connected. So when
yes, I agree.
When you take, for instance, a helium balloon fully filled inside a hot room outside into the cold, it will appear to deflate and become very crumpled up.
Yeah, I agree.
The gas inside got compressed because the temperature changed.
I agree.
Yeah, so we would expect there to be less pressure because there's less temperature up there.
And that's why I said I would also make temperature readings and then compare that with.
Also, all of the gas generated at the ground level, at the earth, the bottom. That's where all the gas gets generated and released, and then it goes up against what you claim is gravity and holding it down. It diffuses up and goes straight up into the air, and then it condenses due to the cold out of the sky and falls back down. So we have gas generation at ground floor and gas being removed from the system above. On top of Charles's law, on top of things like the humidity gradient, which creates a increase in pressure because there's more stuff in the air.
Can I comment on the condensed part?
Sure.
Before you go on, we can then go to the next point. Water vapor makes up a very small part of the atmosphere, and just the taking up of water and then condensing it back down wouldn't be enough to explain the pressure difference.
Water is not the only thing that cycles here, my friend.
A lot of things cycle, but they don't.
Cycle here, except maybe helium. We don't know how that works.
So you're saying hydrogen condenses at the firmament or whatever?
We don't know how that works. We don't have. We're not privy to higher cycles.
You're saying oxygen? Okay, interesting. Oxygen and nitrogen also condense on the
cycle. There's a sulfur cycle. There's a bunch of cycles of gases that come up and down.
CO2 cycle. Yeah, but the CO2 cycle happens only on Earth. On the ground, you have
Only
CO2 taken up, and then also oxygen has a different gas pressure. What? Yes?
Yeah, we only have access to the Earth, my friend.
We
have only access to the verifiable. And according to all verifiable science, there is no evidence, solid, verifiable, actual scientific evidence to support the globe. There's just these pseudoscientific evidences, so-called, and these claims that we must just take on faith.
I don't know. I would disagree in that sense. I mean, like before, we have been talking about other stuff that I am not knowledgeable enough and I haven't researched into, where I would definitely give you the benefit of the doubt. But also, like we have been talking about this whole gas pressure stuff for way too long now, and I think like nothing I can like way before you came, and also
I know.
I would argue that everything I can tell you now is probably quite similar to everything I've said earlier. And if you want me to come up with, or if you want me to present you other solutions in that sense, I would argue that you would probably need to give me some time to think about, and also like look up calculations, look up other laws of physics.
What I would recommend you doing is try to formulate some sort of experiment where you can show gravity holding on to gas and preventing it from expanding and filling an available volume. That would be a good start. And then you could try to figure out some sort of experiment where you could make it so that gas does not get compressed or lose pressure with displacement. That would be interesting.
The second part was what? That gas cannot lose pressure with displacement.
Yeah, if you, for instance, make a container larger, you lose pressure within the container because there's displacement.
Right.
So if you can prove that doesn't happen, I would love to see that.
Or you can just accept that the Earth is not a spinning globe.
But you know, like I want to know it's true.
I like that one.
If you could be the same like all the other people telling you the Earth is round, and you could be sitting here the Earth is flat, but actually it's like not even existent in that sense as we all think of it. So like I would prefer to be able to prove either one of the cases, or like
We all want to prove that. We all want to test it via empirical science, things that we can see, sense, taste, smell, all those things, but not trust pseudoscience.
I can help him do that.
Yeah.
So, Yellow Weasel, you agree that light travels in straight lines, correct? Unless it's being
Unless the line is being, unless you have, yes, I would agree.
Yeah. So generally, when light gets refracted, light of different wavelengths get refracted at different rates. Do you know
Exactly. Yes.
Okay. Cool.
That's why you see a rainbow effect when you have light refracted.
Yeah. So it's super simple then to see if the globers are telling the truth and use two lasers of different wavelengths. And if they both hit the target that's supposed to be hidden behind the curve, it cannot have been a curved ball refracting the light around the curve because it would cause the lasers to deviate from one another. Do you understand?
Unless you agree that NASA and the other agencies can just, at their own whim, change the calculations to fit their need.
Okay, so you would propose an experiment where you shoot two lasers of different wavelengths over a distance which would imply that the bulge of the Earth would be in the way, and then see if both of them hit, or what is your experiment?
Yeah, you would see if both of them hit the target, or if there is a difference in deviation between them, like one of them is getting refracted more than the other one, so they must have both gotten refracted, and based on that, you can actually see how much they're getting refracted. You don't need to assume they're getting refracted around any curves. You can just literally calculate it based on your results.
Right. And what would be what would you think would be expected on a flat Earth? No refraction at all in both of them, or?
No, there can be slight refractions. We can see that generally in the air. There can be slight refractive effects, so there can be small deviations, but there's not going to be the deviation that the globers need, which is first of all, the beam should never hit the target. If one of them is hitting the target, that means the other one should not be able to because it's getting refracted much less.
I'm unfortunately not knowledgeable enough in lasers to see how big their wavelengths deviate, but it would be an interesting experiment.
Yeah, we have done this essentially from all angles. So, for instance, infrared is refracted more than visible light. So we used infrared cameras to look at the horizon, and the horizon doesn't get closer like it should on the globe because there's less refraction. You actually can see further, and that's not.
Yeah, I mean,
good
that's
for the globe.
no. Isn't that exactly what you just said? Infrared gets refracted more, so you would see it get refracted further behind.
Less. Look it up. It's the opposite of what you just claimed.
It says a longer wavelength.
Instead of trying to get a gotcha, just look at someone doing it, and you can see how far they can see.
I'm not trying to get a gotcha. I just want to be sure, like what he's saying, man. If I want to believe him, then I need to be able to know what he really said.
Well, we're encouraging you to just look at it and then tell us what you think about it. I mean, it's just creating that thought process rather than, oh, well, what does this science say? What does this calculation say?
Hey, bro, how many flat surfaces do you need to make a ball?
How many flat surfaces do you need to make a ball? I guess that depends on how exactly you deflect. What is your minimum requirement of? Yeah. What is your minimum requirement of?
How many 500-mile surfaces do you need to make a sphere of 3,959 miles of radius.
I guess just one Bolivian salt mine.
Because like no one would be like I don't no one claiming that the Earth is made up of more or less like I don't know, like I don't think anybody is saying that the Earth is made up of level things only.
No? Have you ever heard of level buildings, level lakes, level pools, level sea level? It's level it's level everywhere.
Well, if you
If
already
you want to
say
do
that
anything practical.
it's level, then that doesn't allow for a globe. That of course
Exactly. You got it. You got it, bro.
Right, but I would go so far to argue, or like they would as well, of course, also say
Hey, bro,
that.
if you want to accomplish anything and if you want to do anything practical in real life, if you want to do anything, you'll never take the globe into account. Never, ever. For nothing practical.
Oh, I would argue you do. Like
I second that. You never do. You never, ever.
Please try to argue how they do, but first check out the bottoms of all the oceans. It's claimed to be one of the flattest places or flattest places in the world. It's called the abyssal plateaus. There's nothing but flat spots. They also surveyed Kansas flatter than a pancake, and then extrapolated and took all the other surveys of the USA and found out the whole of the USA is flatter than a pancake. It would require a mountain bigger than the tallest mountain in the world.
I'm check it out.
Not be flatter than a pancake.
I mean, being flatter than a pancake is not even that difficult. A pancake has quite a lot of surface imperfections.
Who the fuck is this guy?
How many flat pancakes do you use to make a sphere?
Are you saying that it's in there's that's like saying I'm going to go in my flat black backyard and then just dig a hole and therefore there's imperfections and that makes it a sphere. Like what?
No, that was not at all what I'm saying, man. There's different definitions of flatness in that sense. When you talk, for example, about like a pancake being flat, you wouldn't say it is level in that sense, but it would be about how deep are the surface imperfections. That's what you use in metallurgy. Like a flat surface isn't necessarily complete. Like there are different measurements of deviation.
Right. This is exactly what I explained to you with the elevation problem. Because
Right.
flat just means without deviation from a specific point. Like, it's not this high or this low from this 0 point versus somewhere else where the variation is great. So that's what they mean. Like this area has the least amount of variation. But the bottom line is when you're talking about all of that, the 8 inches per mile squared is not even in. There's no reason or nowhere you would apply that. You would just assume that
You can never
for
find
all
it.
intents and purposes there's a zero baseline, which is a line.
You
pretty
can never
much.
prove it, that there's 8 inches, of travel that creates that curve ever. It doesn't matter what industry or what profession you go to, pilots, civil engineering, nothing. You'll never find it. It's never taught. It's just trust us.
If you say so. Anyway, I gotta grab a bite. After some time. No, I'm not
Just
allowed.
kidding. Bon appetit. Bon appetit.
Yeah, don't believe us. Just check it out for yourself. That's what we do, and we did. So if you have any new information, we're always welcome to hear it.
Hey, welcome to Flat Earth. Remember when you making that flat bread, that flat sandwich, before you eat it, it's all flat.
Right.
Come back later with questions and tell these flat earthers how the Earth is a spinning globe. Just bring your proofs.
Bring my proofs.
Yeah.
Okay.
It was a good talk, guys. This guy.
Anyway, but wait, but before I forget, what do you think about like when it comes to lunar eclipses? Like what
observable phenomena that wouldn't determine the shape of the Earth.
Well,
what causes the round?
Geometrically, it's impossible in the heliocentric. What causes it is one of those questions. Remember, I said some things we can know and some things we don't. Well, everything that we know about eclipses are based on geometry that isn't apparent. For what I mean by isn't apparent, meaning the cause that they've given us is due to there being an alignment of the three bodies, where the observation is exactly not that. Yet again.
Wait, but
So
we can calculate.
What's causing it is not what we've always believed most of our lives, but we obviously also don't know what's causing it. If it isn't that,
how can we then calculate it for centuries to come?
Because it's
like
just
when eclipses will be.
Because flat earthers did the calculations for you already.
Oh, they do.
Yeah, that's true. Yeah. That's true, but it's just
but, like,
a cycle.
I know, but
listen to what I'm saying. Listen to what I'm saying. Right? Just listen to what I'm saying. Okay. The cause that we all grew up thinking it was isn't, and that's by simple observation. Because we were told that the reason that we're seeing it's an eclipse, for Christ's sake. Something is eclipsing something. That's what the definition is for. But the bottom line is that's not what we see, because we see both the sun and the moon above the horizon. That's why they call it an impossible eclipse, because it's geometrically impossible.
Wait. A lunar eclipse where you both see moon and sun above the horizon.
Yeah, and the reason why we can post-dict the eclipses years into the future is because the Chaldeans and the Babylonians used to monitor the sky, and they were flat earthers, and so they recorded down the cycles of the astronomical objects, and we still use those cycles today.
Yeah, you're not predicting anything. It's a cycle that repeats and repeats and repeats, and it's not a prediction.
Which group did that?
Babylonians and Chaldeans. It's the Saros cycle.
Gotcha. Sorry, no,
I found on the website I'm at the moment, I found something about like a third body or something.
Yeah, they had ideas about what was causing it, similar to how globe believers have ideas. We have no evidence to verify either idea. Well, you can exclude the globe idea, but based on evidence, but we don't know what's causing it.
Hey, it's okay for you not to know something. It's okay. If we don't know what causes the eclipses, we can observe the cycles and the luminaries and what is causing it. If we don't know it, you don't have to know.
But if we don't know what causes it, then how can we calculate them like hundreds of years into the future?
Because it repeats.
It repeats in a cycle, and they've used a 2D circle to figure that out. Not a sphere, but a circle based on what appears to happen in the sky.
Yeah, you know when it's going to happen.
Anyway, I'm a grab a bite, but yeah.
Yeah, refuel your body and your senses and come back with double the energy, okay?
If you think so.
Yeah, eclipses are really, really simple, guys. They happen and have been happening the same for thousands of years. You wouldn't need to know one thing about why or how it happens. Just go back and record it happened here, does the same thing again next year, does the same thing again next year, does the same thing again next year. You don't need to know why, and they don't know why. They never have known why, and they never will. So, well, maybe not never, but as of right now, nobody knows for sure. And because it's certainly not the Earth falling in between the sun and the moon. So That's been
have,
proven. That's
yeah,
been
some people,
absolutely thrown right out the window. So
we
some
do know
people
the
figure
when, but not the why and the how.
exactly.
yeah, some people figure it's spiritual. Other people figure it's just by nature.
I don't know about that word, nature. I'm like kind of like losing that one. That sounds like a globe word, like
No, it's
black
not.
holes and
No, it's
exoplanets.
not. I mean, yeah, you can, I guess, but it's not usually the indication of it.
That nature word sounds like evolution.
No, not to me.
More like revolution because it comes around the same time every year. Round and round and round we go.
Yeah, I'd be more concerned if it didn't happen.
Yeah, exactly.
Yeah.
And then you know something's going on. Something
That's
bad is
right.
happening.
Yep. Exactly right. Yeah. If all of a sudden we don't have a eclipse happen exactly when it's been happening for the last 2,000 years, something's going on.
Yeah, that's
But
why some
what?
people think it. You know, it could be spiritually related or other things like that. But that's just one side of the equation. Maybe not everyone kind of thinks like that.
I just want to say, Trace, you handled that guy really well. I'm very impressed.
Yeah, you guys did great. I was listening to the conversation. That was good. He actually he's thinking. He's thinking, so that's good.
I almost thought there for a second at the end he was gonna kind of go into troll mode. I almost figured it was about to come.
He was really respectful and he was
But
very
yeah.
polite. Yep. It was good.
I think he realized that it's not that kind of group. It's a different kind of group. So I think he was pleasantly surprised, probably unpleasantly surprised, because now he's got to think about it.
Good job, guys. Well done. GG.
I want to be mad if someone finally proved it, because then that would mean that the whole world wasn't gaslighted and lied to and all this other stuff. You know what I mean?
I can predict that you're going to get slapped in the face every time you say something rude to your wife, because every time you say something rude to your wife, you get slapped in the face. That's how much we know about eclipses right there. Maybe we're done with that subject, but I was out of the room and I just wanted to throw that in. It's pretty much the same. It's going to happen. We don't really know why. It's just going to happen.
I can predict that every time you jump into the ocean, you're gonna get wet.
Hey, yeah, there you go.
To continue that analogy, so when you are rude to your wife
and the earth has nothing to do with it.
When you're rude to your wife and she doesn't slap you, you know there's a problem.
Oh yeah, there is a problem.
There you go.
I just really get a kick out of these globers that come in and say, we can predict eclipses up to 2,000 years in advance from now. How can we do that if it wasn't a globe? Well, because
they didn't
it's been
really think
happening
about it.
for the last 2,000 years already. Oh my God. It makes me just laugh.
You gotta remember that they watched it in a cartoon, therefore must be true.
I mean, I did too. That was my thinking until I had the slap in your face moment.
I knew cartoons wasn't real, so.
I mean, we know now. When you're 7, 8, 10, you think the world grows up like that.
Mm-hmm. That guy's gonna be eating his food on a flat, motionless table, and he's gonna be like, am I spinning? I think not.
Actually, that's one thing, Jamesy, you taught me during my early days on this server is that these globalists, they always presuppose a round Earth. I mean, even when they come up with the mathematical proofs and formulas, right? You're assuming that it's a round globe to start with. So, that kind of like nullifies the so-called premise in the first place.
Hey, do they forget like history and whose calendars we use and how we go on about life? Like, we didn't create all those things, but we carry it on off of, I don't know. That's so funny. It's only about here and now, not about what was and what we did learn and the legacy we continue on from.
Just kills me when they say we know that we live on a globe, but therefore this and therefore that, and we know this about the stars. We know how far they are away because we know we live on a globe with a radius of this, and it's like, okay, then we debunked the radius many times to be not what they say it is. In fact, it's not even a ball at all to begin with. But anyway, it just kills me. I mean, it when I hear these guys go on about this kind of stuff, I just have to sit there and giggle. I do. Anymore, it's just so funny to me that they just can't seem to get it in their head that you just can't pre-assume something that you haven't proven yet. But boy, are they good at it.
Well, once I find out that the ground I was standing on is not spinning and there's no asteroids coming from space to destroy my house, I feel this sense of relief and peace.
Yes, I agree. When I found that out, when I realized that was a big relief to me too. I mean, one time I was afraid of asteroids. I believed that stupid story that one was going to hit the Earth and cause, all this destruction and massive deaths and all this kind of stuff. It's like, oh my God, they're predicting this asteroid to hit us in 27 years from now and put everybody in this state of fear all the time. It's just constant fear about things that are not real. That's just straight psychosis is what that is.
Yep. What are the craters that we have? They just lies for testing or for bombs or whatever?
I personally would think that it's some sort of possibly a bubble of like from underneath the ground, like a geothermal, or who knows? It could be a number of things, but certainly not an impact, in my opinion.
Could be water coming from it.
Yeah,
they could be minor. There could be minor sinkholes.
Okay, yeah, that's true. Sinkholes, or I was thinking if it were bombs, well, at least it couldn't be like nuclear bombs because you could test the radiation in the area.
Yeah, just to.
Well, that's a whole new conversation there, in my opinion.
Just with what you guys were saying before, in Siberia, for instance, they found two craters that they thought were impact craters, which then were later discovered to have been due to natural gas deposits exploding or
Oh, yeah. I've heard about that, in Siberia. Because they got... That's a good point.
Yeah, that's what I meant by a bubble of some sort coming up from underneath.
Yeah, because some of those places are even dangerous. You know, just you got a lot of nitrogen coming from the ground and stuff. That's a good point.
People want to wonder where the magma that lava comes from. You know, I think personally that if the ground is it all have any moisture in it, or where it could settle or start to sink from all the weight from above, like the massive tons of dirt compressing down, and it's moving, even slightly movement under that much pressure can cause a lot of heat. It could cause just naturally to warm up and just get hot just from the pressure.
Yeah, the Earth is really mystical and magical. Like,
Yeah,
I
it
have
is.
no
I mean, I'm
idea
just
how it. I
Yeah,
have
you're
no
sorry.
idea how it was made or whatever. Like, if you just look at the aquifers and stuff, it's layered in these weird ways.
I would say intelligent design. Absolutely.
Yeah, it's a very dynamic system that like is amazing.
To me, I would say all these things come back to as being intelligent design. You know, place was created, but I know not a lot of people are on the same page on that.
Oh, I'm definitely on that page.
Most people are on the same page on that, at least within
Yeah.
this community, but we don't have a consensus on what created it or how it was created.
Right.
When.
I mean, yeah, because religion is convoluted and has created a lot of bad things, but
Well, that's like taking a Rolex watch and setting it on the counter. No one's ever seen one before. There appears a Rolex watch on the table, and you take it and you look at it and you take it apart, and you realize very quickly that it took some massive engineering and, you know, to put that team together to make it work the way it does. And the Earth, I think, exhibits the same type of complexity.
Oh, absolutely.
I mean, you'd know for sure, but if you'd never seen a Rolex watch before, you'd know for sure after looking at it for a few hours that was definitely put together by someone. Very, very, all the mechanics behind it all and the way it works and everything. I mean, it's really obvious that it was made by someone. And
yeah, but
the Earth exhibits the exact same, type of appearance to me. You know, I mean, it's not like wheels and cogs and this and that, but it's certainly many other things that fall into the same design category, in my opinion.
Yeah, but then you talk to Brenda, and Brenda tells you that that watch is a natural phenomenon.
Oh, like the shoe. Like the shoe, I get it. Babe.
That's part of the fun.
Yeah, I got dinner. You guys have fun.
Yeah, it's too bad we can't take this Earth apart a little bit more, like dig a little deeper and look a little more intricately at all the layers of the Earth, and and if we did that, we probably could figure out a whole lot more about what's going on.
Yeah,
just to dig down any deep. What did they done? Like maybe almost 8 miles. That's not very deep.
Yeah, I think we'd find some very scary things if based on all cultures that went before us and whatnot, with their theories on what is down there.
That's one big thing. They keep saying, "Oh, the oceans are less explored than what we know about the outer space." Bullshit. But the Earth itself is even more unexplored.
Yeah, our core is. I mean, if you take any culture before, you know, they would say that Seoul, or I don't know if you guys know what that is, but essentially hell resides there. It's an interesting theory. If that were true, I definitely would not want to bore down there.
Well, I would rather they wage war against hell than each other.
That's true. That's true.
There seems to be, in my opinion, there seems to be a very similar Karman line below us, as just like it says, as above, as below. I think there's a Karman line below us too. It's an impenetrable line distance that we can't go beyond.
That is a good point. Yeah,
and that's the same as above too. You know, it's a Karman line. Cannot, never been above it. Can't go there. So all you get to figure out is
you think those would you think those that are, would you think that those who are in power, who created this lie, this paradigm of a spherical Earth, they've come to that realization a long time ago, and they're bored, or they're trying to figure it out or do something about it, or they know something that we don't, and they're trying to just control the masses?
They definitely know some things we don't know. There's no doubt about it. As far as the powers that be, I mean,
whatever, Stacey, I can copy and
they wouldn't be
something. Why can't I?
Yeah,
Yeah.
if you just look at the history of it, I think I forget what. Yeah, that was what I was gonna say when God Rockin started talking, and then I forgot what the follow up was. What were we talking about? I was talking karma as well, so it's
was it digging down?
Oh yeah. No, that was the one before that. I already talked about that. What was God Rockin talking about?
There's food, so let's go.
Oh yeah, I should eat my food. I'm sorry.
Guys, it was nice talking to you. Hope you guys have a nice Sunday.
I'm back with my food and you guys are quiet. I remember what he was talking about, though. He was talking about as below, or as above, so below, and the those similarities, essentially. And I was thinking about how if Bezos wanted to go to outer space and he could get past the Kármán line, he would have. And then I was just thinking about how amazing the Earth is.
I watched a funny video the other day put out by Elon Musk. It was about a month ago, shortly after that Bezos rocket launch. He said, well, he says, I'm not trying to bash on Bezos by any means. He says, but he keeps talking about space exploration and this and that. And he said, I think there's one thing the guy's missing out on here first. He says, first, we need to be able to go into what's called orbit, which doesn't seem to be anything we've been able to do yet. Elon Musk actually admitted in kind of a way that he did come right out and say, we've never orbited, but he did say that that'd be the first thing that we should master before we start thinking about outer space, is to orbit the Earth. He acted like basically saying it's never been done yet. So that would probably be your first step, Jeff. Bashed on him pretty hard about it in that way. You know, so quit talking about going into outer space, dude, when you can't even orbit the Earth yet. And neither can we, so.
I think I have a short clip I can play on this with Neil Hostile Witness Tyson.
Neil Hostile Witness, what Tyson? Yeah, that's good. That ought to be good. I'd like to see that. He is pretty much a hostile.
You didn't ask, but I'm going to tell you. Do you know how high up above the Earth he was?
No.
So if you take a
63 miles.
Well, yeah, so right. So take a schoolroom globe, and that's how high above it is he? So he's about 2 millimeters above the surface of a schoolroom globe. So nobody has seen the curvature of the Earth from that height. I just want to make that clear.
Yeah, that's pretty hostile for the Globers. I'd agree 100%.
Yeah. So Bezos never saw any curve up there. He didn't go high enough. And you think the millionaire just wanted to go up there and not see anything special and then go down again?
No, he didn't go up there. That's my opinion. There was no one in that thing. No one went up anywhere. Still too hazardous for manned flights to try and go into a realm they've never been into yet. They would do an unmanned flight way before they would do a manned flight. And there was either no one in there or they knew what they were doing. They was just going to go up 63 miles, make a little arc over, come on back home.
It was literally designed to go up to 63 miles or 60 miles and then fall back down to create a parabolic drop so that they would experience zero-G effects.
They're just going. I know. What are you guys doing? You look stupid when you do that.
Wait, he didn't. What do you mean? Stupid to who, motherfucker?
To him.
He's thinking we just got here. You stupid.
Oh, all right.
God. I'm that dumb. God.
Just mute him. His friends forgot the booze.
Wait, what's going on?
Nothing. The Earth is not a spinning globe. That's what is not going on.
So what are your thoughts on the Earth, Izion? How do you pronounce your name?
You pronounce it Etzion.
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 Etzion. Okay, thank you.
Yeah. I think it's flat. I haven't done like scientific research for it, but a few days ago I went on a flight to Spain and back, and I couldn't see any curvature on the horizon. Like, I don't know if that's like viable proof or anything, but I know it's like there probably would be curvature if the Earth was supposed to be round.
That's funny because I was just playing a video of hostile witness Neil deGrasse Tyson saying that there would not be any curvature to the horizon even at 93 miles up.
Well, I don't really know.
Damn.
I don't know.
93 miles up?
Yeah.
But I don't know, but I also do think like people like NASA can lie a lot.
But I can understand where you're coming from. When you look at the horizon and you get told that boats are disappearing over the curve of the horizon, and you look at the horizon, there's no curve. The horizon is a circle around you, 360.
Yeah, that's what I'm trying to say. I can't speak so much about the science and stuff, researched it that much, but I can just say that like, you know, I don't think you should believe straight away that the Earth is.
Your volume is a little low, so it's hard to hear you.
Oh, okay, yeah, sorry. Because I lost my mic. But I'm just saying that like people are led to believe that the Earth is round like straight away. But I think people should research it more before coming to that conclusion.
Is it me or did his volume just get lower?
It is a bit low. I was able to understand him, but it is low. It is.
If you can hear him, Jensi, you can talk to him, because I can't hear half of it.
Wait, is this better?
I can hear you. Yeah.
Yeah, okay, so I was just saying that like people are led to believe straight away that the Earth is round when there's a lot more to it. And like they should research it a bit more before coming to that conclusion.
Yeah, I agree with that.
I don't really have much else to say, to be honest.
We just remember, round isn't necessarily, how do you say, doesn't have to do with sphere much, because you could have a flat round table, right?
Yeah, it's just like I'm just wording that way. Sorry, I should probably say like globe and sphere more, but
Yeah, the Globers think the Earth is a cartoon sphere flying through the vacuum of space.
yeah,
But they do use the round word a lot. They do say round this, round that. The Earth is round. Flat Earthers are wrong.
yeah, I'm just
That's like
faster.
that's like a half statement. I don't know.
Yeah. All right, I've got not really got much else to say. So if anyone else wants to talk, they can.
It's okay. You don't have to own the mic.
Okay.
If you have questions, if you want to say anything, you're welcome to ask questions.
Okay. Cheers, mate.
No, if he started to speak, he need to speak half more hour.
We also
Hey, listen this, my friend. Talk to my friend Sasha.
we also have DEA, their X, and I'm probably butchering his name, but he's deafened now, so he can't hear us.
How dare he?
I was gonna try to lure him into a conversation, but
Might be pronounced D there X. I don't know. Sorry about earlier a minute ago. My kid's off his rocker. He pissed me off. Just comes bursting back in the house after he left because a sheriff drove through the parking lot. Oh my God.
yeah, I heard that teenage sass. I knew that was a teenager.
Tell him he will be fine. He will survive.
Yeah, I know. I once you guys meet, I realized my mic was open. I got pissed. I said, "Why did you do that?" Burst in my house and start blabbing off about a sheriff coming in the parking lot. They come here all the fucking time. They practically live here.
I muted you.
I know you
So,
did.
yeah.
Thank you. Thank you. You know, the problem is with this whole thing is if they would start the conversation off in the beginning, which they never will, they say that the Earth is a globe. Well, the very next question or the very next thing should be, we know this because we've done this, this, and this, or ask, how can that be possible? Could the Earth actually be a ball floating in a vacuum with an atmosphere next to a vacuum? You know, are these things even possible to begin with? I mean, before we start assuming all this other stuff about planets and this and that, and first of all, let's go right back to step one and determine whether or not even just that one simple thing is even possible. They'll never do that because it's not. It'll prove very, very quickly that those things are impossible to do. They'd never get away with telling the story if they were even halfway honest about anything. They would just destroy themselves along the way. And that's kind of what we've done, in my opinion. We looked at it and wait a minute, a ball, when was that ever proven? I mean, and is it even possible? It's not. Defies physics, defies the second law of thermodynamics. You've got to throw it out the window. You got to throw all these things that we were told to be absolute truths, have to go right out the window if it was a ball. They don't match. They don't work together well at all. I mean, it's like that they don't go there.
It's also super simple. You just ask for the experimental validation, and then you look at it. You don't just get told what it means. You look at it, and then you compare it to everything you know, and then, oh, it doesn't actually match everything they're saying. They just have beliefs about it. It doesn't actually prove their claims.
Well, they're really not even claims. They're just spouting off at the mouth. Because the real claim would have evidence behind it. You know what I mean? I mean, that's the first thing. If you're going to make a claim, you have to have evidence to support it.
Yeah,
you
it's a
just
valid claim.
Yeah, you just don't spout off at the mouth. It's a globe. Okay. And that
globe.
You can prove that how?
Yeah, this is because
globe. Why? Because globe.
This is because they never learned logic. So they just give you a bare assertion, and you're just supposed to believe it. That's not logical.
No. But we are the illogical ones for doing that because we don't just believe. Oh, we've known for all these years. We've known that we have. When did we know these things? It's just really odd. I mean, it's just a bass backwards way of going about things. And I understand why they do it, because it would complete their whole model would fall to pieces right before their eyes. They used logic from the gate, it just wouldn't work. So
Yeah, it repeatedly violates the law of non-contradiction, and it doesn't have any valid reasoning for it. It's just fallacious argumentation. So, yeah, it would fall flat right away. I think that's why it really didn't gain a lot of traction until they had already gotten control of the educational board and removed logic from the curriculum, and you no longer had the trivium and the quadrivium, and you got the worker. You got all the workers created for the Industrial Revolution to work as debt slaves, essentially.
Yep. Yeah, I think you're absolutely right about that. It didn't. There's no way it would gain traction until they pretty much just shut the door on logical, thinking. We already know. No, you don't have to do your own research. The scientists have determined this is what it is, and you don't need to check it out. We know that they're right because they're scientists. They're, in fact, their name's Neil deGrasse Tyson and Bill Nye, the science guy. They're just smart people. Of course they know. So if you're told something like that your whole life from when you're just a little kid, it's like you don't even have a chance to try and learn anything about real truth. They're just going to brainwash you with whatever they want.
It's kind of like with this previous scare they put the whole world through. There are establishment mouthpieces which history will remember as their saviors, and we will get taught about how they saved us.
Yeah.
While actual accredited people who have experience, knowledge, and specialty in these fields are getting censored and ignored, and this has always happened. This is something that is not new.
Well, it's a perfectly a well-designed education system to keep people dumbed down. They think they're being educated on this massive level. They think they're being told all these great truths. And when you actually believe that's what you're being taught, then you're in real trouble. Because you don't feel like you need to even investigate. No, man, I heard it straight from the mother's mouth. This is what it is. And how people came to trust that so much that they don't even feel like they need to question anything about it. I don't know, man. That's pretty surprising that they could be that efficient. Because that's pretty much what's going on. I mean, the Glovers that come in here, a lot of them, they think they actually know. They know that where we live, they've been told their whole life, and it's like, no, we live on that so-and-so said this, and then we know this because of this, and this, and this, and this, and on and on and on. And it's like, none of it is true. You don't know anything because of anything, because you haven't been told. Just been told that's what it is, without being shown that's what it is and why that's what it is. It's just, I don't know, man. It's pretty powerful indoctrination they've got on everybody right now. Even with us and other people fighting and putting this information out here, it's so strong that I think that they just refuse to think. It's got to be a subconscious thought too, because it's not like when I first heard this and I'm going, no, that's not true. We live on a globe. I wasn't thinking about it in a logical way. You know, I was just thinking that no, I was told, I was learned, I was taught all this stuff, and I didn't stop and think, well, is it true what I was taught?
Bless you, bro. Bless you. Thank you for sneezing on the mic.
Zoom tight.
I was just coughing. Sorry.
Yeah, sounds like a healthy cough.
Oh yeah, coughing up some cheese.
Yeah, just let it go, bro. Let it go. Next time, just mute your mic.
Sorry, I didn't know my mic was on when I came in. My bad.
And
you don't need to
make
be
sure
sorry.
you cover your
So
mouth.
what are we talking about?
Hot Mike, and you don't need to be sorry for doing that because I'm not. I'm just kidding, guys.
Yeah, but if you're sneezing, you have to cover your mouth.
That is debatable, my friend. I guess out of politeness, maybe, but out of necessity for any other reason, I'm gonna have to say sorry. There's no evidence to support there's any damage going to be done to you because I didn't cover my mouth.
Bro, I don't want your boogers in my face.
Yeah, but is it going to hurt you or kill you or what?
Oh my goodness. All right, let's share saliva, everybody, and boogers. It'll be fine.
It might sound nasty, but I do think it would be fine. We do it all the time.
You'll survive.
You swap spit every day with your wife. I mean, come on. How could it get any worse?
Yeah, you're not my wife.
No, but you swap spit with another human all the time. I mean, it couldn't be that harmful, or every married couple would be dead.
No, every human out there.
No, I said every married couple.
Special ones only.
I'm surprised as of recently, they didn't make it against a lot of kiss anybody.
It's a small club, and you ain't in it.
Okay, George. Carlin.
My name is Giorgio.
So, where do we get educatable Globers? How can we step the game up a little bit?
Educatable?
Educatable, yes.
It's a good word. I like the sound of it.
I don't even. It's probably not even a word. Now someone's going to look it up, and now I'm going to look stupid. So now I need to be educated.
No, I wasn't saying you were wrong. I don't think I've ever heard it said that way. That's all.
I could be, though. I don't even know.
I mean, all sorts of people are educatable, right? So, Globers, non-Globers. So, educatable
I have to be careful.
Globers.
Because educated, what does that mean?
Sure.
Indoctrinated is what it means these days.
Basically, yeah, that's what I'm saying. I mean, if it didn't mean that, then yeah, maybe we'd look at it differently, right?
Made it.
Well, indoctrination is clearly not education. It's brainwashing. 100%. We're all MK Ultra. We're all just going to wake up one day and go, it's a ball. We're on a spinning globe. Because we've been trained daily, year after year, month after month, hour after hour. That Star Wars is real. Or it will be someday. See, that will be reality. Getting in a spaceship of some kind and flying through the universe. And Jeff Bezos can't even go into orbit yet.
That actor guy?
No, it's that billionaire dude.
Yeah, the actor guy.
I don't think Bezos is an actor, is he? Maybe he is. Who knows who Jeff Bezos, what's his present forte?
I don't know. I tend to believe that all these rich people that claim that they are somebody probably aren't at all. But that's just my opinion.
Well, I know he's a billionaire. Once you become a billionaire, I think you can pretty much take on any title you want. You just buy it. Oh, I need a certificate to be this. Here's a few $1 million. Thank you.
Wouldn't it be nice? Maybe somebody should talk him into going to the North Pole. Or the South Pole, whatever.
No, he's in the club, dude.
Yeah,
He's part of the. He's part of
That's why I said he's an actor. That's what I meant. Yeah, he might be a millionaire, but he's basically doing whatever he's told. He's acting.
Under those conditions, most of humanity is an actor.
Yep.
We've got It's All Flat with us, if he wants to say hi. Maybe tell us about how he got to the flat Earth or what he believes. Or not.
Anybody talk to Death Air or whatever that is? Death X or whatever?
No, he deafened himself.
Oh, I just noticed that. The spot on my screen is cracked, so.
Mic check.
Good. I hear you.
Oh, nice. I just fixed my phone. So happy about it.
Or now you can listen and talk. I hate when, yeah, I hate when I don't.
Yeah. My screen got broke, so I had to replace it, and wow, it was quite a journey.
Yeah, it's easy to do, but it can be delicate work.
Yeah, it's delicate with these glued phones. It's so hard to open them, take them apart. But
Nah, good
now
heat
it's
gun,
like a new
good heat gun
phone.
and some pasta.
I'm
It'll work.
so happy about it. Yeah.
That's awesome. Mine's cracked. The outside screen's cracked, but not the digitizer underneath. So I bought a screen to fit over it, but I'm afraid to try to take the other one off because it's one of them Samsung phones that's angled on the sides, and I'm worried that when I'm taking the other one off, that I'll damage the other screen, and then I'll have to buy another one, and it's like $200 and something bucks. So I've been putting that.
That's what happened to me, actually. I had this infrared heater, so you have to warm up the screen before you remove the glass, you know. And
Exactly,
I
yeah,
started removing it without warming it up, and I just pushed in this metal thingy I was using beneath this LCD foil, and it short circuits something in there, and the screen went white, like dead instantly. So I had to buy a whole new screen.
If anybody's interested in seeing that video where Musk pretty much makes Bezos look like an idiot for going into suborbit. He said I find it interesting that he's at least spending some money, towards space exploration, but he said it's orders of magnitude more difficult to go into orbit than just suborbit, like going up and down, back down again. He said he was telling him how much more fuel you need and this and that, pretty much making him look like a complete moron.
That's funny considering he ain't been there either.
And he also says in this that he has doesn't want to go. Then he said, well, maybe at some point, I guess, when it's possible.
At some point. Oh, yeah, of course. Got to stick with the media's storyline, yeah, of course. I don't know. Somebody was talking about, I don't remember where, but somebody mentioned to me that they think that the reason why Flat Earth is out is because that they're slowly bringing it into focus for a reason. But I don't know what that reason would be. But I mean, I heard it. I was thinking about that. I was like, I don't know. Is that really? I don't know.
Well, it could be something that we're not made aware of, like a cyclical event that reveals the firmament.
Yeah, but we all kind of assume that happened in the 20s, right? 30s with Bird and all that.
I mean, reveals it to all of mankind.
Right. Oh, that's true too. That's a good point.
I think that there is possibly some sort of an event that could take place that would reveal that to be truth. Everybody'd be going, what's that above our heads? Why are we covered? What's going on here? So,
well, I'm starting to think, this is just me speculating, that Flat Earth was a controlled release under the name Flat Earth. For example, if millions of people woke up to the realization that it's not a globe, but they didn't have a name. They just realized it wasn't a globe. It'd be really hard to control them. Whereas they make the name Flat Earth and now are labeled Flat Earthers. And there's people who push Flat Earth, and we're all Flat Earthers, and that's it. We're just in a group, the Flat Earthers.
And that does what? Do you think, Dave?
I don't know. I think could be just
Makes
a way
them able to track us,
it.
I guess. Right? Well, it's able to track us too because they put out and they make it possible for us to make sites like this, and then we're all basically exposing ourselves in a way.
No, I'm talking about more on the level of not who's doing it, but how do I put this?
I'm not sure.
You mean like what the eventual goal is? Is that what you mean?
But now anyone who says, "Oh, I don't think it's a globe," or you flat Earth. But if there was no term flat Earth, and people were just like, "Well, it's not a globe, but I don't know what it is," it'd be so hard to control because it wouldn't be one group.
Well, I don't know about some people think that it's going to be slowly released and worked into, telling everybody that we're on a flat plane. But I have a really hard time with that because it would completely destroy so many things like the radius number and orbit and all this space exploration, and everything would go out. Everything would go out the window. All these educated people would no longer be educated. They would all be basic morons for believing in a complete fantasy world. So that'd be some pretty drastic change for mankind. I'm not talking about us. I'm talking about the people that spent hundreds of thousands of dollars on an education to become some sort of, high-tech individual that uses the cosmos and whatever else is part of their living. When, you turn that into all nothing but a big lie, what are these, I can imagine a lot of those people would freak the fuck out. I would. And you mean I just spent $150,000 on an education system that taught me nothing but straight bullshit and lies? That wouldn't go over too well.
Well, I don't think if they did do that, I don't think they'd word it like that. They'd just be like, "Oh, this is the latest theory, then this is the latest theory," and it'd be like a gradual change.
It's always hard for people to come to terms with their life's work being based in a fallacious assumption. That's something people don't want to face.
Right. That's my point. Exactly. You don't want to face it at all. I mean, that even if it's slowly, whatever, it's just that's a slow, painful destruction of your hard-earned dollars and your life's work. I mean, that even makes it worse. I mean, get it over with all at once, and then so the guy's at least got a little time to start over and maybe re-educate himself a little bit. I don't know.
I'm not even sure they'd bat an eye because, like, if it came from the right people and the right institutions, it's like they almost don't even notice. Like NASA, for example, saying the moon's in the Earth's atmosphere, and it's like they haven't even said anything about that. They just accept it. They've not gone, "Oh, so everything else was a lie." They've just gone, "Oh yeah, the moon's in the Earth's atmosphere." Not a single thought in the head.
Yeah, but if you look at the literature, they actually fuck. I focused too much on what you were saying, and I too much imagined all that shit and threw my shit away.
It'll come back to you.
Yeah.
Yeah, I don't even think they grasp the fact that they've lied to. I don't even think they think. I think they just go, "Oh, the science has changed," and continue being like non-playable characters in a computer game or something, and just regurgitate the new line, whatever that may be.
Oh yeah, it came back to me. Essentially, if you look at some of the quotes about science and how science changes, they admit that science doesn't change through debate and anything like that. It changes when the education system changes, what it teaches the children, and a new generation is born that believes something completely different. And you can see them doing it today. They're doing it with CTR or critical race theory or CRT, yeah. And all these other agendas that push them through the schools, and kids grow up. That's one of the reasons why it always feels like we're fighting this uphill battle, because every year there's a new batch of pseudoscientists just freshly educated, and so or indoctrinated because they don't actually receive any education. So that's why it feels like an uphill battle. But I honestly think we're winning. They just don't want us to think that. We're just slowly but surely working over people one at a time individually, versus they cut off our options and spreading it through their medias. That's why we're censored on YouTube or like we're not cut off from it, which would just raise red flags for people and make them believe us more. But we're relegated to the bottom of it, where it's just supposed to be laughed at.
Well, I saw a video the other day, and it dawned on me how it was a TikTok video, right? And the guy had got around the censorship somehow, and it was just a video of him showing clouds copied and pasted on the blue marble. And anyway, it had 1 million views and 40,000 likes, and you never see flat Earth content like that anymore. And it just dawned on me that we must be out there if 40,000 people have liked this video, But most of the videos don't get any exposure.
If you're interested in the picture he's talking about, I think it's a composite. So yeah, they made an error where or I don't know if it was on purpose or something like that. But I would argue I don't think that's a good flat Earth argument. This one picture, I think you have much stronger arguments than that.
What are you talking about?
What I'm talking about?
Yeah.
There is this. I know exactly the picture he's referring to, but the problem is that before even like people said, "Oh no, there's a problem with the picture," NASA already said this is a composited something. This is not like one camera shot.
But most people don't know that. Most people think it's a photo of Earth, and it's commonly quoted as a photo of Earth and used as globe evidence.
But that's not the blue marble photo, then? What do you mean?
I don't know. It's a photo of the globe, supposedly from NASA, with cloud formations copied and pasted 500 miles apart all over the place.
Yeah, identical cloud formations, and they just put one here, put one there, put one here, like it wouldn't be noticeable.
Oh, that's the reason why I would say that that's even not that good of an argument, because they said like this is manufactured, this picture, but like I don't know.
Well, it totally was. It totally was manufactured, 100% manufactured. Guy goes into complete describes exactly how he made it, with strips of photos, wrapped them around the globe, and then filled in the blank spots with artist renditions. And it went on and on and on. I mean, it was a 100% fabrication. So it's a great argument as far as destroying that globe as being anywhere near reality. There's no reality whatsoever in it.
Can you link a picture of like the guy recreating the image or something like that? Because that would be really interesting.
I could find the TikTok video, possibly.
Yeah, no, yeah, but I know that I've seen the TikTok video as well. That's why, but I would be more interested in the video. I think was it Batman? I can't remember. Like one of the guys further up in the text in the channel that like there's a video of a guy recreating the whole thing, just from a computer generated globe map thingy.
But this is all besides the point. The point I was making was 40,000 people that are questioning the globe that have seen that video. Because no globers like it. And if you looked in the comment section of the video, every glober had their own explanation for it that just plucked out of their imagination. It's like they're speaking for NASA.
I don't know, how long does one need to watch a video for on TikTok in order for it to count as a view? Yeah, I think it's a few seconds, but I can't remember how long exactly.
I don't know, but I'm not talking views, I'm talking likes. Someone's clicked like.
Oh, okay. Oh, sorry, then I misunderstood you earlier.
Yeah.
That's a lot then. I agree.
I spoke to the guy who made the video, and he said views. Like he managed to get around the censorship on TikTok, but he never spoke on the video. He never mentioned flat Earth or anything, so he got onto the For You page.
Interesting.
It's more interesting the fact that whatever that guy is saying about that picture, there is no curvature in reality.
Is anyone is anyone familiar with the Witsit Gets It which video where he interviews those two NASA employees that are someone not he doesn't interview them, but he shows a video of guys being interviewed while they're making images of the planets in the cosmos, and they're two of them are sitting at a computer screen, and they're describing how they take sometimes up to 6 months for them to make one photo before it's presentable to the public. And they say the scientists keep coming back to, we'll work on it for a few months, and then the scientists will come in, or maybe it's not a scientist, maybe it's someone just higher up on the food chain there that works for NASA, comes in and says, no, we got to do a little work on this and this. We need this to look more realistic, or we want you to add a little more color to this part of it, or what. So they spend 6 months at the computer, and they sit there and explain it. That's what they do for a living. When they work for NASA, they make these pictures of the planets and whatnot, the black holes, whatever they're going to present to the public. And they take 6 months to do it. And with massive intervention from some sort of artist professionals, or what, maybe I think they're graphic artists to begin with, and they're full-time employees of NASA, and they just go on to explain. I'm looking for the video right now. Does anybody know the name of it? I can't remember it. I'm looking through all of which it's shit here. Really interesting to watch that. It's only like a 3-minute part, 4-minute part of the entire video. I could flip it, find it, and give you a minute marker on it and put it in the live stream, but it's pretty interesting because those guys just lay it straight out on the line. They look, we work for NASA. We make the pictures that they show you and tell you are real. And we're here telling you they're not even close to reality. A lot of it's just radio photography, which is just data. And then someone comes in and tells us to add color to it or whatever the color the data suggests, then, start adding the color and then start adding texture and whatnot. They just go in and describe it. It's exactly what they do. And then once it's all done, it gets inspected by somebody from NASA and okay, now we can release it to the public. And then they say, oh, here's a picture of this planet or that planet, whatever the picture is of in the cosmos. And they've been working on the damn thing for 6 months before they present it to you. I mean, that's pretty damaging, I thought. When I seen it, I thought, oh shit. They probably don't want a whole lot of people seeing that. NASA employees admitting they spend 6 months on these stupid photos from outer space that aren't real at all. And they come right out and say it. They're not real at all. I mean, they're just not.
Yeah, like Math Powerland used to be he used to draw photorealistic globes for NASA, and then went on
stuff.
Yeah,
he's good.
And then he went on to become a comedian, making fun of them, and yeah, rest is history.
Yep. That Matt Powerland, when I first seen it years and years ago, that was one of my favorites, to be honest with you. That HBO comedy skit he did.
Yeah, it was good.
Yeah, it was. He was so cynical too throughout the whole thing. He'd say little cynical things and just acting, like kind of like throwing little hints out there without sort of actually saying it, but in a sort of a real cynical way. And he's just like, I thought it was funny as shit.
And like people always say, like, why are there no whistleblowers? Yeah, there's a bunch of them. They're like from all over, but because of compartmentalization, they don't have all of the information. They just have their part. So we're all puzzling together this massive puzzle piece from all the parts.
I always get a kick out of the Globers too. If I was to find that video I'm talking about there, and pull that snippet out of it, and I can just hear her say, "Oh, that's not what they mean. That's not what they mean." They're just saying that, but it's a real photo. They're just fixing it up just a little bit, taking the blurs out of it or whatever. And I can just imagine listening to somebody try and explain it away like they do so well. No, that's not what he said. He didn't say we're living in an enclosed system like that. Who is it? We live in an enclosed system. There's nowhere to go, guy. I can't remember whether that's Nye or his name. Anyway, that's a pretty damaging. Huh? Is that Bill Nye? Yeah, it's a pretty damaging video, in my opinion. I mean, it comes right out and says it straightforward, straight out. We live in an enclosed system. You cannot leave the earth. There is nowhere to go. Wake up. And people just like, oh, that's not what he means. He means there's nowhere to go. I mean, like, it's too far. You just can't go that far. what he meant. That would be a lot of places to go, not nowhere to go. No, that's not what he meant. Because you're taking it out of context. It was that video was about throwing trash away, and it was to some degree. There was a time when they thought they could just take all the dangerous trash, and even if it exists, like chemicals or radiation, which I don't buy into the radiation thing anymore, but dangerous whatever waste products, and just toss them out into the cosmos and let them drift off into nowhere land, and just eventually entropy would take place and it would destroy itself and fall apart and disperse throughout and not harm anything or anyone ever. A good way to get rid of all your hazardous waste. And I guess they tried that. They tried, and they hit some barrier. They couldn't get out. That's why he said that we can't. There's nowhere to go. You can't leave, dude. Sorry. And so he was trying to tell the kids to recycle our waste areas, the dumps and stuff. Find a more efficient way to recycle all the plastics and metals and whatever you find in your garbage, cardboard, whatever, because it's just literally millions and millions and millions of dollars just laying there on the ground. Find a way to pick it up and put it back to a usable form, and you become a instant millionaire. And I had a friend of mine that actually did that, but he was only separating metal. He had this big hopper that he threw the stuff in, and it had magnets. And as it spun, the magnets would catch some of the metal, and then some of it, just the dirt would fall off it as it rattled, and then it would dump out in the end. This guy, his name is Kurt, he's a friend of mine. And another friend of mine and his dad helped him build this machine, and he had it at the dump down here. He had a contract with him. That kid was making, I swear he was making $15,000 a week, just extracting metal out of the dump that had been just little pieces, big pieces, whatever. He was just getting so much of it. He was loading it up with the front end loader every day, taking it to the place where you sell your metal. And he got rich. And then he got all strung out on cocaine and spent all of his money like an idiot. But yeah, I think there probably is a lot of money in the landfills. Just finding an efficient way to pull it out and reuse it, instead of keep making more and more and more and more, and then try to launch it off the earth and get rid of it. They tried that, it didn't work. They hit the dome or something, and it came back down. Oops. What was in that? What's coming back down on us? What did we try to throw away? That probably wasn't too good. Pesticides and what? Chemical waste from making what? Fertilizers and what? What's falling down? Some real nasty shit. That's what.
I guess you could just take the trash away and just pretend we're taking it into space. Show them a video of a toy rocket and bury it. They're all fake in space anyway. Why can't we?
Yeah.
Bury it in a big hole and say, "There you go." Show them a video of Thunderbird.
Show it to NASA. Look, we sent it into space. And NASA's what are they gonna do? Argue you that you can't go into space?
I know.
That's funny, Dave.
Began in healthy-looking pigs.
Someone's, yeah.
Now, I don't want to fool you here. Last month, for the first time since 1972, NASA released a blue marble, a single snapshot of the Earth taken from outer space. And so much has changed in the decades between that first picture and the second. Borders have shifted, generations have come and gone. Our global population has nearly doubled. But one thing hasn't changed. Our planet is as beautiful as ever. It still looks blue.
In 2002, Blue Marble 2.0, NASA's Rob Simon made this. And it had wide appeal too. For example, it ended up as the default background on the iPhone.
I didn't even know until I bought an iPhone and turned it on and kind of did a little happy dance.
Simon's job is...
It's primarily taking data and making pictures out of it.
That's what this is, a composite of data sets from several different instruments translated into a picture.
To us, the really cool thing was the data set. Up until that point, there was no realistic color map of the globe anywhere.
So the land layer here comes from
the moderate resolution imaging spectroradiometer aboard Terra.
And the tricky part here was the weather.
So we actually had to take clouds out.
They stashed the clouds for later, went onto the ocean. That came from an instrument that measures phytoplankton in the sea.
Where it was low, I colored it dark blue because they're low mostly in mid-oceans. And then where it's a little bit higher, it was like a little bit brighter green.
Then add the clouds back in.
There's a small problem with it because there's a very slight gap in between each orbit.
So some of those are painted on.
It is photoshopped, but it's has to be.
Then
there was another layer to sort of simulate the atmosphere.
And then there's this little bright spot.
It's called the specular highlight. So it's the reflection of sunlight off of water.
Those are the pieces, but you can't just slap them all together.
It just didn't look realistic. It looks kind of flat, or the clouds are sort of too see-through. So I just hit Command Z a lot.
There's artistry to creating the world.
What I imagine it to be. Unfortunately, I'm not an astronaut. I've never been to space. But I've looked at these images over and over again, trying to sort of get the essence of it. It is photoshopped, but it's has to be. It is photoshopped, but it's has to be.
It is photoshopped, but it has to be. It is photoshopped, but it has to be. It is photoshopped, but it has to be.
What you're seeing here is a mirage.
A lie is a lie, and it don't matter how many dumb people believe it. And the truth is the truth, hiding right out in plain sight, and still people don't see it. Man, this shit got me heated, and I won't stop till the elite are being defeated. They keep us deceived about everything that we think, and they keep it a secret. What we're taught is not conducive with reality. Big bang, evolution, and there's gravity. I tell the truth, and then these motherfuckers laugh at me, telling me the earth is photoshopped because it has to be. Most people accept the deception happily, but what they're doing to us all is a tragedy. God created the heavens and the earth in a verse, but we're living in a Freemasonic galaxy. They say we're monkeys on a ball flying through outer space, but there's no proof, it seems to have vanished without a trace. NASA and other agencies falling down from grace. You can take that bullshit pseudoscience and get out my face. I'm the antisocial type, you're a government prototype. That's why you make it a point to tell me that I'm crazy every time you're angry, cause you know I'm right. I'm standing outside the house of cards about to watch it fall. No more living on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl, we follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, no, not at all. It's a criminal enterprise where deception intensifies. Assholes got us all living like on a cartoon ball.
It is photoshopped, but it has to be. What you're seeing here is a mirage.
They say that we went to the moon 6 times, but pure BS is the way that smelled. Now they're telling us that we can't even leave the planet because of the Van Allen radiation belt. Yeah, okay, sure. NASA, what you lying for? You lying now? You lied before. I can't take this anymore. The only thing they took to space was your imagination. Fake aliens are coming, now they have you waiting. We need to do something about it, no procrastination. Trying to cause the masses to awaken, that's the path I've taken. But you can see if you check all the percentages, so many people having cognitive dissonance. But that's what happens at the loss of your innocence. Then you get involved with all of this wickedness. They try to do all the humans this way. So are they just idiots? Who is to say? Conditioned by the television, it makes your decisions, opinions, and you just obey. Stuck in the material domain of Satan, where everything in each and every day is pagan. Mandela effect, cause the game is changing. People waking up and now the cage is shaking. The earth is flat, and that is a universal fact. If it isn't that, then tell me where the fuck the curve is at. They tell us that we can't see it because we're all too small. And now we're spinning on a cartoon ball. Horizon means horizontal. Indoctrination is awful because you're taught the globe model. Ever since y'all could crawl, we follow rapists and murderers, liars, thieves, and sun worshippers, saying we can't see curvature cause we're all too small. And though it's never been proven, they say we're ripping and shooting. The earth is spinning and moving. Oh no, no, not at all. It's a criminal enterprise where deception intensifies. Assholes got us all living like on a cartoon ball.
It is the world that has been pulled over your eyes to blind you from the truth. Like everyone else, you were born into bondage, born into a prison for your mind.
We accept the reality of the world with which we're presented. It's as simple as that.
Yo, We Truth has been telling you this for decades now. First you called us crazy conspiracy theorists. Now everything we told you came true. What now?
Why would they lie?
Tick, 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 time's running out. Beliefs are in doubt cause we got the clout. You don't have to shout. Just listen up, sprout. We know what it's about. We know about this route. Never any doubt. You're talking to your scout. You didn't evolve from a trout.
No, platypus.
Why would you lie? Why would you die? Who gave you rights? Why are there nights? Who gave you lights to take in the sights? Who has that almighty might? You gave up your rights for the stories of light. How about daytime tonight in your box is uptight? You put up no fighters, that's not what you light.
No.
That's not too bright. Why would you lie? So you bow and comply. Thinking you know him while only gas blowing. Meanwhile we over here flowing. The truth is showing. Denial's still ongoing.
But why?
Why would they lie? They got things to hide. Bound in their egos and pride. The science is misapplied. System designed to divide. Truth it gets denied before it is survived. Don't ask me why. I'm not the one who lied, my guy.
I don't know. Everything anyone sees could be an illusion under the control of an all-powerful demon.
Who's the conspiracy theorist now? You have no ground to stand on. Sad fact is, I don't think all of you can be saved. Some of you just need to go through some life changes before you're ready. We Truth has been telling you this for decades now. First you called us crazy conspiracy theorists. Now everything we told you came true. What now?
Why would they lie?
Tick, 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 time's running out. Beliefs are in doubt cause we got the clout. You don't have to shout. Just listen up, sprout. We know what it's about. We know about this route. Never any doubt. You're talking to your scout. You didn't evolve from a trout.
No, platypus.
Why would they lie? Don't ask me why. It does not apply. To blindly ask why, just let it all cry. It's okay, guy.
Now.
Besides, you can review. It's long overdue. Don't let them subdue you using voo-voo like you two and poo-poo. With your mind ain't a thumbscrew. With your mind askew, it's hard to change your view. Sorry, we falsified our former worldview. There's nothing left but the glue. We broke free of the mental zoo and you can do it too. Just break through and learn the mental kung fu. To logic stay true and I thank you. We are your peer review. The earth is flat, stationary, and the sky is still blue. Who knew?
Me?
Now you do.
Oh, me.
Welcome to the earth. Snacks on the left, drinks on the right, and toilets at the back. The DJ is spinning all day, 24/7, Flat Earth Discord.
So I win.
Diamond Drace.
Yellow. So you're saying that that picture of the blue marble is real? And the one that I posted showing the moon behind the blue marble. Let's do it. Let's just post it again. Is perspective. I mean, I want to make sure I end my sentence correctly. You said it was perspective? I mean, you are here. You can speak.
Oh, sorry. I had myself muted on my
I just
headset.
want to make sure we're clear on this, and I don't want to be rude or jump on you if you don't know what you're looking at.
Which one are you talking about now?
This one right here. Okay, so you're saying that that's perspective.
You know from what this photo was taken?
It's two different photos, first of all. Okay.
Of course, yes. I'm referring to the big one.
What you're saying here is both of them are real?
Yes.
Great. Then you are a troll. Good job.
No.
They're not real, dude. That's not real at all. That's photoshopped. 100% photoshopped. Both of them.
If you say so, but I'm just...
No, I'm not saying so. It's been proven 100%. Are you not reading the chat? I sent a NASA post saying that it was photoshopped by Simmons. So please.
But wasn't that
stop
referring
trolling.
to...
No. It's straight from NASA, and he said we composited them together with Photoshop.
it's also your counter argument.
Unreal that you don't even understand this.
Your counter argument to perspective makes no logical, coherent sense because things do not get smaller.
Yeah, perspective.
Or sorry,
Derace.
get larger with distance. So you're saying the further back we go, the bigger the Earth is. The closer
No,
we get.
no. That's
You're
not
saying
at
the
all what
moon,
I'm
the back of the
saying.
moon is real. First of all, that's what you're saying. That picture of the back of the moon is real, and you're saying the picture from NASA moon landing is also real. So when you say it's perspective, no, because they're both fake.
When has anyone ever taken the picture of the backside of the moon? I mean, it's not what?
It's also the top picture. It's also was just faulty to begin with. The Earth cannot be that small from that distance.
And Drace,
the Earth cannot be
hit it on the
size
nail.
of the moon from Earth. That's just that would mean that the two balls are the same size.
Yep.
Wouldn't that be the first photograph ever taken of the dark side of the moon?
Yes, that was. That's why I posted it like that. That's why it was combined like that originally. I didn't combine it like that. Someone else did, but he explained it to me. That's exactly what it is. He just wanted to get the perspective of it being small when you're out on the moon. Yeah.
Oh boy.
It's amazing though. The Earth should be humongous out on the moon.
If you're standing on the moon by the numbers they give us, yes.
Why should can you explain that to me? Because
how big is the moon? How big is the moon?
The moon is about the size of your how much degree is that? I think it's
No. How much do they say the moon is? Why are you going into a story? Tell me what NASA says the moon is shaped.
Give us the circumference. Give us the circumference.
The circumference. Moon, I think it's 2,000 miles in diameter.
Okay, so how big is the fucking Earth?
10 over 10.
It's over 40 times that.
No, it's not.
Yes.
It's 4 times larger than the moon.
No.
But it's a lot heavier.
It's over 10. 2,000 times 10 is what? 20,000.
You're still telling me that when you're on the moon, that the Earth is going to be tiny.
How big is the moon seen from Earth?
What I'm saying is the moon is smaller than the Earth. The Earth should be bigger in the background.
But not when you're standing on the moon.
Yes, when you're standing on the moon.
Yeah.
Because the moon is so tiny.
You'd be looking, if you're looking into the sky on the Earth and you look up and you see the moon, and it's got a 2,000 mile radius or circumference.
It's
tiny. Then you exchange that out, just swipe that moon off to the side, throw another Earth up there that's the size of the Earth, which is like 24,000. 24,000 miles circumference.
So
that would be a huge globe in the sky.
I'm just saying, like if we calculated.
It would be way bigger than what that is saying. I'm just saying.
Let me help you.
Now.
Let me help you. Look at this picture, and look at the not the top picture, but the
that's perfect.
And the moon in the front. Now imagine if you're going closer and closer to this scenario until you get to the surface. In your idea, the Earth is shrinking.
No, this is not. This is a very zoomed in picture of the whole thing. You see, like if you like the
it doesn't matter
part of the picture. No, it
how do you know
matter.
that?
Look at the.
Once you're at that point where the zoom is, and this is what you would see, then you would continue to go closer and closer, and you would think the Earth would continue to shrink until it would give you the appearance of the picture in the left corner.
Did you say we keep the zoom or we take away the zoom?
Yeah, we take away the zoom and we just go to the distance so that we see this without the zoom. Just like when you can zoom up to someone and see him as if you're standing close, but you can also stand close.
Right. But like I don't see like so okay, so the quote unquote official numbers.
So he's asking you why would the Earth get smaller the closer you get to it?
Is that how perspective works?
But it wouldn't.
Okay,
The-
yeah,
the
okay,
thing
good. It
is,
wouldn't. All right, so those are debunked then. Thanks.
No. The moon would get bigger. If we let's say we're coming up from the side that this picture was taken, okay, like the big one, and you get closer and closer towards the Earth-Moon system, based on the official numbers, quote unquote. Then the moon would get bigger and bigger and bigger, and then we are in orbit of the moon, and then you would get a picture like the small one in the corner. Until then you pass the moon and the Earth gets bigger and bigger and bigger, and then you're on the Earth. But this thing,
the Earth goes smaller and smaller and smaller until you got to the surface of the moon. And
no,
then
it
you saw the
doesn't.
picture. That's what you just said.
No, it's not what I said. I said look at the small picture. You see the small picture in the left upper corner.
Yeah, the very unrealistic picture, which has a way too small of an Earth.
That's what like I don't know. I don't know with what they say, what the settings of the camera were when it was taken. But generally speaking, if you were, because this picture, the big picture is taken from very, very far away, supposedly.
Okay, that's interesting. Can you independently verify any of that? Can you go 1 million miles from the Earth and take a picture of the backside of the moon?
Well, they say they did it.
Can you?
I can't, no.
No, so you have to take it on faith from them that what they're showing you isn't just a cartoon. So who cares? Do you have anything verifiable?
Do you have anything verifiable? No, I'm just, just like you were saying, this doesn't work with the official numbers, okay? And I was just pointing out that it would work with the official numbers.
Oh, you didn't point that out. You just contradicted yourself and said it was perspective, and then inverted perspective and made the globe shrink when you never.
I never said that the Earth would get smaller. If you were to keep the zoom,
you said it would be small, and then you never explained how we would go from seeing it big relative to the surface of the moon.
Yeah, simply put, if you're on the moon, that Earth's going to look huge.
Let me see if I can point you to like a simulation that takes the numbers that they say they take, and if we can maybe recreate that shot. Because I'm just saying, because I'm not convinced, you gave me, a friend of mine is a flat earther. He gave me some doubts. And I'm more convinced that the Earth is a globe, but that's doesn't matter. I mean,
have you seen it curve?
This is just an
not with my own eyes. No, I'm just saying that with the official numbers, this would still work.
No,
with the official numbers,
model it and show us, and then come back and say that with confidence. Don't just base it on beliefs. We can go on into a different subject, and you can try to substantiate the globe belief, or we can show you what we have as evidence against it. Your choice.
I'm downloading Celestia now, so.
Why don't you download some pics of Earth curvature and show us those?
I would just want to. Because I'm just saying, I'm giving you clues that if it's a
globe, you're giving us clues?
It's a globe, you say. So it has to curve on its surface at a specific rate, right? So have you seen it do that?
What was the question?
You in a little bit here. I'm going to clue you in a little here, mister. You sound pretty funny, man.
Yeah. Thanks for the help. Well,
you just joined yesterday, is that it?
Yeah. Before that, I was just listening to the live stream.
Like research-wise, into flat Earth is just
not
coming
much,
in here?
Man.
So why wouldn't you come in and ask us what we have done instead of tell us?
I have been here for 5 hours or so today.
5 hours?
But
that's
you're.
it? Oh,
you're going to clue.
Good.
You're going to
my
clue
8 years of research means nothing, right?
No, that's not at all what I'm saying. I'm just saying I came in here and
5 hours. You're saying you learned the flat Earth in 5 hours, right?
I'm just saying. I also
Come on,
asked
man.
a lot of people.
You're not listening to us at all.
Yeah, 5 hours, and now you're going to drop clues for people who've
It's
been here for 8 years.
amazing. You're telling us clues? 8 years I've been in this. Not one time has someone come in here and convinced me of one thing. Not once.
I'm not trying to convince
Yes,
you,
you
man.
are. You just said, I'm trying to give you clues. That's
Well,
trying
no,
to
he
convince
said that he
someone, dude.
was
Stop.
not. He said he was not trying to give you clues.
Well, here's a clue. If the Earth is that thing that you're showing us in those cartoon pictures, then it has to
Rex,
curve at
no,
a
you
specific
lied.
rate.
Rex, you lied. He did say it. So stop lying for him.
I thought he said not.
No, he said, I'm trying to give you clues.
Okay.
So, Rex, are you here? Are you here too? Are you in the conversation as well? Because he just said that these photoshopped images are real.
They're definitely not real.
Oh, okay, great. Okay, so you're with us. All right, good.
Yeah. No,
Okay,
100%.
good. Okay, no. I just want to make sure because you came off like a little. Because he was saying that he was trying to give us clues.
Not.
Us. We need clues. We do. Us.
Yeah, but what's silly about it is like if you're talking about this image, like on the moon, the Earth would be dramatically bigger in the sky.
Dramatically increased.
And the other thing too is if the Earth is that thing that he's showing us in those pictures, then its surface has to curve. Why can't he show us that?
That's what got me in the beginning in 2015 is the long distance photography. When does the 360 happen? It don't.
We've been asking for it this whole damn time. And then showing what ISS shows us. Like, this is the Dragon ISS mission. Okay? 2 shots, 2 Crockets, but one's flat Earth and one's curved.
Oh.
How wonderful is that to get that on live broadcast? And they did nothing about it. They just let it go. What idiots. Clearly it shows fisheye lens, right? So what is the reasoning for NASA using a fisheye lens if it's real?
Yeah, Yellow Weasel. Why not just take a picture of the actually curved Earth if that's what it is?
What picture are you talking about now? I mean, supposedly they did. That's what they say.
Well, he just showed you a video in the live stream text where they're using a fisheye lens and the curvature goes from convex to concave.
Oh, the ISS
mission,
video.
the Dragon ISS mission. It shows 2 rockets going up, two video feeds. One is flat Earth, and one is a globe Earth. At the same time, live.
I'm currently looking at the video.
So why impose fake lens curvature on the Earth if it's actually curved and that's what they're trying to show us? There'd be no need to do that, would there? Couldn't they just take a picture of what it actually is instead of have to resort to this fakery?
But wouldn't it also be stupid then to use a fisheye lens so it's easy, so you can also have a convex Earth shape? I mean, if they're just taking it all.
That's what he's showing you. It is stupid.
Yeah, it'll show convex all the time too.
It does. Yeah, that does happen all the time.
Yep.
Did y'all see that one that Cherism showed where it was like China or someone did it recently and it's showing it just weirdly convex. Like it's curved and convex at the same time.
Yeah, according to the math of the globe, the ISS only sees 3% of the surface, and the horizon should be a flat line all around them, according to the math and planetary director Paul Larson. So, why are they pretending there's a curve there?
Yeah, I'm totally with you guys that even from the, like with the numbers given, from the height that Felix Baumgartner jumped from, you can't see curvature. Like it's not noticeable in any degree with your own eyes.
That's not just curvature that I just took there. That actually is when he jumps out of the ship, whatever the hell he's, the capsule, whatever the hell he's, and then he starts rotating around, like, and then going straight down. When you see that's right at the clip, as you can see. I posted to YouTube and cut it all out so you know it's actually on YouTube. You can go right straight to that and show it to yourself. It's curving into space, like that's clear manipulation, right? That's clear camera lens making that curve go into space. So now what you're seeing there is space is actually the globe, right? Space is actually round. It's very odd that they actually show this to everyone, but we are the only ones that actually react because we are awake. Awake to their fakery, of course. These ones are always great too. When they go up in a balloon, you clearly see the rope is curved, and at ground level, that curve. What the fuck?
Well, and so they got smart with that and they started doing layers because we're like, that's definitely a fisheye, right? So then they Photoshop in the space station on a different layer, and then they are able to still use a fisheye lens or whatever they want to use on a different layer. You know what I mean? The more we notice, the trickier they're getting.
We're just helping them fix their own problems.
Yeah, exactly. That's a good one. This is another one. Look, this one. Now, of course, I don't know if that one was actually real or not, but you clearly see it go flat and then concave.
Mm-hmm.
Yeah, I think that's another layered one, right? Because you can see it, the bending. Sure. Yeah, exactly.
And the funny thing is, you can see all of the stuff coming from NASA fits completely in line with what we can fake using cinematography and the technology we have for that.
Yeah, just in OBS alone.
I really want to go here because I want to see that view right there.
How many miles away is that?
I can't post pictures.
Nice.
I can't post pictures in the chat.
I will give you
post
terms. Just, make sure that you abide by our rules here and just don't troll, okay?
No problem, man. Would be stupid of me, man. I want to learn shit here.
People are dumb.
That's good.
So
all right, yeah,
this
you're good.
is. Wait, I need to take the picture.
Now you can just drag and drop it. You should be able to. Now this.
No, it's a screen capture. So
this one
is
right
made
here. I don't know if you've seen the Black Swan. Oh, that's a good one. Yeah, I've seen that one. But you clearly see that's digital, man.
Yeah, I told you I wanted to show you. This is a program that is running all the official numbers.
Awesome.
Okay, like even if you don't believe them, I'm not fully convinced. I'm just saying this is how they say it would look. And so based on that, I would
program that into it, right? So yeah, go ahead.
Right. I'm just like so in that sense. Like they can still, of course, Photoshop all these pictures.
Exactly.
I mean, I'm not saying that's not what's happening.
Where are you getting at? Where are you going with this? Just make sure.
I'm just because before you said that it was both of these pictures, the one here. I'm gonna.
I can post it again. It's
this. I linked to it.
It's 2 pictures in one. Yeah.
Exactly, and you were saying that like this big one of that would not be possible.
The actual moon landing one. The moon landing one. Yeah.
Oh, you mean the small one was the
I meant the
problematic
small
one,
one.
or
Yeah. The
so
one
let's
with the backside moon, that one's kind of, in my perspective, if I were out there, that's kind of what I would like to see, right?
right.
But
Okay, so
with
let
the
me.
moon landing one,
That's why I told you to imagine you're zooming in to the surface of the top
the
of
moon
the
landing
moon until you
That's the
are at
one
the
I'm
position
talking
of where the moon landing is, and you told us earlier that the moon would continue to grow bigger, but the
Yeah.
Earth would not.
So that's what
no,
I think you misunderstood what I was saying then.
Yeah,
If
I
you
think we
think it
all
was the
misunderstood
background.
each
Okay,
other.
no. Listen. So the moon is smaller than the Earth. So how is the Earth going very tiny like that? That's what I'm trying to say. It's just that right there. That cannot be possible. The Earth should be way bigger. It should be way bigger than that right there.
Trying
That's
to
all.
Yeah,
recreate
like
this with
Earth should be like the sky should be almost nothing but Earth.
So it's
And I
just
just-
crazy to think that one from Moon is real. I'm telling you.
Plus the box that was around that image that they end up having to fix on their site. Remember what Skiba did?
Correct. So if you haven't watched the movie, A Funny Thing Happened on the Way to the Moon, I'll post that for you right now. Because listen, you have to make sure you watch this. You will not understand what we're talking about. You truly don't. Because that right there, that picture of the moon in 1960, that was a masked window. That shot right there, they masked the window to make that Earth look that way. That's the thing. So let me get it for you. Like I have all of the information here for you. We don't leave anything behind because these things are actually out there for public knowledge for you to actually do yourself. But I like to, just give it to you, right? Just give it to you right off the bat, and then you do the research. Give me just a minute. Let me find it.
Hey, I have something to add.
Yeah.
So we're on the moon topic and how it appears from Earth. Now, they claim that there's a tidal lock on the moon, and that the same face shows to the Earth. And if being that's their claim, I'm not saying I agree. The moon should not be on the horizon of. I mean, the Earth should not have been on the horizon of the moon. It should have been in a z-axis above, because
that's a good one.
It's tidally locked to the Earth. So I wanted to hop in. I was listening, and I just wanted.
Good one.
What?
Yes.
What do you mean? Like the small picture of the two?
No, the claim is that the same face of the moon always faces the Earth, which is what we see. So the claim can be at least visually, optically verified. I'm not saying it's on every level, whatever. That's not my point. My point is where the Earth is in the photo, basis, and where it ought to be, because it's not where it ought. They claim they went to the Sea of Tranquility. We can point out where that is. We can point out the angles are wrong. They're wrong. And you can believe they're not. I don't give a shit what Globers believe anymore. You guys say some of the craziest. Oh, and then I wanted to add one more thing, and I'm trying not to be rude. I apologize. I get too butthurt. That's why I don't come on voice very often. All right. Anyway, another one. Oh, I forgot. It was another topic that was brought up, and I thought it is an important point. I can't remember. I appreciate getting on though, and that you got to
just remember, Limp. Just remember, you are in control of yourself and your emotions. That's all I have to say. Because when you know that, you don't have to. You really don't have to worry. Okay, so just make sure you know that right there. Okay,
right.
Yellow. I posted that. Hopefully you saw me link you to it.
Wait.
And I also posted the wiki for it, as well as the astronaut gone wild.
Funny thing that happened on the way to the moon.
That is
that the
correct.
one you mean?
Yes,
Okay,
you need to watch that entirely because you will understand things went wrong when they got research back from NASA. And I'm saying this over and over and over again. This is my belief, okay? I believe that there's someone in NASA or in the highest of highest, okay, that is trickling down information for us. Just trickle, And they're not letting themselves known, of course. They can't, else, of course, they won't be able to trickle it down to us. And this stuff that you're going to be seeing in this funny thing happening, it was not supposed to be released. It was not. They were supposed to delete it, just like the rest of the moon landing crap that they did. Destroyed it, whatever. But the researcher went in there and asked him all these questions, okay? And got all of these videos, all of these clips, and this came out of those clips. It's literally Buzz Aldrin flying in the spacesuit in the capsule right after they take off the thing of the window and show you the actual Earth, which they're probably only up like 100 miles, maybe even not even that, because it's huge. The Earth is actually huge in the window when they take the little thing off. And that's why I posted the Astronauts Gone Wild. When it's said to the astronauts, when the guy goes in and actually, tests these astronauts, he asks them to swear on a Bible that they actually went, and none of them would.
Yeah, they literally went wild.
It really is crazy how they went wild. Like, why would you do that? And watch the full video of them going to space and then coming back. They're completely changed men. When you get to the top of Mount Everest and you come back from the top of Mount Everest, you're fucking happy as hell. But not space.
Yeah, that interview. Whew.
But not space? You're not happy as hell in space? They had no clue when they went to that rocket that they were going to make a show. And they were told on set. That's why it worked. And they probably were told your families will be covered. We have billions of dollars. It's an endless... So don't worry, right?
I don't know how y'all feel about Masons, but I feel like that's a good dig for someone that's a beginner.
That's another story. That's off topic first of all.
Right, but that puts things in perspective.
We do talk about that, yes. We completely understand that as well. But what we want to make sure is that we stay on this topic right now. But yes, the clear happiness that was on their face when they actually were going to the moon, when you saw them getting on the spacecraft, right? I bet you anything, when they hopped on that spacecraft, they walked into another elevator and it took them straight down. And
there's a slide.
They took the slide, or that would have been fun at least.
You know what I'm saying?
they got told to cancel the mission.
Fireman pole,
and then they got told to fireman pole, and they were going to use the exercises for it. If you listen to Buzz himself talking to the child, I'll play this real quick.
Yes, the child.
And, you can listen.
It's
to
right
him.
at 2:30, or sorry, at 30 after.
Oh,
he's going to play it. Great, go good.
Why has nobody been to the moon in such a long time?
That's not an 8-year-old's question. That's my question. I want to know, but I think I know. Because we didn't go there, and that's the way it happened. And if it didn't happen, it's nice to know why it didn't happen, so in the future, if we want to keep doing something, we need to know why something stopped in the past that we wanted to keep it going.
Like, that completely doesn't even make sense. But to us, it makes clear sense.
It's like a Biden ramble.
Yeah,
holy shit.
Hey, I can be polite. I'd like to add another thing is that over the years, as flat Earth information, say like the sextant argument and these different arguments and all of a sudden the anti-flat Earth or whatever they are, globe Earth promoters, suddenly become an expert in that area. I was going to mention that earlier when I was on voice, and that was what I forgot. But it happens over and over and over again. And you guys brought up like the imagination replies maybe 15 minutes ago, if you remember that. And yeah, it's a thing to be considered for us. It's like, is that helpful at all?
Sock 'em, bop 'em. I have no clue what you were talking about.
Oh, okay. So the sextant argument about getting an angle if the baseline is curved is impossible. And now, say Bob the Science Guy, as an example, or Bite the Flat, they're all of a sudden experts in using a sextant when it was avoided to begin with, or the Rayleigh criterion being eliminated from Earth curve mathematics. That point in the distance where an item that you would normally see would begin to converge, either with like a brick building. When you're close to it, you can see each individual brick, and as you go back, the bricks appear to join, and then eventually the building will just converge with the horizon. But that's never a consideration brought up by the anti-flat Earth side. But they become an expert in it immediately when they avoided the topic previously. Each topic, as they come up over the years, has been argued against with just whatever they just make up. It seems that it's almost like they organize together and kind of maybe like we do with talking, and then they come up with a fantasy as to how to reply, because it seems that they're doing it together in a way. Does that make sense?
Yeah.
I'm not trying to waste anybody's time.
No.
You're not wrong. They have a server similar to ours where they do similar stuff, although it's painful to listen to. And I say that mostly because they yell a lot.
Oh, Justin left?
He had to go and check on someone. So, Yellow, are you still 100% convinced that it's a globe, or starting to just not sure?
I would say I'm still reasonably convinced.
Yeah.
You made some points about the gas law stuff, which I can't refute based on my current knowledge. So I'll certainly try and research into that.
Another thing that gets me though is like the fact that they say that we're moving like 2 million miles an hour, yet you don't feel a thing, and it's not like we're moving in a straight line either, because we are going 66,600 miles an hour around the sun, supposedly. So that means that you're constantly turning, and then even with the spin alone, you're saying that the atmosphere has to move faster to stick with the Earth to go to the same place the higher you go up, and yet you travel in a plane.
Yeah, that's the Coriolis effect. That's like part of the Coriolis effect.
But there's
that's what is said.
Right.
I'm not saying this is exactly 100% how it is. I'm just saying what they. Yeah.
Right. They can say it. I understand that, but the whole thing is that can you see that to be true? Like I just don't see it to be true.
Well, so
it doesn't make sense for it to be true.
So the thing with not feeling anything while on Earth makes sense to me because like I studied a lot of classical mechanics.
Right, so just like driving in a car, going 60 miles an hour, you don't feel anything, right?
So, and also like,
now turn that wheel left and hold it there. You're gonna feel that.
Right, but this is, it has all to do with how big of a turn it is. You see, so like the angular velocity of the Earth revolving around itself is
you
around
barely turn it. I
360
think you're still
degrees
gonna
a
feel it.
day. So it's
He's talking about the ellipse. So if it's an
But you-
ellipse,
but
it's
that-
going
Right.
to have a change in speed. And so
But
with
that-
that change in
Yeah, as
speed, there would be
well.
something that you would feel.
what do you
Yeah,
mean?
you
What
would
is
feel it
the-
because you would have to have a change in speed as well when you're going around the sun because of the elliptical orbit.
But our point of reference is the Earth, who's experiencing the same forces. So that to me makes it is feasible that we don't feel a thing in that aspect. To
No,
me,
that
based on
doesn't
that doesn't make
If you
sense.
have a change in speed, if you have an ellipse, if you are turning and there is a change in speed, that would be felt. Even if it's the tiniest little change, it is felt. There would be a ripple. There would be something that is felt. So to say,
So
it's
are
only
you-
visible, we wouldn't feel anything. That's just like
And then the
Cameron
same
dismissing
thing,
what we know to be true.
right? And the same thing going just traveling from north to south or south to north, you would feel a change there too. Yet you don't.
I have one more thing to add. The Coriolis effect is the claim that the air is not spinning with the Earth. That there would be a second reference frame.
No, that's not Coriolis effect. The Coriolis effect means that
No,
if
you're
travel-
I apologize, but you're not. You're the Coriolis effect is detailing how an object in the sky is deflecting because of Earth's rotation. That's literally
Right,
the
because
claim.
of movement
so
north
it's
and
not
south.
correct to impose upon yourself with the idea that the air is spinning and the air is not spinning at the same time. You both can't be true.
Well, the air is not always moving at the same speed as I'm moving on this planet. I mean, then that's what we call wind.
That's
I mean,
because you're not moving.
Yeah,
no, even if I'm not moving,
Wind-
we can
no,
have,
we're-
like, there is movement in the air.
We
so
gotta get
it
back
would
to
make it would
Coriolis.
make it really difficult. You can see like the Coriolis effect in like
wind shows
weather
that-
patterns.
Hurricane. Tell me
Wind
a hurricane. Tell me a
Just a second.
hurricane.
Wind, just a second. Wind
Go ahead, man.
prove that his earlier statements about the gas being glued to the rotation to maintain the appearance of no rotation and his claims of Coriolis now are all in contradiction.
Mm-hmm.
But like you can also, but like look at the ocean. You also have a huge ocean currents, and it's not spilling everywhere.
Well,
Yeah,
that's
it's not
kind of
spinning.
like that argues against your claim too,
Well, how?
because all the water would go to the middle, basically. Take a tennis ball. Well, you'll invoke magical gravity, but take a tennis ball, get it soaking wet, and then spin it. All the water starts spinning out the middle of that.
Ooh,
The
yes,
middle of
that's
the
interesting.
axis, 90 degrees. 90 degrees from
yes.
the rotation.
Yes, that's because of
your
centrifugal
claim is,
forces, and you see.
if you're able to
go ahead.
listen for a second, and again back to Coriolis, you're believing two realities at the same time, because their claim, Coriolis, is two reference frames: Earth spin, air not spin. That's the claim. That's what they claim. And like snipers would need to take it into account and all these things. But you're arguing against the claim.
No.
Yes.
I'm not.
Yes, you are. You're saying air moves with Earth. Coriolis' air not move with Earth.
The
That's why
Coriolis
snipers
effect
supposedly have to factor it in.
describes a change in angular velocity around the Earth when you have a change in distance from the rotational axis.
No, the
That's
Coriolis
great.
effect is an
Yes.
optical effect looked at from within the rotating frame. If you're standing outside the rotated frame, you don't see any deviation because there's no actual deviation of the object. It's just apparent from being rotated relative to the object not being rotated.
I'm search for a GIF or something I can
Oh,
show
you posted it. Also, by the way, Coriolis effect was discovered by flat earthers long before it got the name Coriolis effect. And it was used as evidence that the Earth did not rotate. And that's one of the reasons why they claim that the air is velcroed to the Earth and completely follows the rotation to hide any effect of rotation, which in turn makes Coriolis effect not exist under helicopters or airplanes or anything like that.
What would Coriolis effect have to do with a helicopter? Please explain.
Because the Earth is not rotating underneath the helicopter, like you just claimed it was.
What? No, I claimed that objects traveling north or south from the equator experience a change in angular velocity. The angular velocity stays the same, but it makes for a change in radial velocity.
That's not Coriolis. That is just a claim that has not been substantiated. We want evidence of that claim.
Well, yeah, you have evidence. Don't you have it in weather patterns?
No,
I don't
weather
know.
patterns are not related to the spin of the Earth. Here's
Aren't they? No.
Here's for instance, they assumed that hurricanes and tornadoes were due to Coriolis, but they're not.
Oh, but I'm not talking about hurricanes or tornadoes. They're like these wind phenomena in around the equator. Fuck, what is it called again? I can search it up.
Yeah, I know what you're talking about. You're talking about pressure belts, and these happens because of change in temperature. Think about where the sun goes. The sun goes in a circle around the center, and so under the sun there's more temperature, so there's more pressure created.
So you're saying that...
This is why I love that you said wind earlier, because wind just destroys all of this idea, because wind is moving because of the second law. There's less pressure, so it's moving to fill the available space.
Right, but look at the picture I sent. I completely agree with you that you have winds going from high pressure zones to low pressure zones, which is what is kind of like.
I agree with this, but you are not accounting for the motion of the sun. As the sun moves in a circle, it's stirring the pot in a certain direction, and that causes all of this. So none of this has anything to do with any globes or any spinning.
But if we look at the movement of the sun, wouldn't that then mean that the winds would need to be like flipped? You would see north of the equator, you would see a southeast wind. Well, depending on where exactly we are from Greenwich, of course. But I mean, like a wind to the left. When we just think about where the sun.
No, because the higher pressure moves into the lower pressure.
And in my opinion, that's what creates the wind.
I mean, of course, high and low pressure, that creates the wind. I couldn't disagree. I mean, that's what every how are you called? Geologist is someone else. The guys that look at the weather. I don't know their English name.
Yeah, it doesn't matter the titles. It's just the basics of how gas moves. It moves with the second law. So they want you to believe that there's this infinite vacuum or volume for the gas to expand into. But the gas isn't expanding into it. The gas is moving around within the dynamic system based on the temperature and other factors.
I'm not sure if I understand this right, but I have an idea about the layering effects that we see on Earth, and I think that all gas is pushing into each other, and I imagine this is what I imagine is all the gas above us is pushing down on the gas that we're experiencing, because it's all like bouncing into each other with elastic collisions, kind of like being deep underwater. You have more weight pushing against you. I might be wrong, but I think that the temperature would be a big factor in how the barometric pressure, and then I believe also that layering based on hydrologic sorting, like specific density of I don't know what gas really is, but it seems to me that it will layer as well. But either way, to have pressure, it needs to push against something. regardless of helium going up or whatever. If we had a hole in the sky, it would fill space. That's just what gas does.
So wait, so what are you saying? How does the pressure difference underwater come about?
Well, it's just an idea. I can't verify this, but I suspect that all the gas around us is kind of a cumulative effect. Also, but big time based on temperature. Also, because I can take a Go ahead.
You got to think about the composition. There's also a big difference in the content, the salt content between the top and the bottom. There's a big difference between the gas content that's been what it called soluble. Right, it basically presses down into the water, and there's oxygen and other gas in that water. Higher up, but the lower you go,
there's less oxygen. Yes.
Yeah, there's less dense, so it becomes more and more dense the lower you go.
That's what I mean. And then another thing is
I agree,
as you go up, things because of the temperature change. So, say on the top of Everest, we might need oxygen. Well, all the oxygen would be created at the ground level, and it would be expanding, and also based on temperature. So we would experience less pressure because of the temperature, probably the primary reason. And then I suspect that all the gas on top of us, and again, it isn't pressing like water, but I think there's a pressure so I think that the pressure from things above would be pressing on everything below. But I can't verify that. I'm not sure about that. But it's an idea I have as to why temperature would be a bigger factor, though. But that would be why up on Everest, the oxygen level would be really low, because it's a much lower temperature and it's much further from the creation source of the gas.
Okay, so I don't know if they installed just, I think, like a year ago or 2 years ago, they installed a new weather station closer to the top at Everest. And you can look at the data live. Currently unavailable, waiting for station data. Seems like they have bad weather there. So here, this one is South Col at 8,000 meters. And you can see the temperature data. Oh, these motherfuckers have it cold.
Yeah, but we gotta take that data on faith as well, because we didn't test that. We didn't verify any of that. We're just taking data we're getting from a source we don't know if it's trustable.
But wouldn't it then be interesting to go there and install your own station? I mean, the Flat Earth community managed to come up with, I think it was 20,000 for that ring laser gyro, and you also sometimes buy expensive lasers and other expensive equipment. I mean, that might be a cool project, wouldn't it?
We have the Black Swan. It's over.
We do tests, and we don't need to go to the Antarctic, although many of us would probably want to explore it at some point under the right conditions, with all the you have all the equipment, and you can send the data and information and everything back, and you could have it super transparent where you record everything. We would love that. But
that'd be amazing.
But there is actually the Antarctic Treaty, which North Korea and China and Russia and America and all of the countries agree that you are not allowed to independently explore or do your own tests in Antarctica. You must have it approved before you go, and to get that approval costs a lot of money. Just the environmental assessment alone, could bankrupt some of us, and most of us couldn't afford it, and they can still deny you. So it's not feasible economically to do it while the governments of the world are refusing people to even try to do it. And the people who actually go against this and go to Antarctica without permission, they get escorted back by military boats, and sometimes those boats disappear. And like Earl Antahoy, he lost all his friends in an incident like that, and really wants to go look for his friends or any sign of them, but he's not allowed.
Isn't it the case that Admiral Byrd is so revered is because he was able to explore a place that no one else has, only because he finally got the backing from the government? Point being
Yes,
that with that story, it's like, you know, considering that, it's like, well, why hasn't anyone, like, just your average person doing it, like you said? Well, the only precedence of it happening is when someone finally got the backing from the government to do it. And unfortunately, it's not even a source we can validate because, again, the treaty and whatnot.
Hey, that's okay. So, no, but like if a flat Earth community were to approach, I don't know, one country's government or something, or like maybe, I don't know if there's a specific council overseeing the Antarctic activity. Do you think, like, don't you think it would be worth a try, just like asking nicely, saying, well, we would like to set up some weather stations and stuff, and like if we die down there, don't come looking for us or stuff like that? Because it gets quite cold.
No, we can prove
No?
them wrong right here repeatedly by measuring the surface to be flat and excluding all of their delusional excuses. We don't need to tell them we're going to go to one of the most dangerous places on Earth so that they have an excuse to kill us and say, look, the flat earthers are really dumb. They killed themselves.
Well, yeah, I guess.
I don't know why
bring some public. But like, cut the shit. I have a question. What exactly do you mean by the sky still moving in the drone time lapse? Because
the drone should be moving in the sky as well. Is the point?
Maybe they have it like locked on like one position. I don't know. Could be like my drone can do that. My drone can like push a GPS lock button and then it wouldn't move from its spot.
Yeah, that's fun.
I don't know.
Mm-hmm.
Again, you're like believing out of both sides of your mouth.
Well, even if like GPS is fake and they just do it with like antennas
not
or
fake.
stuff.
No, no. You're getting it wrong. It's not fake. It's towers that it's using, dude.
Right. Okay. I'm completely.
But hold on, time out. Stop. The GPS capability you said your drone has, right? If it's a capability, that means that it's capable of not being on also, right? So when it's not on, then obviously, who just made that point? It still stands. Because it's not what if it is locked to, a geostationary kind of position? How about forget that and just send a drone up like we've done?
Then it would probably move with the wind, like balloons, wouldn't it?
Yeah, but what
if
about
it was a wind?
What about
a lot of wind?
Then I guess it would stay in about the same position. Like to
so it's going to stay in the same position whether it's if it's not windy, then it's going to stay in the same position. Why?
Like you're only sending it up like 100 meters, and if like you have no wind, okay, which means no air movement relative to the surface. Do you agree with me that that means no wind?
No, you're fighting against the claim of Coriolis again.
Yeah, air does not.
No,
also
Coriolis
stagnate.
would only if you.
The air is always moving. The gas molecules are always bouncing around, moving freely and randomly in all directions, even if there's not a lot of wind.
I agree. Yes. But okay, so with Coriolis would mean
air not spin.
No, that's
Earth
not
spin,
what the
air
Coriolis
not.
effect means.
Yeah, it's 2 reference frames. It's the claim, man. When I read the description, it tells me there's 2 reference frames. It tells me that Earth is spinning and the air is not spinning. And that if something leaves that inertial reference frame, the Earth, and then it would go into the air, and the Earth and the air can't be Velcro. That's just not real because air's unbonded. And it would also violate first law of thermodynamics. As you elevate, the air would have to speed up, and there's no evidence to support that claim at all. And I have evidence that I can spin an object with air around it, and the air doesn't suddenly start spinning unless there's like fan blades on the object.
Was the last one a question?
No, I'm just telling you the claim. It's their claim, man. You're believing 2 things at once.
I'm claiming 2 things at once. Okay, no, I'm just saying.
No, you're fighting against the actual claim. The claim is Earth spin, air not spin, 2 reference frames, inertial, non-inertial.
Right, but okay, so let's say. I'm saying like the official story is that the atmosphere spins together with the Earth rotating.
Well, then
do you agree that that's the official story?
No, not at all.
No, that's not the official. Okay, then what is the official story?
Yep.
I've said it a number of times. Earth spin, air not spin. 2 reference frames, inertial, non-inertial. That is as clear as I can say it. I don't know what you hear when I say that, but that's what I've said a number of times, and it's what I mean to say. So, and
right, but like that isn't what you're. Then you're not arguing against me because this is not what I'm claiming, and this is also not what like Glovers are claiming.
2
like
reference frames.
I would
inertial,
like
non-inertial. What don't you understand about that?
He has the belief that the air is Velcroed, and you're talking about 2 different reference frames, like actual Coriolis. But I would like to
also
hear him.
Coriolis only affects stuff that moves either further away from the center of the Earth or moves north or south. In the sense of you have, like, let's say
we've heard
you're Superman, okay?
This isn't new to us.
Then I'm just interested in why you
Coriolis. Look at demonstrations of Coriolis, and know that we're not talking about the same thing here.
Can you send me the definition of the Coriolis effect that says that the atmosphere should be completely free of the Earth's movement underneath?
That has nothing to do with the Coriolis effect. The Coriolis effect is an optical effect from within the rotated reference frame. So there's 2 reference frames. One is rotated, the other is the inertial reference frame. So you throw the object in the inertial reference frame over the rotated frame, and then you can see the Coriolis effect from within the rotated frame. That is how you show someone the Coriolis effect. That is how all of the institutions of education use examples to show their students how it works and what it is. So you're not talking about the Coriolis effect anymore.
Okay, so then if you say it means something different, then we can go with your definition, and then I would say, no, that's not completely how I think it works.
Yeah, I know. You believe that the gas is bonded to the Earth somehow, but we would like to hear or see the evidence that gas is bonded to the Earth and moves with this imaginary rotation that you're trying to beg the question with.
Excellent, Grace. Yeah, air's an unbonded. It's just unbonded. That
It's
that simple.
unbounded every time. Because have you heard of the surface layer effect?
Help us, Lord.
It also applies to other moving stuff, but generally speaking, when you drive a car down a road, the air molecule that is directly above the metal molecule, or like the metal grid, the structure, would be moving at the same speed as would be more or less stuck to the metal, right? And then the air molecule above that, because of friction, and the air molecule above that would move slightly a bit less, would be slightly a bit slower, and then the air molecule above that would be also a bit slower, and so you have a surface level.
Okay. So that's 60
problem.
miles an hour.
Time out. Sorry. Do you know why there's a problem with that?
Go ahead. Why is there a problem with that?
Because there's a layer of air above us that's supposedly moves faster than the rotation of the Earth. According to them, I don't even know why they say it, but that's the case. So it kind of works against what you're talking about, how it spins less, how it moves less and less. So then how is the air then moving faster up there?
Another one,
Well,
Elijah.
because on the other end.
Hey, hold on. I was before you. Another thing is if you're driving down the road, the air 2 feet above the car basically is unaffected from the turbulence of the car moving through the air, and you're claiming that the air would be your logical parallel would be that the air 2 feet above the Earth as it rotates there'd be a vast difference. You're trying to compare what we would know to be a vast difference in turbulence created due to movement and friction, and that would be 4 or 5 feet above the Earth as it was spinning. There would be a huge gap between what was being affected by the Earth spin. So that's your logical parallel you're using, but it's again talking out of both sides of your mouth. And I'm not trying to be rude by saying that.
Right, but I'm in the model, in the globe model, on the outside, there's nothing holding it back. Like you see, even let's say that at the beginning, right, the atmosphere was not moving together with the planet beneath it, right? Like the planet was spinning beneath it and the air was just rushing over it. Over time, because of that effect, the Earth would slow down just a tiny little bit because it's crazy massive, and the air would adapt to the same, would move in unity to the ground.
Yeah, it just made no sense at all.
It would never be faster above than it is below, but that is what would be required to show the effect of no rotation, which is what we see.
It would need to be faster above than below. Well, it needs to have the same angular momentum. It's not about there needs to have the same angular velocity.
Faster on the outer edges around the globe than closer to the surface to maintain the appearance of no rotation, and this excuse doesn't really work to the stirring effect, because you can stir water in this way and make the water all move, but towards the edges is never going to be as fast as towards the blades. But you're inverting that, and with the no Coriolis, then suddenly the atmosphere is moving faster on the outer edges and slower closer. That doesn't work. And besides, you're breaking the question there with you can't even contain the gas in any way, so you can't have gas on a ball in a vacuum.
Correct. Another one.
So you understand it has to travel a farther distance. That's what Drace is telling you. The further you are away from the surface, for the gas to do a full rotation, it has to travel a further distance. Because that circumference is larger, so it has to be going faster.
Okay, so a way to look at this is if you had a roll of toilet paper that was, say, 4 feet in diameter, and you take and go from one beginning point of the roll to the end, and then measure how much space that had traveled by the toilet paper, which would be, who knows, whatever, 4 times 3.14. Anyway, and then you take and get to the end of that roll of toilet paper and you make one full revolution, and now you can see the difference in surface area that had been traveled. And as a machinist, I use surface area all day long for speeds and feeds, and yeah, the size of the diameter massively affects the surface speed.
Yeah, so I don't see how that wouldn't be possible in the globe Earth model.
Models are not. Earth measures flat.
I mean, if that's the case, man, I would believe it. I'm just saying, man. Like, my friend started this whole stuff, and like he told me, look outside, man, or like talk to people, look, and like he bred me to a bunch of stuff. I haven't looked forward also to your live stream.
Yeah, that's cool. I'd like to have you, but go measure it. That's all I wanted to say. You guys
but even sorry.
Go ahead.
Even with like when you say that the air has to be moving with the earth and this, that, and the third. Well, I mean, before going there, and claiming that the effect is no effect to be observed, then the first thing we got to prove is the earth spins in the first place. There's no proof for that.
Or curve.
I mean, we can go to the whole gyroscope argument, but I've heard a lot of interesting stuff.
You are aware that in academia, people pretty much argue the same thing we argue, right? So it's not like everyone is like, yeah, this is some experiment and this proves conclusively that the earth moves. That's not true. People write stories against it all the time.
I'll make a claim. I can't prove it, but I'll make one. I claim that the movement detected are the stars above us, and yet the magnetic field rotating above us.
What type of gyroscope are you talking about?
We would be able to measure a rotating magnetic field.
One that detects light.
I don't want to go away from the point before Indio mentioned it.
Okay, cool.
What type of gyroscope are you talking about, Yellow?
Like I heard that with the ring laser gyroscope, I heard that someone argued that it was due to ether interference, and I'd say that would be a reason to see the issue. Like if you just say, well, the ether rotates, and therefore we have a change in what is it called? Density, like the fruit there, because the ring laser gyroscope goes by measuring, like it needs refraction of light to occur, and that is usually, and that is the key of. Well, we're like, I don't know. It's hard to explain for me, man. I'm sorry.
A ring laser gyro uses a Sagnac effect, so the optical path going in one direction versus the other direction would be longer because it's moving, right? So that causes a phase shift, and then they measure that with a photodiode inside of it and infer rotation from that. The so-called Earth rate rotation is calibrated in on design. But so here's this funny thing about fiber optic gyros and ring laser gyros is that when you take them to altitude or you put them at, or you lower the air pressure, the rate that they measure slows down.
If you lower the air pressure.
Yeah, so what they did was they took a fiber optic gyro and they used it at a high elevation, and they were wondering why they were getting like 10 degrees per hour. So then they took it and they stuck it in a vacuum chamber, and they got it all the way down to 3 degrees per hour. So then they went and they researched to see if anybody else had found this thing, and there's a Russian published paper that when you take a ring laser gyro or a fiber optic gyro and you put them in a rarefied vacuum chamber, the so-called Earth rate drift slows down.
No, okay, I'm completely fine. I'm completely fine with giving you that ring laser gyroscopes aren't a good way of measuring the.
Is that if you're going to say the ring laser gyro measures Earth rate drift, then okay, when we put it in air pressure, does that make the Earth slow down? Like, we take away the air, is the Earth slowing down? Then you have things like the Laplace effect, right? So this is a mechanical gyro. They notice that during an eclipse, the gyro precession either speeds up, reverses, or does some other anomalous stuff. So during the eclipse, does the Earth's rotation slow down?
Have you seen that yourself happen?
It's documented. Like, Elias won a Nobel Prize for it. Elias won a Nobel Prize. I don't know if it was for that. Google Elias effect. It's ALLIAS. That's his name. So NASA actually did this ALLIAS. Elias effect. Thanks. So NASA in 2011 was supposed to do a worldwide test of this, and they never released the result for some reason. I don't know why. So this is the problem with like Foucault's pendulum, ring laser gyros, is that you have all these anomalous data points, right? It's not a reliable measurement of anything, because if you say this is measuring the Earth's spin is causing this gyro to measure a rotation, when it measures something else, to stay logically consistent, you have to say the Earth's sped up or it's slowed down, right? Stay logically consistent. If you're saying this is the cause, if it's the cause of the precession, then you have to say if it's less precession, the Earth slowed down. If it's faster precession, Earth sped up. And then we have things like Airy's failure, which demonstrated that the Earth is not in motion.
Is something demonstrated that the Earth is not in motion?
Airy's failure. So there's something called Fresnel drag, right? So when you have a refracting medium and it's in motion, it will deflect light in the direction of the motion, right? This is on top of refraction. So the motion adds onto it. So what Airy did was he pointed a telescope at a star, and then he filled the telescope with water and viewed the same star. And if the Earth was in motion, because that refracting medium would be in motion, it would deflect the light, and he wouldn't have got it in the center of the eyepiece. But there was no visible change. That's why they call it Airy's failure, because he was trying to confirm something called stellar aberration, which is linked to the entire cosmic distance ladder. He went to verify this, and he failed. Now, if you go on Wikipedia, it'll say something about the ether, which is garbage, right? So the test had nothing to do with the ether. If you look at his published paper, there's no mention of the ether in it. They've erroneously linked, because of this thing called Fresnel drag. Fresnel thought that he could prove the ether existed using Fresnel drag. That was not what Airy was trying to do. He wasn't trying to do anything like that. But because he's using the Fresnel effect, Goldberg went on Wikipedia and erroneously linked his experiment to the ether. But if you read his paper, it doesn't say anything about ether in the entire thing. And I'll link the paper in the live stream voice text. George Biddle Airy was the astronomer royal for the Royal Society.
I'm gonna look into the aliasing effect. Like that is what something that we call it aliasing in electrical engineering often. Just I've seen that happen to me as well before in one of my experiments.
The point is that these types of experiments are very like these so-called trying to measure the motion of the Earth. They're very inconsistent. They're anomalous. Like, I'll give you an example. So at Emitted Station in the South Pole, they tried to do a Foucault's pendulum, right? The first measurement they got is it was spinning the wrong way. Second measurement they got is that the Earth was rotating every 12 hours. And then they kept doing it until they got what they wanted, and then they stopped. And you'll see this with the Foucault's pendulum all the time. If you look at like manuals for like museum pendulums or scientific pendulums, Foucault's pendulums, they stick in malls and museums. They're driven, and they have adjustment screws that tells you how to adjust it. Hey, put in your latitude, whatever. If it's spinning too fast, do this. And if it's spinning too slow, do that. Right? This is like cherry picking and confirmation bias. These are not scientific experiments. It's just, I believe something, so I'm going to cherry pick data until I can confirm my belief. And this is the same problem with Cavendish. It's the exact same problem. Is that any failure to get the so-called prediction, they say it's user error, or you set it up wrong, or something else, right? Not that this is an actual measurement. They just say, oh, it must be wrong. We'll do it again. Keep doing it until we get what we want. That's not scientific. I think you can agree with that, right? That's not
I completely agree.
Method.
But also sometimes, I mean, if your experiment doesn't work, you should do two things. You should either see if maybe your hypothesis is wrong, or if you did something wrong with your experiment, like if you weren't even testing for your hypothesis, or if just your ways of measuring were too faulty and you didn't get any results that you can do anything with. But it's important that you always look at all of these three things. If you just say, well, I didn't get the measurements I wanted, I need to run it again and again and again until I have the right measurements, then of course that's not very scientific. I completely agree.
Yeah. Yes. But how do you tell the difference, though? How do you tell the difference? How do you tell the difference when I set it up right and I got a different result versus I didn't set it up right? How do you tell the difference? Right? You run lots and lots of experiments, right? You generate like a p-value, right?
Mm.
And you have to do experiment. Like the proper way to do it would be to like set up a Cavendish or a Foucault's pendulum, rip it all down, set it all back up, rip it all down, set it all back, and do it over and over and over again.
Right. Use different materials, go to different places on Earth, like change a bunch of variables. Yeah.
Yeah, exactly. See, but you would, even if you did all that with things like Foucault's pendulum and Cavendish, you're really never going to get the true cause because you can't manipulate the so-called cause, right? You can't change the spin of the Earth. You can't change, well, when we change masses, so-called masses, you don't get different results, right? If I drop a 100-kilo fucking bowling ball and a 1-kilo bowling ball, they both fall at the same rate, right? So, like, you can manipulate the masses. It's not gonna change what you're measuring. And that's how you do a causal scientific experiment, right?
Right. The only thing, like, let's imagine a Foucault pendulum and we change the mass. I think you might see a decrease in consistency with a lower mass because it has less inertia. So you would need to start it up earlier. And that, of course, introduces errors in resetting the pendulum. But yeah, I mean, if you want to test it out, just, I don't know, go to, like, I know people that have like a 2-story entrance way to their villa or stuff like that. Put it at the fucking fixture at the top and let it run. And then if you don't get the right results, maybe try it in a vacuum. Maybe try it with different setups. But I mean, let's just test it, man.
Like the one they did at the South Pole was 4 stories. 4 stories.
Yeah, but the one at the South Pole, like the first setup, that looked so stupid. Like they set it up horizontally. So as soon as it would like change to a side, like no matter if it were to change, like you would have like too much just possible interference with the air. I mean, why even fucking start it that way?
Yeah,
But
I
yeah.
don't know, man. You seem more like rituals to convince people of something. It's almost like a
Oh,
religious
yeah,
ritual.
yeah.
You go,
Well,
go to
yeah,
science class.
that
Oh,
is.
do the Cavendish experiment. You know,
Yeah,
like,
also maybe
oh,
sometimes it's like, well, oh my god, we're at the fucking South Pole or North Pole. Let's do this experiment just for fun because this is like the only place where we would be able to see it this way. And of course, like you can introduce a lot of inconsistencies.
yeah. Well, I mean, really, is this like the best we can do in 2022? We can show we can do better than this. I mean, if you look at things like LIGO, they claim they measure a displacement of 1/1000th of a proton radius. So, like, you know, we're doing Cavendish. I mean, seriously, balls in a shed. This is the best we can do. Did you know that? You know what LIGO is?
Hey, can you repeat?
LIGO.
Isn't that the
gravity wave detector?
Yeah. But then I think they had like, I think LIGO wasn't there multiple facilities that?
Yeah, there's multiple. Yeah, there's a couple of them.
Yeah.
I'm not going to get into the problem with that, but they claim that they can measure a displacement of 1/1000th of a proton radius. This is what they claim. That's
it's crazy,
ridiculous.
isn't it?
Yeah, because it's bullshit. Because if you look up the actual documentation, it has like the thermal noise. So there's the Brownian motion, right? The random thermal noise of everything moving around. The thermal noise is a displacement that's 11 orders of magnitude larger than that.
Maybe they had like a bunch of nice. I don't know. I wasn't there. I wasn't part of the team doing it. I'm not saying what
you
they
have to
found
think of
was
it as like
right or
signal to
wrong.
noise. You have to think about it as a signal to noise ratio. Now, think of it like a jigsaw puzzle. Say you had a jigsaw
I know.
puzzle with 10
I am.
Yeah.
So
you have one
aware
part
of
and
problems
10
with signal
followed by
to noise.
11 zeros. You think you can pick a signal out of that?
I certainly wouldn't been able to. No. I mean, I've been like
nobody.
I work with not work like I study with electrical engineering. So like my field of study is a mixture of electrical engineering with like standard mechanical engineering. And in the sometimes when you do certain transmission stuff in the electrical engineering part, you like it is certainly possible to get decent
If you know the source.
results.
You have to know the source, right?
Kind
you need
of, but
priori
not.
knowledge of the source.
You need to know what kind of wave you're looking for. But generally speaking, I would say signal to noise ratio of like a 100 signal to noise is doable for me. But like I'm also not very skilled, and these guys spent a lot of money. Maybe they can do it. Like, but I haven't looked at the documentation.
10,000 to 1. 10,000 to 1. In MRI.
That seems feasible with like a lot of high tech technology.
That's like 1 followed by 4 zeros. Not like 11 zeros.
Yeah, that seems. I wasn't aware of the big issues they had with signal to noise.
Well, I'm just saying, LIGO's are very fishy, right? Their funding was up. It cost $4 billion. They didn't detect anything. So what they ended up doing was, this is what they did. They said, well, if we did detect a gravitational wave, what would the waveform look like? So they came up with 800. They came up with 800 scenarios. And then they pumped a simulation into it. And then boom, all of a sudden right after that they detected a signal. I'm just telling you what happened with LIGO. And then they got another $4 billion.
I mean, it wouldn't be the first time in the history of scientific inquiry that people who were just running out of funding decided to make up results. And if that's the case, I hope they get slapped in the fucking ass as hard as possible. Because that's not nice.
No, they're doubling down, man. You're like, we created a whole new field of astrophysics. I'm dead serious. So that's the funny thing about astronomy and astrophysics is that whenever they make an observation which falsifies their ideas, they call the discovery and give themselves Nobel Prizes. Oh, general relativity doesn't work for the radial velocity of galaxies. Oh, we discovered dark matter. Nobel Prizes. Like, it's nuts.
Yeah,
So
also
you are aware of dark matter, why it exists, right?
Yeah,
Because the radial velocity of galaxies and shit isn't right. So they said there must be some missing matter.
Right, I know. But it's the problem, unfortunately, with a lot of this stuff is that you would need to spend so much time sometimes going into this field in order to find where they make their little errors. And then it looks like there's been a lot of times where like huge new discoveries, like 10 years later, they found, no, there was this one little error in there. No, it's actually nothing. Like, I don't know, have you heard of this whole EM drive stuff like 10 years back? There was this guy who claimed he could like
drive,
create
the PAIS drive, PAS, that guy.
I think he called it EM drive because it was like microwave bouncing around like a box, and he said, well, this produce a force in one direction. But it was a whole bunch of
there was a
bullshit in the
couple of
end.
them. There was
Yeah,
the
maybe I
Alphabet
can't
drive.
remember.
There was the PAS drive. I don't know if the PAS drive was the same as the microwave one.
Anyway, it was just a whole bunch of, because it broke all of the laws. I mean, so
yeah, I mean, it's big money. I mean,
of course it is. That's why the fuck they're doing it. And then, like, there are a lot of charlatans out there.
Someone did. So a guy he's a particle physicist. He works at CERN. So there was this thing with like the expansion of the universe, right? So they came up with two. One estimate was based upon supernovas. The other one was based upon redshift, right? So astronomers are arguing or whatever. So this guy, he's outside of astronomy. He comes in and he looks at, this dude, that's what he does. He crunches numbers. And particle physics is very statistically based. And needless to say. So he goes and he, goes over all this stuff. And basically he said, this is all a bunch of bullshit. You know what they do? They say, well, you're not an astrophysicist. This isn't your expertise. You don't know what you're talking about. And they just brush him aside. And they do this all the time. They like, this what would you call it? Just protect, the terms of art and protecting your little field, right? And not letting anybody outside of it in, even though they have the expertise in the brain power to, cross over. They don't like they don't like people like crossing over fields, right? Commenting on, stuff their degree isn't in. But he basically said, your error bars are so large, you can't draw any conclusions. That was his conclusion. So basically they said, yeah, it's all doing this, and this is what we estimate. But they use like these gigantic error bars, right? I could say there's 100% certainty I'm going to jump over the moon, There's 100% probability I'm going to jump over the moon with an uncertainty of 99.99%, right? You can just increase the uncertainty to astronomical levels, and you can make any claim and say it's 100%. It's little games, statistical games. Anyway, none of this shit has to do with flat Earth. My recommendation to you is test it yourself. That's all you can do. Don't trust us. Don't trust anybody. Don't trust NASA. Just test it yourself. It's the most surefire way.
It's I don't know. I think for a lot of people, they often, I think, just can't afford to be to challenge their own views, and also to put in the time and energy to then try and search for correct answers.
The real question is, why do people such as yourself think it's reasonable to say this sentence? It is too expensive to answer a what is question.
For a lot of people, like, they are busy enough with their everyday life bullshit. Look at how many people don't.
No, it's very simple. It's very simple. A lot of people go to the beach. Okay, a lot of people go to the beach. And I'm pretty sure none of them have considered whether the horizon is at a measured distance or if it's just an optical phenomenon. So the bottom line is, it's a sick. I am without the means to know the nature of the world that I live in. That's insane.
Yeah,
Because it's not
I know
true.
people that are scraping by with like fucking 3.5 jobs, and they can't do shit, man.
How's that relevant?
Well, I'm just saying, like, a lot of people. I think a lot of people are just.
How's that relevant?
In the position.
How much do you think it costs? Like.
No, I'm not saying researching it costs money. That's not what I'm saying. I'm just saying a lot of people probably are just.
No. He didn't ask you how much it costs to research the subject. So I don't know why you're answering that question. How much does it cost to definitively know that you live on a ball? And what do you think you would need to buy?
That's a good question.
So why are you proposing it?
Well, I would, because I think it would be similar to how much
great
I would
that
need
the
to
regular
invest
person can't.
to find out what other shape the Earth would be. I think.
So I'll tell you the test I did. It cost me exactly $2.40 in train fare. Took the train up to the beach. Went on marinetraffic.com. Found a boat. Watched it sail away for 3.5 hours. When it got 30 miles away, looked at the curve calculator. Said, "Oh, that's supposed to be 425 feet under the horizon, but I can still see it." Okay, so it's literally that simple.
Huh?
I'll certainly do that the next time.
And you could have hopped the train and paid nothing.
Okay.
Maybe got arrested, but that's okay.
Depends on how long your train ride is, I guess.
It's a subway. You just hop the turnstile. Of course, Elijah would never do that. I mean, you could do it with a door mirror. There's all sorts of ways to do it. It doesn't really cost money, and it doesn't really take that much time. I mean, I just happened to do 3 hours because
the beach is nice.
So, yeah. So
no, I'm just, but this is not what I was arguing.
Come out of Boston Harbor, right? And you can go to Revere Beach, and I can watch them come out of Boston Harbor. They go from right to left. There's like a little what would you call it? Like a lane, a shipping lane they have to travel in. So they travel across the lane, right across your line of sight, and then they go straight out to sea. Marinetraffic.com will tell you like where boats are all over the world, right? So I can definitively get where this boat is, tracked by radar, out of a place called Gloucester Station. So they track it by radar, so I definitively know where the boat is. I know my elevation above the ocean. I can just look in a curve calculator and just see what is the prediction of the globe. Does this fit the prediction? I know there's no 47-story boats, right? They don't exist. And the great thing about marinetraffic.com is they often have a picture of the boat you're actually looking at. So you can actually see the boat. This happened to be like a container ship. So it was about a 5-story boat. Ship, I should say. Ship.
Oh, I just the other day had a discussion with someone of what classifies as a ship and what is a boat.
I don't know, man.
With sailing vessels, it's quite strictly defined, but when it comes to motorboats, it's like two motorized vessels. It's not that clear. Anyway,
So there's
I
one
don't want to.
guy.
I don't want to
He was at
diverge.
the so yeah. So there's a guy he did an observation at the Canary Islands. So the Canary Islands, they have the world's largest telescope there, and they have it there because the air, they call it, they say it has good seeing, whatever that is. Seeing in astronomy has like a special term. So that means there's a lot little turbulence, there's a lot less particles in the air, it's low humidity. So this guy was 100 feet above sea level.
Yeah.
He caught a
That's
24
it.
foot sailboat on the horizon,
Sorry.
but the horizon.
I just don't, because you're saying my lips.
Elijah,
you're hot, Mike. You're hot, Mike. Elijah.
Someone's hot micing here hard.
I got it.
All right.
Okay.
All right. So the gold model from 100 feet predicts that the horizon's 12 miles away, and this boat is sitting on the horizon. Guidebooks on marinetraffic.com, it says the boat's 27 miles away, and it's supposed to be 180 feet underneath the horizon. Now you can see the sailboat clear as day, the sail, everything. You know, all these like we have the horizon, especially. Like if you test the horizon, I've never almost I can't think of a single time where I've seen where we knew the distance to the horizon where it matched the goal prediction. Not even one time. Because it's a very specific prediction.
Yeah, not even with infrared cameras.
Yeah. The Jay Tolan, like San Jacinto, right? So you can see, so he took this from, it's called Dunes Beach, or Dunes, can't remember the name of it. It's something, no, it's Domes Beach, right? So 50 feet above the sea, he captures Marina, what's something called Marina Del Rey. Marina Del Rey is like an inlet where people park their yachts, right? That is 19 miles away, but if you look in the curve calculator, the horizon's supposed to be 15 miles away. So how can he see the surface of the water 19 miles away if the horizon's supposed to be 15 miles away? He also captures a mountain 123 miles away that you can't see, invisible, right? When he switches to infrared, you can see the whole damn mountain. See, that's the thing about infrared. The infrared radiation penetrates dust, water vapor, all that stuff. Quite useful.
Yeah, and it doesn't get refracted as much as visible light, so we should see the curve more pronounced in infrared. If their claims were correct.
Jay Tolan in infrared, he was on an airplane at 27,000 feet. He captured the Rocky Mountains 600 miles away. He was at 37,000 feet flying over Texas. He captured Cabo San Lucas 750 miles away. He caught George's Bay from, like, he was over Lake Ontario, something like 1,200 miles away. He even fed it into software, right? And this particular software will do like you take multiple snapshots, it'll make a point cloud and do like a 3D map of what you're looking at. If you got a whole bunch of snapshots, like when he fed this his observation and ran through this software, it was completely flat. And that YouTube channel is called Jay Tolan Media. Now, I'm going to make this little caveat. I don't agree with everything he posts. Okay, so I'm not a fanboy of anybody. The observations speak for themselves. Let's put it that way.
Yeah.
It could be fucking Hitler posting it. I don't care. It's the observation that counts. Did you know the moon is inside Earth's atmosphere? Did you know that too?
We were just talking about the moon just a minute ago with the blue marble and how it was like represented, the backside of the moon, how it was represented.
Oh yeah.
I'll put it in live stream real quick, just so that you know exactly what picture I was talking about. Here, this one. Right
Yeah, I know.
here.
Come on, man. Now you're telling them that the moon is in Earth's atmosphere? Come on, man. You're breaking them down at this point. I mean, I know that that's what space.com says, but, do you believe it, new guy? Do you believe space.com said that the moon is in Earth's atmosphere in 2019?
You know the Russians say that the moon is brown? Yeah. They say that the moon is brown, dude. NASA says the moon is, and they supposedly went to the moon. They sent a probe there. They said it was brown. But NASA claims it's asphalt color.
Asphalt color. Do they really say that? I've never heard that before.
They'll say the albedo of the moon is the same as asphalt, which is the reflectivity. That's what they say.
Oh my god.
Weasel is still here. Yeah, Weasel's the one that we were talking to about it. So, Weasel, are you here, or can you reply?
Yes, of course.
Awesome. So now, of course, we've talked about it. What's your thought about it? Do you have like a confusion now about it?
About what exactly?
The size of the moon and the Earth. I mean, you showed us the CGI program, but clearly,
right. I was. That was due to discussion.
No, it's okay. I'm just saying that's what you showed us, and it represented it. Yes, but clearly,
right, I'm not saying I believe. I would say I'm more convinced than not. Definitely.
That's what I meant. Just because we're talking this whole time about it,
Right. But like the if I remember correctly, the earlier discussion was about if the pictures
size
hit exactly if the size
ratio
of the pictures
of the Earth compared to the moon.
Exactly, if it fits the numbers given by NASA.
I know.
Because like there was some discussion about that, and
correct.
I would argue that it does fit.
Well,
their numbers.
Yellow, I wasn't arguing about the numbers. They fit perfectly. I was arguing about the actual the picture itself. Like you were saying that it's perspective, right? That was your first answer, and it's okay, and that's it. But you clearly didn't understand that the first picture, the one from this moonwalk, is absolutely fake. And then we showed you that with the funny thing happened on the way to the moon, So clearly,
I unfortunately haven't been able to.
Clearly, that is fake. Well, we addressed it to you that it does clearly show him taking a film off of the window and then it's showing the big Earth in that clip. But that shot beforehand is that shot right there, that little teeny Earth. That's what I'm trying to tell you. The whole thing is fake. The whole thing was fake, and you wanted to put it in as perspective, and that's why.
No. I'm not. I was not saying that the picture itself was
with the
real
measurements.
Like
I meant with the
I was
measurements.
Just exactly. I was just saying that in the type of even if they faked it, they stick
they stick to it.
To their numbers.
I'm just clarifying. Now that picture was absolutely faked. I mean, because like I say, they have proof of them taking the film off of the window and never being out 250,000 miles. Never.
That was by Bart Sibrel, right? He made that. Found that film?
Funny thing happened on the way to the moon. Yeah, I think.
Yeah, so I actually saw an interview with him about a month ago. He said he's coming out with another video that's even worse because NASA accidentally sent him that. It was accidentally sent to him.
That's exactly what I told Yellow.
He FOIA'd a whole bunch of stuff, and he found that after going through it, he didn't even know he had it for a while. And then he's like, oh my God, what's this? Yeah, so they say some pretty ridiculous things. So Neil Armstrong, so this is something he said in an interview, that they navigated to the moon using a sextant. Right.
Yeah, that's actually quite funny, isn't it? I think, but
Yeah.
I think based on their model, I think it would be possible because I mean, also now
Where's
they
the
claim
horizon?
that.
Where's the horizon, though?
I think you would need to just have like a different, like standard point in that sense. I agree with you that you have the problem of when you can't really say in what direction, like you're towards the Earth, quote unquote.
Yeah.
I
I've
would
asked,
say it gets difficult. I completely agree.
I've asked. We had a guy in here. He's so-called satellite engineer. What was his name? Stuart Gray or something like that. There was a the Stardust mission. Supposedly they sent the satellite to a comet, picked up some stardust, and sent comet. So supposedly picked up some stardust. So I asked him. He was in this chat. How do you know how fast you're going in space, and how do you know your orientation? You know what he said? Oh, NASA tells us where we are. Like, he has to be told how fast they're going and what way they're pointed, right? Because once you leave the Earth, like, how do you know which way you're oriented? How do you know which direction you're facing? Pretty crazy. Like,
but even worse, you can't measure an angle using a sextant and then travel there, because once you get there, we would have moved, I don't even know how much with the sun in 3 days. It wouldn't be where they calculated or measured it to be.
yeah, everything is moved. The Earth is moved, the moon is moved, you've moved, everything. You're spinning around. The Earth is rotated about 50 fucking times, or, Earth is spun, like, wherever you left the ground, like that, you're not above that ground anymore. That rotated away from you. And then you're headed to the moon, wherever that is. Like, how do you even know how fast you're going? Like, that's the main thing. Like, how do you know how fast you're going? No one has an answer to that.
How do you slow down?
If you want to slow
You're like
down,
Bugs Bunny, air brakes.
you throw stuff the other direction. That's basically the idea of a rocket motor. Is that you take a bunch of shit you don't want anymore and make it
Just out
explode
the
out
back
of your
end.
ends. Exactly, and then you, because of the force, you push it away from you, and the inertia and the momentum the other object has, you can like.
How you gonna, how much energy you have moving at whatever top speed you reach, like,
crazy much,
because you're okay, you're not losing much, right? Because at least tangentially, because there's basically nothing in your way. So how do you slow down then?
What do you mean you're not losing much?
The energy it would take to throw something in the opposite direction. That's a really silly answer.
What do you mean? Can you please repeat?
Am I wrong? Am I not making sense? Because I'll shut up right now, guys.
I'm
not asking you. I'm asking other people, because you're making me think that maybe I'm bugging out for what I said. It seems so simple.
You got to calculate the mass and the velocity at which you throw something out, right? But you also have to know how fast you're going initially to know how much you're slowing down. It's like one of these complicated things, like compensating for the Coriolis effect. You got to not only know your attitude, you got to know what direction you're pointed in.
Hold on, but if I'm driving, if somebody's driving in a car and I throw something, it's not going to change the speed of the car? I don't get it. Like, what?
but
Am
it
I-
would. Like, okay,
Otherwise, you gotta have a good arm, man.
If you want me to give you an experiment, maybe that, like, sit on a swing, take a bowling ball with you, and sit like on a swing, like a children's playing thing swing, and then throw the bowling ball away from you as hard as you can.
What is the bowling ball, like 1/10 of your weight? And
Yellow,
maybe-
yellow. Look in the live stream. I just showed you.
So
live stream?
that would be like all of the fuel at once, right?
Which one? The last one? The last GIF? Or what do you mean?
It's on a merry-go-round, right? You were talking about?
No, I said a swing. Like, how does what is the swing not the same in the US?
Swing set.
I mean, I don't know. This one looks or works a lot better though with the spinning.
I like Hank's point.
Isn't that two different reference points, right?
You mean the GIF, or what do you mean?
So if you see the left side, it doesn't curve; it's going straight. But the right side, it looks like it's curved because you're actually on the thing that's spinning, right?
Oh, okay. I see now. I see what the lines mean. Yeah, of course.
Okay.
Yeah. This is just difference in reference point, and you can clearly see that the centrifugal force doesn't really exist in that sense. I mean, like, you would see that it's the path the ball on the right takes would be the one you would expect if centrifugal force was a real force and not just an apparent force. But anyway, it was completely off topic. I'm sorry.
I'm sorry.
No, the picture on the left is just someone throwing the ball or shooting the ball over in the non-inertial reference frame. This is just an example of Coriolis.
No, okay, so the left side is the reference frame of the ground, and the right side is the reference frame of the rotating disk.
Yeah.
Exactly. And so the thing when it comes to, like, rocket propulsion, like, even if space isn't real, that would still work, because you're just like it all works on the fundamental.
I always say that I believe that they can fire rockets up. It's just, where are they going? We can't tell you that. And we know that there's not going into space because it does this parabolic curve out to nowhere. Every time.
Ooh, that's an interesting one. Want to talk about the parabolic curve?
Look at that. Look at, where the heck does that one going?
Oh, it's going into orbit, man.
But that's the thing. Well, okay, look at this one here. Is this one going into orbit?
Yes, that's also going into orbit.
And I posted this like 5 times right now. This is from NASA.gov. It's their trial by fire video on Orion's flight test. In that, they explain that they cannot go beyond low Earth orbit, as they call it, because the Van Allen radiation belt would kill everyone. So, no moon landings.
Yeah, but okay, so even if, like, low Earth orbit, let's say like even on the flat Earth, in the same way that, like, the sun, and I don't know which model you subscribe to, I'm sorry. I've heard different stuff.
Just subscribe to any model. There's no shape or size that we can actually determine.
Just don't tell the astronauts the Van Allen radiation belt exists and it'll have no effect. That's Buzz Aldrin's excuse.
Didn't
he
they?
Said we didn't know about them. No. That Buzz Aldrin said we didn't know they existed. That was his reason.
Oh, that's an asshole move, isn't it?
It is.
Well, I mean, someone confronted him and said, "How'd you make it to the?" I think it was Jared White, who hates flat earthers, but he's got a whole series on fake moon landing, and he went to a talk that Buzz Aldrin was giving. He asked him about the Van Allen radiation belts. He said, "I don't know anything about that. We didn't know about the Van Allen radiation belts." So I guess if you don't know something, then I guess it has no effect on you.
I heard. So this is what they say. I'm not saying this is completely true. Anything like always when I use they, just understand that. Yeah. Anyway, they said that they changed the trajectory from low Earth orbit to Moon, or I don't even think they entered orbit. Right, from Earth to lunar orbit. They had the trajectory in a certain way so they wouldn't pass through the craziest parts of the Van Allen belt and also just stay in there for very short.
No, they didn't know about it. So
they knew about it from a probe. That's what they say. They knew about it from a probe they sent up earlier, of one of the earlier satellite missions they ran.
Well, listen. I'm not going to get into it here, but Jared White, he has a 3-part video series just on the Van Allen radiation belts with the actual numbers, right? Not like we did this, we did that. How much radiation they say there is, how much radiation a human being can take, how long it would take to get through them, how high the Van Allen radiation, because there's 2 Van Allen belts. One of them something like fucking 8,000 miles thick. And supposedly when they went up, there was a solar storm. So there would have been a lot of highly energetic particles circulating around the Earth, right? So, but it's too complicated to get in here. Obviously, if it's a 3-part video series, it goes through all the documentation, and I'm talking the documentation, their documentation. They've tried to retroactively rewrite history because the Van Allen radiation belts were discovered pre-Apollo, right? So they have all that data pre-Apollo. And then, it just got ignored during Apollo. Then, a decade later, when people were, how'd you do this? They try to, we weren't in there long enough for anything to happen. But if you actually go look at the numbers, they were in there long enough.
Might also be the case that they just lied about it because they didn't want anyone to find out that they supposedly
they sterilized,
damaged the people in there. But I mean, that radioactivity, that would be a bit of an asshole move, yeah.
There was an NASA astronaut that said that when he closed his eyes, that he could see, sparkles and shit. And supposedly, according to him, this is the International Space Station. According to him, this is during a solar storm or something. That the particles will actually hit parts of your retina and actually cause little flashes of light with your eyes closed. This is what one of the guys said. But you go by what they say. Sometimes they can see stars, sometimes they can't. Sometimes it's pitch black, sometimes it's completely white. They have a bunch of different stories. There's somebody that's been asking NASA since the 70s if they can see stars in space. And we're talking about pre-internet. So he mailed them letters, right? So you got one department, like the public relations department, saying you can't. And then you have another department saying you can. And then if you look at interviews of astronauts, some say you can, some say you can't, some say they can't remember.
Okay, I have a question into the room, if that's fine for you.
Go for it.
And it's do you believe low Earth orbit exists in a certain way? Not even if it's not of course, if the Earth is not a sphere, then it's not going around the Earth in that sense. But do you believe that there's a place up there in which you can just hover and go in a circle above the plane?
I'll go first. Yep, they've had balloons since the 1800s. In the Civil War, they had hot air balloons and cameras. So you're asking me, can they get up really high and take pictures? Yeah, they've been doing that.
I would say not balloons, but you hang out up there without needing propulsion or something. I don't know what model you subscribe to, but in the similar way as in some models it is portrayed that the sun and moon.
We have zero evidence of no gravity space.
Okay, I'll just let you answer the question. Go ahead.
Well, let me answer this real quick. In the 1950s, the National Reconnaissance Office of the United States used to send up balloons and let them fly all over the place, and they would take pictures of everything. There were spy balloons. They would stay in the air for 8 weeks, and the only reason they came down is to retrieve the film. Otherwise, they would have stayed up there indefinitely. So what would happen is it was called a skyhook. So it was called skyhook. So when the film was used up, they'd send up an airplane, they'd punch in a transponder code, there was little explosives in the balloon that would pop the balloon, and they would catch the gondola out of the air. But those balloons would stay up for almost 8 weeks.
But even if you have a balloon, I think you wouldn't be able to keep it up there indefinitely without, like, I don't know, refueling your helium or hydrogen that you use as your lifting gas.
Well, I mean, because hydrogen and helium will leak through.
Yeah, exactly. Hydrogen escapes everywhere.
Well, so here's the funny thing. Well, I want to mention one more thing, and you can go ahead. Echo 1, look up that. It's supposedly a communication satellite. It was actually a balloon. A balloon they supposedly put in a 1,600-mile high orbit. Yeah, I mean, you can't make this shit up, man. It's a giant Mylar balloon.
A balloon satellite.
This is one of the first ones. So there was Explorer 1, and then the Echo 1. Explorer 1 was supposedly like a regular satellite. It was a what do you call it? They actually used it for a spy satellite. And the reason we know all this is because the NRO did something called the Living Memory Project. So they interviewed people that worked for their National Reconnaissance Office during that time, and they interviewed them, like, what did you do, blah, 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 blah. So this one guy, his name is Lieutenant Mitchell, he went through, like, all this balloon stuff, capturing the stuff, the Explorer 1, because he was, they had a bunch of planes, because they, like, it was supposed to be just like a regular satellite, but they were, the United States actually using it for spying. So, but he never actually saw it. So the point is that back then in the 50s, they called these things satellites, and they were balloons. That was the name of it. It's called the Corona Project. Listen, in the documentation, it says we're floating satellites. That's what they called it, because satellite, they just had a different meaning. The concept of satellite is new.
Well, yeah, also like
in the 30s.
As far as I know, also the moon would fall under the definition of a satellite in the globe Earth world, in the sense of like everything that just orbits a other thing in any way, shape, or form. So if these balloons go around the Earth every 2 hours or something like that, then I would say satellite seems also like a good definition for it, maybe.
Yeah, in the newspapers they said Sputnik was an artificial moon. Soviets launched artificial moon. That's what a lot of newspaper headlines said. They called it that. Yeah, it's pretty. It's funny. Foucault at his eulogy, right? So the Paris Academy at his eulogy, they said Foucault proved Earth was a wandering star, because that's like the real definition of planet, is a wandering star. So they think that Foucault, proved that Earth is one of the things we see in the sky.
Well, I think didn't wandering star came from these old civilizations. They looked at the skies and they saw all the sky, I don't know, the star formations, and then you had little glimmers of light in there that would move across the sky over days and weeks. I think that's why they're called wandering stars.
Well, I mean, people just did. There was the Earth, and then there was, shit in the sky, and at some point, people went, "Oh, we're them, and that's us,"
Mm-hmm.
But anyway, sorry, Hank, to interrupt you. You can go ahead, because I got a phone call.
No, it's no big deal. I wasn't really thinking you were interrupting. The guy asked me a question, I tried to answer, and then he interrupted, but that's okay. All is good.
Other people can answer it too. What do they think is up there, right? So I read a story 2 days ago.
Now you're
someone took a
interrupting
picture.
Hank, I would say.
So yeah, I know. He reminded me of something. 2 days ago, I read an article that said somebody took a picture of a fucking astronaut on a spacewalk on the ISS.
Like
That's
from the Earth
ridiculous.
with the telescope, or what do you mean?
Yeah, from the Earth with a telescope. Yeah, from the Earth with a telescope. Took a picture of a 6-foot man.
You think that wouldn't be possible
that
because
didn't
it's too
happen.
small?
It's
Or
beyond the diffraction. It's beyond the diffraction limit. You would need something like a goddamn 8-meter telescope.
It means it was 25 miles away instead of 250 miles away, is what it means.
okay, Hank,
So
now
in
you
the
can
Earth's
please Hank
atmosphere.
go. No man. So no, sorry, no problem.
Yeah, I don't mind. Indio can interrupt me anytime because he's hardly on here and he's the one that put in all the work. But yeah, I was going to say that the thing is, we can send balloons up to high altitude, no problem. Let's say they were to start coming down. Well, after a certain altitude they're coming down, maybe they could turn on some sort of what is a dehumidifier where they suck the water out of the atmosphere, right? And then they could pump that water into a hydrogen on demand fuel cell, pump some hydrogen back into the balloon, and then after a certain altitude, drop that water that they picked up off, and they're on their way back up. Thanks.
Well, that sounds like a cool idea. Let's build something like that. I'm all in, man. Okay, so no one
I think
else.
we need manned stuff. I think we need somebody on whatever it is you send up there. Otherwise, you're going to be able to tell for sure what's really going on.
Ooh, but that's putting on like a lot of weight.
Now you just got to find a really small dude.
Okay, we can set a dog up.
They got jockeys that weigh 100 pounds or just around there.
Yeah, I don't see any reason to send the guy up.
I'll sacrifice.
I was just thinking, if we zoom our telescope, we can certainly see where they landed on the moon. We see the flag, see the Chinese flag and the American flag there sitting there. Pretty sure. Zoom in a little bit more.
Okay, so how small would the flag be in like angular like how small of an angular resolution would we need to see the flag on the moon if it exists?
Right, so do the math on that. 250,000 miles away. Go.
Yeah, I can't do math with miles.
That's too bad. I don't do kilometers. Can you do it in feet?
I can. I'm currently searching for stuff on the web because this is I don't want to do anything by hand.
How come no one zoomed into the moon to show us the flag? It's been 50 years.
Well, that's the thing. Like, I don't know. Like, could we see it? How big of a telescope would we
the flag.
need?
I want to see the camera.
With like the official numbers.
I mean,
I want to see the camera that took that film of them flying away. That's what I want.
You still
that hang on. Wouldn't the sun have completely destroyed the flag after 50 years? Because I put a flag outside, and my flag turned white after 5 or 10 years.
Wait a minute. If you don't believe they live streamed from the moon, right, and took a selfie of the limb taken off, you're a conspiracy theorist.
How dare you?
We're all conspiracy theorists.
You believe it, you're a moron.
If you question it, you're a conspiracy theorist. Stop questioning stuff, man.
I guess that's who I am. I guess I might as well put that on my put that in my description. Huh?
So, if gravity makes things fall at the same rate regardless of the mass of the thing, and the sun is holding onto the Earth moving at 66,000 miles per hour, why aren't we all falling towards the sun?
Because of magic gravity.
Gravity is like a princess. It's very selective of who it wants to mess with.
It's very touchy too.
Picky.
I found a
Very
40 second long video. Let me see
Go ahead. Yeah.
if
Oh, boy.
he can see anything. But he has a fairly small telescope. Oh, that's
I mean,
a bigger one.
People with commercial stuff can zoom up to the moon. I mean, with the industrial powered telescope, I believe they could show us if it were there.
But
This guy says we need a
It's not
telescope as big as the whole Earth, but he didn't put any calculation in. Let me see if I can find anything.
It would be easy to figure out exactly how far you're actually seeing, right?
I mean, what is the flag
send
fly? Like
something up there?
2 feet by 4 feet tops? I mean, it wasn't a really big flag. I don't think you'd be able to see something like that from 238,000 miles away.
Yeah, I think was like half a meter by like half a meter max. I would say like rounded in that sense.
Oh, by the way,
Even
have you
smaller.
seen the American Moon documentary?
A one that like tries to debunk it. Or what do you mean? Or like one of the
It's a
official
documentary
ones?
called American Moon. I don't know if you've seen it on YouTube. Could be a good thing to watch for you to see how they.
Yeah, it's 3.5 hours.
Yeah, but it's well worth it. You just split up in sections.
Okay, so Hubble wouldn't be able to see it. That's, I think, expected. It's said to have quite a small mirror of just 2.5 meters in diameter.
Hubble.
They don't want to take a picture of it because if they do, then it would have way more land than is what is shown in the globe model. I'm pretty sure that's the main reason. And this is my opinion. If they go higher than the blue marble shot, their measurements are off. Because it would show more land.
And not only that, if they shot off the Earth, there's no way they can land on the face side of the moon. They have to land on the dark side of the moon because of Coriolis.
That doesn't make any sense to me. Or are you trying?
It doesn't make any sense to us either.
I think.
The best argument for Coriolis. That's so good. We do have a couple of new people in here. I don't know if you want to speak up. I'm not putting you on the spot or anything. I just want to make sure that we answer all questions. Anybody want to speak up that I just verified? It's okay if you don't want to. That's fine. We just want to make sure we answer all questions that we can.
So, Yellow, how's your brain holding up so far?
I would say still quite good. You gave me some interesting stuff I need to look in.
Yeah, for sure.
Yeah, see if you can verify it for yourself, not having to rely on NASA.
Exactly. I mean, like if if you're telling me I can't trust these guys, then I mean I shouldn't. if I need to verify their stuff, I need to verify your stuff as well, of course.
Yeah, science isn't about trust. It's about proofs and knowledge.
Ooh, there's some guy. There are some pictures of telescopes in orbit.
You mean images?
Is there? That's kind
No,
of
no,
funny
I mean
because
images
there was this.
taken
Hold on.
by telescopes in
Hold
orbits
on.
of the landing sites. But like, I mean,
Hold
it's
on.
hard.
Up in orbit.
Relax. Can I be heard? Okay, so there's this guy,
Yes.
Robert Masano. He called NASA and got a hold of like one of the project directors for Hubble. And he asked the guy, have you ever laid eyes on it since it went up? And the guy said no. Like he'd never seen it the whole time since it's been up. Hubble's been up for a long time. So you're saying that somebody's got pictures of telescopes in space, but we've heard it from the horse's mouth, right, that there is no such thing. And I can post the video if you like, Robert Bassano, Planete Veritas. You want to see that? It's like an almost hour-long interview. And he had the guy talking.
Post that thing.
Yeah, so
Alright.
the only pictures I could find that show the landing sites are ones that were taken from a lunar orbit. So unfortunately, we are not able to verify that for ourselves here from Earth.
Images.
What is the difference between an image and a picture? English isn't my first language, so please.
Do you mean photograph or Photoshop?
Yeah, like for example, the last piece of
Yeah, I
visual
got that.
content posted in the live stream chat. How would you
of the lunar module?
Yes.
I
What
stand
would
with the
you say that is?
KKK.
Yeah, that's real. That's a photograph, but doesn't mean it's out in space.
I'm not
do
saying
that in
that.
a
I'm
video
just
easily.
I'm just saying, like, because when I said pictures, you said images, and like I was interested in the difference.
Yeah, they're two different definitions. That's why I was asking you which one you meant.
Yeah, but like I'm to me it's
Yeah, that's
both
why
the
I was
same because I
asking.
learned English, so I don't.
Yeah. I just explained it to you. Someone was saying, sorry for
I
interrupting.
just posted 3 in there. I just posted some stuff in the live stream board. A photograph is a picture obtained by any process of photography from 1839, coined in English. Okay. An image is a piece of statuary, an artificial representation that looks like a person or thing. There you go. That's the difference. An artifact. An artifact is an artificial production, anything made or modified by human art. Those are the 3 keywords. And
So then, like, everything I see,
you'll notice that all the photographs from space they'll always change that word that you put in there as from photograph to image. And what does that tell you? Image is what? An artificial representation.
But like, doesn't everything I see on my computer screen then be an image? Probably yes, wouldn't it? Because it's a artificial representation in like pixels that my screen.
If you take an image of a photograph, no, that can be honest, right? Because that's what you're doing, right?
Yeah, like I'm looking at an image of a photograph. Sometimes,
right, but if it's altered at all, then it's not. It's considered an image, not a photograph. See what I'm saying? Think about it.
That's interesting, because I would then argue that like every picture of you that you take that isn't in raw format would be an image.
Right. If you don't have like a negative or some kind of a data stroke, like if it's an image off of an electronic eye, it's still data. The data is still a photograph, right? It's actually an actual copy of what the lens saw, right? It's not an image because an image is an artificial representation of it. You get what I'm saying?
Right, but like often, but like I would like if you take a picture with your phone right now, and you don't look at the raw formatted one, so like the one that is just the data your sensor picked up, then your phone automatically applies a bunch of different methods to make the picture look better, and then it wouldn't be a photograph anymore; it would be an image.
Right. That could be true, depending on what kind of options
That's
you
interesting.
have on your.
Okay, these
camera,
definitions are interesting. I'll try to keep that in mind.
Yeah.
Well,
so
I'm not saying that it means anything. I'm just saying that it's good to consider, what words mean.
I see. Yeah, but I don't want to convey a wrong meaning through my words because, like, I sometimes struggle with formulating myself correctly in a way that's understandable.
The question we need to answer is this image an accurate representation of reality? Can we test the image to determine that? What test can we do? Can we apply the scientific method to this test? And this should be applied to all images, not just flat Earth images, not just NASA images.
Yeah, I agree with you. I completely agree with you.
Is this an accurate representation of reality? That's all we need to know. And can we test it? Can't test it, then problem with images is if you just start taking images at face value, then where do you stop? Where do you draw the line? What images are you going to throw out? Aliens? Bigfoot? Where? And then there's that part, right? What is the image of? Is it something extraordinary? Is it the Loch Ness Monster? If someone takes a picture of their backyard, I'm going to tend to believe that because, backyards exist and they're pretty common, and it isn't really extraordinary that someone takes a picture of their backyard. When someone says they took a picture from a place where you drop things and they don't fall and they're 250 miles above the earth, that's kind of an extraordinary claim, and you kind of need a little more evidence for that than that. And then if you take the legal route, right? So what do you need to enter an image in court? You need the person that took the photograph to testify as to the authenticity of the image and the conditions on what they took it. So just images alone aren't enough. There's always has to be more, some supplemental information to bolster the image.